Clubs at every level of the football pyramid are becoming smarter and more efficient. How? The use of data.
To hell with conventional wisdom. The way we've been doing it has not been working.
You know your team's big stars, head coach, maybe even the rookie bench warmers. But you probably know very little about the PhD mathematicians like this woman. Her job is to crunch the numbers of the game.
We're all in sort of an arms race to acquire information.
Hi everybody, I'm damn sure you must be a fanatic of either NBA, football or cricket. These sports are like a common source of entertainment and adrenaline rush for us. But would you believe me if I said that today, in this age, these very sports have kind of become science driven? We live in the era where everything has become data point today. And these data points are captured and analyzed by data professionals working with sports clubs in order to create personas of the players. How they move, what is their game plan, and how you can beat them all at their own game plan. There is a famous book out there, Don't Trust Your Gut. Use data to get what you want in your life. And believe it or not, data is absolutely a big stuff. And if you know the science behind making sense of it, you are 100% successful. Every industry, every business knows that. And that's why they have sound team of data scientists optimizing their business processes and driving every decision that the company makes. That is the reason why this field is considered as the most hottest career choice of 21st century. At this moment, if you go over the Google search and search for data science jobs, you'll figure out that in India there are 1,50,000 plus data science jobs available. Whereas around the world there are more than 6 lakh plus jobs are available. And these jobs are just available on the LinkedIn job boards. If you consider all the platforms, this number could be even more higher. And this sole reason is enough for you to look into this domain. And to help you exactly do that, we have created this particular data science course. With this course, we are going to take you through the basic to most advanced data science concepts to help you get started in the field of data science. But before we get started, make sure to enable the subscribe button and bell icon for Intellipaat's YouTube channel. Also hit that like button if you like this learning resource. Having said that, let me take you guys through the agenda that I have at my hand for this particular session. So I myself will help you guys understand what exactly data science is, how exactly the data science lifecycle looks like, and what are the processes involved in data science lifecycle. After that, we'll go ahead and do a thorough analysis of data science job descriptions in order to understand what exactly you need to learn in order to become a data scientist today. We'll get started with basic statistical terms that you need to understand in order to learn data science concepts such as bias, variance, bias-variance trade-off, covariance, covariance in machine learning, and more terms related to inferential statistics. Now once we are done with this particular part, we'll dive into the implementation of linear regression. After that, we'll understand what exactly logistic regression is and how to perform it on a real-time data. Next up, we'll learn about decision tree algorithm in machine learning alongside random forest algorithm in machine learning. We'll also look into naive Bayes algorithm. Remember guys, while we tackle all of these machine learning algorithms, we'll be taking on multiple case studies and projects that you can go ahead and readily highlight on your resume. And finally, we are going to close this session with data science interview questions that are most commonly asked in interviews at MNCs and startups. So make sure that you stay tuned right until the end. Having said that, let's get started with the very first topic on our list. That is understanding what exactly data science stands for, or what is data science. Generally, when people think about data science, they see data as a lot of numbers and a bulk of mathematical equations. When word science comes into play, people think of it as a person working in a lab or wrapping his head around computers. But is that what data science really is? Well, it is not. Data science is not technical as software development. It is more of a problem solving and creative field where the real world problems are solved by diving deep into the data. And this is something we ourselves naturally do while making even simple decisions in our life. Like for example, if you were to travel from location A to B during the monsoon season, first you'd go ahead and check what the weather is like. What are the chances of precipitation? Then you would go ahead and visit Google Maps and figure out the shortest path to reach location B. If you want to reach there fast, you'll end up checking whether there is traffic on the road or not. See, in a very basic notion, you went ahead and gathered data from different sources, and by understanding that data, you'll be making the informed choice, which will be having very less chances of failure or disruption. Data science comes up from this notion itself. It's the problem solving discipline where you make use of data to drive successful business decisions. Not only that, by recognizing the pattern in data points, you predict the future trends using various statistical modeling techniques and machine learning. This is basically what a rough definition of data science looks like. If I were to refine it as per the industry reference, I would put it like data science is the field of study that involves extracting knowledge and insights from noisy data and then turning that noisy data into insights or actions that business or organization can go ahead and take forward. Okay, let's go ahead and dig a little bit deeper and try and understand this data science term in more detail. So, when we talk about data science in very basic terms, it is an intersection between three different disciplines. From whatever that we have discussed till this particular moment, you can figure out one thing, that data science is there to solve business problems. So by default, one critical pillar of data science becomes the business acumen. Then data is nothing but a lot of numbers and mathematics and statistics, right? So definitely mathematics and statistics naturally becomes the second pillar. And finally, the logical block that puts together both the mathematics and business side of things into a problem and solves it is something called as computer science. So basically, in a nutshell, data science is intersection of these three disciplines, and every data science initiative involves collaboration across these three key areas. Now let's talk about the different types of data science methods you might use depending on the questions you are asking in your organization. And believe me, these questions can range from simple to downright complex with varying levels of value they can provide. So let's map this out by complexity and value. First off, we have descriptive analytics. This is all about understanding what's currently happening in your business. It's like a quick status check. A common question here would be, did our sales go up or down? It's about having accurate data to know the current state of affairs. Next, we move on to diagnostic analytics. This one is a bit deeper. It focuses on figuring out why something happened. If sales went up or down, we would ask, why did that happen? We dig into the data to find the root cause of any change. After that, we hit predictive analytics. This is where we start forecasting. It's all about asking what's likely to happen in the future. For example, what will our sales look like next quarter? Here we use historical data patterns and trends to predict future outcomes. Finally, we have prescriptive analytics. This is where we get actionable. It's about figuring out the best course of action. So we might ask, what do I need to do to boost sales by 10%? This helps us decide the next step based on our analysis. This sounds cool, right? Now let's dive into how exactly data science actually gets all of this done and who is responsible for which part. This brings us to the concept of data science lifecycle. The starting point of every data science business problem is understanding the business. This is critical because if we are asking the wrong question from the get-go, we are setting ourselves on the wrong path, and that path is definitely going to lead towards failure. This phase ensures that we clearly understand what problem we are trying to solve and why it matters. Once we nail down our business question, we move on to data mining. This step is all about gathering the data we need for analysis, searching through databases and pulling out relevant information from the web. Next up is data cleaning. Let's be real, when we find data, it's really not in the best shape. It might be full of missing values, duplicates or errors. So we have to roll our sleeves and clean it up to make it usable for analysis. With clean data in hand, we move on to exploration. This is where we use various analytical tools to start answering our business questions. If you want to dive into more complex problems like predictive or prescriptive analytics, we have to use advanced tools such as machine learning models, that leverage huge amounts of computing power and high quality data to make accurate predictions and recommendation actions. Once we have explored and analyzed our data, it's time for visualization. We need to present our findings in a way that's easy to understand for every business stakeholder and take action out of it. Now let's quickly break down who does what in this particular life cycle. In most organizations, you'll find roles like business analysts, data engineers, and data scientists. Business analysts are the ones formulating questions and working on the business side of things. They are also involved in visualizing insights and making them useful for decision making. Data engineers, on the other hand, are the people who gather, clean, and organize the data. They make sure that the data pipeline is running smoothly, enabling the analysis process. Finally, we have data scientists. These are the professionals who dive deep into the exploration phase, applying machine learning techniques and advanced statistical methods to get the most value out of that data. Here is the interesting part. These roles often overlap. Business analysts might need to dabble in machine learning, while data scientists may have to hunt down data themselves. Collaboration is a key, and it's becoming more common for people in data roles especially. So there you have it. The data science lifecycle takes away from raw noisy data to achieving actionable insight that can have a significant impact on any business decision. Alright, now that you guys have a basic understanding about what data science is and how data science process looks like, the next thing I would like to do is go ahead and analyze what exactly we need to do or need to learn in order to get data science jobs. And the best way to figure this out is by studying the data science job descriptions. This is not a rocket science or something difficult that we need to discuss, but having clarity about what is expected out of you or validating whether what skills you exactly need is critical in order to become employable. And as we have been emphasizing, that's what our goal is for this entire data science course. I just don't want you to follow me blindly throughout this particular course ahead. Hence, I want to present the proof points about what exactly you are required to learn. So let's go over a Google search and search for data science job description. I'll open this job description provided by LinkedIn over here. See, whenever you are going to do analysis of job description, it's always better to first look at the expectations or prerequisites. If you look at this particular JD by LinkedIn, you can see that in the prerequisite or bottomest part, they have mentioned minimum bachelor's degree is required in statistics, applied mathematics, or related discipline like computer science, right? Then you are also expected to have a professional certification behind your back. Now this is the section where certification courses become absolutely valuable or kind of mandatory. See, it's not that I'm saying you cannot learn data science on your own. What I'm saying is a certification from credible source can boost your resume or your profile tenfolds during the recruitment process. I mean, if you are an entry-level professional, I would seriously advise you to consider taking on certification course. Intellipaat also offers a range of data science certification in collaboration with IITs and NITs. You can visit our website and check whether they align with your requirements or not. Okay, let's get back to our job. That is analyzing the job description. Alright, now that we are done with one section, it's time we move up. Now in the skills and qualification section, you can see that some sort of experience is expected here. I'm 100% sure that it wouldn't be 7 years everywhere, but data science is not like a foolproof entry-level tech role. You at least need to have some sort of development, analytical or business side of experience behind your back. If you have that, then you can go ahead and further apply to that particular job post. Alright, moving on, the next pointers are kind of highlight of the hard skills. See, these are the keywords or key skills you just need to master, but you really need to put them out there on your data science resume. We have keywords like statistical analysis, predictive modeling, data mining, Excel, SQL, programming languages like Python or SAS, etc. So basically, in order to showcase the use of these skills, you need to add projects and the results of those projects. In this particular course, we are going to work around almost 4 projects by the end of this particular course, which are basically going to touch upon almost all the aspects. So in a basic context, you will have some sort of projects ready to showcase on your resume by the time you are done with this particular course. Now let's move up to the final section again, which talks about the responsibilities. Here you can further see more keywords like collect data, pre-processing, analyze trends and patterns, implement analytical models and machine learning, right? See, data gathering most of the times, as we discussed early, is done by data engineers. So in this course, we have not focused on setting up data pipelines. Instead, we have started from the section where you have to understand the basics of machine learning and implementing those machine learning algorithms in order to find out prescriptive, descriptive statistics, right? So if I jot down the critical pointers once again, I need to critically work on programming language like Python, libraries like NumPy, Pandas, and prepare the data. Then I need to understand statistical analysis process, machine learning, etc. to basically get started in the field of data science. Having said that, let me hand over the further proceedings to my colleague to quickly take us through the fundamental and basic concepts of statistics that you need to know in order to get started in the data science domain.
In this particular section, we will be covering the basics of machine learning. But first, what is machine learning? Well, to put it in very simple terms, it is nothing but training the computer based on data. Now consider this example where you show a child different images of, say, cats and dogs. Over time, the child will start to recognize and differentiate between the two. Just like that, in our case, the child is a machine and the images are in the form of data. This very logic is used in things we see daily, like recommendations on Netflix or your personal voice assistant Alexa. Understanding the basics can open doors to amazing innovations, and it's simpler than you might think. So let's get started with our basics of machine learning, and our first topic is bias. So bias is a constant error added to all the predictions or estimates, which causes a systematic deviation from the actual values, right? So the impact on data is basically the data or the predictions are shifted away from the true values, and it directly affects the accuracy. So as you can see in this diagram over here, we have the actual values over here, and due to the bias, this is our calculate, or this is the result that we get. So the bias basically shifts the results a little away from the actual values. So this is the basic meaning of bias over here. Now let's see the role of bias in machine learning. So in machine learning, bias is again the error due to overly simplistic models that don't capture the data complexity. Now, overly simplistic models over here are called underfitted models, as you can see, right? So let's understand underfitting with an example. So let's say you're trying a new recipe, and instead of following each step in the recipe or each instruction, you just use the basic ingredients and assume that your almost inedible dish is exactly the same as the recipe, right? You have oversimplified the instructions. You have not followed each instruction step by step. Rather, you have just assumed that these are the instructions that are going to be followed, right? So in machine learning, bias almost has a similar effect. That is, if your model has high bias, it is going to have an underfitting state, or it is going to tend to underfit. That is, they ignore the important patterns and oversimplify data. Just like we saw the example of following a new recipe, right? So an example would be a linear model for complex data. Now what this means is whenever you have complex data, you are supposed to use more complex algorithms, like it could be random forest or any other model. But if you use a linear model for a very complex data, your model is going to have a very high bias, that it is going to oversimplify the data, and there's a huge possibility that it ignores the important details, right? Another example of underfitting or underfitted model is a weather model that is too basic to forecast different climates accurately. Now, what this means is your model probably assumes the average of every day's temperature, right? Now, this is an oversimplification of data. So there is a huge possibility again that it would ignore the important weather patterns. So in order to have more accurate predictions and understand more from the patterns, you need to reduce, or your model needs to have a very low bias, right? So this is basically how bias affects in machine learning. I hope this was clear and you guys got a basic understanding of it. Then we have our next topic, variance. So you can see two images over here. The first one is having a very wide range of heights over here. As you can see, we have a person, or you can say a child with a really small height, and then we have an adult with a really good height over here. So you can see there's a huge difference, right? And in the second image, we have people of almost the same height, as you can see. There is very little difference between the heights of the tallest person and the shortest person over here. So basically, when we have a scenario like this, where we have a really huge gap between the highest and the lowest value, we have what is called as high variance, right? But in the other case, where we have a situation like the highest and the lowest is not very far, you can say the data is not spread too much, we have what is known as the low variance, right? So let's look at variance in detail. So variance basically measures how spread out the data points are from the average or the mean, right? It basically reflects the data's dispersion or variability. So basically, in very simple terms, the bigger the spread, the higher the variance, right? So high variance indicates that data points are very far from the mean, or that the data is showing high spread. So this is what high variance means. Now, how does variance affect machine learning, or what is the role of variance in machine learning? So in machine learning, variance basically refers to how much the model's predictions change when it's trained on different data sets. Now that we saw what variance basically is in mathematical terms, in machine learning, it has a different role. Now, in machine learning, we always have a training data and a testing data, right? So we always train our data based on this particular data set, and then we test our data based on this particular testing data set. Now, whenever we train our data, now if our data has a high variance, there is a high possibility that whatever predictions we get on the training data will not match with our testing data, right? So this is basically how variance affects the model calculations or the predictions, right? So variance in machine learning basically represents how much a model's predictions change based on different training sets. High variance models are sensitive to minor changes in data, often overfitting by capturing noise along with pattern. Now, we already saw the case of underfitting. Now let's understand overfitting, right? So overfitting is basically when your model is too specific, or it learns too much from the patterns. Now this might sound good, right? Like your model is basically considering every aspect, or every little, or every minute detail. But consider this example where, so let's say a student is preparing for an exam. So instead of understanding the main concepts, the student is basically memorizing or by-hearting each and every specific example or every specific problem from the textbook. Now, on the day of the exam, if the questions are exactly the same as what the student by-hearted or memorized, the student is going to perform really well. But on the other hand, if the questions are changed even slightly, the student is likely to suffer, right? So this is also what happens in machine learning in the case of overfitting. If the data is changed, or if the patterns, if the trends are changed slightly, the model is not going to perform well. So this is why we cannot have overfitted models as well as underfitted models. So underfitting is basically too much oversimplification. So you can basically say overfitting models are too detailed. And they basically end up memorizing the concepts, right? They end up memorizing the patterns, which is not good for our model. We need to understand the patterns, not memorize them. So a good compromise is a good balance between the two, which brings us to our next topic, which is bias-variance trade-off, right? So as we saw, a high bias is basically an oversimplified model, or which is also known as underfitting. A low bias model would be something more complex. Variance, well, high variance models overreact to small changes, which is known as overfitting. Low variance models are comparatively more stable. So this is a basic understanding we have developed so far. Now let's understand bias-variance trade-off in detail. So the bias-variance trade-off is all about finding a balance between your bias and your variance, right? If your model has too much bias, it won't capture important details like we discussed, and it will underperform. So it is too simple, and we say it is underfitting the data. If the model has too much variance, it is going to be too complex, it is going to be overfitting, or it is also going to capture the noise or the pollution. So now the noise or the pollution is basically the unwanted data, right? So say we're looking at the house price data. Now in the data, if we start considering factors like the color of the house, it is going to be unwanted or the unnecessary details, right? We cannot assume that the color of the house is probably going to affect the price, right? So these are the unwanted details which will be captured or will be considered in overfitted models wherever the variance is too high, right? So the goal is basically to find a balance where the model is neither too simple nor too complex. That is, it is not underfitting, neither it is overfitting, right? So how do we do that? Well, let's look at this diagram over here. So whenever we have low variance and low bias, as you can see. So as you can see in this diagram, whenever we have a high bias and a high variance, we're going to end up with something like this. And this does not look good, right? A high bias and a high variance is not an ideal model that we come up with. If we look at high bias and low variance, so basically whenever we try to fit a straight line to the data that actually follows a curve, the line will not capture the complexity of the data, right? Your predictions will be off again. So this is also an example of underfitting, right? So this is basically trying to tell us that there's too much bias and there's not enough variance, right? Then we have our next scenario where a bias is too low and our variance is too high. So basically when we're trying to fit a very now high variance and a low bias is basically what is known as overfitting again. So this is also not our ideal model, because it is going to lead to overfitting, right? Whenever there's a high variance and we try to fit a curve, first of all, it is going to be too wiggly, right? With every small change in the data, it will lead to very drastic changes in the model, right? It will look great on the training set, but again, whenever there is any new data, whenever a new data is encountered, it will perform very poorly. So this is again an overfitting model, whereas a low bias and a low variance is something that we would ideally want. So in a situation where our bias is low and our variance is also low, we would be easily be able to fit a straight line or follow a curve, and the line will also be able to capture the complexity of the data, right? So this is something we would ideally want to achieve. So basically in machine learning, whenever we train a model, we do not want it to just memorize the data, the patterns that it sees in the training data. Neither do we want it to be too simple that it misses the important patterns, right? So this is where the bias-variance trade-off comes in the picture, and it is all about finding the right balance between the variance and the trade-off so that our model is neither too simple, neither too complicated, right? So this is all about bias-variance trade-off. Moving on to our next topic, which is covariance. So covariance basically measures how two variables or two features change together. So it basically tells if two things are related in some way or not, right? You can think of a situation where you're looking at two things. You can say the amount of time someone spends studying and the result of their exam score, right? So think of a situation or think of a data where you're given the amount of time spent studying and the result of the scores or the exam scores, right? If both increase together, that is more the study time, higher the exam score, that means there's a positive covariance. So that basically means that one feature increases with the other, right? But on the other hand, if more study time leads to stress, which basically means lesser exam scores, this would mean that the features have a negative covariance, or basically one feature decreases with the other, right? Or there could be a third scenario where you do not really see a clear pattern between the two variables. Now this basically means that there's no strong relationship between the two variables, right? So we've already covered positive covariance, negative covariance. You can see this is what they look like. So whenever there's a positive covariance, one variable or one feature increases with the other, right? But where there's a negative covariance, one feature decreases with the other, right? If one feature is increasing, the other one's decreasing. So this is basically what it means. Moving on to our next subtopic, which is the relation of covariance with machine learning, right? So covariance measures how two variables change together, as we already saw. It indicates whether an increase in one variable results in an increase or decrease in the other variable. So now high covariance in machine learning basically reflects a strong relationship between features which can be useful for prediction. But wherever there's a low covariance, it suggests that there's a weak relationship between the features and they're potentially irrelevant for the model, right? So let's look at the formula for covariance. So it might look a little complicated, but it's simple once you understand it. So it basically compares each data point's deviation from the mean or the average for both the variables and then multiplies these deviations. So let's see. So let's say I have two variables, x and y. So the covariance for these variables is going to be 1 upon n minus 1. N is the So n is the population, that is the total data size, you can say, right? So we're going to subtract 1 from the total data size, and then we're going to find the difference between the average of each point, between each point for both the features, right? So over here, xi and yi are basically the individual data points of the features x and y, and x bar over here is the mean and y bar is also the mean of both the features x and y, right? So this is all about covariance in machine learning. But before we go ahead and move to the next topic, let me quickly tell you about a technique in machine learning called PCA, or Principal Component Analysis. So the logic behind principal component analysis is basically if there are two features with high covariance, they are likely to contain important information, and PCA is likely to combine these two features into a single feature, right? So this is the basic logic that is implemented in PCA. We are not going to go into detail right now. We'll be covering these topics in detail through the course later on. So right now it is just important to have a basic understanding or a basic insight. So you know that PCA is something known as a feature reducing technique, and it basically works on the principle of covariance, right? Moving on to our next topic, which is inferential statistics. So these are the four main topics that we'll be covering, which is population versus sample, point estimation, confidence intervals, and hypothesis testing, right? So over here, as you can see in this diagram, is what we have a population, right? A complete data set. So a population is basically the entire group of interest. You can say, for example, all the students in a school, right? Whereas we have a sample over here, which is basically a subset of this particular population. And in a majority of cases, this is what is used in analysis, right? So say, for example, say the top 100 students from the school, right? So this is basically a subset of the population. So a population includes all the individuals or all the items that the data is aiming to study, whereas a subset is a chosen part of data that represents the larger population. So a population where all the data is included, it basically provides more complete and accurate information. But the only drawback is that it is very time consuming and costly to collect the data of the entire population. Whereas it is easier and cheaper to collect the sample data than the population data, but it is not as complete as the population data, right? So a population includes every possible observation, while a sample includes only a selected few observations, right? Then we have scalability. So why do we prefer using samples in machine learning? So the first point is it is scalable. So training on the whole population again is not very feasible, right? And again, the cost and time factors come in. Collecting the data for the entire population can be really expensive and also time consuming, right? So say we are aiming to understand the average height of all the adults in the United States. Now the population would be every adult or every individual living in the United States. So now if we were to go and measure each individual's height living in the US, it would be very time consuming and also expensive and practically impossible, right? So instead of collecting the entire population's height, we would go ahead and say choose a random sample of 1,000 people, and this would give us a very good estimate of how the heights of the people are spread in the United States, right? So this is all about population versus sample. Then we have our next topic, which is point estimation. So point estimation is basically using a single number or a point from the sample to estimate something about a larger group, or in our case, population, right? So say for example, you want the average height of everyone in the city, but instead of measuring everyone, you just measure a small group or a small sample of people, right? So from that sample, you will calculate the average height, and that average is your point estimate for your population mean. So the mean of the entire population you get from your sample data, and that mean from the sample data is called your point estimate. Clear? Simple enough? So it is basically the process of estimating a population parameter using a single value from the sample. Now these parameters could be the mean. Now these parameters could be any numerical characteristic. It could be the mean, it could be the variance, right? There are n number of parameters that you can calculate. Then we have our estimator. Now this is a statistic used to estimate a parameter. So estimator is nothing but our sample mean, right? Then we have our sample mean. So it is the point estimate of the population mean. Finally, our point estimate is again the value derived from the sample data to estimate an unknown population parameter, right? So over here, as you can see in this diagram, we have our sample over here, and then we have our population over here. Now from the sample, we calculate our mean, which is over here. Let's call it x bar. And then this x bar becomes a point estimator for our population, right? So whatever value the x bar gives, that becomes the population mean. So now this point estimate becomes a parameter for our population, which is telling us more about the population characteristic, right? So now we have something known as good estimators. So basically the quality of our point estimation depends on, so our estimators are nothing but that what we discussed over here, the statistic used to estimate a parameter. Now say for example, our sample mean is exactly equal to our population mean. Our estimator is said to be unbiased, and so this is again a property of good estimators. The next one is consistency. Now if an estimator is consistent is basically if it gets closer to the true population parameter as the sample size increases, right? So it basically means that as we keep increasing the sample size, we're going to have our estimators more consistent, or you can say more closer to the value of our population parameters. Then the last one is efficiency. So an estimator is efficient if it has the smallest variance among all the unbiased estimators, right? Now efficiency basically refers to how much variation there is in the estimator. A more efficient estimator is basically going to have less variability or less variance, meaning that if you repeatedly use it to estimate the parameter, the values will be close to each other and the true parameter as well. Then we have our applications in machine learning. So basically point estimates are used to predict the outcomes based on data. So in machine learning, point estimates are basically used to predict the outcomes based on the data, such as predicting house prices based on a sample of data. So now in a linear regression model, so whenever we're predicting a model, the main goal is to find the best fit line, right? That estimates a really good relationship between, say, the input features. Now, in case of our house price model, it would be, say, the area, the number of bedrooms, number of bathrooms, balcony, parking, and so on. And our output variable would be the house price. Now, the output prediction is a point estimate of what the house price might be for a given set of input features, right? So that is basically the main application of point estimate in machine learning. So moving on to our next topic, which is confidence interval. Now, confidence interval, or CI, is basically a range of values that is used to estimate an unknown population parameter. Like, say, for example, the average mean or the variance, right? So what confidence interval does is, instead of providing a single value, a confidence interval will give you a range within which you believe the true value lies. Now you take a sample of 100 people and you calculate the average height of that sample, but you know that sample might not perfectly reflect the entire population, right? So instead of giving back a single value, the sample mean in our case, we will calculate a confidence interval, say a 95% confidence interval for the true population mean. Now, what this 95% confidence interval means? It basically means that if you were to repeat the sampling process many times, say 1,000 times, about 95% of those times, the confidence intervals would contain the true average height of all adults in the city. So basically, this interval provides a range of values that are possible for the population parameter, right? So now we'll see why confidence intervals matter in machine learning. So confidence intervals basically help us to understand the uncertainty of our estimates, right? So basically, the wider the confidence intervals are, that is basically the larger the confidence intervals are, the more uncertainty our model contains. Now, conversely, narrow confidence intervals suggest that we have more confidence in the estimates. That is, they are more accurate, right? So now confidence intervals are not just limited to estimating the model parameters. Their use can also be extended to make predictions. Now, say for example, you want to predict the test score of a student who studied for 5 hours. You can calculate a confidence interval around that predicted score. So the interval will give you a range of possible values for the student score, considering the uncertainty in your model's predictions. So say your model predicts that a student who studied for 5 hours will score 80 on a test with a 95% confidence interval. So now say your model predicts that a student who studied for 5 hours will score 80 on a test. Now this is based on a 95% confidence interval of 78 to 82, right? That is the range that was given, and based on that, you assume that 80 will be the score. Now this means that you are 95% confident that the student's actual score will fall between 78 and 82, right? So again, 80 is a pretty good number based on this particular confidence interval. So moving on to our last topic, which is hypothesis testing. Hypothesis testing in a nutshell is basically something that helps you make decisions based on data rather than a gut feeling or a random guess, right? So say for example, you're a teacher and you want to know if a new teaching method will somehow improve the students' test scores compared to the traditional teaching methods. Now, this is where you can use hypothesis testing and make an informed decision, right? So there are basically two hypotheses. One is the null hypothesis and the second one is the alternate hypothesis. So this is basically a baseline assumption. Now, null hypothesis always makes assumptions containing a no difference statement, right? It always prefers to use an equal to sign. So basically, if we were to consider our example we just talked about, our null hypothesis would be that there is no significant difference between the new teaching method and the traditional one. Then we have our alternative hypothesis, which is denoted by H1. So this is the opposite claim. Now, whatever our null hypothesis is claiming, our alternate hypothesis is going to claim the opposite of that. So considering an example, it would mean that there is a significant improvement between the old teaching method and the new one, right? So it is always going to use a greater than or a smaller than or a not equal to sign, right? So once we have established the two hypotheses, we will then collect the test score data from the students who tried the new method and students who used the old one. So after analyzing this data, we will calculate something known as the p-value, right? So now this p-value is going to tell you how likely you are to have found a particular set of observations if the null hypothesis were true. So in simpler terms, it basically means that the chance that your results happened by random luck. So if the p-value is very small, which is less than 0.05, we will reject the null hypothesis, concluding that the new method is significantly better than the traditional one. But if the p-value is higher than 0.05, we will fail to reject the null hypothesis. That is, there won't be any significant difference between new teaching method and the old teaching method. So this is basically how the hypothesis testing works in basic mathematics. Now let's see how it relates in machine learning. So Hypothesis testing is very often used to check if changes to a model or a new feature really make a difference, right? Whenever we make a new change or we introduce a new feature in the model, we need to know whether it is making a significant difference or not, right? So, say for example, you're building a model to predict the customer satisfaction, right? And you decide to add a new feature, which is time spent on the website. But how do you know that if adding this particular feature is truly going to improve your model's accuracy, or if it is just something that looks or sounds good to hear? So, hypothesis testing is going to help you make an informed decision. You will again perform the calculations just like we discussed. You will make an assumption based on your null hypothesis. You will have a claim for your alternate hypothesis. You will calculate your p value. You will either reject your null hypothesis or you will accept it. And then, based on that particular assumption, you can decide whether you would like to keep that new feature or not. Right? I hope you guys got a hang of it and you guys are clear with the basics, the fundamentals of machine learning. So, these are basically the pillars that are going to help you perform the complex operations that we'll be discussing throughout the course. So, stay tuned.
Let me explain you what linear regression is, and you will be sorted in your life. Point number one. In machine learning, remember my people, you don't have to take an advanced level class to understand machine learning. Listen to me very carefully. It's common sense. Machine learning has three different main categories. Okay. All right. Listen to me very carefully. Guys, machine learning is segregated in three different categories: regression, classification, and clustering. Okay. Anything in machine learning is only these three things. Okay. Anything in machine learning is only one of this thing. Now you must be confused. Sir, what is regression? We don't know. What is classification? We don't know. What is clustering? We don't know. Let me tell you. Tell me one thing. Machine learning is me giving data to a machine or an algorithm and it learns the pattern, right? The keyword is pattern. Yes or no? The idea is pattern, correct? You tell me one thing. Ek baat batao. You guys think of it logically. In a country like India, we have roads that go like this, that go like this, that go straight, that go left, that go right. Then there is another bypass road. Is it possible for us to program each road? If you want to go from point A to point B, is it possible to program all kind of roads? Is it possible to program all kind of extensions? No, right? We can create an algorithm that tells you how many intersection comes between point A and point B, and an algorithm can be smart based on the intersection, based on the law of mathematics. It can create roads. It can create paths, right? Like for example, path number 1 could be this. Okay, path number 2 could be like this. It could be created automatically, right? This is exactly the problem machine learning engineers faced initially when machine learning did not exist. To some logic in life, you can program. But if the data changes, let me give also an example. Back in 1990s, people used to wear bell-bottom jeans. In 2023, if you start selling bell-bottom jeans, will people buy? No, the trend has changed. The fashion has changed. The way people approach clothes has changed. The data of 1990 does not apply to 2023. So that means what? Companies every 10 years have to change their logic. That takes money, that takes resources. Machine learning is created so that automatically from the data, I pick up the pattern and I understand what people want, or I understand what this data has. So what is regression? Very simple, guys. Do you know what is the meaning of continuous variable? Do you understand the meaning of continuous variable? Yes. Continuous variable means 15, 19.66, 1400, 1,69,992.619. Any number that is continuous in nature. Are you clear? Any number that is continuous in nature. Let's suppose I tell you my problem statement is, given my age, given my job, I want you to predict how much salary am I making, money I am making. Now tell me one thing. Things like temperature, salary, age, they are continuous variable, right? They could be anything. They could be any number, right? Between certain range to certain range, right? In machine learning, listen to me. In machine learning, whenever you are asked to generate, predict a number which is continuous in nature, what is that thing called as? Regression. What will you use? Regression algorithm to predict an output. Are you clear? In machine learning, I hope you know that you have two kind of variables. One is called as an input variable and the other is called as an output variable, also called target variable. I will give my age and my job as an input, and my prediction is if your age is 23, your job is a data scientist, your predicted output is you must be making 1,80,000 a month. Example I'm giving you. Did you understand? In machine learning, you have to give some input to get some output. This relationship, do you understand? Dependent, independent variable. We call it predictor variable. Yeah. So whenever you want to predict or print a number which is continuous in nature, it could be 1,80,000, it could be 1,85,991 rupees. Who knows? It depends on your data. When such kind of numbers are supposed to be printed, regression algorithms are supposed to be used. Now tell me one thing. I am asking you guys another question. I will give you a photo. I want you to tell me whether the person is a male or the person is a female. So tell me one thing. Here, the thing is very simple. I just will give you a photo. I want the answers in two buckets. Is the person male? Is the person female? This is a simple example of classification. Classification is a simple concept of bucketing things. Are you clear? I give you something, my answer should be whether it is bucket A, bucket B. Simple. Your pizza classification, whether a person is a dog or not, cat or not. Simple thing of whether something falls in bucket number one, bucket number two. That's called classification. Now, regression and classification are all for labeled data. Don't worry about it. Clustering is for unlabeled data. We'll talk about that, okay? But I want you guys to be aware. Machine learning is only these three things: regression, classification, and clustering. Okay? You've understood what is regression. You've understood what is classification. Now, can I take you guys through linear regression mathematically so that you absolutely understand what exactly is linear regression, boss? For that, I want you to tell me, have you heard of something called line equation? Have you heard of something called line equation? You call it as y is equal to mx plus c. Yes or no? You must have heard of this concept y equals to mx plus c. To all my people, I want to show you something. You guys will love this, but you will be amazed. Let me tell you something. Let's say you have a graph. This is called my x-axis. This is called my y-axis. Okay. Suppose I have this coordinate system, this x-axis and this y-axis system. Okay. Suppose there is a line passing through this particular graph. Suppose this is the line. This is passing through this graph. This line is touching the y-axis on some point. Yes or no? This point here, it is touching the y-axis. Yes? Okay, good. And this line is sort of infinite in nature. Like it goes on and it goes on and on and on. Clearly, this is a line, right? Like if you talk to me and if you look at it, this is a line, correct? Now, this y is equal to mx plus c. Y equals to mx plus c is sometimes also written as y is equal to b naught x plus b1. Okay? b1x plus b naught. People change it all the time. Okay. So that is why I always ask you to keep it in this format. Y is equal to mx plus c. Easy to understand. This m is called as slope. Okay. This c is called y-intercept. This is the equation. Now you must be like, wow, sir, what is this? I have no idea what you're talking about. Don't worry, I'll explain. This y-axis is 1, 2, 3, and 4. This x-axis is 1, 2, 3, 4, and 5. So, do you see that I can calculate this line slope by this formula? This is 4 points on the x-axis and 3 points on the y-axis. So, can I say 3 divided by 4 is my slope? Guys, this line could also be like this, right? This red line could also be a little more steeper, correct? Line can be flat or even more steeper. Mathematically, what is a steeper line? What is not a steeper line? That calculation can be done by slope, right? Slope is nothing but the difference in the x-axis versus the difference in the y-axis. So if you just ignore this definition, but let it go, it's okay. Point being, your m, this value m is nothing but your slope. And your c is y-intercept. Y-intercept means where am I touching the x? Sorry, where is the line touching the y-axis? At what number is it touching the y-axis? At what exact data or point is it touching y-axis? Isn't it touching y-axis at number 1? So your y-intercept is 1. Your c is 1. Are you clear? It is touching the y-axis at 1. Hence, your y-intercept is 1. That means the number is 1. Okay. I want to take you guys through an example. This data is weeks and cars sold. Okay. Imagine all of you, you work for a company which is a car company, like a car showroom. Suppose you work for a certain car company and they want to run machine learning algorithm specifically called linear regression, that when weeks increase, like week number 1, week number 2, week number 3, how many cars have been sold? So suppose week number 1, 2 cars have been sold. Week number 2, 4 cars have been sold. Week number 3, 5 cars have been sold. My job is, can you predict if week number 6 comes, how many cars will I sell? So point number 1, isn't it a linear regression problem? Because it is a continuous number that I want to predict outside. Yes or no? 100%, sir. Now this data is given to me. Let us learn how linear regression is the best fit algorithm for this particular thing. Okay. Let us first plot the data. I have a variable called weeks. I have a variable called car sold. Among both of these variable, which variable is a independent variable, which is a dependent variable? Can somebody tell me this? Between weeks and cars sold, what is a dependent variable? What is an independent variable? Acha, tell me one thing. What am I trying to predict? Am I not trying to predict cars sold? How many cars is being sold? So tell me one thing. Isn't weeks my independent variable and cars sold my dependent variable? In machine learning sense, weeks is my independent variable and my car sold is my target variable. It is my target to get that as a prediction. Very good. Okay. 1 and 2. Good. 1 and 2. 1, 2, 3, 4, 5, 6. Sorted out. 1, 2, 3, 4, 5, and 6. Okay. 1 स्टार्ट होता है ना, यहाँ से 0 तो यहीं से हो जाएगा, ये तो इनिशिएटर है, 1 2 3 4 5 एंड 6, ठीक है, 0 1 2 3 4 5 एंड 6। ये सही है। ओके, द फर्स्ट डेटा पॉइंट, व्हाट इज द फर्स्ट डेटा पॉइंट? अच्छा, टेल मी वन थिंग, do we always divide our graph into x axis and y axis? Yes or no? Remember one thing very carefully, and I want all of you to listen to me, okay? If you don't listen to me, I swear to God, I will come in the night and I will haunt you all. Listen to me very carefully. Your x axis in machine learning, your x axis in machine learning is always the independent variable. Are you clear? Your y axis should always be your target variable. Never miss this. Your x axis, whenever you want to do linear regression, should always be your independent variable. Your y axis, the one that you want to predict, should always be in the y axis. Are you clear? So this is weeks. Yes, this is weeks. And this is cars sold. Are you clear? So tell me one thing. What is the first data point? 1, 2. Yes or no? For week number 1, 2 cars are sold. So can I say this is the first data point? 1, 2. Yes or no? See, x is 1, y is 2. X is 1, y is 2. X is 2, y is 4. So x is 2, y is 4. X is 3, y is 5. So 3, 5. 4, 4. This is 4, 4. Next is 5, 5. 5, 5. Can I say that this is what my data is? 1, 2, 2, 4, 3, 5, 4, 4, 5, 5. This is how my data looks like. Agree? Our goal, our aim, our job is to actually fit a line, yes or no, to this data. Our job is to fit a line to this data, right? The job is to fit a line such that this line is in the middle of all the data points. Like this is the data point spread. Agree or disagree, my people? This much is how my data is spread, yes or no? So my job is to basically fit a line that almost fits in the middle. It fits everything properly. Is this a best fit? Is this line called best fit? No. Is this line called best fit? No. This line is best fit, right? Something that goes between the data, matches everybody properly, very nicely fits inside. Yes or no? Yes, that is our job. But do you think we'll be able to just directly plot it like that? सीधा हम लाइन डाल देंगे, मैथमेटिकली कुछ समझे नहीं, सीधा प्लॉट कर दी? नहीं, that's not how it works. We will plot it based on mathematics. Okay. So far, this is the data that is given to us. Yes or no? Have I done anything which is absolutely different? I have done something new. This is the data that is given to me. Yes or no? एक बात बताओ. In mathematics, I could do this. I could take a random line and I could plot it. And I could move this line. Okay, I want to show you guys one thing. Do you see this line, my people? Do you see this red line move? Look at it. Can you see it's rotating, 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 rotating? It's moving from the initial position wherever it was plotted by a random guess by the computer. It is moving, 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 and it is making itself into the best line. Can you see? It is rotating, rotating itself, and then going to the best line, best fit, what we called as. Okay. So you know that whenever if I put a random line, it will move itself and it will position itself in a proper way. This is possible. But you know what? We are statisticians, we are mathematicians, right? People who created linear regression were smart people. You know what they did? I have a data given to me by somebody. Can I not make an educated guess where to first plot the line, where to take a line and take it, like have the first guess of the line? You know how they did it? You want to know how? Very simple. In the x-axis, take the mean of x-axis. What? X-axis, whatever data points you have in the X-axis, take the mean of X-axis. So what will be the mean of 1 plus 2 plus 3 plus 4 plus 5 divided by 5? It will be 3, right? So take the mean of X-axis. Can you tell me what is the mean of Y-axis? 2 plus 4 plus 5 plus 4 plus 5? It will be 4, right? Take the mean of X-axis, take the mean of Y-axis and pass the line from between. Now you have an educated guess. Did that make sense, my people? Remember, whatever I'm teaching you is the algorithm. This is the thumb rule. Any machine learning linear regression algorithm you're going to implement actually works like this. So far, you guys are clear? Okay. Let's talk mathematics. Okay. Let's talk how linear regression achieves this all. Okay. And then we'll slowly, one step at a time, move forward with how exactly is machine learning going to do this, right? Like how exactly is machine learning going to solve this problem? Give me 1 second. Okay. Let me copy this and make it a little smaller taki it fits the data that we are doing. Okay. Remember, guys, whatever I'm teaching you right now, algorithm of linear regression is exactly written this way. There is another way of writing linear regression that is called stochastic gradient descent. Don't worry about it. Linear regression is of two types. Linear regression can be solved in two types: ordinary least square and stochastic gradient descent. Now, the method that I'm teaching you right now is called ordinary least square. I'm not teaching you stochastic gradient descent because उसके लिए बहुत समय लग जाएगा. Okay, that is another topic for another day. But remember, linear regression can be solved in two ways: stochastic gradient descent, ordinary least square. The one that you implement in your production or sklearn is an ordinary least square, not a stochastic gradient. If you implement it in PyTorch and TensorFlow, it is stochastic gradient descent and not this. So basically gradient descent based, not this, not ordinary least square. It depends on the library also. Remember, we have a column called weeks. Okay, we have a column called weeks. We have a variable called car sold. Can I write this week as an X variable and my car sold as a Y variable? Will you understand? This is my X axis. This is my Y axis. Ordinary least squares. OLS. So tell me one thing, my people. I have a variable called X axis. I have a variable called Y axis. Okay. This is how my graph looks like. This is mean of X. This is mean of Y. Huh? Let's keep it like that. एक बात बताइए. From X axis, from this mean of X axis, isn't this data point this much far away from the actual mean? Isn't this data point this much far away from actual Y? Like, for example, this is the distance between the mean and the X-axis, the data point. This is the difference between the mean and the data point, and this is also the distance between the mean and the data point. So mathematically, if I want to write this distance between the data point, actual data point, and the mean, can I write it like X minus X bar? Can I write it mathematically like X minus X bar? Your X bar is basically the mean value, right? The mean value. So tell me one thing, my people. What is the X bar? 1 plus 2 plus 3 plus 4 plus 5. What is the X bar? It is 3. 2 plus 4 plus 5 plus 4 plus 5. What is the Y bar? Sorry, it would be 4, right? So tell me one thing. X minus X bar is nothing but the distance between, okay, the distance between, do you see this X bar, right? This is X bar and this is Y bar. The distance between this point, this distance between this point to this point, this point to this point, this point to this point, and this point to this point. Are you seeing this? Your X bar versus this distance, your X bar versus this distance, and your X bar versus this distance. Your actual data point and the X bar. This is your X bar and this is your Y bar. Yes or no? X minus X bar. So tell me one thing. What is 1 minus 3? What is 2 minus 3? What is 3 minus 3? 4 minus 3 and 5 minus 3. So tell me one thing. What is 1 minus 3? Minus 2. What is 2 minus 3? Minus 1. What is 3 minus 3? 0. 4 minus 3? 1. 5 minus 3? 2. Yes or no? Do you know what it says? It tells you that this data point and this y bar is minus 2. This data point and this y bar is minus 1. This is 0. This is 1. And this is plus 2. Are you clear? The distance between the x mean and the actual data point. Are you clear? Any confusion? I have just calculated the actual data point's distance between the mean of x-axis. This black color dot, is that my actual data point? Yes or no? Okay. This green line to your left is my x bar, which is called mean of x. I want to calculate variance, the distance between or forget variance. I want to calculate how far off is my data spread from the mean. From mean, how much distant is my nearest data. So this is the distance. This is the distance. This is 0 because it's on the x bar, and this is the distance. Yes or no? This is exactly what I'm calculating. See, 1 minus 3 minus 2, 2 minus 3 minus 1, 3 minus 3 0, 4 minus 3 1, 5 minus 3 2. Are you clear until here? Okay. Because you have calculated the distance from x-axis, shouldn't you calculate it from y also? So can I not do y minus y bar? So we just calculated the distance between the data point and the x-axis. Should we not calculate the distance between the data and its y-axis mean? We've calculated the distance between the x bar with the x mean. Should we not calculate with y mean also to know how far you are from y? Yes, we have to. So what is y minus y bar? 2 minus 4, 4 minus 4, 5 minus 4, 4 minus 4 and 5 minus 4. So what is 2 minus 4? Minus 2. What is 4 minus 4? 0. What is 5 minus 4? 1. What is 4 minus 4? 0. What is 5 minus 4? 1. This tells you the distance from y-axis to the actual data point. Are you clear? Do you see that you have just calculated the distance from x-axis to x bar, y bar to the distance of the actual data point? Okay. Now tell me one thing. This x minus x bar, isn't minus 2 and plus 2 cancelling each other out? Isn't this plus 2 and minus 2, if I want to get a clarity how far the data is, aren't they cancelling each other out? And this is mathematically not correct. So can I not do x minus x bar the whole square so that they will automatically become positive also, and they will not be cancelling each other out also? Can I tell you guys a little trick? You may not understand it 100%, but this will save your life in the interview. Yes or no? Can I tell you guys something that will save your life in the interview? You may not know the mathematical idea of it yet, but can I tell you this? Because this question is going to be asked in your interview, 100% guarantee. I assure you they will ask you this question in your interview. If you want to go for a machine learning interview, they will ask you, whenever we do linear regression, you have x minus x bar and you have a number called minus 2. In mathematics, we have a concept called abs. Have you known? Do you know what is the concept of abs? This minus 2 can be converted as positive 2. If you put it as a 2 double degree sign there, it can become 2. It's called absolute value. Are you clear? It's called absolute value. Actually, what you do is you multiply minus 2 with minus 1. So it becomes 2. It's called abs. Point being, why do I need to square something? Can I not take an absolute value and then be done with it? Yes or no? Make sense? Why should you always square? Why can't you take the apps value? The answer is the absolute value in mathematics is not differentiable. What is it? The absolute value in mathematics is not differentiable. Square, on the other side, is a differentiable value. Let me explain. Do you know how abs look like in mathematics? It looks like this. It looks like a V. But do you know how a square looks like? It looks like this. Like a curve. Have you heard of calculus in your mathematics? Has anybody done calculus in your mathematics? Whenever we want to take differentiation of x square, isn't it 2x plus c? Or ignore c, but 2x. X 4x4 is equal to 4 into 4x cube. 16x cube. This is the differentiation of 4x4. I know some non-tech people are like, kya bol raha hai ye? I understand. My people, listen to me. Ignore all of that. Okay? Do you see this graph in front of you, my people? आपको ये graph दिख रहा है? It is like a V. Do you see it is like a V? It is like a V. This -3 is plotted as 3 again. आपको दिख रहा है? Like, do you see this graph? Your -3, okay? Your -3, which is this, is plotted here. It goes here and -3 became 3. Do you see? Your -3, when it is plotted on this line, becomes +3. Do you see? Why -3 becomes 3, -2 becomes 2, -1 becomes 1. This is how mathematically it looks like. But if you look at square, do you see it is like this? Do you see the difference? It's like this. It's like this square graph. Are you clear? Remember one thing, in your interview, they will ask you this question, I don't know, millions of times. Just be very careful. The reason why you square them and not abs them is because you want your function to be differentiable. You want to differentiate later on. Hence, we keep square. Are you clear? Don't have to go deeper. Just keep in mind. Okay. So coming back to the topic, what is x minus x bar the whole square, my people? So what is -2 square? 4. What is -1 square? 1. What is 0 square? 0. What is 1 square? 1. What is 2 square? 4. If you take the sum of all these values, how much will they add up to? 10. I am going to take one more column. This column may not make sense to you now, but this column will make sense to you in 2 minutes. Listen to me very carefully. I am going to take another column called x minus x bar into y minus y bar. Don't worry, I will explain it to you in 1 second. It will make all sense. Guys, what is -2 into -2? 4, right? What is -1 into 0? 0, right? What is 0 into 1? 0. What is 1 into 0? 0. What is 4 2s are 8? Sorry, 4 2s are बोल रहा हूं मैं. 2 1s are is 2, right? And together they add up to 6. Okay. एक बात बताओ. In a rectangle or a square, how do you measure the area? Is it length into breadth? Yes or no? Come to my graph and एक बात बताओ. This distance, थोड़ा गहराई में सोचो, थोड़ा प्लीज ध्यान से सोचो. This distance is called as x minus x bar, yes or no? This distance is called y minus y bar, yes or no? So let's say this is length and this is breadth. Am I not calculating how far I am both from x and y as a rectangle term? This information tells me how far my data is from x and y. Did that make sense to my people? Did that mathematically make sense? X minus X bar, Y minus Y bar. I am taking the combination of both. This tells me the area I am covering between the data point. Are you clear? Like how far off my data is from both an X and Y. That information is holded or informed in this particular part called X minus X bar into Y minus Y bar. Are you clear until here? Yes? Okay. Now, this is all that you had to calculate for linear regression. This is enough for you to calculate linear regression. Now we will do mathematical calculation. Now tell me one thing. To calculate linear regression, okay, to calculate the line, don't you need y is equal to mx plus c, this equation? Let me write it in red. This is the line that you want to fit mx plus c. Yes or no? अब आप मुझे एक बात बताओ, for the given problem statement, have I calculated the value of m and c yet? अभी तक have I calculated the value of m and c? That is main, right? Bhai, if the movie is about Shah Rukh Khan and Shah Rukh Khan has not made an entry or intro in the movie, are we going to be interested? No. We are waiting for the main actor to come and watch the movie. We have not calculated MNC. But what did we do? For the given data, we calculated x minus x bar, y minus y bar, x minus x bar the whole square, and x minus x bar into y minus y bar. Basically, we've kept couple of things ready in the data. Yes or no? Now tell me one thing. If I want to calculate m, do you know what is the formula? Can I tell you what is the formula to calculate m? Summation of x minus x bar into y minus y bar divided by summation of x minus x bar the whole square. So tell me one thing. Do I have these both? Do I have both the answers with me ready? What is x minus x bar, y minus y bar summation? Is it 6 divided by what is x minus x bar the whole square? 10. So tell me one thing. What answer did we get? What is the value of m from the data that we have? Okay. M is calculated. Now, when we started this intro, when I started the intro, do you remember I told you that whenever you do linear regression, by default make a mean of x and mean of y and then pass the line through it? So our x-axis and y-axis becomes x bar and y bar. Yes or no? My x-axis becomes x bar, y-axis becomes y bar. So y is equal to mx plus c. This equation, can I write it as y bar is equal to mx bar plus c? What is my y bar? Isn't it 4, my people? So 4 equals to, what is the value of m that we just calculated? 0.6 into, what is the value of x bar, my people? 3 plus c. Are you understanding what can I do now? 4 equals to, what is 0.6 into 3? 1.8 if I'm not wrong, right? 1.8 plus c. So what will be c? 4 minus 1.8. What is 4 minus 1.8? 2.2. Did you now calculate 2.2 and this? So your line equation, which was y is equal to mx plus c, became y is equal to 0.6 into x plus 2.2. Are you clear? My people, what you did right now with this mathematical calculation was you have now calculated a line equation that cancels the y-intercept at 2.2 and the slope is 0.6. Did that make sense? You have calculated the very first line that passes between x bar and y bar. But you have clarity what is the y-intercept and what is the slope. The first line, this is not the best line. This is just the first line that passes through the middle of x and y. Are you clear? This is in no way I'm saying this is the best line. I am just telling you this is the first line you have plotted. Can I tell you one thing? Also, one small example. You must have heard people do linear regression using scikit-learn, sklearn, scipy and all of scipy is for stats, sklearn, TensorFlow and all of that. What if I do not use any library and show you linear regression exactly using the same formulas we wrote, and then we will use the library linear regression function and compare the results? They will be exactly the same. How about that? Write linear regression from scratch. Whatever I'm teaching you now, I will write a code from scratch from this. Then we will take linear regression function from sklearn and we will match the results. It will be dot same, exact 100% same. This way your clarity will become more better. Bhaiya, whatever we are learning is the same thing. Make sense? Okay. I want to ask you one question. Did you all understand why are we doing this? This formula? Why are we dividing it by x minus x square? Why are we doing this? My people, remember, have you heard of something called derivation in mathematics? This formula is generated by derivation. There is no logic behind it. I hope you all understand. There is no logic that I can show you why we are dividing it with x minus x bar. When we create the mathematical derivation, it is created out of that. There is no logic behind this function. It's just that if you divide it by this, you get m. This is just the logic. This is created from derivation. So I will not be able to tell you the exact logic why this is divided. It comes from derivation of mathematics. There is this big derivation, this derivation which I can teach you, but it'll take us 1 hour and you don't need it. This derivation helps us create this function. Are you clear? So we don't need to worry about it. To ignore that. Okay. You don't need to worry about it. It comes. This is how the mathematics works. So we have to sort of take it by its value. Okay. There's no reason, no logic behind it. It just comes like that. You clear, everybody? Can I take you guys through the example fatafat quickly, and then we will jump into the best fit line part? Yeah. Okay. I had an axis called x-axis. I had a y-axis. In case I want to run linear regression, I have to do nothing. I have to take a column called x minus x bar, which is the distance from the actual data point and the mean of the x. Then I have to take y minus y bar, the distance from the data point and its y-axis or y mean. Then because x minus x bar is a negative value, cancel each other's out, you square them. X minus x bar the whole square. And then just to take the area of both the x and the y, you do x minus x bar, y minus y bar. You do x minus x bar, y minus y bar. This is enough for you to plot the first line that passes between the mean of x and the mean of y. This particular mathematics, what I've taught you, is the way to calculate that passes between the mean of x and y. Are you clear? It is not making a random line. No, 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 no. This line goes between x and y, but it makes sure where it touches in the y and what will be the slope. This math is for that. Are you clear? All I did is m is equal to the formula, y bar is equal to mx bar plus c. I was able to calculate y is equal to mx plus c properly. I got my line equation. Yes or no? Okay. एक बात बताओ. We had to calculate the sale of 6th day. Yes or no? We had to calculate the 6th day. Yes or no? So tell me one thing. How can I calculate or get a predictive answer for the 6th day? Can I say y is equal to 0.6 into my x is nothing but my 6, right? My x value is nothing but my 6 plus 2.2. So what is 0.6 into 6? What is 0.6 into 6, my people? 3.6 plus 2.2. What is 3.6 plus 2.2? What is 3.6 plus 2.2? 5.8, right? If I'm not wrong. Did you get an output for your 6th day, 6th week? How much sale you will make? Approximately 5.8 cars. Did that make sense to everybody? This is how you do predictions. For almost the 6th week, you will make a sale of 6 cars, almost 6 cars. Approx 6 cars, yes. Did you get it? In the x value of this equation, you just have to fill your target variable, sorry, your independent variable and your output will be dependent on this y and you will get your output. Are you clear how linear regression works? Can slope be negative? 100%. Slope can also be negative, boss. एक बात बताओ, ये जो आपका line है, like this graph, can it also not be like this? Possible है ना? Hold on. एक minute. Let me clarify some questions. My data is like this, yes or no? So I am fitting a line like this. This is called positive correlation. Isn't it possible that one target variable declines with other target variable? The rise in education decreases the rise in sales of guns or drugs. Yes or no? The more you are educated, the lesser the drugs you will use. Negative होता है ना line. दोनों possible है. This is called positive correlation. Actually correlation नहीं होता है. This is like, you can call it as a positive relation and a negative relation. Are you clear? दोनों हो सकते हैं. Both are possible. In linear regression, you can calculate for this also and for this also. एक बात बताओ. What if my data is like this? Area of the house, number of bedroom, hall and kitchen, and with this I want to predict the price of the house. एक बात बताओ. Now don't you have two independent variable x1 and x2 and you want to predict your y? Rather than having one x and one y, आपको दो x मिले हैं and you have one y. What will be your y is equal to mx plus c equation? क्या होगा? The equation will be like this. Y is equal to m1 x1 plus m2 x2 plus c. Are you clear? You need to calculate the slope and x1. You need to calculate the slope of x2. Are you clear, my people? The number of variables you have, that many m1 x1, m2 x2, m3 x3, m4 x4, m5 x5, m6 x6 goes on. C is only one. Did you understand the concept? The more variables you have, column A, column B, column C, column D. If there are 4 columns in your x-axis and your target is 1, m1 m1, m2 x2, m3 x3, m4 x4. 4 times m1 will repeat, x1, x2, x3, x4 will repeat. C will only be 1. Is the concept clear, my people? If this is clear, I'm happy. Remember, this is your interview questions, okay? ये सब पूछेंगे. You guys need to be aware. This is how feature space is mapped, okay? Okay. So tell me one thing. Did I calculate a way to have a line fit on the data? I just taught you mathematically how to fit a line to the data. Do you want to learn now the line that I just fit? Is that the best fit line or not? Do we need to learn that? Should I teach you mathematically? The line that you just fit. एक बात बताओ. I want to ask you guys in a common sense way. Whenever you make a first guess, don't you first gauge was your guess correct or not and then make another guess? So machine learning is no different. Let me give you guys a best example. एक बात बताओ. Imagine there is this big lake. Okay? In the middle of the lake, your friend is on a boat. Okay? Your friend is sitting on a boat. This is a big lake, huge lake. Your friend is on a boat. Okay? You are here. You're standing here. You want to throw stones at your friends. Okay, now listen to me. Disclaimer. I do not recommend you should throw stones at your friends. No way you should do this. Okay? I do not take any responsibilities for you throwing stones at your friends. I am just giving this as an example because usually my friends deserve it. My friends deserve it. I don't know about you, okay? But my friends absolutely deserve stones. But, okay, I do not promote violence. I'm just giving an example. Imagine your friend is here and you're throwing stone. Let's say you threw stone number 1 and it fell here. It went and it fell here. This was your first guess. Don't you think you got a knowledge that I need to throw a little to the left and a little to the lower bottom? When I threw the first stone at my friend, it did not hit my friend. I kind of got a feedback, right? That I need to do a little more far and little to the bottom. Let's say you did it again and it basically falls here. Won't it give an idea a little to the left, but a little to the top? And now suddenly you hit your friend in the third guess. Yes or no? Yes or no? In linear regression, when I fit the line, won't I move the line to the left a little, to the right a little to see is it in a best fit line or not? Is my line fitting the data perfectly or not, properly or not? Yes or no? So machine learning is no different. We will shift the line a little bit and see which is giving us the best output. Are you getting the logic, guys? We have just plotted the first line. Is that line the best line? We don't know. We will calculate now. People, in linear regression doesn't mean you have A, B, C and you have one target variable called Y. There can also be two target variable. ये भी होता है. Are you clear? You have more than two target variable also. But the point is, usually in real life, they don't exist like that. It does not exist like that. Like it does not exist like that. I'll give you an example. Let's say you want to calculate the price of the house and you want to calculate the buy this house score. Okay. There is the location of the house, the area of the house, the locality. Your X variable is what is the location of the house, the area of the house, what is the locality, the price of the house, and how much percentage I recommend for you to buy the house. I recommend you buy this house 73%. Your output should be of two type. Your variable is of two type. Tell me what will be the price. Also tell me how much percentage it's possible that I should buy this house right now. So don't you have two target variable, Y1 and Y2? I need to print the price of the house also, but I need to recommend you. I recommend this house 53%. Buy this house right now. Making sense? Did you guys get it? Under such conditions, you have to implement it in a different way. Look, you've just started linear regression. Don't go into it. It's a complicated topic. Not to be taken by you guys. Of course, you can also do it. That is called multiple linear regression. Okay. Multiple X's, multiple Y's, how to deal with it. We'll talk about that later. Abhi to aap log first standard mein ho yaar. You guys still need to clear first standard exams to go to fifth standard. Right? Don't worry. We'll go that. We'll reach that. Don't worry. Until here, are you clear? I am about to teach you a concept called R square. What? What does R square tell us? R square is a technique in linear regression that tells me the line that I have just plotted, how well does that line fit my actual data? How close is the line to my actual data? That is called R square. Are you clear? That technique is called R square. Are you, all my people, folks, are you clear with the logic of R square? How does it do? Don't worry, I will teach you. But are you clear until here? R square tells me that the line you just plotted, how close, how good it is. Now, what is exactly R square, sir? What is R square? Don't worry, let me tell you. What is R square? Very simple concept. Okay. It's also called GOF, goodness of it. But let me teach you how that works. Yeah, there it is. Okay, hold on. Let me copy this. Is this my data? Yes or no? Is this my graph? Yes or no? My people? Yeah. यार एक बात बताओ. I want to ask you all. Okay. My people, there is so much more math that I'm going to teach you right now. I don't want you to lose your head, okay? Because they're absolutely important. And point number two, I'm going to make the math very easier for you. So you don't have to worry about it, okay? But I just want you to give your focus. My people, R square is nothing. You remember we took the mean of X and mean of Y? In R square, you should only and only take the mean of Y, which is called Y bar. Are you clear? Are you clear? You are just supposed to take the Y bar. And we also got a line, right? A line equation we got now. What was that line equation that we got a while ago? Y is equal to 0.6 into X plus 2.2. Yes or no? So where is 2.2? 2.2 here. Okay. Let's say I have a line like this. Let me make it in blue. Okay. Got it? This is my line. 1, 2, 2, 1, 2, 2, 4. This is my line. So tell me one thing, my people. Listen to me very carefully. If I write something here, will it make sense to you? R square is nothing but comparison of comparison of two distance. Distance and distance. Distance of what? The actual value minus its mean. The actual value minus its mean. The estimated minus its mean. The estimated minus its mean. Let me explain it to you. Guys, this green line, are you all able to see it clearly? Is my color combination good? Are you able to see the green line called the Y bar? You are. The distance between the Y bar and this actual data point is nothing but the actual minus mean. Can you see? Are you able to see? The actual data point is this black data point. Yes or no? I am going to make a circle on them. All these circle and blacks are my actual data points. Yes or no? This is the actual data, the correct data. The distance between the mean value and this data point is nothing but the actual minus mean. Yes or no? Is this green line my estimated line? The one that I think it is correct? Yes. The green line, this I don't know what this color is the line that is my estimated line, right? I believe this is what the data should look like. The first comparison is actual mean minus the data. But the other comparison is estimated line and the distance between the data. Isn't it this much? This is the actual data of the line and this is the actual data point. This, I believe, according to line, should the data lie. I say that the actual data should lie here, but it is actually lying here. I am in this much error, right? This much is the difference between the line and the data point, and this much is the distance between the mean and the data point. Comparison of this both is R square. Did you understand the concept for me to take you in the math now? Did you get the concept? R square compares two things. Listen to me. You will never go wrong in your interview or in your professional career. Just listen to me for 1 minute. R square compares the distance between the mean and the actual data point by how far off I am. Then the line you just plotted in linear regression, from that line, how far is the actual data point? You compare them. That's your R square. Are you clear? Mean to actual data point, line to actual data point. Mean to actual data point, line to actual data point. Distance between your mean of y and the actual data point and the line, the linear regression line and the actual data point. The distance is what you compare. In R square, what data did we have in X and Y? I believe it was 1, 2, 3, 4, and 5. And what number did I take? 2, 4, 5, 4, 5. 2, 4, 5, 4, 5. Okay. 2, 4, 5, 4, 5. Okay. My people, what did I tell you? First, we calculate the distance of actual data point minus mean. Yes or no? We first calculate the actual data point and the mean. Okay. So tell me one thing. What is the mean of X and what is the mean of Y? Mean of X is 3. Mean of Y is 4. Yes? So actual data point minus its difference, like the actual data point minus its mean. So can I say that actual data point minus its mean, Y minus Y bar, could be 2 minus 4, 4 minus 4, 5 minus 4, 4 minus 4 and 5 minus 4? What is 2 minus 4? Minus 2. 4 minus 4, 0. 5 minus 4, 1. 4 minus 4, 0. 5 minus 4, 1. Yes or no? Because they cancel each other out and we don't want them to cancel each other out, what do? So 4, 0, 1, 0, 1. Yes or no? And the summation will be how much? 6. Is everybody clear until here? All I have done here is using this calculation, I have just calculated, Control Z, I have just calculated the distance between the mean and its actual data point, and I have squared the data. That's it. I've squared the distance. That's all I did. Point number 1. Everybody clear? What is the next step that I need to calculate? I need to calculate this distance. Yes or no? The distance between the actual data point and the predicted data point, right? This is my prediction and this is my actual, and this is the error. Correct? I have predicted that, but this is my actual data point and this is my error. Are you understanding, my people? Whatever is on the line is your actual prediction and this is the actual data. The distance is the error. Yes or no? Correct or not? Okay. So in order to calculate that, your equation, your line equation is equal to y is equal to mx plus c, correct? If you place m value, x value, c value, you'll be getting the prediction value. In machine learning, whatever you predict is called as y hat. Are you clear? It's called as a y hat. Y hat equals to 0.6 into x plus 2.2. This is the equation, yes or no? Let's calculate y hat. Let's calculate y hat. How do we calculate y hat? 0.6 into, what is the value of x? What is the value of x? 1 plus 2.2. What is the answer? 2.8. 0.6 into 2 plus 2.2. What is the answer? 3.4. 0.6 into 3 plus 2.2. I believe this will be 3.5, 6, 7, 8. I think this should be 4, right? Because it's taking 6 points as a increment. 6 points are being incremented. So 0.6 into 4 plus 2.2 is equal to 4.6, if I'm not wrong. If it should match, and 5.2, right? It goes on. 2.2 is equal to 5.2. So tell me one thing, my people. Have I calculated the actual predicted value? Using y hat, I have just calculated the predicted value. Now I will calculate the distance of the difference between, I told you, right? R square is the distance of actual minus mean, which is this value, y minus y bar, right? Actual minus mean. We did squaring so that the numbers don't cancel each other. Now we will do estimated minus mean. So will I do y hat minus y bar? Okay. Let me explain. Let me quickly explain. Guys, एक बात बताओ. I want to ask you guys. Aren't we calculating the mean and the actual data point? Yes or no? Did everybody understand? Did you understand that I'm actually calculating the mean, the distance between mean and the actual data point? Yes or no? Okay. This part, we are calculating this. We are calculating this. But in order to calculate this, don't I need to calculate the distance between mean and the predicted data point first? I can't directly calculate this, right? Don't you think I need to calculate this distance and this minus this could give me the overall distance? Are you understanding why this is predicted minus mean? I am taking this predicted value, the predicted value, which is this, minus this. Okay. Predicted value minus the mean will give me this distance. I can calculate this later. Okay. So don't get confused. Okay. Yeah, estimated minus mean. So tell me one thing. What is y hat? 2.8 minus what is y bar? 4. 2.8 minus, what is y bar? Sorry, 3.4 minus 4. 3.4 minus 4, 4 minus 4, 4.6 minus 4, and 5.2 minus 4. Is everybody clear how I got this estimated minus mean? I'm not calculating directly. I have to calculate mean and the actual predicted value. This will be minus 1.2. 3.4 and 4 will be 0.6, right? Negative 0.6. This will be 0. 4.6 will be 0.6. You guys are understanding what's happening here, right? Yeah. Because the numbers will cancel each other out, won't I do y hat minus y bar the whole square? So what? 1.2 is 1.44, 0.36, right? This would be 0. This would be 0.36 and 1.44. Are you clear, my people? What's happening here? First, I calculated the mean minus its, we calculated actual minus mean. Then I calculated estimated minus mean. I'm getting these numbers. Are you clear with all these numbers? The formula for R square, the formula that you're going to use is summation of y hat minus y bar the whole square divided by summation of y minus y bar the whole square. Do we have both the answers? We do. I'll tell you how. What is y minus y bar the whole square? Like y minus y bar the whole square. If you take the summation, what would be the summation for this? It would be 6. It will come in the bottom. What is y hat minus y bar the whole square? If you add this together, how much do you get? You will get somewhere around 2 and 3.6. Is it correct? 3.6 divided by 6. So 6 is 36, so 0.6, right? So because point has to go there, 0.6. This is the formula. You have to follow this. The R square value, the more it is closer to 1, the better the fit. Are you clear? The closer the R square is to 1, the better the fit. The lesser the R square is to 1, the terrible is the fit. So can't I change my line little left, little right, and then this was the best output I got for line number 1? The line that we passed from the middle, this is the output for that. Did you guys get the logic? What I did here, I have taught you R square. In R square, we just calculated how best fit is the line. Can I tell you one small logic and you guys will love the idea behind it? Can we do it? Can I teach you some concept with which the idea will become clear? You will not be confused anymore. Okay. एक बात बताओ. Logically telling you, I'm asking you this logically. Whenever you have a linear regression problem, rather than going through the nonsense of calculating mean of x, mean of y, everything is from mean, rather than that, bhaiya, this is my best fit line, okay? And this is the actual data. Hold on. Give me 1 second. Rather than going through the nonsense of calculating it again and again and again, can I not directly calculate the error that this is my actual value, this is my actual value, and this is my linear regression line? This is saying this line, this x cross is my prediction. Yes or no? This x bar is my prediction. Yes or no? And this dot is my actual value. Yes or no? Can I not directly take the difference and that will tell me the error? Can I not do this? Can I not do this? Guys, can I not do this? Listen to me very carefully. Can I not do this? I calculate the error 1, error 2, error 3, error 4, error 5, error 6, error 7, error 8, and all the error 1 plus error 2, all error 8 I can add together and I will get some number. Make sense? But there is a small problem. You know what is the problem? The problem is this number will cancel this number out. Yes or no? If this is +4 and this is -6, 4 and -6 cancels each other out, right? -2 will be the output. So rather than just adding them together, can I do one thing smarter? Can I take all my errors, square them, and then add them? So they will not cancel each other out. And I will get a mathematical number called 23.66. 23.66. And if I change this line slightly to the left, it will be 12.14. So tell me one thing. Did I not reduce my error, square error? Initially, my line was giving me 23.66 as the error. I changed my line. It became 12.14. That is the best fit line. Okay. Let me teach it to you like this. Everybody. This dotted line, you know what? पूरा ही इतना expand कर देंगे, चेहरे पे दिखना चाहिए ये. Hold on. This dotted line that you see, what is this line? Did I predict the line? I created this line, or this line was given to me? I calculated, correct? I calculated using a function called y is equal to mx plus c. Yes or no? Okay. When you have a linear regression data, you have a line that fits the data. Agree, disagree? Correct? Hai? This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this could be 1, this is 2, this is 3, this is 4. एक बात बताओ, you want to calculate on 5th month how much will be the sale, yes or no? If I plot this line straight to the line, isn't it giving me the value of y to the left? This is why we do linear regression, my people. Yes or no? All my non-tech people, please don't get confused. The reason why we do linear regression is we want a line with a proper slope and a proper y-intercept so that whatever value of x I have, I plot this value on the line and this line's y value will be my output. Yes or no? अब एक बात बताओ, अगर ये लाइन थोड़ी ऐसी होती, if this line would have been like this, for the green line, isn't my prediction this much? Isn't this my prediction for green line? And this is my prediction for red line. So did you understand one thing, that the change, the slope of line changes the prediction itself? Yes or no? The line slope actually gives the y value, the one that we want to predict here. It changes the whole thing. So tell me one thing, my people, I am asking you people, suppose I have a data. अब मेरी बात बहुत ध्यान से सुनना. Listen to me very carefully. Suppose I have a data like this. 1, 2, 3, 4, 5. There is a line called this, and there is a line called this. Between red line and green line, which line appears to be in the middle of all the data? Red line appears to be in the middle of all the black points. Yes or no? People, tell me this. This part here, isn't that the prediction and this is the actual value? Let me explain it to you. This black dot is my actual value. But when the predictions happen, isn't the red value that will be predicted? Because all the red values are the prediction values. Yes or no? Because the line is in the middle of the data, the distance between the actual and the predicted is the smallest. But if you consider the green line, the distance between the actual and the whole predicted is higher, bigger. So the far you are from the data, that line is the worst performer. Yes or no? So based on that logic, won't you calculate the distance between the actual data point? This green is the actual data point and the red one is the prediction that I'm making. This is the distance. We can call it error. Error matlab from actual, I am 5 centimeters making bad predictions or wrong predictions. Each point. This is also called error 2, error 1, error number 4, error number 5, error number 6, error number 7 and error number 8. Are you understanding? When the data, the line fits the data properly, the error will be smaller. If it is bad, the error will be higher. We always choose a line with the lowest error possible. Makes sense? We will always choose a line that has the lowest error. That means the distance between actual and predicted is the lowest among all. We have a data, it is scattered all over. We just want to put a line that fits all the data properly so that we can predict the future values with some error. But at least we will get some approximate number. Are you clear? Okay. Can I tell you something and you guys will take me by my word? The distance between actual data point and the predicted data point. So this is your predicted data point. This is your actual data point. The distance or the error is also called residuals. Are you clear? The technical name for this error is called residuals. Did you understand the technical terms for it? They are called residuals. Do you see this, my people? Hold on. Yeah. Do you see? Hold on. Hold on. Look at this. Look at this. Can you see? The ball is dropping. Okay, hold on. I'll just show it to you. Hold on. Give me 1 second. Okay. Do you see that the time you reach at the middle of the loss, it's getting better and better, and the line is more approaching the best fit? Initially, it was a bad guess, then better guess, then better guess, then much better guess, then much better guess. And by the time you come to the bottom, it's the best guess. Can you see the line shift from terrible to better to much better to much better? And you actually go in the middle of the data. Can you see? This is called gradient descent. It's called stochastic gradient descent. There's mini batch, vanilla, and all of that. I'll talk to you about that. Not now. I don't want to confuse you guys a little bit more. But the logic or the way you actually reach the best fit line is a technique called gradient descent. We'll talk about that. Not a problem. But did you guys get the logic? Like, how do we do it? How do we reach the best fit line? You use gradient descent algorithm. I'll tell you what that is later. Is everybody clear with the answer? You guys got the logic of what I wanted to teach you? Okay. Can linear regression be applied on all data? No, right? Can I tell you certain assumptions of linear regression? If you want to apply linear regression, you have to go through these rules. If the rules are not matched, you cannot run linear regression. Can I please teach you the logic behind it? And also, can I tell you one thing, that this assumptions of linear regression is a 5-star question. In your interview, this is guaranteed to be asked. I am not joking. This will be asked in your interview. It's a guarantee. Because I have taken interviews in my life. Every interview I ask this question. Can I do that? Can I teach you some topics with which, if the assumptions don't match, linear regression won't work? For linear regression to work, you need linearity. What do you mean by linearity, my people? Can I explain, please? In linear regression, the data was like this, right? Or the data is like this. This data can be fit very well with a linear line. Yes or no? The data very well fits the line. What if you have a data like this? Is it possible for me to fit this entire data in a line? So tell me one thing, X with respect to Y, is there a linearity in my data? Linearity does not exist. Hence, linear regression cannot be applied. Okay. Are you clear with the definition of linearity? That in order to run linear regression, linearity should exist. If there is no linearity, no linear regression. Independence of variables. एक बात बताओ, I am asking you, area of the house, price of the house, and how many BHK the house is. among all three variable, which two columns are same only? Almost same idea they are giving. Isn't the area of the house and BHK? अगर 3 BHK तो बड़ा एरिया ही होगा. Making sense or not? अगर हम लीनियर रिग्रेशन में ये दोनों वेरिएबल डालेंगे, इन लीनियर रिग्रेशन व्हेन वी पुट ऑल दीज वेरिएबल्स, there's going to be a problem, right? Yes or no? They are correlated with each other, right? या तो BHK डालो या तो एरिया डालो, दोनों मत डालो, right? Either one you put, right? Don't put two. They are having the same. Aren't they correlated with each other? Okay. Coming back to my topic. Your X variable, your column A, column B, column C with your target variable Y. A, B, and C need to be independent of each other. Column A should not have any relationship with column B. Column B should have no relationship with column C. They all need to be independent. There cannot be a correlation among themselves. Are you clear? If column A and column B are correlated with each other, drop any one. But they need to be independent of each other. Are you clear? Imagine you are taking somebody's age, somebody's salary, and somebody's cost of living, okay, and you want to predict how possible is this person going to purchase a 3 BHK house, okay? This is sort of like a classification problem, but I'm just giving you an idea. यार एक बात बताओ, जिसकी सैलरी हाई है उसका कॉस्ट ऑफ लिविंग भी हाई होगा ना? नहीं, कॉस्ट ऑफ लिविंग डायरेक्टली टेल्स यू दैट पर्सन हैज मनी, राइट? सैलरी हो, बिजनेस हो, डज नॉट मैटर. कॉस्ट, अभी पैसे ही नहीं है तो घर कहां से लेगा? सो ये दोनों कॉलम एक दूसरे से रिलेट नहीं कर रहे, एक ही आइडिया नहीं दे रहे पैसों के बारे में. Aren't they giving the same idea about the money, cost of living and salaries, directly pointing towards one fact, richness, money? Aren't salary and cost of living highly correlated with each other? Higher the salary, higher the cost of living, lower the salary, lower the cost of living. So any one could be used, right? For the prediction, either use salary, either use cost of living. Does that make sense? You guys got the concept? Column A, column B, column C, whatever columns you're giving in the independent variables, they need to be independent. They can't be together. They can't be presenting the same idea. Money, growth, age, salary, they can't be presenting the same thing. नहीं लेना चाहिए उसको. Are you clear? चलो ऐसा समझ लो, मुंबई में the cost of living and salary needs to be high to survive. गांव में, village में, lower salary also is okay with cost of living. But tell me one thing, in village, can you not construct a house, a big mansion within 50 lakh rupees? But try doing it in Bangalore. In your village, your land is cheap, right? Your food is cheap. Your cost of living is cheap, right? Try making a mansion in Bangalore or Mumbai. Are you understand? The point is, these variables, it does not matter which part of the world you are in. They tell you the same idea about the money, hence you should not be used. They represent the same. Okay, let me give you another. Can I give you one more example? Okay. Let's say your CIBIL score. Do you all know what is CIBIL score? The Indian government has a score called CIBIL score. If your score is higher, it is between 300 to 900. If your score is higher, people will give you loan on the lower rate of interest. Okay. Imagine you have a CIBIL score. You have somebody's salary and you have somebody's loan. टेक्निकली इसको क्या बोलते हैं, लोन एपेटाइट बोलते हैं इसको, कुछ रिस्क एपेटाइट बोलते हैं इसको, बट या लोन एपेटाइट. एंड हाउ मच लोन कुड बी डिस्पर्स्ड टू दिस पर्सन. अब एक बात बताइए, जिसकी सैलरी ज्यादा होगी उसका एपेटाइट भी तो ज्यादा होगा ना लोन लेने का? नहीं. Aren't these two variable telling you the same idea? If somebody's risk appetite is higher, he has the money. If salary is higher only, then is he able to afford his appetite, right, for risk? If your salary per month is 15,000, can somebody give you a 1 crore loan? Does this make sense? But if your salary is 1.2 crore per month, will you get a 1 crore loan? Easily, right? Are you understanding what I presented, what I meant by independence? Did you now get it, my people? I hope the idea is clear. Normality of residuals. Whenever you plot linear regression and you have residuals, whenever you take the residuals and plot them, they should always follow normal distribution. Are you clear? The residuals that you have, can you see this? This is a residual. These are all residuals, right? The errors. Whenever you plot these residuals, what distribution should they follow? Normal distribution. If they don't follow normal distribution, you cannot run linear regression. Are you clear? Point number 4. This is one of the highest asked question. Homoscedasticity. Now you must be like, what is this? Homoscedasticity or heteroscedasticity, okay? You can take any of this. Can I assume you guys will go through it yourself? Residuals is only possible after I plot the linear regression. How can I predict before that? Isn't this a very sweet and an innocent question? See, I am telling you the assumptions of linear regression. If they don't match, you can't run linear regression. But now you're telling me, sir, to create normality of residuals, first I need to have a best fit line, right? Point number 2, you don't need to run linear regression with 100 different lines. The first line you create in linear regression, even that will tell you at least normality of residuals. Are you clear? Did that make sense? You okay? एक बात बताओ. Logically telling you, most time if you plot the x comma y and the data itself is not proper, will you even go forward with the linear regression? So most 99% of the time only you will get here in the linearity part ही समझ में आ जाएगा. It's not possible to run linear regression. And if it is linearly following, linear regression will work. And all these points will match. Are you clear? I said you don't have to worry to that stage also. It's just that this is an interview question and I'm teaching you this. It's important question. There is one more thing called homoscedasticity. Let me tell you what that is. You must be very confused with this word called homoscedasticity. Give me 1 second. Yeah. Do you see that the data spread is like a conic distribution? This is residual and this is the fitted value. They are not evenly scattered, but they are cone-wise scattered. If you have a conic representation, the scattering is conic in nature, you can't run linear regression. Are you clear? Can you see? Homoscedasticity, heteroscedasticity. Hold on. See, you want homoscedasticity, you don't want heteroscedasticity. Did I teach you this thing called linearity in point number 1? Yes or no? Linearity tell you the spread of the data. Yes or no? Is homoscedasticity telling you the spread of the data? No. Don't get confused. Hold on. Give me 1 second. Give me 1 second. Give me 1 second. I'll tell you what I mean. 1 minute दीजिए मुझे. I'll show you a graph. Everything will make sense. Can you see this graph in front of you? In front of you? On the x-axis are residual errors. On the y-axis is the errors of the residuals. And on the y-axis is the spread of the residuals. Not the data. Are you clear? Have you ever done a scatter plot? Have you ever done a scatter plot? When you calculate positive residuals and negative residuals, on the top section are all the positive residuals. On the bottom section are all the negative residuals. When you plot them according to their error, you will get this kind of distribution even when the error of residuals become conic. That's heteroscedasticity. You can't run linear regression then also. But if they are even, then you can run. Are you clear? Homoscedasticity is the plot of residual scatters, not the data spread. Did that make sense, my people? It is residuals on the y-axis, positive and negative, and the scatters of that. You can also call this as variance of errors. The variance should be equal, right? The spread of variance in the positive direction and negative direction should be equal, right? If the variance is increasing, can you run linear regression on it? No, right? So you can think of it like this. The variance in the data is uniform. The variance in the data is not uniform. Hence, linear regression cannot be applied. Are you clear? What is homoscedasticity, heteroscedasticity? Homoscedasticity you want. Yes. You don't want heteroscedasticity. You want homoscedasticity, no heteroscedasticity. Are you clear? Okay.
Just a quick info guys, Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI and Power BI. Get a data science certification from IIT Empower, an innovation hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.
We are linear regression and logistic regression. Of course, we will be completing linear regression hands-on, and I'm also going to take you through a couple of other stuff, linear regression, logistic regression, couple of other stuff that we can actually proceed forward with. But I have complete different things in my mind. Let me explain what that is, right? And we can complete on this. Anyways, the point being, the main reason what I want to discuss with you guys is we went through an important topic of linear regression mathematically. We went through a topic in linear regression, and mathematically, you actually implemented a technique. And guys, you should remember this by name. You implemented something called ordinary least squares method. You implemented a method called ordinary least squares method. In this method, you have y is equal to mx plus c equation. What you did is you calculated the m and the c for the given line, for the given data, y is equal to mx plus c, right? What you also did later on is you implemented another method called r square, okay? And you identified via r square a number, say some number called 0.6. Is this number closer to 1 or is this number closer to 0? Based on this feedback, you are able to say whether my goodness of fit was good or not, whether the line equation is good or not. Basically, you basically learned these techniques or these methods, and it gave you a good idea. But you know what? To be frank, just to let you guys know, and I'm being very truthful and very honest with you. If you expect me to complete, or if you think linear regression can be completed in a day, it's not possible, right? Linear regression is much more complicated. I'll even give you an idea. I'll even give you one more idea. What did I tell you in the last class when I was teaching you assumptions of linear regression? That there has to be point number one, linearity. Do you remember? Do you remember a concept called linearity? Okay. What if I tell you there is a kind of linear regression when the data is not linear? Suppose if the data follows this pattern, you can still fit, instead of a line, a curve. Would you believe me? Rather than fitting a line, you are fitting a curve. It's called non-linear regression or polynomial regression. In fact, there is also a kind of regression in machine learning where if your data follows like an S curve, for example, it follows something like this. Okay. Now, this is not predominantly like S, but your data is kind of spread like this. You can even fit a line like this. And this exists. Yes, this kind of regression also exists. There are different rules for this kind of regression, but a linear regression and a non-linear regression also exist. Hence, regression is vast. Okay, regression is incredibly huge. For you to get an idea on regression, all you need to do is you need to get your fundamentals very, very clear. You need to make sure that your basics are absolutely clear. Once your basics are clear, everything is sorted. Hence, just taking you guys through the concept what we did yesterday is clear until here. Specifically did a method called ordinary least squares. Nothing complicated. It's not a very complicated thing. It's a very simple, elegant solution which we covered. Here is my plan, my idea for you guys. Hear me out. We did linear regression, we did theory, and we did couple of conversational aspects in linear regression. Let me do one thing. Let me also cover logistic regression today, theory. The reason is both linear regression and logistic regression, the only complicated part in both linear regression and logistic regression is its theory. Its practical is super easy. And do you remember yesterday I told you that linear regression does not need a library. You can code the solution from scratch. Do you remember? We discussed this yesterday. You don't need a very complicated library for linear regression. Whatever we did yesterday, whatever mathematics we followed yesterday, you can implement the same mathematical aspect and you can actually get the output exactly the way an sklearn package output would be. Everything would be sorted. But it's the theory that makes a lot of sense, right? Let's do this. Linear regression is done. A small portion, maybe 12% of linear regression is remaining. Let me complete that. Let me jump into logistic regression, complete that. We will complete linear regression and logistic regression hands on. And let me ask you all a question. I will give you two scenarios. Scenario number 1 and scenario number 2. You tell me in practical career as a data scientist, which scenario makes more sense? Let me ask you this question. Imagine you are going through a problem. Suppose your company says, here is my data. I want you to run machine learning and give us some output. Suppose there is a column called A, B, and C, and you need to predict D. Okay, so your A, B, and C is your independent variable, and D is your target variable, which is a dependent variable. Okay, this is the data that is given to you by your company. Now, scenario number 1. Do you implement algorithm number 1? Algorithm number 1's accuracy is not good. Then what you do is you implement algorithm number 2. Its accuracy is not good. You implement algorithm number 3. This accuracy is good. And then you go to your manager and say that I guess algorithm 3 works well for my data. This is scenario number 1. Scenario number 2 is you take the data, you run all possible algorithms and then decide top performing 3 or 2 algorithms. Which scenario do you think actually works in the industry? Scenario number one works in the industry or 2? Okay. In practical aspect of data science, no matter what company you work for, no matter which industry you're working for, scenario number 2 holds true, not the scenario number 1. Let me explain why. And let me come back to my topic, why. See, remember one thing, guys. Whenever you are given a data, you will have to do data processing and all that nonsense you have to take care of at school. But are you going to be foolish enough to take this data and run algorithm one by one sequentially? Do you think you have that much time when you work for a company? Don't you think you have deadlines? Sometimes the manager wants the output by evening. Am I making sense? Have you worked in a company in your life where the manager has a very strict deadlines? We all have worked in a company like that. Manager is not ready to listen. You have to deliver your project. You tell me this. Won't you take a data, run all possible algorithms, and then choose, say that algorithm number 1, algorithm number 2, and algorithm number 3, they all are performing the best, and then relevantly choose anyone and deploy that algorithm. That's how the industry works. That's how your work is going to be. Now tell me one thing. We have done linear regression. We have done logistic regression. But what would be the main difference between them? Okay. Linear regression and logistic regression. One of the main differences is logistic regression is a classification problem. Yes or no? What linear regression can do, logistic regression cannot do that, right? A logistic regression algorithm cannot predict a number called 10.956. A logistic regression, right, classification algorithm can only classify into A, B, or C. It cannot predict a number, right? And vice versa. They cannot work without their specific kind of data. Does that make sense? Okay. So here is the agenda for all of you. Listen to me very carefully. I want all of you to have a look. The agenda is learn the theory first, because I have been thinking you complete the theory, you have a lot of time, and what we will do is we will implement these algorithms on two different kinds of data and learn exactly how they function. Are you clear? Is everybody clear? Foundations are very, very important in machine learning. Let me tell you one thing very clearly. This is one of the most underrated advices anybody have told you or I have learned after a long time in my life. That advice is your basics make you a good data scientist, not where you've done your degree from. Your basics, your foundations is everything in the field of data science. If your foundations are not strong, you can learn that algorithm 100 times, you will forget that algorithm 100 times. I can guarantee you. Maybe after 2 years, you may have to reread what is linear regression once again. I guarantee you this. But if you've not understood the foundations, the reason behind that modeling, the reason behind that logic of implementation, nothing cannot be done. You will be back to square one again. Let's not make that mistake. Did you guys understand in ordinary least square, why did we calculate M? Why did we calculate C? You got the intent of why did we do that? Okay, once we did M and C, you also got an intent of R square, right? R square is a measure whether how good my algorithm works or not. We kind of got a gist on that. Agree, disagree? Okay, good. Can I help you understand one more thing in linear regression and we are done with linear regression? Can I do that? Okay. Help me understand one thing. I am asking you guys this question logically. I am asking you this question logically. Imagine there is a data where you have a column called column A, column B, column C, column D, column E, and you want to predict column F. Versus you have another data, column A, column B, column C, you have to predict column D. Now tell me one thing. Does linear regression become a little problematic when the columns increase or not? Try answering this logically. When the number of columns increases, जैसे column A, column B, column C, column D, column E, these column A, column B, column C, column D, column E, they are all extra data. That means your feature space. Okay, listen to me very carefully. I'm about to make a lot of sense. And this is a very important topic. I'm teaching you something called adjusted R square. Listen to me very carefully. Imagine, guys, you have two columns, column A, column B, or you have one column, column A, and you need to predict column B. So one independent variable, one dependent variable. Does it not become a two-dimensional data? Column A here and column B here. It's two-dimensional in nature. Now listen to me, listen to me. If you have column A and column B as an independent variable, you need to predict C. Did it just not become a three-dimensional column? A three-dimensional problem? Column A, column B, and column C. So that must mean more the columns I add, higher the feature space becomes. Dimension. This is 2 dimension. This is 3 dimension. And the more columns I add, higher the dimensional space becomes. This is called feature space. Remember this. If you want to become a Gen AI engineer, Chat GPT engineer, prompt engineer, you need to know what is feature space. Listen to me very carefully. So that must means more the column, higher is my dimension. Is this a true statement or not? In natural language processing, vector spaces are like feature spaces, but they are embedding layers. So they are basically like you push it down, narrow it down with a smaller embedding size. But yes, feature space and vector space to an extent can be called the same. Transformers embeddings are higher dimensional feature spaces. So it's the same thing. Again, my question to all of you is, higher the dimensions, higher is the feature space. Agree or disagree? Do you all agree? Do you know what is the problem that happens in linear regression? Do you know what problem happens in linear regression? The problem is the more columns you add, the more bias my algorithm becomes. Let me explain this concept of biasness in just 1 second. My algorithm stops performing that well. There is a reason behind it. We'll come to that topic. Don't worry. Did you get the context? The idea? Why? We'll talk later. But you got the idea? Imagine you have just learned how to ride a car. I am telling you, don't press clutch too much. You don't know why, but I'm telling you, if you press clutch too much, there's going to be a problem. We are in that situation. Did you understand? Is everybody here? I am saying, while implementing linear regression, more the columns, there's a bigger problem. There's a challenge. I'll tell you why in about a second. But did you understand why there is a, did you understand that there is a challenge? Okay. Let me show you something. Give me 1 second. Copy image and paste. Give me 1 second. 1 second. 1 second. Yeah, I can take this. Okay. Is this visible to everybody? Yeah. Is this hopefully it should be visible to all of you. See, my people, whenever you do linear regression, you calculate the formula of R square using this. R square equals to 1 minus sum of square residuals divided by sum of square total. Now, do you remember yesterday I brought in a concept called sum of residuals? Do you remember we learned a concept called residuals? Whenever you have a linear regression problem, this is the actual data and this is the line. The line is here. This difference is called residual. Do you remember? I called this error as a residual. Sum of square residual means take all the errors, square them and add them together. That's called sum of squared residuals. Did you learn this? Sum of squared residuals, okay? It's also called as sum of square errors. What they are? What are they? Very simple. Just listen to me very carefully. Whenever you calculated sum of squared residuals, did you not take the difference between the errors? You've taken up all the errors, you added up all the errors together. Because they are scared, they don't cancel each other out and they get added together. Okay. Do you see this thing called sum of squared total? Okay, I'm going to write something down. Tell me if it makes sense to you or not. Okay, I just want you to tell me if this makes sense to you. Sum of square residuals can be written as sum of each individual y subtracted with, or let me write it like this. Sum of square total, sum of square residual. Try to understand what this formula says. If I say summation of each individual data point minus its mean, the whole square, versus the predicted data minus individual data, the whole square. Does this make sense? So tell me one thing. I have a question I want to ask you. This is the formula for R square and this is the formula for adjusted R square. Can somebody tell me why did we need to adjust it? Why do we need to adjust R square? Why do we need to change the R square? Why should this R square formula be changed? Reason is, listen to me carefully. R square, listen to me very carefully. N is the total sample size. So this N is the data size. How long or how big is my data? Number of independent variables. Aren't you dividing the whole R square by something called P? You're dividing something by P. Whenever you divide something from numerator with denominator, won't the number become lesser? Okay. Listen to me carefully. Listen to me carefully. I have a number called numerator. I have a number called denominator. I have a number called 4. I have a number called 2. What is 2 divided by 4? Can somebody tell me what is 2 divided by 4? 2. What is 4 divided by 3? 1.83. 1.33. Now tell me one thing. When I divided 4 by 2, the number was 2. When I increased the denominator, did my result not become smaller? Okay. Now listen to me very carefully. Okay. Because the numbers of columns are higher, don't we want the model to be not very confident and just come down, reduce your excitement a little bit? Don't we want the model to just like calm down a little bit? Don't get too bigger in number. We want that number to go smaller and lesser and lesser. We don't want it to be exploded with the values. In order to do that, when the column size is bigger, this value of P penalizes means it reduces the output of R square in such a way that it becomes between 0 and 1. The value of output of R square is between 0 and 1 Because what if you have a 30 column data and if you solve it using R square, you know what? Your output will be bigger than 1. But always we want the data to be between 0 and 1. If you're closer to 1, good. Closer to 0, bad. Because the number of columns are increasing, we add this penalizing term called number of variables also, so that it reduces and is always between 0 and 1. Are you clear? Why this is important? So listen to me very carefully. If somebody asks you from now onwards, sir, why do you need to do something called adjusted R square? Your answer should be something like this. Due to higher feature space or higher dimensional space of the problem or the data, we need to reduce the model's output to a deliberate number between 0 and 1. And because R square says higher you are, the better confident you are in the fit, we want the number to be deliberate fit between 0 and 1. Hence, we penalize the R square with something called n minus p minus 1. We consider how many is the total data size. We subtract it with the total independent variables and we subtract it with 1. Hence, that penalizing term lets the data between 0 and 1, and hence R square, adjusted R square is a necessity. How did you... Okay, let me ask you a question like this. Has any one of you... Okay, I don't know, in your, not the class with me, but your class with your, I don't know, other professor in linear regression, did you ever get a chance to implement a linear regression model? Like a little, 1%, 2%? Did you get a practical chance of implementing a linear regression model? You did that. Okay. Did you measure something called RMSE? It's called root mean square error. Okay. Can I tell you an important part about this? And we are done with linear regression. Can I tell you one thing very, very, very important? Tell me one thing. Have you ever heard of something called loss function in machine learning? Ever encountered a term called loss function? If you've done it, good. If you've not done it, I'm about to teach you something super critical, super important. Have you ever encountered a function called loss function? Okay, let me tell you something. एक बात बताओ, थोड़ा listen to me a little carefully. I had a linear regression problem. There was a data. I fit a line. My mean square error was 31.246. I was like, okay, good. I shifted the line a little bit. My line shifted a little bit. My mean square error became 20.694. No problem. You shifted the line a little bit more. My mean square error became 15.114. Very good. I shifted the line a little bit more. My mean square error became 9.114. I shifted the line a little bit. My mean square error became 10.1161. I made one more shift. My mean square error became 21.619. Now, listen to me very carefully. This is a super important point. Each time you change something in linear regression, what do you want to reduce? You want to reduce this mean square error, yes or no? You want to reduce the error. This error is called mean square error. Now listen to me very carefully, okay? Mean square error. जरा ध्यान से सुनना मुझे. You guys will fall in love with this beautiful thing. Okay? हाँ. Is this visible to you? Okay. You ran the algorithm how many times? Iteration number 1, iteration number 2, iteration number 3, iteration number 4, iteration number 5, iteration number 6. The algorithm ran to make itself better 6 times. This is called as an iteration or epoch. In technical terms, I'm telling you in terms of technicality. These are called epochs. Epochs are basically in neural networks, front and back, forward and backward pass. Let's not worry about it. These are also called epochs or iterations. You can actually call them iterations. No problem. You had to run the algorithm 6 times. But tell me one thing. You had one thing which became your foundation, right? Your mean square error, which reduced, and you will pick up only the fourth one line. Fourth one will be the best fit line because it was the lowest. Yes or no? Listen to me very carefully. Every algorithm in this universe, every algorithm of machine learning, deep learning, natural language processing has a loss function. In this case, in our example, the loss function is mean square error that you want to reduce. Your aim of the algorithm is to reduce it such that the output is the best. Did you now understand the concept of loss function? Loss function is a function who you want to reduce, the one that you want to reduce in number so that the output is the best. I just taught you something called loss function. Do you know that there is also something called cost function? Please read up on the concept of what is loss function, what is cost function. You guys will be shocked to know the difference between loss function and cost function. And can I tell you something? Any algorithm in machine learning that you want to implement, you cannot implement it either without loss function or cost function. ऐसे हवा में linear regression के बारे में बात करने से you will not be able to learn. You need to talk every algorithm with respect to loss function and cost function. From now onwards, change your mentality a little bit. Don't think how the algorithm works. That's not the main point. From now on, whenever somebody tells you linear regression, suddenly it should hit your head that root mean square error, mean absolute error, mean absolute percentage error. There are so many different types of loss functions available in linear regression. Are you clear? You should think it from the loss functions perspective. Okay. So far in linear regression, the approach, the logic, and what we've learned so far, from ordinary least square method to implementing R square, to understanding the assumptions of linear regression, to understanding how sum of square residuals work, to implementing how exactly adjusted R square works. Do you have any questions so far from complete understanding of logistic regression? Okay. How many times should we be shifted? Mean square error. How many times should we shift? Are you asking how many iterations are you supposed to do? Okay, tell me this. Does anybody know how many times we have to actually run linear regression to get the relevant output? Do you know how to do that? Yes. So did you observe something? The error was the highest. It became lowest, lowest. It became lowest. And suddenly it started increasing again. And it is not becoming lesser until that. It's called global minima in gradient descent. So for your clarity, you have to make sure that your loss constantly decreases. If your loss decreases and then suddenly starts to increase, that's a problem. Yes, mathematically speaking, it depends on the size of the data, number of columns you have, but this is the general idea of what you have to follow. Do you remember yesterday I told you there is a topic called gradient descent, a concept called gradient descent? You remember I very broadly gave you a concept of idea called stochastic gradient descent. It's called SGD. That decides with a parabolic function using a tan function, which is basically a tangent. It tells you that your global minima is the most effective algorithm. Let's not go there. It decides somehow that this loss function has to be at this peak and then your output comes. So there is much more complicated stuff in machine learning. We'll talk about that later. Okay, no problem. All right, guys. So I want to actually take you guys through a concept called logistic regression. Now, before I jump into logistic regression, my questions can be more of a brain fry, but I promise you, if I fry your brain now, you will thank me later. Can I do that? Since you've already learned linear regression and logistic regression, let me ask you some questions if you think you really know logistic regression, and I will break that perspective that you don't know. It's much more than what you looks like or what it seems. Tell me one thing. Have you ever encountered a problem where I wanted to classify a problem? For example, you give me the input data and I will classify whether this item is belonging to category A or category B. Isn't this what we call classification? Okay. Have you ever heard of something called multi-label classification and multi-class classification? Do you know that classification also is of two different types? One classification is called multi-label classification and the other is called multi-class classification. Okay, ready for something weird in machine learning? Listen to me very carefully. Imagine you have a category, okay? Things like love, hate, don't know. You tell me the name of the movie and I will predict whether people love the movie, hate the movie, or don't know the movie. So tell me one thing. How many categories do I have of classification? 3, right? Number 1, number 2, number 3. These are called categories, right? So-called buckets. Yes or no? What if my problem statement is under love, also there are 2 categories. Really love it? Okay, okay, love it. Did I make the problem statement more complicated? First, you predicted whether you love it. Under love, Do you really love it or not that much love it? In real life scenarios, have you not seen that this is more predominant? First, tell me with this idea. When you have a classification problem called you love some movie, under love, is it not possible that you can really have another category between them? But in logistic regression, you only know it is a classification problem. That is very good in theory. What in practical life, if you want to implement something like this, will you be able to do with logistic regression? Will you be able to solve this using logistic regression? Make a smart guess. The answer is yes, 100% you can. But should you do it? No, absolutely not. I'll tell you why. The reason I told you I will do Bheja Fry right now is for a reason. Let me ask my question again. Okay. Let me make it very simple. Imagine you give me your age, you give me how much salary you make, and what is your CIBIL score, and I will tell you either you are a high risk person, low risk person, or moderate risk person. Is this a classification problem or regression problem? Is this a classification problem or regression problem? Classification problem? Okay. Under high, if I want to predict that you are a very high performer or moderately high performance, under low, very low, moderately low, and under moderate, you just say moderate. This is the problem statement. When I predict, given your age, your salary, and CIBIL, first I want you to tell me which category I belong into. And in that category, I want you to tell me which subcategory do I belong into. This problem statement, is it understood by everybody? Are you all understanding what problem I'm presenting right in front of you? Acha, tell me one thing. Whatever I've told you, isn't it very practical in real life? This must happen. Whenever people are doing classification, they must be going through this problem. Okay. My question to you is, you guys know logistic regression a little bit. Do you think this is possible using logistic regression? This problem? Can you keep this question on the top of your head for about a second until I introduce the topic and then we will talk about it? So my people, from calculating continuous values, I take you to another topic called logistic regression. Now, let me tell you, do not underestimate the topic of logistic regression. Logistic regression is going to become your foundation for learning very complicated algorithms like naive-Bayes classifier, k-nearest neighbor, decision trees, and random forests. If you don't understand logistic regression really well, you will not be able to learn naive-Bayes classifier, k-nearest neighbor, you'll not be able to understand random forest, and you'll not be able to understand decision trees. And if you don't understand decision trees and random forest, you will not be able to learn an algorithm called XGBoost. So everything is connected. Everything is like a dot by dot connection. So you need to learn the topic of logistic regression. And what I'm going to do is I'm going to take you guys through a journey which will be a little mathematical in nature, but also important for you to understand it theory-wise. I want to ask you guys a question so that I don't end up teaching something repetitively, from my sense. Were these three topics introduced? Okay. 1 by 1 plus e to the power of minus x. Remember? You guys know the concept of 1 by 1 plus e to the power of minus x? Okay. So tell me one thing. If I ask you how the data comes, what steps happen and how you get the output, will you be able to tell me? What will be step number 1? What will be step number 2? What will be step number 3? Do you know at that much level? This much level of clarity? Okay. Tell me one thing. You guys need to listen to me little carefully and everything will start making sense. Okay. Listen to me very carefully. Everything will start making sense. When we do linear regression, we fit a line. But does the line go beyond infinity? And this line can also go beyond positive infinity and negative infinity. ये possible है? 100% it is possible. Line का कोई अंत ही नहीं होता. Line has no end. Now listen to me very carefully. Okay. Whenever you do logistic regression, you want to give a probability as an output, right? For example, you have a category called cat and dog. Whenever I input an image, don't you think I will get something called probability, like cat is 92% probability and this is 8% probability. But always the probability of cat and dog together add up to 100. They don't go beyond 100. Whenever you do classification, unlike linear regression, where the line can extend up to positive infinity and negative infinity, in classification, we don't have the luxury to do that. Numbers cannot go beyond positive infinity and negative infinity. They need to be probabilities. And guess what? The probability of a cat and the probability of a dog all the probability should add up to 100%. Are you clear? Let me give you one more example. If your output was, are you possibility of a high input person, low input person, or moderate input person? Suppose if the probability, I have a given person's data, I pass it through my algorithm, the probability is 92% high, 6% low, and 2% mode. You see, no matter how many categories you have, the probability for one input, the one input that you've passed, you always have a probabilistic output in the output. And whichever has the highest probability, 92%, that is my output. For the given input, my output is, yes, the person is a high performer. Yes or no? Even though low has some percentage, more moderate has some percentage, but because high had 92%, my output of this classification is high. Yes or no? Did you learn the difference between linear regression and logistic regression? Linear regression is a continuous value. Logistic regression is a probability value. Are you clear with this concept? Okay. Do you know what happens in logistic regression? Because when we have an equation like this, or when we have a data like this, we want the data, or we want the output to be between 0 and 1. Yes or no? 0 means 0 probability. 1 means 100% probability. The reason we get this output is because we have a function in mathematics called sigmoid. What do we call this function? It's called logit function or sigmoid function. What it does mathematically is, no matter how big a number you give it, it will convert the number between 0 and 1. Did you get it? You got the concept? You want to feed it 1,060,048 something rupees. No matter how big of a number you give, it will always convert that number between 0 and 1. Did you now understand why we choose sigmoid function? We want to bring down every data between 0 and 1. Got the concept between why linear regression and logistic regression is not preferred? But let me tell you an example and then we will understand. Give me 1 second. Let me explain. Let's take this example. Okay. You have a data 0 and 1. Okay. You have a data 0 and 1. Okay. Okay. I'm thinking of a good example for you such that you will understand what I'm trying to say. But let me start like this. Is logistic regression a supervised learning or unsupervised learning? Is it a supervised learning algorithm or unsupervised? Okay. You guys already know that supervised learning means the data is labeled. Yes or no? What do you mean by labeled data? You have a column A, you have a column B. The column C will be the answer is labeled 0 or 1. 0 or 1. Yes or no? This is how the label is. This is your target variable C. This is your independent variable A and B, predictor variables. You have a label 0 and 1. Do you know what is supervised learning and unsupervised learning? What is labeled data? What is unlabeled data? Okay, I'm telling everybody what the context is. Okay, we have a dear friend with us who has a question or clarification on what exactly is labeled data and how do you call label unlabeled. Let's clarify his confusion. At the same time, we will also learn. This will be a revision for all of us. Okay, and everybody else, listen to me very carefully. In machine learning, you are only going to be given two kinds of data. Listen to me very carefully and everything will make sense. Imagine you work for a finance company like mine. Okay, let's say you work in a finance company. Okay, you want to predict whether the person should be given loan or not. Is this a classification problem or regression problem? You just want to predict whether the person should be given loan or not. Isn't this a classification problem? Yes or no? So what do? We take the person's age because age matter करता है, right? Your age matters. अगर आप 70 साल के लोन तो नहीं दे सकता मैं आपको. Age will matter. Okay. आपका CIBIL score will matter. Higher the CIBIL score, better is the chance you will pay the money back. How much money you make? What is your salary per month? Which company do you work for? Based on all these variables, I will predict whether the person should be given loan. Give loan. LOAN, loan. Answer is yes or no. Imagine my age is 23, my CIBIL is 600, okay? My salary is 15,000 per month and my company is some XYZ company. I will say no, you will not be given loan. Imagine my age is 40, my CIBIL score is 875, my per month salary is 1,50,000 and I work for say Google, example. Yes, I will give you a loan. एक बात बताओ, and I want to ask this question to everybody. Age, CIBIL, salary, company. They all are helping you to predict something, yes or no? To predict whether you will give somebody loan or not, yes or no? Labeled data का मतलब होता है, labeled data meaning your independent variables like age, CIBIL, salary, company, all are helping you to predict whether the person will be given loan or not. This is called labeled data. Are you clear? Label meaning you always have a target variable. Always have a target variable. Can I do something amazing now? अगर मैं ये टारगेट वेरिएबल को ही डिलीट कर देता हूं, इज दिस डेटा लेबल्ड और नॉट लेबल्ड? कोई लेबल ही नहीं है. देयर इज नो मोर लेबल. आई जस्ट हैव एज, सिबिल, salary and company. Yes or no? No more label. This is called not a labeled data. Remember one thing. Whenever your data is not labeled, you will always use clustering algorithms here. Are you clear? Problem state machine learning where you have no label. Do you know what you can do with that data? Nothing. Only and only clustering. That is the only solution to that data. Whenever you have label, you can run regression, you can run classification. But if you don't have label, it becomes unsupervised. It means you need to do clustering. Does that make sense? Sir, how will you decide a company's weight to decide whether the company should be given a preference or not? एक बात बताइए, everybody, I'm asking you guys a question. Have you heard of a concept called encoding in machine learning? You have not heard the concept of encoding? Okay. What if Google, Amazon, Meta, and Adobe, all these companies get a label 1? So suppose every company that is a good company gets a label 1. Every company that my bank does not recognize gets a label 0. Did I give machine learning a value mathematical saying that 1 means it's a company that we prefer? 0 means it's a company we don't know, we don't prefer. Did you just encode the information? This is not one hot encoding. This is label encoding. But did you just encode the information? Do you understand how machine learning solves problem? Does machine learning understand 15,000? Yes, it does. It's a number. Machine understands numbers. Does machine understand the word path? It won't. You need to convert that. So you have to follow something called encoding. Okay? Okay. Anyways, my point to you guys was, imagine I have a problem statement where the data is labeled. Okay. And I have data between 0 to 1. Suppose I have some data points here and some data points here. Now tell me one thing. Is it possible to fit a line here in linear regression? No, it's not possible for you to fit a line, right? It's not possible because the problem is I want my data to be clipped between 0 and 1. But linear regression takes me beyond 1 and lesser than 0. Yes or no? Do you know what logistic regression has in its backend, in its engine, in its hood? It's a very simple concept. Give me 1 second. Okay. 1 second, 1 second, 1 second. I will take you guys through one more concept. Give me 1 second. Yes, perfect. I'm about to teach you something that will absolutely make you get confused with logistic regression. But don't you worry, it will all make sense. My people, when you have a data between 0 and 1, your data labels between 0 and 1, the problem statement with this is you need to account for all the data between your left and your round. You need to account all the data. You just can't encounter one data to the top, one data to the left and fit a logistic regression curve because the problem statement is this logistic regression curve the best? Is this logistic regression the best? Which curve is the best? You don't know. You don't know that problem. So I'm going to give you a slight idea and I will make a lot of sense into it. Okay. I promise. What logistic regression does, whenever your data comes, whenever your data has arrived, it will first put your data between the label of 0 and 1. Tell me one thing. This above example, have we not labeled the person? That whether this person will get a loan, yes and no. Yes means 1, no means 0. Now that the concept 0 and 1 is given to me, right? I have segregated my data, yes or no? I have put my data. My people, you know what we do? Once this data is given to us, you know what I do? I apply a concept called log of odds. Now listen to me carefully. It will be a little confusing. I apply something called log of odds. What it does is it will convert this data that is between 0 and 1 and it will convert and make this data go between positive infinity and negative infinity. And your data will go here and your data will go here. and you actually fit a line. Now, don't worry, I'll explain it to you. Do you see this part? You had a probability distribution data. You applied something called log of odds. It became negative infinity and positive infinity, and you are actually trying to fit a line. Now, you must be very confused. Why are we doing this? Right? We already have a number between 0 and 1. Why do we need to convert our data into a negative infinity and a positive infinity value? And we are trying to fit the line. I have a small question to ask you. Just listen to me. All you do is just listen to my nonsense. Everything will make sense. In regression, what is the best thing about regression? Linear regression? Linear regression tells me, is this line better? Is this line better? Or is this line better? Yes or no? Basically, the concept of linear regression tells me which line fits best. Yes or no? Yes or no? Okay. Imagine I take a data that is between 0 and 1, convert it between positive infinity and negative infinity. Suppose my data is here in the positive infinity. My data is here in the negative infinity. Can't I draw a line, drop all the points to the line, and make some judgment later that from this line is better? For example, line number 1 in green and line number 1 in red. Which line is better? I can make a judgment. Don't worry how. We'll talk the how later. Just think, imagine, listen to me very carefully. My data is in positive infinity and negative infinity. I have two lines. One is green line, other is red line. Can I not drop all my data points on the red lines and green lines and make a judgment that maybe line 1 and line 2 does a better job? Can I not make that guess? Are you all with me? Everything will make sense. Don't worry. Are you here with me so far? After I decide between line 1 and line 2, which line is best, and I drop all the points, can I not apply something called sigmoid function, which is to this data, I applied the logistic regression 1 by 1 plus c to the power of minus x, and I will get 0 and 1 output again. The value is between 0 or 1 again. And this is the entire operation of my logistic regression. And we will learn everything in depth. Just giving you guys a hint, subtle hint. How it happens, we'll look into it. Don't worry. Are you understanding the overall perspective of logistic regression? Only 4 steps are performed. Data is given to us, is converted between 0 and 1. We convert that data between positive infinity and negative infinity using log of odds. Via log of odds, we fit a line. Whichever line is best, we apply a sigmoid function to it and we get the output between probabilities. You kind of got a subtle hint. What steps are involved? Can I repeat the steps once again and then basically teach you how each step works? Once the data comes, you actually apply something called log of odds. On log of odds, you apply something called sigmoid, and then you get a probability value. Are you clear with the chain of process? What happens? Okay. Imagine I tell you there is a fruit in the world called fluorobomba. Have you ever tried this fruit? The reason you have not eaten this fruit is because this fruit does not exist. I just made up the word. But did I give you an idea that there could be a word like this that could be a fruit? My point is, I know you did not understand what is log of odds, what is sigmoid. Ignore that. Can I at least tell you what the fruit tastes like and you can get an idea? I know you've not eaten the fruit yet, but if I explain at least 5%, you'll have an idea. What is the fruit? It is sweet. Is it sour? Is it huge? How do you cut it? Are you understanding what I'm trying to say? Yeah. Point number 1. Did you get the process of what logistic regression steps are? Step number 1, you get the data. Step number 2, you apply log of odds. After log of odds, you need to convert it back again into probabilities. Hence, you apply something called sigmoid functions. Actually, you apply something called maximum likelihood. And after that, you get the output. So step is clear. Now, let's go in depth. Now, let's try to understand in depth how this particular thing works. Excited? Ready? Let me show you how that particular thing works. Okay, give me 1 second. Okay. Before I do that, did you learn the difference between probability and odds? Are you guys clear between the concept of what is a probability and what is an odds? You guys are clear with the concept or no? Okay. Do you want me to reiterate it once or should I proceed forward? Listen to me very carefully and look at this problem statement, okay? A guy went fishing 5 times a week. How many times did he go fishing? 5 times in 1 week. Remember this number, 5 times in 1 week. He caught fish twice and he failed to catch 3 times. Okay. He caught fish twice. So twice he got success and thrice he got failure. This is the data. the current situation, the scenario. Probability is how many times did he get success divided by total times. So 2 times he caught the fish divided by how many times did he actually go out for fishing? 2 by 5. What is 2 divided by 5? What is 2 divided by 5? 40% success ratio, right? Can I say that this guy had a 40% success ratio? Every time he went for a fishing, the chances, the probability that he will get a fish or catch a fish is 40%. But have you heard in English, what are the odds of that? In English, you must have heard of this question. Hey, what are the odds of that? You encounter a problem. Suppose you are going into a, you're walking in a mall, you encounter or you meet your friend who you've not met after 5 years. Your first thought is, hey, what are the odds, right? Like, what is the odd you met me now, here, today? Listen, the concept of odd is different than the concept of probability. Odd is not the success of total event. Odds are 2 divided by 3. It means it is not the total time. It is the success by the total failure. And odds are higher than probabilities. So what is 2 divided by 3? What would be 2 divided by 3 in percentage? 60%, approximately, higher than that. Are you now clear that whenever you do probability, you divide it by the total values inside it? But odds don't happen like that. It is your success by your failures, which is called P by 1 minus P. Are you clear? Listen to me carefully. You got 90% in your marks. You got 90% marks in your 10th standard. What did you fail to get? Isn't it 100% minus 90%? The 10% you did not get? Am I now making sense? 100% may say it. 1 minus P, matlab 100% can also be called as 1. So it is called P divided by 1 minus P, success by failure. That makes sense to everybody? Are you now clear with the concept of what is probability and what is odd? Okay. Let me ask you one more question. I just want to get a clarity. Imagine there is a ball. Imagine there is a bag. In this bag, you can't see the bag. There are 2 red balls, 3 black balls, and 4 green balls. Have you heard of something called conditional probability? Let me explain. Everything will become clear. If I remove 1 red ball, 2 black balls, sorry, 2 black balls, and 1 green ball, what is the probability of getting the red ball? Can somebody tell me the answer to this? It will be 1 divided by 5, yes or no? Because only 1 red ball exists among all 5 balls, yes or no? Did you even consider the one that are not in the bag anymore? Did you not divide the whole category by the total data? Did you now understand? Any kind of probability, you always divide by what is left with you, total what is left with you. But odds don't work like that. Am I making myself clear? Like, did you guys get the concept of probability versus odds? I even showed you an example with a conditional probability. You guys got the concept, right? Now that you have understood the concept of conditional probabilities, okay, let me tell you, why do we apply log? You must have heard of this thing called odds. I just taught you odds. But why do you need to apply log, 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 log? Have you ever encountered a word called logarithms in your mathematics ever? Let's break it down. What are logarithms according to you? Okay, I want to show you an example. Yeah, this is better. Okay, let me also take this because ye bhi sahi hi hai and paste it. Yeah, guys, can I say that 2 to the power of 8, or hold on, what is 2 to the power of 3? Can I say 2 to the power of 3 is 8? 2 to the 4, 4 to the 8, which is basically 2 to the power of 3. Can I not write this equation as 2 to the power of 3 equals to 8 as log to the base 2 of 8 is equal to 2, is equal to, 3? Am I making sense? Based on the given definition that I just showed you, logarithm helps us identify the power, right? The power x, the exponent, what we called as. Logarithms help us identify the calculations of exponents quicker than any other mathematical function. Yes or no? Can I also tell you something? Logarithms also have a base of natural logarithm e, or a natural base 2, or a natural base 10. Have you ever heard of this? Log to the base e, log to the base 2, log to the base 10. Okay. Now, look, I will not be able to tell you in depth because log to the base e is a very, okay. E is called Euler's constant. Okay. Euler's constant. It is 2.7 something something. I don't want to get into it. Okay. My people, what logarithm does, let me tell you something. Logarithm is a clipping function. What function is it? Clipping function. If you are suddenly increasing, I will make your increment like this. Imagine it like this. You are a very excited person. What logarithm would do is, it will make you less excited. It doesn't ask you to curb your enthusiasm. It will say, let your enthusiasm go over a period of time. Somebody whose growth has been happened exponentially, the opposite of exponence is logarithm, right? So it will ask that person to go steadily but more longer. Do you see that increment here is shorter, but the increment here is longer, but both are increasing? So the data is not lost, but it's just that it is expanded like a clipper. Making sense to some extent mathematically? Are you understanding what I'm trying to say? Okay, let's do this. Yes, let's do this. Let me ask you a couple of questions, and I want you guys to give me a straight answer to it, and we will finish linear regression within a couple of seconds. Does y is equal to mx plus c happen for line equation? Is this called a line equation? Yes or no? Very good. Okay. When the number of variables are higher, suppose there is a column called age and column called salary, and I want to predict something like, I don't know, loan amount, example. So can I say that age and salary is another variable? So I can say y is equal to m1 x1 plus m2 x2 plus c, or you can call it m1 into age plus m2 into salary plus c. Can I call this as the line equation to solve this problem? This is mathematical way. If you talk from a mathematical visual way, it means that there are three equations, right? This is my loan amount, this is my age, this is my salary. So there will be a line rather than two dimension. Let's make it one dimension. Let's make it so that it's easy to understand. So can I say that I can, whatever value of x I have, I drop that value of x on this line, and the corresponding value of y is my prediction, y hat? Yes or no? I change the line, I take the value of x, plot it on the line, and whatever is on the y is my prediction. Yes or no? So listen to me carefully. What is the equation of logistic regression? It is 1 by 1 plus e to the power of minus z. This is logistic regression. Yes or no? Do you know what is this z, guys? What is this z? What is this z? This z is nothing but, imagine you want to do logistic regression problem where you have age, you have salary, and you want to predict whether somebody will be given loan or not. LOA and loan. So suppose my age is 23. My salary is 1,50,000. Should you give loan? Yes. My age is 45 or 40. 15,000 is my salary. Should you give a loan? No. This minus Z is nothing but g of x is equal to 1 by 1 plus e to the power of minus of m1 into age plus m2 into salary plus c. That's it. You're done. Plus c. This is what a logistic regression will be like. That line equation I told you that we are going to fit in positive and negative infinity, right? That line you just have to simply put here. Now, whichever value you will put, logistic regression will convert that between 0 and 1. Are you clear? Did the concept become clear? Did the idea? See, guys, logistic regression is not very complicated. Okay, I'm just telling you guys an idea. It's not very complicated. How we get this equation is log of probability of x divided by 1 minus probability of x is equal to mx plus c. This is the core equation of logistic regression. When you do mathematical, movement and change it and all of that, you arrive at this equation. That is why. Does it not look like logistic regression? One sigmoid function 1 by 1 plus e to the power of minus x. Your z is nothing but the line equation that you're trying to solve. And if you apply the value, you'll get the output. Did that make sense to everybody? Anybody here confused? Okay. Can I tell you some more idea? The value How do you get the coefficient m1 and m2? You cannot use ordinary least square here. Can you? Suppose there is a line equation. Can you use ordinary least square here? No. Remember one thing, my people. To calculate the coefficient on m1 and m2, you use a technique called maximum likelihood estimation. Are you now clear? Did you get the idea? In ordinary least square method, we calculated the value of m and c. In logistic regression, because we also fit a line, but this time we fit a line on a sigmoid, we calculate m1, m2, and c using a method called maximum likelihood estimation. Are you clear? Yes or no? I will wait until all of you give me some heads up, because suddenly there is a radio silence on my chat section. Guys, that's it. That's all logistic regression is. You were thinking some complicated stuff. It's not. It is not. Truly, frankly, there's nothing complicated in logistic regression. That is it. This one equation is the final equation of logistic regression. You're done. Okay. Can I ask you a question? Can you write the equation and give it to me? Will that be fine? If I write down a formula, if I write down the variable, can you write the equation for me? Imagine I want to take, okay. Imagine I have a data called area of the house. Hey, you know what? Let's take something nice here. Okay. Low height, low ground clearance. Okay. Ground clearance, low ground clearance, longer body, and 3000 cc, greater than 3000 cc or not. Probability that this is a supercar. Yes or no? If can you write the logistic regression equation for this particular example? Are you guys even trying? I want all of you to try. Can you write the logistic equation for this? The logistic regression equation for this? 1 by 1 plus e to the power of minus of whatever you want to write. Did you guys know how to write the sigmoid equation? 1 by 1 plus e to the power of minus of m1 into low ground clearance plus m2 into longer body plus m3 into greater than 3000 cc plus c. Yes or no? Did you all write the same equation? Did you all write the same equation? Did you now get it? It is that simple. That's it. You take a line equation, you convert the line equation. Boss, listen to me very carefully, people. When this is how our data looks like in linear regression, sorry, logistic regression, all I'm doing is taking this logistic regression line, this linear line, and converting it into a squiggle. That's all I am doing. And I am doing this using the help of this function. Are you clear? कुछ complicated नहीं है. That is it. आप अगर mathematically also if you code this up, you only need one equation and that is this much. Done. To calculate m1, m2, m3, c, you cannot use ordinary least square. You have to use a method called maximum likelihood estimation. बस इतना ही complication है. That's it. You're done. Sorted. Are you clear? And you know what? अगर आप ये steps observe करो, all the steps that I taught you a while ago, these steps are all included in the 1 by 1 plus e to the power of minus x equation. Everything you will see. Maximum likelihood estimation you will see. Probabilities you will see. And your answer is done. Are you all clear? By the way, did you get the concept of logistic regression so far? Can we jump into practically applying these algorithms? What do you think? Can we do that? Let's do it. Do you remember the linear regression part? All of you, do you remember the linear regression part? Linear regression. Do you all remember the mathematics of linear regression? If not, don't worry, I will remind you. Acha, tell me one thing. According to you, which is one of the most important library in Python? Import NumPy as NP. Yes or no? Yes or no? Import pandas as PD. Yes or no? If you don't know anything in machine learning, just import these two libraries. People will think you know a lot. Okay. So, and we can import matplotlib.pyplot as PLT. Okay. Pyplot as PLT. See, these three libraries to boss are needed. ठीक है. अगर इंटरव्यू में कुछ आए ना आए, इसको लिख दो. At least some time will be there. ठीक है. Okay. I told you there are two kinds of data, right? Weekly data and sales data, right? So week underscore data and sales data. Sales underscore data. we had a weekly data like first week, second week, third week, fourth week, and fifth week. And give me 1 second. First week, second week, third week, fourth week, and fifth week. This is properly equal with spaces. 2, 4, 5, 4, 5, if I'm not wrong. Because I remember I did that yesterday. PD. Yeah. Yeah. Acha, by the way, oh, I love this. By the way, if I would have written here also NP, would I have gotten any error? Okay. Can I do this? Import numpy as, can I do this? Very nice. I like it. Thank you so much. Yeah, in Python, you're allowed to do that. But good, yaar. Thank you so much for pointing it out. I really appreciate it. df equals to pd.dataframe. Do you understand what is this data frame? Like how do you actually implement a data frame? So you can say things like week, right? Week or weeks, anything is fine. And you can pass something called week data. Okay. And you can take up another variable called sales, and you can take up sales data. Yeah. Is this clear? This is the data. Oh yeah, sorry. Yeah. I do. Thank you so much. Yeah. Is this clear? Did we have the data that we had discussed the last time? The last class when we practically took the part, do we have the same exact data? Okay. From this, in machine learning, don't we divide our algorithm into two parts? Suppose I have a weekly data and I have a sales data. Won't I divide this into X and Y? Y is my target and X is all my independent variable. Yes or no? So tell me one thing. X can be equal to, what can I say? df of, right? X equals to df of, I want weeks, right? So I will say X is weeks, right? And I can even take values, like all the values of the data, values. Yeah, this is my X value. What could be my Y value? My Y value could be sales. So if I run this and print X, not small, but the capital one. This is my X and this is my Y. Can you see that I've taken two data, X and Y, separately? Okay. In the last class, when I was doing something manually, what was the first thing that I did in linear regression? Do you remember I told you, whenever you have a linear regression, you first need to calculate the mean of X and mean of Y so that you know where you want to pass from? Yes or no? So let's calculate it. Mean of X equals to and mean of Y equals to. So if I want to calculate the mean of X, can I not say NP dot mean of X and NP dot mean of Y? And if I calculate print mean of X and mean of Y is 3 and 4, yes or no? This is basically all my mean values of X and Y, basically, right? I just wanted to print it, didn't want to take it. I'll take another variable called N equals to length of all the variables X. So how much data set do we have? What is the sample size do we have? 5 is the sample size. Okay. Now, what was the formula that we calculated in the last class, in the machine learning class? What was the formula? Hold on, give me 1 second. Let me try to find that number that we did. Yeah, right here. Perfect. Yeah. To calculate linear regression, yeah. To calculate the value of M1 and X1, did we take X minus X bar into Y minus Y bar by X minus X bar the whole square? And to calculate Y, then we used that equation to calculate it. So X minus X bar into Y minus Y bar by X minus X bar the whole square. If I want to write this in mathematics, can I say numerator equals to 0 and denominator equals to 0? This is like assigning the value. And now I will loop. For I in range of the total sample size, which is N, numerator plus equal to, now tell me one thing, each value of X, X minus X bar, which is each value of X minus its mean into each value of Y minus its mean. Yes or no? Each value of X, independent value of X minus its mean into Y independent minus its mean. So can I write it something like this? X of I, because I will loop, minus mean of X into Y of I, independent values of Y minus mean of Y. Can I do this? X minus X bar into Y minus Y bar. This will be my numerator. And I can take something called denominator, right? So denominator plus equal to, I'm also calculating for that. What is the value of denominator? X minus x bar the whole square, which is basically x of I minus mean of x the whole square. This completes my calculation for my m value. You remember m value? So if you want to calculate m, the value of m, is it not numerator divided by denominator? And if I calculate the value of m, what value of m did we get, my people, when we calculated the value of m? 0.6. What answer did I get? Have I used the same equation I taught you yesterday and we got the value of m? We got the value of m. Okay, chalo, theek hai, very nice. We got the value of m. Now we need to calculate the value of c. What is the formula for c? If you look very carefully, c is nothing but, see, look at this formula, okay? Listen to me very carefully. Y bar is equal to mx bar plus c. If I rearrange everything properly, isn't c equals to y bar minus mx bar? Just rearranging y bar, which is mean of y, minus your value of your m that you have calculated into mean of x. Yes or no? So if I replace that exact same equation here and call this as c, like you call this as c, right? C is equal to mean of y minus your m value multiplied by mean of x. And if I calculate c, did I get 2.2? The same exact thing that we got yesterday. So tell me one thing. Did we implement any library in this to calculate the coefficients? We did not. We didn't specifically need any library to calculate that value. We did not do that. Okay. How about we look at the data? We visualize the data. Can we do that? Okay. Let's observe how does our linear regression look like. Okay. Now, what I'm going to write right now is going to be a little confusing, but don't worry about it. I will explain it to you what I'm basically doing. Okay. Plus 2. Let's take a range of mean. You can call it max of x also, actually, and mean of x or min of x. Okay. Min of x. Max of x, min of x, np dot x, np dot min, and yeah, that could be the range. If I increase the range, okay, that will work. That will work. Not a problem. Yeah. Though, like I said, give me 2 seconds. I will explain what I'm doing. Okay. Have you ever encountered a function called line space or linspace? Have you ever had the opportunity to work with this? Do you know what in NumPy this is? You guys already know this, right? Okay. Then I don't have to explain the concept of min x and max x with linspace because that is a little complicated. Okay. M into, okay, mx plus c. So you can call it as a, okay. Okay, hold on. I think I need to tell you one other thing. Guys, tell me one thing. I forgot to tell you this, but this is important while I'm coding it up because this is like super critical for you to know. Can you tell me among M and C, which remains constant no matter how many variables are added? Which, see, usually this M is also called as B1 in the equation, right? Like, and this thing is also called as B0. Like B1 and B0. You guys know that this is also called B1 and B0. Like there is no confusion there, right? So if you actually think about it, right? So let's say I have written my equation called C plus, okay? Let's say C plus B naught X, which is M into X. So say M into X, or X value could be anything, but I'll just write it down here. Which equation does not change at all in MX plus C? C does not change. What happens to M? Does it change every time there is another variable added, another target variable, another independent variable added? Will you keep this in your mind while I'm doing this code? Will you keep this in mind while I'm doing this code? Okay. Tell me this. If I pass in x comma y, okay, and give it some color like hex code online, okay. Let's take like a good hex code. Let's take darker color, or maybe, yeah, let's take like this magenta pink sort of a color. Yeah, this is good. Let's copy this and paste it for this color. Yeah, this is, I think it's going to be neater, but it's okay. Label equals to regression line. Actually, regression line, but take care. It's called whatever we feel like. Do you all understand what is mat? Have you all worked with matplotlib? It's not like I'm writing something and you guys have absolutely no idea what I'm writing, right? Like it's not like I've confused the hell out of everybody here. You guys at least know what matplotlib is and how the whole thing works, right? Okay, good, good. I hope it's not very confusing to all of you. Let's take this, copy this and paste it here. Yeah, I can paste this. And I can even change the line width and all of that stuff. But okay, label equals to my data. And I can even change the alpha and all of that. Have you all worked with something called alpha and all of that stuff in this? Do you know what is an alpha in a linear regression line or maybe a matplotlib line? Do you all know what is alpha? Okay, so for example, if I want to use something called line style, would you understand what line style is? Suppose if I want to implement something called line width, width is equals to 4 maybe. If I run this example, basically this is the data point that we had, and I'm basically plotting this data. So do you know that I can also do something called plot.legend, plt.legend, and I can do location equals to best, log equals to best. And if I do this, I now have what does this line see initially? Observe to the left. This line is regression line, red, green is the data was not there. If I comment it, run it, see my graph is not very good. But the moment I print the legend, my graph is much more neater. Are you clear? Like, see, if I want to make it alpha, for example, alpha, ALPHA, alpha equals to 2. Do you see that my line, matplotlib alpha, okay, a matplotlib alpha plot, dot plot, ALPHA, ALPHA, okay, my spelling was correct then. ALPHA equals to something. What is the value? 20, yeah? 0.2. Oh, okay, okay. You're not supposed to have a, you're supposed to have a fraction values. Yeah. Do you see that my line became very light? You saw that my line, the red line became very light, right? Like, hold on, I'll show it to you. Wait, I want a jatang red color, like a red color that should just make us feel like what are we doing in our life? Give me 1 second. Like, ultra bright red I want. Hold on. Yes, let's take this. Copy and paste it here. Give me 1 second. Yeah. This is good. Okay. So if I change this 0.2 to 0.9, do you see it is ultra bright now? Full. So what I'm doing here basically is, guys, do you see that the range in the bottom, I wanted the range to be smaller. That's why what I did is I created a max range +2, min range -2. So that on the left and the right, I have ranges for the line to plot. So if I do see, look at this, +10, -10. Can you see that line is being extended and the points? This line, I want to make it bigger. That's why. Can you see the range starts at -10, range ends at +15? Do you see that the range is -10 and +15? So I wanted the range to be good. That's why I did it. Let's keep it to only 2 because that's the best one. But do you see how my data is plotted and how my first logistic regression graph is plotted? My data points. Everybody kind of got the idea, right? Like what I'm doing here. First, we implemented the ordinary least square method. We calculated and we fit the line. Basically, this is the linear regression line that we fit using the y is equal to mx plus c that we calculated. See, I am replicating the value of c and m, whatever we calculated on top, and I'm calculating the answer correctly, directly from the value. Any confusion here? Okay. Can we calculate something called r square now? Acha, by the way, I have a small question I want to ask everybody. Guys, between 1 to 10, how good is your Python? Okay. Guys, is everybody's attention on me? Like, is everybody listening to what I'm trying to say? Is everybody's focus on me? Okay. Guys, let me ask you a question. Do you think to become a really good machine learning engineer, your Python needs to be exceptional? Exceptional? Do you all agree with me? 100%, sir. Okay, hold on. Do you think I come to the class prepared with a code or I just write my code on the fly? I write the code on the fly. I have nothing prepared in front of you. All of you are here. The screen is here. My iPad screen is only for your chats and your QA. That's it. So tell me one thing. Python is important. Everybody agrees? What if I give you 250 Python programs? These programs are built in such a way that it will take you from basics to intermediate to advanced. And you only have to do 250 problems, not more than that. What would you say to that? And my claim is bigger because this sheet I have shared with more than 5,000 students in my career. The same exact sheet, same exact code, same exact logic. With this, you should be able to convert between 0 to 10. You should be able to be 8 or 9 in Python after this, for sure. For sure. Okay, I will only give the sheet only when I get the assignment back. Can I make this? Can we have this? You will be like, this guy is a extortionist, right? Like this guy is extorting But the point is, I know you guys have been struggling with Python a little bit. I understand. But please understand that without Python, you are nothing. If you don't know your programming skills, how are you going to implement it? So your job is daily you should solve two problems in Python daily. After maybe 6 months, you will see a difference. And is object-oriented programming required in ML? 100%, yaar. If you don't know object-oriented programming, you can't survive in machine learning. Hold on. Let me show you something. This is one of my projects that I taught long ago in one of the colleges that I keep visiting as a professor. I'll show you something. This project is a very simple project, people. What I did is you type the hashtag of whatever you want, like hashtag Tesla. It will tell you out of 200 tweets, how many tweets are positive, negative, and neutral. So this is called sentiment analysis. In natural language processing, we call this sentiment analysis. Have a look at the code. Have a look at the code. Do you see everything is a proper class? Everything is a proper method. Everything is neatly arranged, and in the end you are calling all of it together and you're getting the output. You see, everything is properly and neatly arranged. Do you get it? If you know Python, that is good, but Python is not where you end. You have to learn object oriented also. Polymorphism, inheritance, encapsulations, all the way from design patterns, everything needs to be learned. Otherwise it won't make any difference. And you know what, can I say something funny? I have a resource for object-oriented programming also. I have a resource where each object-oriented code can also be like, you have an example of all. I can share that with you also. No problem. I'll share it. As long as you promise to share, as long as you all collectively promise that you will send me a cup of tea every day, I will share it with you all. Okay? Machine learning and all, सब भेज देंगे, कोई टेंशन नहीं है, शेयर कर देंगे. Not gonna be a problem. But point is here, आपका Python needs to become good. Just, I mean, jokes aside, Python needs to become good. Otherwise, you guys will not be able to survive. It's a promise. It won't be good for you. I'm telling you. Your Python has to be good. I will give you the resource today, but your Python has to be good. Acha, by the way, so sorry. I forgot to tell you one thing. Parth Sharma 1011.github.io. In case if you want machine learning algorithms also, can you see this library called ML Codes? Here, I have implemented all libraries from scratch. I have implemented machine learning from scratch, and I have a library also. Whole thing from scratch, library also. So if you want, you can also read my link of this. You can always go through machine learning codes there. I've done many logistic regression, linear regression, k nearest neighbor, support vector machine, naive-based classifier, one versus rest classifier. I've done everything there. You can go and have a look at it. Okay. If you want to do a sentiment analysis classification, you can do it with that. Okay. So anyways, my point to all of you is please make sure that your Python becomes good. Otherwise, it's going to be complicated. Anybody has any question what I've done here? Whatever formula I taught you, I have replicated the same right in front of you, in front of your eyes. I've changed nothing in my code. Can we implement R square now? Can I implement R square? Do you see the R square formula that I implemented here? Y minus Y bar, Y minus Y bar minus divided by summation of Y minus Y bar the whole square. The formula is right in front of you. Can I implement R square? Okay, no problem. To implement R square, can I say sum of square total is equal to 0 and sum of square residuals, the one that you want to calculate, is equal to 0? Because I'm sort of creating a counter and then later update it. For I in range of how many times do you want to iterate? N times, because that is the number of samples that we have in our data. Y predicted value, all the Y pred value, the Y hat you called as C plus M into X, yes or no? Rather than calling it X like this, can I not call it X of I each data point? See, here you have B naught, right? Which is C plus M into X. But each value of X means each value of X of I, right? Because that's how we will be able to implement the value. So what will be sum of square total is equal to plus equal to, according to the formula, it is each value of Y minus its mean, the whole square. This is the formula. Sum of squared residuals plus equal to, what is sum of square residuals? Same exact thing, but here instead of instead of mean of I, we calculated with predicted, Y predicted. We just changed this with y underscore pred, and same exact whole square. Now tell me one thing. What is the formula of r square? What is the formula of r square? Look at this. Look at this. 1 minus residual sum of squares, which is called sum of square residuals. See, RSS is residual sum of squares, which is sum of square residuals. It's the same thing. Divided by total sums residuals. So hold on. Let's take it like this. Where is the formula? This is the formula, right? So taking this formula, can I say r square value is 1 minus sum of squared residuals divided by sum of square total? And if I print r square, what answer did we get? Yesterday, what did we get? 0.6. Did we get the same exact answer? Is everybody understanding what? See, these are not my formulas. We created the formulas yesterday and we are just implementing them. So are we getting the same exact output? Yes or no? We are. Okay. We have done ordinary least square method. We have fit the line equation. We've even calculated r square. Do you want to test the actual library from sklearn and see how good are we matching? Can we try that? Okay. To do that, from sklearn, okay, dot linear model, import linear regression. Okay. Import linear regression. That's all I've done. But what I'm also going to do is from sklearn dot metrics import. Do you know there is something called mean square error, my people? Mean squared error. We have MSE mean square error. I told you it is a loss function. Okay. Let's do this. Can we also calculate mean square error quickly? यहाँ पे एक extra fun करते हैं. मतलब let's also calculate root mean square error. उसको भी calculate कर लेते हैं. What do you say? Okay, let's calculate it. To calculate root mean square error, can I take root mean square error is equal to 0, a counter 0 for I in range of n? यहाँ तक clear है? Okay. Root mean square error formula. Can I show you the formula for root mean square error? What is the formula? Predicted minus actual. You need to calculate predicted value minus actual value, square it and divide it by the total sample size. Each value of y subtracted with the predicted value, whole square and divided by the sample size. So this is a very simple formula. अब इसके लिए मुझे क्या करना पड़ेगा? I need to write something called ypred equals to, okay, यहीं से ले लेते हैं. Ypred is equal to this. Copy and paste. Ypred is equal to this much. What will I do? Root mean square error plus equal to each value of y subtracted with ypred and the whole square. Yes or no? Root mean square is equal to each value of y subtracted with ypred and the whole square. After I am done with this, what do I need to do? I need to come outside the loop because I don't want it to be in the same iteration. Root mean square error is equal to np dot sqrt. I want the square root. Do you see? There's a square root here. This big square root, the entire big square root. Now, square root of what? Square root of what do I do exactly? Root mean square error divided by sample size. So root mean square error is how much, guys? 0.7, approximately 0.7. See, we print the value right in front of you. Okay. Any confusion in this? If I want to implement linear regression from my library, so can I not do something called x.reshape? Okay. The reason I have to do reshape is because the problem with sklearn's packages, it does not give me array directly. The x variable, the x from data frame does not give me a array directly. So I need to convert that into an array. Okay, no problem. Regression is equal to linear regression. I'm calling linear regression. I'm passing no hyperparameters whatsoever. Regression dot fit. And I'm passing in the variable of x comma y. Okay. Run. This tells me my linear regression has already been printed. Are you clear? This particular thing tells me that my linear regression has already been printed. I hope you got the idea. Like my linear regression is just printed now. I have nothing else to worry about. My linear regression algorithm has run. That's what it means. So tell me one thing. What is the equation of ypred value? What is the equation of ypred? So can I say ypred equals to c plus m into x? M into x. Is this my equation for ypred value? So mean square error equals to mean squared error, the one function that I've imported from top, and I'm passing y comma y underscore pred. The same exact equation that I've done. Okay. And let's also take r square. Score equals to, you can just say reg dot score, which is the same function that we've just implemented, pass comma x and y. Okay, just x comma y. So r square score. What is the r square score we got and r square score we have from the library? Is it almost same? 0.59999, which is 0.6, which is what we calculated? Yes or no? Okay. How about the mean square error? The mean square error is np.sqrt of mean square error. Did we get 0.6928, 0.6928 the exact same mean square error? When we've implemented something called mean square error function, see, I have imported something called mean squared error. I have called mean squared error and I got np.square root mean square error exactly the same. So there is no difference. We got the same exact fit, same exact output. We got the same exact r square and root mean square error values. You got the concept, my people. It's just the formulas converted back into the code. That's all I'm doing. I'm not doing anything fancy, right? I have just implemented root mean square error from code and then I'm using the same exact line. It's just that the number of lines are lesser for implementing the package versus I had to write a longer code. Guys, how good is your pandas? Do you know why do you have to reshape? Okay, hold on. Kernel, restart and clear output. I have cleared my kernel, okay? My kernel is dead. I've created it from scratch. 1, 2. This is my data. I'm coming directly to here, okay? Is it giving me an error? Acha, where is x? Acha, we did not define x, right? Yeah, just 1 second. 1, 2, 3, 4. x and y. x और y. हाँ, ये print कर दिया हमने. ठीक है? हम यहाँ पे आए. हमने इसको रन किया. n कहाँ पे भाई? अच्छा, लेंथ ऑफ n भी बताया था ना कहीं पे मैंने. हाँ, चलो, n is equal to length of x. ये भी ले लेते हैं. 1, 2, 3, x, y. इसके नीचे ले लेते हैं length of x. इसको वापस रन करते हैं length of x के साथ. And let's run linear regression वाला part and do it. And reshape नहीं करना है, sorry. Let's just take it x as it is, right? So x को as it is लेंगे हम. And kernel restart and clear out. ठीक है? Restart and clear output. Kernel मैंने वापस reinitiate किया. 1, 2, 3, 4, 5, n, and all the way from this and this. अच्छा, tell me one thing. The x variable that you just see here, ये array में इसको convert कर दिया. Not always this x variable is converted into an array. मैं आपको output दिखाता हूँ इसका. Am I getting an error saying that your array is not of proper shape? Anuj, बहुत ध्यान से सुनना, okay? Listen to me very carefully. Whenever you pass a data in a linear regression model, it needs to be a nested array. एक array के अंदर जो array होती है. Have you ever seen it in Python that you need to pass something like this? And then another array called, this is how a linear regression model or any machine learning model expects. But what it gives is this. The difference, whenever you have to do any machine learning modeling, you have to reshape your data. Otherwise, it will tell you the same exact problem that the data is, you need to go ahead and reshape your data. Single feature mil raha hai. It is not double nested. I've shown you the proof right in front of you. Okay? So guys, how do you find linear regression so far? How did you find linear regression so far? Did you guys, I don't know, feel a little understandable in nature? Do you feel like that maybe something could be done? Okay. The programs that I showed you right now, the programs and all the problems I showed you right now was just a warm-up. Can we actually implement a linear regression on an actual data and show you? Can we actually run a regression on a real life scenario? And then let's see what we can do with that. Can we do it? Chalo, let's do that. Import pandas as PD. Data equals to np.read CSV. Okay, READ, read. Arey yaar, not np, sorry, pd.read CSV. मैं क्या कर रहा हूँ? See, even we are foolish. People like me. People call me as somebody who has good knowledge. And sometimes I end up making a lot of mistakes, but it happens. No problem. This life is filled with people like me. Data.head of 4. Can you please look at the data, my people? Is this visible? Hold on. How about now? Is this visible to everybody? My people, it is very simple. You have a gender. 1 means male, 0 means female. Your age range, 1 means greater than 30, 0 less than 30. What is your head size and what is the brain weight? If I want to drop gender and age, it's of not important to me. If I tell you my head size, can you predict my brain weight? Can we make this linear regression model? Are you understanding? I want to understand if I give you the size of my head, will you be able to predict the brain weight? That is my point. Acha, tell me one thing. If I want to do that, shouldn't I not divide my data into two category X and Y, just like how we do it in every machine learning model? Yes or no? So tell me one thing. What will I do with the head data of, right? What do I keep as an X variable? What do I keep as a Y variable? What do I keep as an X variable? The head size in centimeter cube dot values. All this can be my X variable. Yes or no? I don't care about gender or age. I don't need no gender, no age. It's of not importance to me. I am taking this as my X variable. What will be my Y variable, my people? What will be my Y variable? Brain weight in grams? Yes or no? Okay. So tell me this. Before I run a linear regression model, what did I tell you to first validate in a linear regression model? What did I tell you? You should always validate. Import matplotlib.pyplot as PLT. Did I not tell you to check linearity first? Yes or no? So can I say plot.scatter of x comma y, okay, x comma y, and run it? Does it not look like it is possible through linear regression because a line can be passed through them? It's not curvy. Make sense? I have just plotted the data and I've shown you that. Very good, no problem. Chalo, मैंने XY भी plot कर दिया. I know it is done. But what do you need to do with the X? You need to reshape it, yes or no? You can reshape it -1, 1 also, n, 1 also, whatever you want to do. It's up to you. Yes or no? पहले ये बताओ. Am I saying the right thing or am I saying the nonsense things? Whatever. Okay, acha. I want to run linear regression. Have I imported all the packages properly in linear regression? How do you call linear regression? From sklearn dot linear model import linear regression. इतना समझ में आ गया आपको? You have to remember this. From sklearn dot metrics. What do I want to import? Two things. Import mean squared error, and R square error, which is R2 score. Basically, आप उसको एक ही चीज बोल सकते हो. From sklearn dot, you must have not heard of this, but this is called model selection. Import beautiful thing called train test split. This will become your life. If you don't do train test split, you can't do machine learning. I'm telling you this right now, but it's okay. I'll tell you how this works. Don't worry. Okay. एक बात बताओ. Whenever we run machine learning models, don't we split the data into 4 categories? Suppose this is my head. क्या था ये? Just 1 second. Head size and brain weight. हाँ. I have a column called head size and brain weight. अब एक बात बताओ. Head size और brain weight में हम क्या ले रहे हैं? Head size is X, right? Brain weight is Y. Yes or no? We have split the data into 2 parts, X and Y. Yes or no? We've done this. See, X and Y. Here the splitting happened. But guess what, my people? You even need to split this data into train and test. Are you clear? You need to split this data into training data and testing data. Don't your machine learning model need some training? After the training is done, you need to test on to split this data as train and test. Are you clear? X train, X test, Y train, Y test. So you will get X train, X test, Y train, Y test. Are you clear? This concept in machine learning will never leave you. I'm telling you, this is needed. So tell me one thing. This should happen, yes, and this should happen in a sequence. Can I take it? X underscore train, comma, X underscore test, comma, Y underscore train, comma, Y underscore test. Are you clear? X train, X test, Y train, Y test. Who do you call train test split? What will you pass the data? X, comma, Y, comma, test size. How much do you want your test percentage to be? Let's keep it 20%. So 0.2. Are you clear? My training data is 80%. My testing data is 20%. Any confusion in this? My data is split. Any question? Very simple. No problem. Linear regression equals to call linear regression. Just directly. Linear regression, make it callable. Simple. What do you do later on? LR.fit. That's it. Linear regression.fit. Pass X train, comma Y train. Any confusion? You run this. My linear regression model has run. मेरा model run कर गया. My model has run. My linear regression is done. एक बात बताओ. My head size is 4,512, 3,738, 4,261, 3,771, whatever the value is, whatever the value that you want to predict. Can I help you understand how to predict? Can I show you a prediction right in front of you right now? How to predict? LR.predict. I told you, how should you pass the data? Nested list or not? Yes or no? Can you give me a random number between 4,000 and 3,000? Some number? 3,000. Can we take 3,004? Okay, 3,788. What did it tell me? The weight of the brain will be? What is the prediction it gave me? It says that for a weight of head size of 3,788, your brain weight will be 1,317. Did we get the output the way we expected? And see, the output is correct. For 3,000, approximately 400 something range, we are getting 1,297 as the brain weight. So this is approximately doing a good job. Did you just predict? Now, let's calculate mean square error. Can we? Can we calculate R square mean square error just to know how good are we performing? So y underscore pred equals to, what is the equation? LR dot predict for all the values of X test. For all my test functions, my Y predicted values are calculated. The values that are there in my test set, all the values for test set that I have calculated, I have. The predicted values that I have. How do you calculate mean square error? Mean square error equals to, call mean square error. What will you pass inside it? Y test, Y pred. And remember one thing, this will never change. This will remain, this Y test, Y pred will remain Y test, Y pred for all algorithms in the world. I'm not changing it according to what I am doing, okay? Root mean square error is equal to np.sqrt of sqrt of mean square error. Can I say this is true? R square is equal to R2 score of, what do you pass? Y test, Y pred. Whenever you want to test something, you pass Y test, Y pred. That's it. You're done. Sorted. Can I print the values? Print f of root mean square error value is, how much is the root mean square error value? Root mean square error value slash n. What is my R square value? Sorry, R square value is R square value. Okay, R2 value. If I run this, do you see that my root mean square error and my R square value is close to 1? It's close to 1. That means the model has done a good fit. You can even plot it. We can even plot the data. Hold on. Plot dot scatter. What will you pass inside the scatter plot? X test and Y test, right? Because we're doing it on the test. Yes or no? Are you understanding the logic, my people? COLOR is equal to black. Let's take it very simple. I'm not going to do very complicated stuff. I'm just taking it in a very simplistic sense, okay? And you pass in the Y pred values, and you can take the color equals to red. Okay, chalo, simple. I just want to basically plot it off. And let's see कैसा दिख रहा है. Are you see हमारे डेटा पे लाइन कैसे प्लॉट हो रहा है? हाँ, मैंने लेबल ही नहीं दिए तो कहाँ से आएगा? लेबल इक्वल्स टू डेटा, ठीक है, और लेबल इक्वल्स टू क्या है ये? दिस इज लाइन. हाँ, ओके. डू यू सी हाउ अ डेटा runs? We have fit, how good we fit the data. See, it's going exactly in a way which is fitting the data approximately well. We can increase this better. We can make it more better. We will talk about that later. But do you see any difference in how practically we've implemented a linear regression model? We got the R square value. We've just implemented it on a practical data set. I showed you how to download the data, upload the data basically to Jupyter Notebook, how to plot it, check for linearity, run it. That's it. It's no magic. There is nothing fancy that I'm doing that you're doing different. I would have done the same value, the same thing. You need to do it exactly in the same way. Tell me one thing. Can I give you guys a trick to learn machine learning within one day? Can I give you guys a trick? पूरा machine learning एक दिन में हो जाएगा. Can I tell you how? Do you all have laptops? Do you have glass in your house? A glass which is made out of the glass? Okay. Do one thing. Pour water in the glass and take in front of your laptop screen. Whole machine learning book, just scan the glass like this. 200, 300 pages and drink the water. That makes sense? Listen, I'll tell you again. Open a machine learning book, take a glass made out of glass and scan like this, woo, 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 like this, and keep scrolling, but scroll slowly and then drink the water. Suddenly machine learning will go inside your brain. You will just learn everything. How do you think I know machine learning? I do this every day. Do you think this works? The advice I just gave you? No, right? So don't you think practice is the actual true thing with which you can almost get machine learning? To become a beast in machine learning, you don't need to be good. You just need to start and then you will become good eventually. Yes or no? When I started machine learning, you think I was this good in machine learning or natural language processing or Gen AI, or the community, the people know me by my name today, that there is somebody who's good in machine learning. I was like this. No, it was practice. Guys, there is no magic in this world. Please realize this. There is no magic in the world. Let nobody divert you from your focus. You need to practice, and there is no escaping that. If you start blaming, अरे यार, I learned machine learning, but 2 दिन हो गए भूल गया. It's your fault. It's nobody else's fault. And I'm being blunt. I'm being very truthful to you guys.
Just a quick info, guys. Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI, and Power BI. Get a data science certification from IIT Empowertak and Innovation Hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.
You guys understood the concept of regression, what it is, and all of that stuff. But you know what? It still will take a little bit time, a little bit of practice for you guys to become really good at it. Like I'm talking about couple of months, 5 different projects, doing it couple of multiple times on different kind of projects. So your linear regression will become good. But you know what? I have a little something I want to tell you, because we have actually completed linear regression. We've completed the theory of logistic regression. So I have something I want to share with you guys. I have some knowledge. I have some industry information that I would like to share with you that will help you with your interview for sure. I'm not sure if it will help you in your professional career. Uh, I think it should, but I can definitely help you how to ace your interview today. Okay. There is this amazing website which I absolutely love, and I have shared this website with, I don't know, hundreds and thousands of my students. And the feedback that I have received, that when they actually went for the interview, this website helped them a lot. Okay. Now, imagine for 1 second, okay, that you guys have completed all the machine learning from me. Like I have completed all machine learning algorithms for you guys, and you guys are all set. You guys know what is linear regression, what is logistic regression, what is k nearest neighbor, what is k means clustering, what is support vector machine, what is XGBoost, what is t-SNE, what is dbScan. Everything you've done. Now tell me one thing. How do you prepare for algorithms? How do you prepare for an interview where the interviewer is going to ask you in-depth questions? He or she, okay, anybody could ask your interview, would want to understand how good or how solid foundations do you have in it. I have a process which I follow, okay? I call it system, okay? I call it my system. The reason I call it system is because uh, if you think for 5 minutes, great companies become great companies because they have a system in process. Okay. Great personalities become great personalities because they have a system in process. They don't do anything about or outside the system. They have a process. They follow that process like a godly principle. They don't move out from that principle. They are successful because they're consistent and they follow the principle. So tell me one thing. Imagine I taught you linear regression. Tell me one thing. Should you not do its theory first completely well, then do some practical example? But at the same time, don't you think you should study for the interview questions also? What possible interview questions only on linear regression somebody can ask? Just for linear regression, if you prepare for these 3 things, don't you think next jumping on logistic regression makes sense? I'll tell you why. You freshly studied linear regression. You studied the theory. You studied the practical. Don't you think you should know all the interview questions that they might ask? I may have missed on the theory, but I now know they will ask, and you're prepared. Then jump to logistic, follow the same exercise. Theory, practical, the interview questions they will ask on logistic. Then go to K nearest neighbor. Theory, practical, the interview. What will happen is you will not be worried that the end of the session, like once you're done with machine learning, you have to go back to do interview questions. And you know what? Let me tell you one thing. Acing your interview is like gambling. I'll tell you why. The more better gambler you are, the bigger bets you've made, the better chances you will get in, because it's all about luck. Okay. Coding you can do, but the theoretical questions and the interview questions, everybody asks the same. Nobody's going to ask you to make a k nearest neighbor from scratch, to make a linear regression algorithm from scratch. That's not how interviews are conducted. They will ask you questions and there is a probability to the questions. Oh, this question might come, this question might come. So I have a small website I want to show you. Okay. It's called devinterview.io. Okay. Here is how it works. Imagine you are doing machine learning. Okay. Under machine learning, you have a topic called, let's say, logistic regression. Where is logistic regression? Let me say logistic regression is here. For example, do you see all the asked interview questions? What is logistic regression? How is it different? Describe the maximum likelihood estimation and how it applies to logistic regression. How do you evaluate a logistic regression and a model's performance? How do you explain feature engineering that can impact logistic regression? What are the some best practices of data processing before you apply to? See, now these questions, you would have never got it unless you would have been asked this question 5-6 years down the line. But now knowledge is your power. These questions, you know that they ask in interview, and see, all these questions are there. Does that make sense? You can actually select topic level questions if you want to here in this particular website. So if you want to go to pandas, if you want to go to linear algebra, if you want to go to, I'm very sure there will be linear regression here somewhere, classification algorithm, anomaly detection, all that stuff that you want to study, that you want to give your interview for, you have a resource here. So my recommendation is, before you start applying for companies, follow this website, take all the question, learn through all the questions, and you're done. You're sorted. I hope everybody got the gist of what I'm trying to talk about. Again, let me reiterate one thing for you. This is a paid site, but you don't have to pay money. Okay. Imagine you have a question with a lock symbol. Do you see this lock? You see this lock on the right hand side before question? This lock means you have to pay for it. You actually don't. Do you know what is Claude? Have you heard of something called Claude? Okay. Here is what you need to do. Copy the question. Okay. Describe methods for selecting a threshold for logistic regression, whatever that thing is. Copy the question, paste it in Claude. Claude is like GPT, Chat GPT, but better than Chat GPT. Okay. Claude is this tool, this website, which is better than ChatGPT. So what happens is you don't have to pay for anything. The answers are same. Copy this, paste it there, and see what answers it generates, and then learn about it. Done. That's it. You don't have to pay for anything. Get it? Pay no money. We are Indians. If there is one thing we take proud in, is we are effective people. We know where to spend money. We know where we don't have to spend money. Okay. That is one thing that I think we are the only people in the entire globe who can do this well, right? So don't spend money unnecessarily. Don't need it. Okay. But this website is incredibly amazing. You have to use this website. It's really nice. I really liked it. I keep suggesting this to my folks a lot of times since I've seen since the website grew, right? So let's follow this now. Tell me one thing. How many of you remember in logistic regression, we are not fitting a line, but we are fitting something called as a curve or called as a squiggle. That is nothing but 1 by 1 plus e to the power of minus z. This z is nothing but m1 x1 plus m2 x2 plus c. Does this make sense? Do you remember that we have a line equation? That line equation, what we do, we try to fit in a squiggle. Do you remember? I'm just revising the concept of logistic regression for you. Initially, the logistic regression data might look like this, right? The data looks like this. Now a line cannot fit into it. So what do? I convert that all the entire line into positive and negative infinities. I fit a line. All the data points fall into the same line, right? And that, what do we do? 1 by 1 plus e to the power of minus z we apply. What happens? A squiggle is fit. that fits all the data point properly. Yeah, this is the flow of the logistic regression code or algorithm, not a very complicated thing. But now let's look at it practically. Shall we? Okay. Before I actually do that, I have couple of questions I want to ask you. Okay. Point number one, I have couple of questions I want to ask you. They say, right, before jumping into the topic, first you have to have your headspace clear. Like I'll give you an example. When I started doing MMA a while ago, right, it took me 2 months to even start punching the bag. For the first 2 months, they made me do workouts, which was uh, all warm-ups. For 2 months, I was dying to make my first punch on a punching bag, but that never happened. The reason is you have to first get your headspace clear before you jump into the actual stuff. You guys tell me one thing and tell me one thing very clearly. In logistic regression, okay, or any machine learning problem that you're ever going to get in any organization, tell me, will you not do this in your practical career that whenever you have a data on and the problem statement is either classification or regression, first you need to understand whether my problem statement is a classification problem or a regression problem. Example, it's a classification problem. So for the same data, won't you apply multiple algorithms at the same time? You will apply logistic regression also. You will apply support vector machine also. You will apply XGBoost also, decision tree also, random forest also. Suppose you've implemented all these algorithms, won't then you decide which algorithm is performing best and select that one? This is how the industry works. This is the reality of the industry. You as a data scientist will be given a data. Correct? You're not going to apply one algorithm one, then second algorithm second time, then third algorithm third time. You don't have enough time like that. You have one data set, you apply all the algorithms at the same time which you think are good and select the best one out of them. Yes or no? Agree? But how do you decide which one is best? Support linear regression, sorry, logistic is best, support vector machine is best, XGBoost is best. How do you finalize? Don't you need some kind of an evaluation? Don't you need some kind of an evaluation? Oh yeah, I think this is good. But what? Do you prefer accuracy score, F1 score, AUC ROC score? We don't know. You don't know. So let me tell you one thing, guys. In linear regression, we decide the model is performing best on terms of root mean square error. Yes or no? If my root mean square error is lower, I'm saying it is good. But in logistic regression, specifically classification, there is a concept called confusion matrix. How many of you know what is confusion matrix? Okay. Let me help you understand. Is this visible? Is this visible to all of you? Now listen to me very carefully. Imagine there are two actors in a movie. I am about to play a movie in front of you. There are two actors. Actors are very simple. One is a doctor, other is a patient. Okay. One is a doctor, other is a patient. Imagine a girl walks into a clinic. This girl is actually pregnant. In reality, in truth, in all the truthness, she's pregnant. The doctor says, hey, my diagnosis is you're pregnant. So is this a good thing the model did? This is a good thing the model did, right? Or the doctor did. Forget model, doctor. The girl had a reality. The doctor also said the same thing, the same reality. The both sentences are true. The girl was pregnant. The doctor says, yes, the diagnosis is you're pregnant. In machine learning, in specifically classification problem, this is called as true positive. When something was really true, you predicted it to be true. Good thing. Chalo, very nice. Now, the girl in reality is not pregnant. She's not. The doctor says, don't worry, you're not pregnant, you're not carrying. Isn't this also a good thing? The top example was a positive example, but the bottom example is a negative example. She is not, the doctor says, don't worry, you're not. Isn't this also a great thing that the model does or the doctor did? This is called true negative. So true positive and true negative are all the labels which were predicted correctly. Yes or no? If something was 1, my prediction is 1. This is called true positive. If something was 0, I predicted it 0. This is true negative. So tell me one thing. Higher the true positives and true negatives, better is the model's performance. Yes or no? Agree? Yeah. But where do we go wrong? Where do we mess up? We mess up in type 1 and type 2 error. Example. A guy walks into a clinic. This guy is, of course, not pregnant, correct? But what does the doctor predict? Hey, you are pregnant. The reality is the guy is not pregnant, but the doctor's diagnosis is you're pregnant. Isn't it the reverse case? When the guy is not pregnant, the prediction says you are pregnant. Isn't this what we call false positive? Did that make sense? You were not 0, but you were predicted 1. 0 and 1 opposite cases. Ulta 0 ko 0 hona chahiye tha, but 0 is 1. Not good. This is called false positive. This is what we called as a type 1 error in the program. What do we call this? Type 1 error. False positive error. It's also called as false positive error. Are you clear? Very nice. What happens in the other scenario? The girl is actually pregnant, but the doctor says, no, you are not pregnant. Isn't this also the reverse case? The girl is label number 1. Your prediction is label number 0. Opposite case. Isn't this false negative? Yes or no? Did you understand the concept of false positive, true negative, false positive, and false negative? Did you guys get the concept of what confusion matrix does? Can I show you guys an example of confusion matrix? Let me show you an example of confusion matrix. Now listen to me very carefully because you're gonna love this fact. Okay, give me 1 second. Copy image and paste. Give me 1 second. Yeah. Look at this particular graph. Okay. Do you see actual versus predicted? Can you see this? Actual versus predicted. This is actual. This is predicted. Yes. Can you see? This is an actual no. Matlab 0. Actual yes meaning 1. Actual no meaning 0. Actual yes meaning 1. What is 50 plus 5? 55. Can you see downright? If you sum them, 50 plus 5 is 55. Okay. 100 plus 10 is 110. Now add them sidewise. 50 plus 10 is 60. 100 plus 5 is 105. Let me tell you one thing. In confusion matrix, there are certain things you need to know. If you add 50 plus 10 plus 5 plus 100, all 4 values will be the total data set size. Try adding it. What is 50 plus 100? 150. Plus 10, 160. Plus 5, 165. Did you get it? If you add all the values of true positive, true negative together, that is the actual size of the data. In this part, what did the model do correct? See, no ko no bola, so this is good. Yes ko yes bola, so this is good. No ko yes bol diya, this is bad. Yes ko no bol diya, this is bad. Are you clear? This is where your model is doing bad. Are you clear? But this is where your model is doing super good. This is how you evaluate the model. The first thing you are supposed to see in a classification model is this. Ye kitna hua? Your maximum amount of number. The bigger numbers, 80-90% of the number should be in this range. As itne mein hone chahiye. Heavier data sets or heavier number should be on this part. Only minimum number should be on this part. That is when you can say your model is done good. Are you clear? Let's learn something super critical. If you forget this, then you may as well forget your career as a data scientist. Okay? Because it's not going to help you grow. Let me tell you what that is. Give me 1 second. I want to show you guys something. Give me 1 second. I'll show you guys an example of precision and recall. And I'll tell you why am I doing this. Right here, nice. You will also understand why am I doing this. अब आपको bigger goal, bigger picture समझ में आएगा. Why am I doing what am I doing? Okay, hold on. Guys, now that we've talked about what is a true positive, true negative, false negative, your story does not end there. Actually, your story begins there. That's Bahubali part 1. I'm still about to teach you Bahubali part 2. Listen to me very carefully. True positive, true negative, false negative. Okay. Whenever you take, see guys, listen to me very carefully. True positive by true positive plus false positive. If you come down like this, TP by TP plus FP, that is called as what? Precision. How precise was your algorithm? How good, how precision, how much precision your algorithm had? Okay. You have also something called recall. Do you see this? TP by TP plus FN. TP by TP plus FN. Can you see this? TP divided by TP plus FN. Do you see this? It's called sensitivity. People call it recall also. Do you see this? TP by TP plus FN. Actual versus predicted. Yes, that's correct. Okay, listen to me very carefully, and you will understand something in a sentence, in a sequence. Have you guys worked on something called arithmetic progression, geometric progression, and all of that stuff in your mathematics class? Do you remember learning one of the rules? Have you done something called Tn is equal to a plus n minus 1 into d? Nth term find करने के लिए a plus n minus 1 into d. So you will have a t of nth sum of nth was something different programs here. Do you remember the rule they taught us in arithmetic, geometric progression, harmonic mean, harmonic progression, and all of that stuff? And that rule was the one that you want to find always comes in the numerator with the total value. Listen to me very carefully. You want to find out all the positive numbers that you predicted from the overall algorithm that were okay. I'm about to go a little bit mathematical, okay? So I want you to just focus of what I'm trying to say, okay? So that you guys understand what I'm trying to say. How many actuals are actually actual? Only the true positive are actuals, right? The one that were true, I predicted it true. Yes or no? False positive is the positive ones, but are wrongly positive. They are not true positives. They are falsely positive. Yes or no? Okay. Imagine from the 300 data set, from the data set of 300, you predicted 190 correctly. All the 190 truths were predicted truths correctly by you. Okay. Divided by this 190 plus what are the other wrong ones you predicted as false, predicted as true, galat say maybe 20 more. Do you understand when you divide the actual value by the total value, you get a probability value, a percentage number? Does that make sense? The actual ones divided by the actual and the false, all the total, मेरे को नहीं फर्क पड़ता है, false है, correct है, नहीं है, but the total one that you divide, that you get a probability value, that overall how good you did with positive numbers only. All the positives were how much percent positive? Did that make sense? Every formula that you see here, precision, accuracy, specificity, sensitivity, recall, they are all very logical. If you just sit and listen, if you look at the code, everything will start making sense. Are you clear? Logically, ये जो 300 data set है, won't it be divided in 4 different parts? True positive, false negative, and true negative. But I am only considering TP by TP plus Fn. So why should it be 300? So the 300 data points that you have, they will be distributed as either true positive, false negative, false positive, true negative. So I am only considering the positive sample. So that's why I showed you an example. It doesn't need to be equal to 300 or lesser than, I mean, it will be always less than 300. Have you heard of a concept called AUC, ROC, my people? The full form is called area under curve, receiver, operating, characteristic. Now remember one thing, my people. We may believe that precision, recall, accuracy is the final score. No. There are 2 more things people will ask you in order to do that. Okay? There is 2 more metric that you need to understand. One is called Cohen's kappa Okay, I will not talk to you about Cohen's kappa. You know what? Let's ignore Cohen's kappa for now. Let me tell you what AUC ROC is. Do you see this curve, this graph? Okay. In classification, whenever you want to show your output to the management, will the management understand all the mathematics, precision, recall, true positive, true negative? Will they understand? People who've done MBA, people who are CEO, CTO kind of people, they only care about business. They don't care about technology. So tell me one thing, will they listen to you? When you say, sir, I got a Cohen's kappa score of 0.86, he's like, क्या बोल रहा है भाई? English में बात कर. Right? They will not listen. So one of the biggest problems we data scientists face is also to make sure to convert a technical concept into a very simple concept and tell them, we are choosing this algorithm because it is performing best. Agree? To help your life make much more easier is a concept called AUC ROC. Okay. So we need to present that topic to the management. Remember one thing, and this is your interview question. I can tell you with 110% guarantee AUC ROC is going to be asked in any classification problem. Aapko logistic regression they will ask. I don't care what classification they will ask. They will ask you what is precision, what is recall, uska formula पूछेंगे, what is AUC ROC. ये question तो 100% guaranteed है, and this question is also relevant to your practical life. See, my people, AOC ROC score is a very simple score. You have a false positive rate and a true positive rate. False positive rate is a formula. Okay, let me false positive rate. Do you see this formula? False positive rate is false positive by false positive plus true negative. FP by FP plus TN. This is a false positive rate. Now, what they do is basically they plot false positive rate divided by true positive rate. We will get this lines, we will get these algorithms. Imagine you've implemented multiple algorithms. Okay. Whichever algorithm, can you see this red dotted line? The red line, the dotted line, red, 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 red. This is called as a random classifier. It means even if you close your eyes and select randomly, this will be the best output you will get. This random line. From this line, from this red line, how much ever farther your algorithm is in curve, that is the best algorithm. Are you clear? Suppose you implemented algorithm called logistic regression, support vector machine, and XGBoost. If your logistic regression curve is the farthest from this thing, you are proving once with accuracy you've proved, but again, you're proving with a graph that this is the best that the algorithm can do. This is the best algorithm among all algorithms. Are you clear? Nothing is higher or lower. Can you see the area it is covering is higher than all other areas? Are you clear? See, the algorithm that is farthest from this red dotted line, the algorithm which is farthest from this red dotted line, won't the farthest algorithm cover the highest area? That's why it's called area under curve. So the farther the algorithm is, the more area it covers, the better precision, recall, true positive, true negative it has. The better confusion matrix this algorithm had. That is what it proves. Are you clear? What does a random classifier means? Random classifier means one को randomly 0 या 1 डाल देना. Randomly. If a true label is 1, randomly putting a 0 or 1 using a random function. That is called random classifier. Are you guys clear? Did you understand the concept of confusion matrix and AUC ROC score? Okay. Can we jump into some practical aspect? That will make our life more awesome. Okay. In order for us to even jump into the practical example, what do we do good or what do we do first that we even start doing something? What do we do for that? Don't we import some libraries? Like for example, import pandas as PD? Yes or no? We also do matplotlib. Import matplotlib dot pyplot as? Yes or no? I've imported all the relevant packages that I needed. Okay. I have a very awesome data set. It's called HR data set. Okay. I'm going to show you how this data set is. Can you see this thing called df.head of 5? Yeah. Do you see this data in front of you? Listen to me very carefully. Before you become a good data scientist, become a good listener first. Okay. Very important. Before we even become a good data scientist, let's become good in listening and understanding and comprehending and reading. I am somewhat representing an HR data, human resource data, correct? I have every employee's satisfaction level, the last evaluation, how much percentage he got, the number of projects the guy did, the average monthly hours he has performed, the time he spent in the company, the work accidents or any fault he did, he left the company or not, did he get any promotion in the last 5 years, what department he worked for, and was his salary low, medium, or high. This is what the data represents, yes or no? My data represents very simple things like, Bhaiya, what is the satisfaction level of the employee? What is the last evaluation? What is the number of charge? Listen to me very carefully. Do we have the guy's name? Do we have people's name? No, it does not matter. This is what I want to tell you guys. In data science, you don't care for individual person, but collectively the results. Are you clear? So your name, sometimes your age won't make much of a difference. Your phone number, absolutely worthless. Okay. It's called PII. Personally identifiable information. If you work for a banking company like me, that information will not be even visible to the most senior data scientist. I have it, but some of the most senior data scientists also will not be able to see the PAN card number of the loan account holder, the PII information like Aadhaar card and all of that stuff. It is a very secure environment. You can't look at even the client's data. So you will have such restrictions. But in this case, we don't have a restriction, and we don't even need the name. So what is the first thing that you want to do? Don't you want to know how long the data set is? How many people are we analyzing for? So when we do df.shape, what do we know? There are 10 columns and almost 15,000 people. Yes or no? If you look at this record, if you look at this data set, one thing will be amazing. Don't you think the most important part for any company is how many people left the organization, how many people are with the organization? This thing in machine learning or in actual analysis is called attrition analysis. Have you heard of it? Have you heard of it? Attrition meaning if 100 people were in a company, 100 people were in a company and 5 people left the company, attrition rate is 5%. People who left the company that year is 5%. It comes under HR analytics. So we are basically doing attrition analytics using logistic regression. So you just have to focus. Are you clear? I'm teaching you attrition analysis using logistic regression. But we will do EDA also, exploratory data analysis. We will see what the data is, how the data is. We'll try to match, we'll try to make sense of the data. यार 15,000 record एक देख सकते हैं क्या? Can you see all the 15,000 record at once? नहीं ना, नहीं possible है. So we'll have to see through some data visualization. Okay. Because we are doing attrition, aren't you interested how many people actually left the company? So can I say left the organization is equal to df of df dot left? मतलब जो people who've already left equal to 1. For all the people who've left 1. So I will say left dot shape. Okay. How many people have left? Did I do anything? Do you know that in pandas, indexing cannot happen outside the array? Matlab, it cannot happen outside, right? It happens only inside, right? See, even people like us make this, and we end up making mistakes like that. How many people actually left the company out of 15,000? 3,571 people left. That must means, just for example, I know it's a very simple math. How many people did we actually retain? So can't we say df of df dot left equals to 0? And I can say retained dot shape. Yes. So tell me one thing, 11,428 are the people. How much is the percentage of attrition rate? What is the attrition rate formula? Should it be retained by left into 100, retained by total into 100, left by total into 100? How should I calculate attrition rate? Tell me that. How do I identify how much percentage people left? Number of percentage people left shouldn't it be with respect to the total people we had? Left divided by, okay, 14,999 into 100. Is this not the formula? Oh, yeah, of course. What was the formula for left? 3571. Shouldn't this be the formula? Whenever you calculate attrition, don't you calculate attrition on overall people and not the people who left? Making sense? So tell me one thing. What is the first understanding? What is the first data analysis that you did? Hey, 23% people left the organization. 23% people left the organization. PEOPLE, people left the organization. Left the LE LEFT. Left the org. Arey, yaar, I hate my Mac keyboard here. Left the org. What does this tell you? Point number one, it's a toxic company, leave. Agar 23% people are leaving, you should also leave, right? There's no harm in leaving because your managers are going to come behind you begging and with the hands folded and say that, hey, mere se galti ho gaya. Bhari mistake ho gaya, right? But it's okay. We're just giving them analysis. So it's our job to give them analysis. 23%, almost 1/4 people left the organization. That is your first analysis. Are you clear? Okay. If I write this, will you understand what I'm doing? Will you understand what I'm doing here in this part? I have done group by. Do you understand? Okay. Listen to me. If you don't know what is pandas group by, I'm so sorry, but you are missing out on a lot of stuff. Okay. You know there is a clause called group by in SQL. Exactly the same happens in pandas. No difference. Same. Group by based on the categories. We have only two, 0 and 1. And I am group buying basis on the people who left. That's correct. Now see, people who left the company, did you see that they had lower satisfaction level on average? On an average, people who left the company had a lower satisfaction rate. So did we now know that people who left the company had on an average a lower satisfaction rate? So this is a good variable to look out for. The last evaluation, what they did, and the evaluation for the people are almost same. So evaluation has nothing to do with people leaving. Yes or no? Making sense? The number of projects that were given to people who left was considerably higher with the people who are not leaving. So the work stress is also adding up. The more projects we gave to the people, the more chances are they left. See, this is only 3.7 and this is only 3.8. Now, please don't be stupid and tell me, sir, only 0.10 ka farak hai na. It is a mean. It's an average. Doesn't mean कि only 0.10 काम दिया है. नहीं, ये mean है. इसका मतलब somebody got work extra harder and somebody got work extra softer. Somebody who got softer decided to stay. Somebody got more work, he left the company. So be very smart. This is dot mean. Don't look at percentage value or 0.10 value. Look at it's an average. So there will be a range. Yeah, so are you understanding what I'm trying to say? Am I logically making sense? 0.10 मत देखो, average देखो. 15,000 का एवरेज है वो, एक एक बंदे का 100 होगा. Okay. Tell me, the average monthly hour worked by the person who left is higher than person who. इसका मतलब ये है, the person who was the most worked is the person who left. They made a person work so much that he left. Isn't it a very important insight? Aren't you giving this a beautiful insight that the more overworked the people are, the more chances are they will leave? The time that they spent in the company is also higher. Can you see? The people who did not leave on an average spent only 3.3, and the people who actually left have on an average spent more time. Make sense? What about work accidents? People who left had the lowest amount of work accidents. And do you see one of the main criteria is because in the last 5 years they were not promoted? Is it not logically making sense to you in your brain that people were not promoted? They are working extra long hours. They have had not work accidents, which is positive. They're spending more time in the company, yet their satisfaction level is low. What do you think they'll do? They'll take a thali and they will do puja of the CEO, or do you think they will drop the paper on the face and leave? Of course they will leave. But we just proved that with analytics and only one line of code. Do you see? Do you now understand? You don't need a longer code. You just need the right functions to help you understand what it is. Are you guys understanding what we did? Satisfaction levels are considerably lower for the people who left the organization. You can even write it down. See, you can write it down. Analysis number one, analysis. Number one, satisfaction level is low for employees who left. What is the second analysis, my people, that we can give? Number of projects were considerably higher for employees who left. Yes or no? Acha. Analysis number 3. Average monthly hours were kitne percent higher? What is 199 divided by 207? What is that percentage? You have to tell the management percentage. You can't give numbers. Kitna percent higher hai that these guys are working? Did you understand? Or are you calculating, my people? From 199 to 207, what is the difference percentage I'm asking you? How much percentage? Let's just take, for example, maybe 5% higher. Okay, 8%. Chalo. 8% high than non-leaving or retained employees. Do you understand? You now have a percentage value. You are telling your management that, bhaiya, people who are leaving are overworked 8%. Isn't that amazing? So the management knows that, yaar, the amount of people who are leaving are getting overworked. 8% overwork ho raha hai. Right? What is the fourth analysis? Promotion in the last 5 years were considerably higher for employees who left. Okay, for employees who left. For example, this is your analysis. You're done. Acha, now that we are done with this analysis, now I want to visualize few things. Okay, I want to visualize how certain things reacted in a certain way. What was the impact? So let's try to understand something like that. What was the impact of salary on retention? Okay, so first of all, I just recently broke my keyboard. Okay, I had a very good keyboard. I have a habit on typing a very long distance. So the keystrokes have to go long distance. That's where I feel fun. The MacBook keyboard that I have is 1 mm, 3 mm maximum depth. So I always end up making a typing mistake. I apologize, but what to do? What can I do? You have to live with my spelling mistakes. भावनाएं समझो हमारी. हम बताना सही चाह रहे हैं. I want to teach the right thing, but in the wrong spellings. I am the sorries, but क्या करें बताओ? ठीक है? Learn to live with it, or put this in chat GPT, they will fix it for you. ठीक है? Now getting back to the topic. Okay, so have you heard of something called crosstab? Have you heard something called crosstab? I want to compare the salary with the people who left, but I want to plot. But what kind of plot I want to plot? I want to plot a bar plot. अब आप एक मुझे बात बताओ. Cross tab का मतलब, the meaning of cross tab is take one data, take one column, take another column, combine the columns together and read them side by side. That's cross tab. Are you clear? Taking one column, taking another column and reading two columns side by side. It gives you more clarity. Now listen to me. What is the impact of salary on employee retention? We saw that, of course, satisfaction lower level hoga, people will leave. Number of projects you will give them more, people will leave. Average monthly hours they are doing more, people will leave. Promotion in the last 5 years not done, people will leave. But what about salary? Isn't that also a main criteria? People who left the company. So salary is divided in 3 range, correct? High, low, and medium. Among which category of salary people left the highest? Isn't the people who had the lowest salary left the highest? Can you see this? The orange is the people who have left for the salary low. Did that make sense? People who had lower salary are the highest to leave. Aren't you going one step deeper? People who have medium salary did not leave considerably. People who have high salary, the attrition rate is the minimum there. So more money you pay, they ignore how much you're giving them projects, how much satisfaction level you have, how much work accident, how much promotion. If you give them good salary, people are usually tend to not leave. Does that make sense? Because the attrition rate in the highest salary is the lowest. And the group by that we did was a mean, right? That means this must apply to everybody, right? Average value, they are almost average, they have worked out too much, they have not been promoted. So it must also apply to the high people, right? The high salary people. But see, the attrition is rate. So that means paisa bolta hai. If you give good money, people are deciding to stay because you're paying them according to the value. Did that make sense? Okay. Now, let's do one more example. Okay. PD.crosstab. Acha, aap log, by the way, you guys should do it however you feel like, but I want you guys to try this out, okay, on your own, because you guys will love this. If I want to do dot plot, okay, kind equals to bar, what will this tell me, my people? Won't this tell me what department most people left in? People left, we know. But which department was the most affected department? Which department people decided to leave more? Is it surprising for you that they left sales? Because people who work in sales know it's a very terrible job, right? Sales job has a terrible aspect to it, right? You have per month, you have a target to achieve 100 people should have been converted. You will get 5% commission on sales. So what is the first department that was the highest, which is the lowest attrition department among all? Management. Can you see? Management, not HR, management. Can you see? Management सबसे छोटा है. R&D and management is the lowest because that's where the pay is high. How can you do it? Can you not do PD.crosstab of department and salary? Yes or no? Did you get it? If you do PD.crosstab of department and salary, won't it tell you which department gets the highest money? So won't that give you an idea that why people are retained? Are you understanding how analysis is connected to each other? You guys got the concept of what I'm trying to say, right? Okay. From all the analysis that we've done, can I say that satisfaction level is a very important variable? Satisfaction level from the group by function was a very important variable. The average monthly hours also was an important variable that caused a change in the algorithm, that caused a change in people's perception. Okay. Can I say promotion in the last 5 years was also an important category? And salary, of course. Salary to bhaiya is the most important. So rather than taking all variables, can I just take these four variables as one of my main criteria? Okay, so let's do one thing. Let's create sub data frame. Inside this, what we'll do is first we will take something called satisfaction level. Okay, so first let's come here and let's take satisfaction level. Okay, let me copy this. Let me paste it here. Okay, I am not taking all the variables. I am only taking satisfaction level. What is the second thing that we'll take? Average monthly hours, correct? So where is average monthly hours? Average monthly hours. Okay, we will copy this and we will paste it here. After average monthly hours, what do we do? Promotions in the last 5 years that the person has gotten, right? So where is the promotion in the last 5 years? Here, we'll take promotion in the last 5 years. Copy it and we will paste it here. Promotion in the last 5 years. Which is the last variable that we will take? Salary, correct? So we will copy it like this and we will come here and we will paste it. So what did we do now, people? What did we actually do right now? So what we've done is, rather than taking all the variables which are not important for me, I have only decided to take specifically these 4 variables that are resulting in the output. What is your satisfaction level? What is the average monthly hour? And what is the promotion? Everything else is just fog. It is not important for my analysis and I'm not going to consider that. Did that make sense? So far, did it make sense to everybody? I'm only doing logical and I'm doing is as simple as I can. Guys, let me tell you something. Do you see the same data set that you see here? The same HR analytics data set? Okay. I have taught this same data set to data scientists who come with 4 years of experience. I'm teaching it to the same, which is you guys who have very less experience in data science. I can go much more complex in this data set. There's more analysis to be drawn. But at a very simplistic level, you need to understand how you need to get started, right? I am doing this because I know Don't you think you also need to analyze some things more that I may have missed out? I have missed out so much more. Actually, department wise भी मैंने calculate नहीं किया है. You need to do that on your own, but do that. Are you clear? Okay. Now tell me one thing. Can I feed this data directly into the machine learning code? Can I feed this data directly into the machine learning code? Can I just like put this in, push it in, and the answer will come? Why? Why can't I do it? Which column is going to cause me problems if I do that? What column is going to cause me problems? Salary, right? Why salary? What's salary going to do that's going to cause me problem? Salary is a column which is a string type, yes or no? We call it as a text. Does computer understand text? No, sir, it does not. Don't you need to convert text into a number? Don't you need to convert a text into a number, yes or no? So tell me one thing. I am telling you to convert text into a number is a technique called encoding. Yes or no? Yes. What kind of encoding exists? Label encoding. Target mean encoding or mean encoding. Okay. आप बोलो one hot encoding or dummy encoding. I can go on and on यार, मतलब मैं बता सकता हूँ आपको बहुत टाइप के होता है, ठीक है? Huge. Your salary is low, medium, and high. Correct or no? If I convert or make low as 0, medium as 1, and high as 2, this is a problem. Yes or no? You know why this is a problem? Because machine learning will consider 0 as a lower number and 2 as a higher number. So it will give more preference to high. Yes or no? Agree or disagree? The weightage issue will come into picture. Yes or no? So which is the best kind of encoding? One hot encoding is the best kind of encoding. So what is low, medium, and high will become 0, 0, 1, 0, 1, 0, 1, 0, 0. Do you want me to teach you one hot encoding again? How to one hot encode? Okay. चलो, let's do it. एक काम करते हैं चलो. 4 नाम लेते हैं. पुष्कर, अनुज, सविता, अमृता, and let's take one more. Supi. चलो. पुष्पा. ठीक है. Listen. How many variables or categories are there? How many categories are there? 1, 2, 3, 4, 5, 6. 6 categories are there. So your encoding will be how long? Your encoding will be 6 digits long. Okay. So 1, 2, 3, 4, 5, and 6. Okay. So see guys, Pushkar is the first person. Yes or no? 1, 2, 3, 4, 5. Wherever Pushkar, because he's 1, put 1 here. Are you clear? Put 1 in the last. Because Anuj is second, 0, 0, 0, 0. But move this 1 to here and make this 0. This became Anuj. Are you clear? Why not left to right? Sir, आप right to left करो, left to right करो. There is no restriction. Are you clear? There is no restriction. Up left to right karo, right to left karo. Answer will be the same. People usually go from right to left. Are you clear? More algorithms you will see goes from right to left. Are you clear? That's why I'm also following the same pattern. 0, 0, 0, 1, 0, 0. 0, 0, 1, 0, 0, 0. 0, 1, 0, 0, 0, 0. 1, 0, 0, 0, 0, 0. Are you clear? You want to know something funny? Let me show you something funny. You know, you could have written this one hot encoding like this also. You know how? Let me show you. Pushkar is 1, 1, 2, 3, 4, 5. Anuj is 0, 1, 0, 0, 0, 0. Savita is 0, 0, 1, 0, 0, 0. 0, 0, 0, 1, 0, 0. And 0, 0, 0, 0, 1, 0. And 0, 0, 0, 0, 0, 1. This is also called one-hot encoding. Does it look like something called principal diagonal matrix? I'm not sure if you studied this in your 12th standard. You had a concept called matrix. where you have a principal diagonal element to the right, which is completely zero. Actually, principal diagonal actually in mathematics is called this number. All this number na is called principal diagonal. Okay? This is called upper triangle. This is called lower triangle. If you remember, this is what we called I in mathematics. 1001 called identity matrix. If you remember the concept. Is it coming back to you, my people? You remember where your math professor used to tell you study math, it'll be important, and you used to ask stupid questions. If I'm going to buy banana, why will I say I need sine 5-degree banana? All that nonsense you must have had in your class. Understand that mathematics is actually important, right? The basic math is actually crucial. We used to make fun of our professors. Array, sir, sine square theta plus cos square theta is 1. We are not going to go to a banana shop and say, give me sine square plus cos square kg banana. Right? We used to make fun of our professors like that. I used to make fun of my professors. But when I started learning machine learning, I actually value my professors a lot because their foundations have made me learn machine learning better, actually. Okay. So, actually value our professors a little bit more. So tell me one thing, the categories that you have, don't you think you need to convert that into a number like this, one hot encoded values, yes or no? So tell me one thing, in pandas, how do you do that? Okay. I'm going to write something. You will have to understand what I'm basically trying to write. Okay. In pandas, we have a function called get dummies. We have a function called get dummies. Okay. So what I'm going to do is I'm going to take the sub data frame that I've taken, all the salary that I have taken from that particular thing, because only salary needs to be converted. And I'm going to make the prefix as salary only. Okay. I'm going to keep the prefix as salary only. This code, what it does is it converts this low, medium, and high, whatever the function is, it converts that. I need to reconnect the data that I just created back into my sub data frame. So can I say df with dummies is equal to, have you heard something called pd.concat? Okay. Sub df salary dummies, if I take it, but once they are added, the data is ruined. Don't you think I need to make it change and say that the axis that you want to connect itself with is the columns? If I run this, what happens is if I run df with dummies, dot head, for example, just say dot head of 5. Do you see that my salary low is converted to 010 encoding? Do I need to explain this code? Salary dummies, pd.get dummies, pd.contact. Get dummies is only and only converting the number low, medium, and high into encoded value. But because it is not directly added, I need to concat it. I hope you guys understood this simple logic. Okay. Let me ask you guys something. In PD, didn't we have a function called pd.concat? But pd.concat do not add row wise. It adds column. It does not add column wise. It adds row wise. You remember? pd.concat function adds row by row, not column by column. Did that make sense to all of you? I hope it made sense. That is why 010 for low is coming. Can you see low is 010 and yeah, okay, good. Fine. I thought that I may need to reiterate the pandas for you guys once again because it is so simple, but Acha, our data set is prepared, but there is still one problem. What is that problem? df with dummies dot. What do I need to drop from this? I don't need anymore. What do I need to drop from this? I don't need anymore. Isn't it salary? Isn't it salary? Axis equals to columns. Or you can also write it once. Does that make sense? In place equals to true. Okay. df with dummies dot head of 5. Dot head of 5. What did I do wrong? Jupyter Notebook has a cache. You remember, right? Tables are all cached in each columns. You need to rerun it once again to set everything so that the cache is updated. You can't run the table again and again. Are you clear, right? Like once you do df.drop, it is dropped. If you go from top only, then it will come back again and drop again. I hope you know this in Jupyter Notebook. If you drop something in the column and that operation ran, you can't drop it again. See, if I run it again, is it not giving me error? Because it is already dropped. The cache is already done. You got the concept. Once you drop something, there is nothing to drop. So if you run the cell again, it will give you an error. That's what I wanted to say. Anyways, yeah, no problem. Is the data clear, everybody? We have satisfaction level, average monthly level, promotion level, salary high, salary low, salary medium. Yes or no? Are you all clear with this? Now tell me one thing. If I want to predict an algorithm, or if I want to make a prediction of the algorithm, don't you need to divide the data into X and Y axis? Sorry, axis bol raha hu main. X and Y different categories. X will be my target, sorry, X will be my predictor variables and Y is my target variable. Yes or no? All the X variable is nothing but the DF with dummies. Yes or no? So if I do X dot head of 5, this is my target variable. Sorry, not target variable. This is my predictor variable. Yes or no? But what is my target? Yes or no? All the people who left, not left, people who left the company. Here, can you see this variable called people who left the organization? This is my target, right? We need to predict, will the person leave or not leave? Yes or no? Will the person, given this prediction, will the person leave or not? That's what I need to predict. So isn't this going to be my Y variable? And if I do Y dot head, actually, I will not be able to run head in this. It's not an array. Yeah, it's not a data frame. But yeah, you guys get the idea, right? Until here, is everybody clear? I have taken my segregation as my X and my Y, my feature variable and my target variable, my predictors and my target, my feature and my target. Are you clear? Okay. Here is where the machine learning starts. From sklearn, what do I need to import first? Dot model selection, import, what am I doing? Linear regression or logistic regression? We are actually doing train test split. First, we need to split, right? X train, what do we do next? X test. What do we do next? Y train, next, Y test is equal to, what do I do here? Train test split, I call, and what do I pass inside it? X comma Y, yes or no? Acha, how much test size should I keep? Let's say 20%. 20% rakh lete hai for simplicity reasons. Okay. From sklearn, if I want to import model, how do I import it? We did that same thing exactly in linear regression model. Dot linear model import logistic regression. Are you clear? What do we do? Model equals to call logistic regression, make it bracket because it is a callable function. We called it. Now what do we do? Model dot fit. Okay. Model dot fit. What do I need to pass? X train, comma. What do we pass in training? Y train. Yes or no? This is what we do. If we run it, did the logistic regression work? Okay. I want to predict a value. I want to predict some number. Say, for example, suppose you have a function called x test. Okay. In x test, you want to take a specific number called 12:13. Let's take this value. A guy whose satisfaction level is 0.61, his average monthly hour is 245. He did not get promoted. His salary is 001 category. If I want to predict for this particular value, whether he got the answer correct or not. So how did we do it? Y test of 12:13. What is the output that we get here? The person has already retained. Can you see it is 0? If I want to do model.predict, what do we pass inside this? X test of this guy, 12:13. Did it give the prediction 0? Actually, the guy did not leave. Our model is also predicting, bhaiya ye nahi jayega. This is what we call true negative. 0. Sahi hai na? I have shown you how to predict also in front of you. How to predict a particular category. See, I showed you what reality it was, 4191. In reality, he did not leave. 12:13 का मतलब है 12th row and 13th row के बीच वाला, मतलब 12th row basically. See, in pandas, if you want to take certain rows, say for example, 14/15. So you see, it gave me only one. Did you get it? But if I do 18, So it will give me 4 actually, correct. 14 से लेके 18 तक के सारे दे दिए. I hope you got it. Did you guys get the concept? From the test set only I have taken the data. I have not created the data on my own. गलत हो जाता. You got it? So if I exclude 18, it will give me all from 14 onwards. If I just take 14, it will give me everything from 14 to the last. Okay. So anyways, just for simplicity reasons, I wanted to teach you this, that see, the model is doing as it's supposed to, right? There will be some true positives, some true negatives, right? That's what we want to predict. That's what we want to get an output for. We need to understand what did our model do good. Now, to get the model accuracy, don't you need to do something called model.score? And tell me one thing, do you need to calculate the true positive, true negative yourself, or the code will do it for you? The code will take care of that for you, right? You don't have to do it. What is the accuracy that we got in our model? Our model is 77% accurate. From all the 15,000 records, 77% of the record positive or negative, I am able to predict. Agree, disagree, my people? Now tell me one thing. Have you seen an accuracy matrix here? The one that I used to tell you, that confusion matrix. Have I plotted that yet at all? Have I plotted AUCRC score? Yeah. So do you think our job is done? No. You need to create another column, another thing called ypred, and that is model.predict. Okay. Model.predict. What do you need to pass inside this? All the X test value, right? The ones that are actually to be frankly predicted, zeros and ones, we need to now categorize. From sklearn dot, does classification not come under matrix? So we have to use something called matrix. Import, use something called classification report. What will you use? Classification report. Specifically start using something called classification report. Just say print classification report of what do you pass when you want to test something? Y test, ypred. Remember one thing. Y test, comma, ypred. If I run this, did we get a precision, recall, and average value? Do you see 79% precision I'm getting in calculating 0 and 0 properly? And 1 is lower. Can you see? All the people who are categorized left, my precision is lesser in that. My recall is much worse in 1. आपको क्या लगा? Listen to me very carefully. You thought 77% came, so my algorithm is performing well. But is it? No. Do you see? You have two categories, right? 0 and 1. You need to do a good job in 1 also, right? दोनों में अच्छा करना है. Not in 1. Are you clear, everybody? Are you understanding me? Let me give you an example. Imagine you're a good husband or a good boyfriend or a good brother. To be a good brother, you need to be empathetic and you need to be kind, but you also need to be very strict, right? Ab you're only and only kind, you're not strict, you don't have empathy. 100% kind you are, but that doesn't mean it's your overall 100%. Only one category or 100%. All three you need to be good at, right? Empathy also, kindness also, but a little strict also. All three. Your classification model gave us 77% accuracy, but that accuracy is only in calculating the people who left. We are very bad, or the algorithm performs very bad in calculating people who've already left or will leave. Yes or no? Can you see our precision is also small? Recall is also small. Does that make sense? Sometimes what happens, one category is so confident that it undermines the other category. You need to make sure both categories are important for you. Does that make sense, my people? Did that make sense to you? Both the categories are important for you and you need to give equal category, equal importance. Okay. I have a small question I want to ask you. Can I? To test your skills. In medical industry or in medical science, is type 1 error more important or type 2 error more important? In medical science, is type 1 important or type 2 more important? Who do they give more focus on? It's the type 2. You know why? Let me tell you. This is actual, this is patient, this is actual, this is patient, this is actual, this is patient, this is actual, this is patient. Not sorry. Doctor, patient, doctor, patient, doctor, patient. Okay. A guy has cancer. Patient also has cancer. Doctor says you have cancer. Did you save this guy's life? True positive? The guy does not have cancer. You predicted you do not have cancer. Did you save this guy's life? Yes, sir. True negative. You saved the person's life from mental trauma, from mental stress. You saved this person. The guy, the patient actually does not have cancer. You say you have cancer, type 1. Did you just make his life a living hell by giving the person stress? But more than giving stress, which is actually problematic, giving harm, right? Patient says actually he has cancer. Doctor says you do not have cancer. Is not type 2 error much worse? So tell me one thing, whenever you're doing classification problem, is 0 more important to you or 1 more important to you? Which is more important to you? That depends on your data. In our data, people who are leaving to identify them correctly is more important than the people who are retained. Yes or no? Did that make logical sense to you? To my logic, I wanted to predict people who are retaining or people who are leaving. I want numbers to be higher and more confident there. If the numbers are terrible in the 0, I am okay. It's okay. I don't want that high answer in the 0, but I want high predict and possibility in the 1. Did you understand? Category wise also you can change the algorithm to give you better output. You are my students, my people. You go to a job, your manager should be impressed by you, that how deeply this person is observing. And this is how you're supposed to professionally work. Whenever, remember one thing, guys, I'm giving you guys a small advice. This is something that you should tattoo on your hand. Whenever somebody gives you a data, never start doing machine learning unless you've understood what this data is, what the problem is, exactly what the question is. Do not start doing machine learning even if you have 5% of doubt. Don't start. Can't start, don't start. Don't do that mistake. Don't be stupid. Unless and until the question is clear to you, the data and the analysis you've done is clear to you, don't start machine learning. 99% of the kids that I work with today, I work with kids from IIT, I work with kids from NIT, I work with kids from VIT, BITS Pilani, BITS Goa, all these people come and work under me. The first thing that they do is they jump into machine learning. I want to do machine learning. I want to do machine learning. They don't even know what the data is. And then they listen very good things from my mouth. And then they come back, their excitement level goes down. And then they start doing it how they are supposed to do it. So point number 1, you have to be very careful before you do an analysis. In our case, can we say we built a successful model? No. 77% accuracy means nothing. Kuch bhi nahi hai. When the actual data point that we want to predict, which is important to us, aren't people who are living catching that more important than people who are not living? So categorizing 1 is more important, but you see the precision is also bad. Recall is also bad. And you know what? This accuracy is not supposed to be seen. You're supposed to see the macro average. What average are we getting? 59%. Did you get it? We are getting a 59% of macro average percentage of the classification algorithm. Are you clear, my people? ये जो macro average है, don't learn about it now. I am telling you guys, you will get confused. Don't give a single anything when you want to do this. Just know that macro average is a much more true reading. Are you clear? Don't care what it is now. Don't read about it now. It's okay. Can we see how AUC ROC is performing? Okay. From sklearn, okay, dot metrics, I want to import something called ROC AUC score. Okay. It's called ROC AUC score. अब आपको समझ में आएगा. You will understand the meaning. Again from sklearn.metrics. Okay. sklearn.metrics. Acha, by the way, I'm telling you this just for fun. Okay. You can import ROC curve directly also here. Comma karke. Comma ROC curve. Because you see, I'm importing from both sklearn.metrics only. You can do it like me. I do it because I like my code to be readable. Do you understand? Whenever I write code, my people, I have a habit. I always write my code in such a way that people are able to read it easily. That's why my codes are a little longer, but they're easier to read. Okay. So you can do it with comma also, but it's up to you. I mean, I prefer doing it like this. It's up to you. I'm going to say logit ROC AUC. Okay. Just because we are using logistic regression. So I'm calculating the logistic regression's ROC AUC curve. Did you understand the full form of ROC AUC score? This is called receiver operating characteristics and area under the curve. That's the same thing. Okay, I'm going to pass in white test, y print. Do you remember I told you that whenever you calculate something, you pass in y-test, y-pred? Same thing. Can you see this? Y-pred model dot predict x test. Rather than calling it y-pred, I can even pass it like this. It's basically y-test, y-pred, nothing else. See, this is y-test and that is y-pred. Model dot predict all the x values of test. Rather than calling it like this, let me call it like this. False positive rate, true positive rate, okay? False positive rate, true positive rate. And there is also something called thresholds, okay? Or you can even write it thresh, okay? Thresholds basically help you calculate, whenever you calculate AOC ROC score, it calculates multiple confusion matrices, right? So we call it ROC curve of passing the value of y-test, same exact thing. What do you think you need to pass next to it? Model.predict x-test. Actually, here you will pass something called predict proba. It's called predict probability. Here what you're doing is you're passing all the x-test value, okay, which is this. But do you know in logistic regression, we calculate something with a threshold? If more than 50% 1, less than 50% 0, we have a threshold set, like for example, something like if it is up to 50%, less than 50% 0, up to 50% 1. Don't we work on that categorization? By default, have I passed any probability to the logistic regression function? 50% ke above 1, ke lesser 0. Did I pass it here? We did not. So what it did is it automatically calculated a probability by itself and it added. But shouldn't we add it ourselves and make the algorithm tweak better? And that is how we will make this one perform better, to tweak the probabilities. That maybe 80 ke upar say 1, less than 80 say 0. Make sense? You guys understanding what I'm trying to say? How many of you actually love Matplotlib, guys? You guys have actually worked on Matplotlib. You guys actually love it. You guys have actually understood what this particular value is. You guys know this, right? Okay. Have you also tried Seaborn? Okay. But to be frank, if you really think the one thing that you're going to use multiple time again and again is going to be Matplotlib much more. Okay. Okay. Now, I have a question to ask you. Imagine I want to draw a vertical line. How do I do that in Matplotlib? Okay. See, I have a graph. I want to plot like a vertical line. How do I do that? Where do I start? What is this called as? Is it called 1, 0 or 0, 1? Okay. If I write it like this, will you understand? Comma, from 0 to 1 to 0 to 1. And I want it to be all dashed. So you can give it like a dashed line. So something like read line dash dash. So do you understand that I'm getting like a dash dash line? Like you can also make it diamond, but like you get it, right? The dash 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 line that you get. Okay. However, or is not done. We'll make it even better. Or you know what? We can even leave it at this. It's okay. I will not make it more beautiful. Do you see plot.legend? Legend. Do you see how our logistic regression is performing? Is it beyond the dash line? Is it beyond the dash line? Is it better than a random classifier? 100%. Do I have any other algorithm I can compare it with? No. But this is my AOC ROC score. The farther it is from the line, the better it is considered. Yes or no? So is this not giving me an output? Yes, it is giving me an output. Are you clear? Now tell me one thing. I need to calculate its area. Okay. To do that, write it here like this. Area equals to, do you know I can write float point values like this, 0.2f like this. If I run this, is it giving me any output here? Is it giving me any output? No. Plot.legend, legend and location equals to best. If I run this, how much area it is covering? 60% of the area. Did you get it? See, 0.59. The area this graph is covering is about 60%. Did you get it? We always prefer the graph with a higher area. I just calculated and show you how to calculate area also. Right there, simple. Did that make sense? See, I've passed in something called logit AUC ROC here. See, ROC AUC score mein, I have just passed in the area that it is covering. That's it. This number is the area, this 0.59. That's what it is. Did you understand? And you know what? No matter what algorithm you implement, the code for AOC ROC will never change. If you take my code, this code, and apply it on any algorithm you want, you have the freedom. It will not change. Same exact code will work. Just the model will change. I want to show you one thing. This is called documentation. Yes or no? The company that created sklearn has a documentation on logistic regression. Inside logistic regression, what have I passed? Can you see? I have passed nothing. It is absolutely empty. But what options do I have? I can pass penalty. I can pass dual flag. I can pass something called C, fit intercept, solver, random state, weight, intercept scaling, worm, number of jobs, L1 ratio. Did I pass anything inside? Are you wondering why I got a bad result? Are you now understanding why we are getting terrible results? Because nothing is tuned. This values that are passed inside, okay, are hyperparameters. What are they called as? Hyperparameters. Now, I will give you guys break for 15 minutes. We will come back and we will talk further on this. And I will tell you what is hyperparameter tuning. You guys will love that concept. And I will also tell you how to make this model better. Okay. Aesthetic. Okay. My people, I have only one question to ask you. Can I explain it from the beginning? Can I do this? Can I run it through once from the top? Here, my people, I've imported all the libraries important for my analysis. Here, I've imported the data, which is in a CSV format. I have uploaded it using pd.read CSV. In pandas, pd.read CSV, read clipboard, read Excel, read feather file, Apache feather, Apache FWF, GPU, GBQ. I use this a lot, Apache Parquet. This is called read Parquet. Super good. Read pickle file, read SAS file, SPSS, SQL. You can even read SQL query. You can even read SQL table. Do you see? So many things are available. XML, JSON, options. Options is something else. You don't have to worry about it. Reading के बहुत सारे options है. I have extracted something called read CSV. ठीक है? I have first decided to take the shape for it. Then what I did, number of people who actually left the company equals to 1. P1 means चले गए. 0 means रह गए, retained employees. I calculated that 23% is the retention rate for the people. A terrible rate, don't like it, no problem. What I did is I grouped by for all the left columns, average 0 and 1, I wanted the mean value. Satisfaction level, last evaluation, number of projects, every monthly hours, time spent, work accident, and promotion. Out of all of this, I figured out that satisfaction level, okay, last evaluation, last evaluation or number of projects or average monthly hours or time spent in the company or whatever that is. Now, shouldn't be a problem, right? I also did something called crosstab. In crosstab, what I decided to do is I also wanted to know, because my common sense tells me salary is one of the biggest factors. So I did a crosstab of salary. The reason why you cannot, can somebody tell me why I had to take salary separately and group by separately? Because you cannot take a mean of string value, correct? Yes or no? If your data set has a department or a column called salary, क्या आप उसका mean ले सकते हो? Can you take a mean of it? Can you do group by? Example दिखाता हूं मैं आपको. How many columns do we have? 10. Can you see 10 columns we have? If I do df.describe, and if I run this, sorry, it's a callable function. Yeah. How many columns am I only getting in the description? Can you see how many? 1, 2, 3, 4, 5, 6, 7, 8. बाकी के दो किधर गए? डिस्क्राइब में, इन्फो में आ जाएगा, डिस्क्राइब में, ग्रुप बाय में, एंड ऑल ऑफ दैट में कभी भी यू विल नेवर फाइंड अ कॉलम विद द स्ट्रिंग वैल्यू, बिकॉज उसका क्या करोगे आप? अंडरस्टूड? कैन यू सी? which is the highest promotion somebody got in the last year. Somebody has gotten 100% promotion. Somebody has gotten no promotion at all. ये भी हुआ है, ठीक है? The highest amount of satisfaction level somebody has recorded is 100% satisfaction level. The lowest somebody has recorded is 9%. Can you see 9%? So you can find descriptive statistics here. Min, max, standard deviation kitna hai, mean, average kitna hai, how much is the average working hour 201. There is somebody in our data who has worked 310 hours. There is somebody in the company who's worked only 96 hours. See, ye bhi difference hai. So when you do describe, you get all this information also. So that is why when I did group by, I did not have the information of salary. So salary I took using a function called crosstab. Does that make sense? I did a crosstab of salary with all the people who left because that is my aim. That is what my intention is. And I got an output which says high, low, and medium with compared to salary. Okay. PD.crosstab, administrative experience. I once thought of becoming an IPS. That's my administrative experience. Once suddenly in my brain, I thought that how good will I look in a uniform? And then I decided that, you know what, machine learning is my field. I cannot be controlled by a politician who is a sixth fail. So I thought after studying so much, after learning so much, after getting so much power, you're still taking orders from a politician who has no idea how the world works. So I thought that rather let me have a manager who knows machine learning to work with it, and working with a politician who may not know what administrative tasks are. So rather I thought that let's not do that. Okay. So when we do PD.crosstab of department and the people who left, we also get how many people left department wise. That is an important analysis for us. What we realized is HR and marketing and management and R&D were some of the lowest. Some of the highest were sales, support, technical, and of course IT. IT is IT infra. I think it is IT. Yeah, IT infra. Okay. Then after creating an understanding of all of this, what I did, I created another data frame. And in this data frame, I had satisfaction level, average monthly hours, promotion, and salary. These are important data sets. These are important features for that matter of fact. What I did from all the original features, I've taken the important features, I've kept them separate. After I've kept them separate, I have taken something called get dummies. Now, remember one thing, one hat encoding is get dummies in pandas, but you can't directly apply because they get concatenated. Row by rows, they get added. So what do you need to do? Once you create them, it creates a number called 010. For example, I should have shown you this salary dummies. Okay, notice this. Can you see it's becoming 3 separate columns? 010. It is not connected to the actual column, which is this, right? Sub df. Yes or no? This is creating a separate independent 3 columns. What do you need to do? Because these are creating 3 independent columns, I need to concat with the sub df at salary dummies, but I want it access not to be row, but columns. So now rather than getting added left by left, it gets added row by row. So basically column wise it gets added because access equals to columns. You can even replace this with 1 or 0. 1 is column, 0 is row. I hope you know you can do this in pandas. Okay. What I did after that is I have taken a separate data frame called df with dummies. From df with dummies, I decided to drop my salary because salary is still a string character. Once everything is said, this is my feature, left or not is my target. The most easiest thing, I've imported train test split, I've imported logistic regression, I fit my model, and I've even taken a record and did model.predict on it. I got a right output on that. The biggest change in the code is at this part. Okay, now please allow me to explain something here. Guys, you must have heard of something called model.predict. It's not a very complicated thing. You must have not heard of something called model.predict probability. Tell me one thing. When you use model.predict, do you not get the output whether it could be 0 or 1? Yes or no? Agree or disagree? But when you do model.predict probability, it does not return 0 or 1. It returns the probability. Then Based on that probability, you can decide output will be 0 or none. Are you clear? This predict probability function prints all the probabilities it has. Suppose for line number 1, the predict, I'll show you. Why not show you, yaar? है ना? Model dot, एक minute, यहीं पे करता है. Hold on. Guys, do you remember I did this model dot predict for 12,13? Then I got the output 0. Okay. Look at this. Model dot predict probability for X test 12,13. What answer did I get? Do you see I am getting probabilities and not the actual output? Are you understanding what's happening here? This is the probability. This is the count threshold. Let's ignore that. Did you get, we got 80% probability that something is 0 or something is 1. Favorable, not favorable. Yes. You guys got the concept, right? Model.predict returns the output. Probability lets you play around with the probability. Whether you want the threshold to be 50%, 60%, 80%, you can change it. If I do 0 of 0, hold on. Is it returning the probability to me? Can I say if model.predict probability is less than or equal to 60 or greater than or equal to 60, what do? Print I am 1. Else print 0. Can I even do this? You got what I'm trying to say? You can tweak the probabilities like that you can set up a threshold like this. Explaining this AOC ROC score, let me make it much more easier for you. The part of import statement. See, this is not me. This is how you are supposed to import. I have nothing to do with it. This is library's work, not my work. Okay. My people, to calculate AUC ROC score, don't I need to calculate AUC, area under the curve? I need to calculate the area under the curve also. This line, logit ROC AUC, using the function ROC AUC score, helps me print the score, help me print the area of the score. For example, let me comment everything out and just print logit AUC ROC. Do you see I am getting the percentage area the model is covering? 59%. What this function does is it tells you how much of an area are you covering. Did that make sense to everybody? How much area is your graph covering? Okay, very nice. Very good. Very good. Observe one thing very carefully. If I take this model.predicts X test and convert it or replace it with Y pred, is it the same thing? Yes, it is the same thing. Y pred Y test, Y pred Y test. It's the same thing. Let's check it out again. Let's say logit ROC score. Same answer. Are you clear? Let's not get confused with anything. Now, what I do is I print another variable called false positive rate, true positive rate, and threshold. If I run FPR, okay, or if I say print, I will say print FPR /n TPR /n and thresholds. Okay. Let me basically copy this and paste it here. Did I write /n wrong? Hold on. Let's see if I got FPR correct first. Yeah, I got it. Right. What is the length of this? Hold on. Let's first calculate the length. Then we will know if we got the FPR correctly. 992. ठीक है. Okay. Comma true positive rate. Positive rate. Okay. And let me also say thresholds. Okay. So false positive rate aa gaya, true positive rate aa gaya, and all the thresholds have also been printed. Okay. My people, let me explain what this is. Okay. Let me explain what this is. To draw a graph, to plot a graph, to plot an AUC ROC graph, suppose if you want to plot it like this, suppose this is my graph. Okay. I want to plot it like this. Don't you think for every line you need a point? Did you get it? Like you need a point in every line. This entire line is of 992 points. And what I did is I connected the lines. Does it start forming like a ROC curve? Did you understand what it is doing? It's calculating AOC, ROC points for X comma Y, X comma Y, X comma Y. See, this is TPR, this is FPR. Let me remove threshold, okay? Let me remove threshold. This is true positive rate versus false positive rate. So 0 comma 0. Okay, you see down at the bottom. Yeah, 0 comma 0 point, 0 comma 0, then 0 comma 0.00 something. Are you understanding? Each row is corresponding to its each point, and that's what we are plotting, isn't it? See, this is what we are plotting. Yes or no? Let me comment it out. Do you see that point itself becomes like an ROC curve? And we take the area under them. I hope that makes sense. What about the red line? See, red line is considered the baseline. Do you see 0, 1, 0, 1 here? This represents diagonality in matplotlib. If you don't know, 0, 1, okay. Here is how you represent 0, 1. In a number line, what is 0, what is 1? What comes first, X or Y? We always do X, Y, correct? So 0, 1 यहाँ होना चाहिए ना? Okay. एक diagonal को बनाने के लिए, to make a diagonal, what property do you need to have to make it diagonal? How do you make a diagonal? You need an equal slope, yes or no? Start point and end point. Okay. अब आप थोड़ा ध्यान दीजिए, अगर मैं इसको 1, 1 कर दूंगा, क्या हुआ लाइन को? Look at the line, right? It's not the X, Y, but it's the diagonal X, Y. So it starts at a different number. Okay? Okay. So far, you guys have learned something called linear regression. You guys have learned something called logistic regression. Guys, do you see this particular thing called logistic regression here? Right here. Do you see this logistic regression here? This part? This logistic regression curve? I have not passed anything inside it. Do you remember we were also talking about hyperparameters of logistic regression? LGBFS, solver, Newton solver, and all of that. Okay. Keep hyperparameters in your mind. Okay. We are not going to cover it now. Hyperparameters, we are not going to cover it. We are just going to sort of go into a little depth on it because here is my plan. You have already learned logistic regression. I'm going to teach you decision tree, after which I'm going to be teaching you random forest. What's going to happen is, how about in practical life, when a data set is given to us, why don't we apply both logistic regression and decision tree and random forest? And once we apply, why don't we hyperparameter tune them and then do the evaluation matrix like AOC, ROC all together? So this makes us make our pipeline as a practical pipeline. Did that make sense? The pipeline that we will learn will be a practical pipeline so that for one data set, we are not taking 5 different data sets. We are taking one data set. On that data set, we apply logistic, we apply a decision tree, we apply random forest, we apply AOC, ROC score, we plot the confusion matrix for each, and we decide which is performing good. If an algorithm is not performing good, then we will apply hyperparameter tuning. I will teach you how to hyperparameter tune logistic regression, decision tree, and random forest together. Are you clear? If hyperparameter tuning does not happen, your model cannot improve. If you are getting 82% accuracy, your 0 and 1 category, only 0 is performing good, 1 is not. Boss, hyperparameter tuning will make both the models well. Both 0 and 1 well. Are you clear? You will be going in balance. So, एक बात याद रखिएगा. Hyperparameter tuning is like that one gun. You just need to shoot once. I don't promote violence, but like, you understand what point I'm trying to make. What I'm saying is, it is that one thing you use, output comes perfect, idhar udhar bhagna hi nahi hai. Okay, so it is an important concept, but hyperparameter tuning is not a very easy concept to learn. Okay, you guys need to learn optimization. You guys need to learn what are parameter optimization, what are significance optimization. What is optimization basically? Ek function hai, y is equal to n, y is equal to 4x square plus 3x minus 2. What is the value of x and y? How do you calculate this? There are 3 methods. Synthetic division. Either you will do replacement method, right? Like for example, 4x square plus 3x minus 2. What is 4 2s are 8? 8 का आप कौन बनाते हो, right? So that the number matches. या तो you have a Sridhara's formula, right? b square minus 4ac by 2a plus or minus root something डाल के. You understand what I'm trying to say? For this equation, what is the minimum number of x? What is the minimum number of y? When you have x square, can't x be two types? X will be of two different, x will have two numbers, right? Which number is the minimum? That is called optimization. Min, max, find karna. That optimization you will have to learn in a different way. We'll learn about it. Don't worry. We'll talk about it. It's not a very complicated thing. Kuch hard word nahi hai. Just it'll take some time. We'll come to that. Don't worry. Okay. Topic that I'm taking you guys through is a concept called decision tree. And let me tell you one thing. This algorithm right here, okay, this algorithm right here is the reason why we have machine learning the way we have right now. This algorithm is an absolute GOAT, greatest of all time. Not that. Okay. This is GOAT, greatest of all time algorithms. The reason is decision tree has resulted in algorithms that are so good, so best that this algorithm performs really well. Okay. Better than logistic regression in some cases. Some cases logistic regression works well. Do not have a preference of your algorithm that I will personally choose logistic as my favorite. ऐसा नहीं कर सकते. Nobody's algorithm could be favorite. You can't do that. Some algorithm performs good in some kind of data. Some algorithm performs in other kind of data. But decision tree is a very good technique. It's a very good concept in machine learning that will make you love the concept really, really well. Are you clear until here? Excited to learn decision tree? I'm going to teach you decision tree in depth, boss. In depth. मजा आ जाएगा. I'm going to teach you decision tree mathematically. Mathematically means we will go till the end of decision tree, do everything mathematically so that you can even replace the whole thing by yourself. You don't even have to worry about anybody else. पूरा in depth सीखेंगे. Cool. Before I jump into this concept, do you remember in physics we had a concept called entropy? Whenever you have a plain glass of water, the entropy will be very less. The impurity in the water will be less, right? 0.0001%. Example. But the moment you put some color into it, what happens to the entropy? It becomes higher, right? Something that was pure is no longer pure. Something which was of same type of water molecules is no longer the same type of molecules. Yes or no? So do you remember that entropy represented chaos? Chaos matlab jhanjat, right? So can I say that entropy is nothing but a measure of randomness? How random is my data? How unpredictable is my data? And what entropy does, it outputs some mathematical number. It returns a number. So that means entropy is a quantitative field, right? It's a quantitative field. It tells me a number with which I can make sense. 0 to 100, 0 to 1000, 0 to 1 lakh, 0 to 2 lakh, some number. I get an idea how terrible my data is, how good my data is, how lesser the entropy, better, higher the entropy, worse. Yes or no? Okay. Can I show you a mathematical example? Everything will make sense. I want to do something for you guys. Let's do this. Okay, give me 1 second. You know I'm a visual teacher, right? So I will have to take examples of visual examples. Elephant ले लिया, ठीक है? Tiger ले लेते हैं. Let's take a nice looking tiger, not a very fierce looking tiger. Okay, copy image and paste. Tiger ले लिया. Oh, what happened? It's not visible. Okay, let's take a giraffe. Okay, let's take a giraffe. This is a good looking giraffe. Okay, copy and paste. And let's reduce the size of the giraffe. Okay, एक monkey भी ले लेते हैं. Monkey I kill. Let's take this looks nice. This monkey reminds me of my sister. So I thought I'll just take it. If she was in the class, she would have killed me, but it's okay. You can abuse your siblings when they are not around. Hold on, let me just take monkey. Yeah, I think I can entropy. I don't want the wider entropy. I can take like a very simple entropy size, but okay, chalo, let's take it like that. Okay. Let's take 2 elephants. 2 elephants should be fine. And 3 giraffes. And 2 tiger, 1 monkey. Okay, let's keep it simple like that so that it becomes more stable. Tiger and 1 monkey. Okay, guys, listen to me very carefully, and I'm about to sort of make this a little expanded. Hold on, give me 1 second. Yeah, my people, this is a zoo. Okay, this is a zoo. If I ask you in the beginning of the zoo, is there a mixture of all kind of animals? It's a mixture of all kinds of animal. More randomness is there. कहीं कहीं भालू मिल जाएगा, कहीं सॉरी कहीं टाइगर है, कहीं monkey है, कहीं giraffe है, कहीं there's elephant, कहीं there's tiger. So there's a mixture of animals. So can I say that my entropy is very, very high? There's a lot of chaos, unpredictability. So many different kind of animals are there. Okay. What if I create a tree like this? COLOR. Is your color yellow? So whenever some animal is sort of added, is your color yellow? Either your answer will be yes, either your answer will be no. Remember one thing, yes is always to the left, no is always to the right. Decision tree is like binary trees. I don't know if you guys know data structures or algorithms, but there is something called binary search trees. In programming languages, we have a topic called data structures and algorithms. We have a topic called binary tree, balanced binary tree, AVL trees, red-black trees. I'm not going to get into that. It brings me a lot of horrific memories. But the thing is, a binary tree, right, has only one node and 2 leaf. So one node is allowed and 2 leaf is allowed. You can't have multiple leaves. Like that is not allowed. I hope you got the idea, like get the concept. So yes and no. Are you yellow in color? Yes or no? Okay. If you are yellow in color, is your neck length, okay, greater than 5 feet? The answer will be either yes, the answer will be either no. Okay. And here we can say that is your size greater than 30 or not, or 30 kilograms or whatever that example is. The answer could be yes or no. Now for 1 second, imagine I want to take Mr. Giraffe. Okay. I want to take Mr. Giraffe. Mr. Giraffe will come in the beginning. Is Mr. Giraffe yellow? It will come to here. Is your neck length greater than 5 feet? Yes, Mr. Giraffe came here. So, what's that? Control copy, Control V. So, Mr. Giraffe came here. Again, let's randomly take Mr. Elephant, okay? Or rather, let me do it like this, okay? Let me take a copy of them. हाँ, ठीक है. अभी करते हैं. Mr. Elephant. Is your color yellow? No. It will come to this side. Is your size greater than 30? Yes. Elephant came and sat here. Correct? Mr. Giraffe. Is your color yellow? Yes. Is your neck length greater than 5 feet? Yes. Mr. Tiger. Is your color yellow? Yes. Is your neck length greater than 5 feet? No. Mr. Tiger. Is your color yellow? Yes. Leg then fine? No. Mr. Monkey. Is your color yellow? No. Is your size greater than 30? No. Mr. Giraffe. Is your color yellow? Yes. Neck length 5 feet? Yes. Mr. Elephant. Here. Mr. Giraffe. Here. Did I just segregate each animal very nicely and neatly depending on the tree that I just made? A decision tree that takes the whole output in a relevant direction? Point is not that. Point is, from the beginning of the class, entropy, is my entropy now little lesser that at the end of the each tree, I have a very pure, same kind of personality or object in the each end of the class or each end of the category. So did I, from increasing randomness to decreasing randomness, did I make a decision tree? So my entropy just decreased. Does that make sense? Did that make sense to you? Okay. Can we learn this a little mathematically? I'll show you an example. See, guys, the formula for entropy of a class S is a class is summation of for data point number 1 all the way till all the classes minus probability of individual class to log to the base 2 of each class. Now, you know what? This formula may not make so much sense for you, but it's about to make so much sense for you now. Listen to me carefully. Is there a negative sign in the outside of the this thing? Minus pi. Take it outside. Put it outside. Like take it outside. Put a minus sign here. Okay. How many giraffe have you seen in this example? Or let's start with elephant. Let's start with elephant. How many elephants? 2. Total number of animals are how many? How many are total animals? So minus of 2 divided by 8 log to the base 2, 2 divided by 8. Plus, how many giraffe? 3 divided by 8 log to the base 2, 3 divided by 8. Plus, how many tiger? 2 divided by 8 log to the base 2, 2 divided by 8 plus 1 monkey. So 1 divided by 8 log to the base 2, 1 divided by 8. Okay. So you will get a number called 5.8, something approximately. Okay, I'm not claiming it to be the right number, something I remember because I've taught this example. So my entropy of the class for all the groups will be how much? 5.8. But by the time I calculate only for this class, won't my entropy be 0? Because ये तो सारे जिराफ ही हैं. कोई chaos ही नहीं है, कोई randomness. There's no randomness. So do you understand that my initial randomness was 5.8? Almost I made it to 0. Did you understand the concept of entropy? What are we going to do? How are we calculating it? What is the formula? You got the concept? You guys got the idea of what the entropy is, right? Yeah. Remember one thing. Entropy is quantitative. It means it always gives a number. Entropy is a measure of randomness or unpredictability. Did you guys learn how to calculate the entropy? Yes or no? Tell me one thing. Is elephant not a separate class? Is giraffe not a separate class or a category? Is tiger not a separate class? Is monkey not a separate class? Now are you able to relate with if you want to predict classes and categories? Multiple categories means that many entropy will increase. Is it making sense? 0 category, 1 category, 2 category, 3rd category. See, my people, I've taught you a concept called entropy. Do you know that in order to learn decision tree, there are 3 things you cannot survive without? And you know what? Machine learning mein aap survive nahi kar paoge if you don't know this. Point number 1 is called entropy. I have already taught you this. But point number 2, which is super critical, they ask in the interview question, everybody, this is called Gini impurity. And the last thing is called information gain. Now remember one thing, guys. If you are not clear in all 3 topics, you cannot learn decision tree because samajh mein nahi aayega. And don't worry, I have beautiful examples for both also. Easily samjhayenge. No, we'll learn it, no problem. But are you understanding that it is so important? It is so important that once Shah Rukh Khan was asked this question and that interview was not even machine learning job. That's how important this is. Are you clear? Super critical. You don't study this, there's a problem. Information gain, super critical, Gini impurity and entropy. I've already taught you entropy. Yes. Can we look at Gini impurity? And what is the meaning of Gini impurity? I will also tell you that. Don't worry. You don't have to worry about it. What is Gini impurity? What is the understanding of Gini impurity? Very simple. See, मैं आपको पहले formula लिख के देता हूँ. I'll write down the formula for Gini impurity and you guys will love it. See, Gini impurity or G of S, you can call it in multiple ways. I call it G of S. S is a function of a class. Okay. So you can call it like this. The Gini of all the classes S. How many classes did we have in the category? 4. Elephant, giraffe, tiger, and monkey. So this S will be, this Gini will be calculated for how many classes? 4 classes. Are you clear? Like, you guys got the concept of Gini impurity is 1 minus summation of I equals to 1 all the way for all the classes, just the probability of each value, the whole square. If you write down this in mathematical sense, it is 1 minus how many elephants are there in our class, or how many elephants were there? 2 out of 8 square, plus how many tiger? 3 out of 8 the whole square, plus 2 out of 8 the whole square, plus 1 out of 8 the whole square. That's it. And if you sort of solve this problem, you will get it at a 0.75. G of S is equal to 0.75. My people, Gini impurity tells me how impure is your data, how different multiple categories have added. Ek baat batao, I have only added 4 categories. If I add 5 more categories, will this increase? Yes. Are you understanding? See, only 2 categories there. Category 1, category 2. Will the gene impurity not be lesser? क्योंकि ज़्यादा impurity नहीं है, सिर्फ 2 चीजें ही mix हो रही हैं. Okay, let me give an example. What if I mix sugar with rice? That's bad, right? That's bad, correct? What if I mix sugar with rice with jeera? Did I increase the randomness and chaos more in the data? Okay. The more the classes, will more the impurity increase? That impurity quantification is done by Gini impurity. Are you clear? How impure is your class? How many classes are being added? Faltu ke ghus rahe, and they're making changes. Are you clear? Gini impurity is a measure of class impurity in the data, which is also quantitative in number. Are you clear, my people?
Just a quick info, guys. Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI, and Power BI. Get a data science certification from IIT Empowertak and Innovation Hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.
Imagine, guys, I ask you to make a classification algorithm. Okay. Let's say I ask you to make a classification algorithm that given the age, given the salary, can you predict will the person get a loan or not? So answer will be yes or no. And suppose the age is 23, your salary is 12 lakh rupees per annum. Okay. Or 12,000 rupees per month, for example. And your age is 40 and you get 1,65,000, example. So you see the output for the loan would be yes and no, right? Like, so no and yes. So actually no and yes. Example. Suppose I ask you to do this. Now tell me one thing. Will age be used as the top node or salary will be used as a top node? Which node will decide how the tree will be made? Are you understanding? Will age come at the top and then salary go to the bottom and then loan is decided on that, or age? So see, that decision is not based on visual understanding. Like you can't say age or salary. That's not how it works. Whichever value has the highest information gain, only that root node is selected. Are you clear? You have to calculate the entropy of the entire data set. Then you have to calculate the information gain of the age, then information gain of the salary. Whoever has the highest information gain will be selected as the decision node. We'll do the exercise. Don't worry. I'll show you guys the mathematical understanding. Remember one thing. This question is an interview asked question. In decision tree, how do you select a decision node or the root node? It is also called as root node. Okay. Your answer should be in decision trees, root node is decided based on the concept of entropy or information gain. What will you say? Entropy or information gain. Are you clear? Any one is used. Okay. Either you can use entropy or you can use information gain. Most algorithms use entropy. Okay. But we will teach both entropy and information gain. Are you clear, my people? Okay. In decision tree, when splits are happening, they are called branches. So every line you see is a branch. Cool. Every line that you see being split is called as a branch. Again, once the decision node is taken, this is called root node. You can call all other nodes as decisions node. And remember one thing, my people. Tell me one thing. If the information gain or entropy was good for decision node 1, the second best will go here. The third best will go here. Did it now make sense? The second most important information goes to the left, the other third goes to right. And if you have more columns, then depending on whichever is the best, second best, third best, fourth best, the split keeps happening. And you, at the end of the day, are left with leaves. Leaves are something that has no branches. It's the end of the decision tree. Are you clear, everybody? Is everybody clear? Okay. You remember I have taught you regression and classification both. Can I tell you guys something? You will be amazed. Decision tree can be used for both regression and classification. This algorithm is so versatile, is so awesome that if you want to solve regression problems, you can even use it. If you want to solve it for classification, you can use it. Look at it. Decision tree, classifier. So see, I will file decision tree classifier, okay? But if I say decision tree regressor, you will find decision tree regressor also. You will find decision tree classifier also. So do you see you have a decision tree classifier for classification, and you can even use it for regression. So decision tree is a very, very versatile algorithm. Okay, it can be used for both regression and classification, and it can do both the jobs incredibly well. Okay, so just for your understanding, I was telling you that this is such an important algorithm. Everybody needs to understand. I taught you guys a concept of entropy. Do you remember? You remember the formula I gave you? Entropy was E of S. S is what, my people? The class. All the classes. Elephant. What did we take? Tiger, monkey, and giraffe. All four classes is this S. Okay, mathematically speaking, is equal to summation of I equals to 1 to all the classes minus P of I log of base 2, actually log to the base 2 P of I. This is the formula for entropy, and I even showed you how to solve that, right? Do you remember? We actually did this example. We actually did that example. Okay. After entropy, I taught you a concept called Gini impurity. Do you remember what I told you? More the classes, higher is the impurity. Yes or no? The more you will add multiple stuff together, the more the impurity, sort of arrives. So Gini impurity could be G of S. S means all the classes included. 1 minus summation of I equals to 1, including all the classes, all the probabilities, you square them. This was the formula for Gini impurity, right? Very simple concept. We actually did this. We actually got an idea. So now tell me one thing. Entropy and information gain. See, the concept of entropy and information gain, they are inversely proportional. Are you clear? If entropy increases, the gain decreases. And if the gain increases, the entropy decreases. Now, I haven't taught you information gain yet, so just keep one idea, but it should give you an idea. Tell me one thing. If the entropy, the chaosness, the randomness of an order is higher, won't the information in that system will be lower? Because it is not giving me a proper system, proper understanding of things. Correct or not? Okay. Now listen to me. Information gain. What is it exactly? See, information gain is a measure of how much information a feature provides about a class. Okay. Information gain is a measure of, MEASURE, measure of how much a feature provides information about a class. Now give me 1 second. I will explain you what this particular thing means. In this example of age versus salary, you have how many columns? 3. How many feature? How many target? 2 feature, 1 target. Imagine, for one understanding, I add one more column. Area. What area does the person live in? Good area, bad area, okay area. For area, there are 3 classification: good, bad, okay. How well does good area relate to the target? How does bad area relate to the target? Okay area relate to the target? How much information is a subclass providing to the entire target? What is causing that variable to cause change in the target? Did you get it? The information. If you don't want to think it like this, think it like this. How good does age provide information to predict a target? Did that make sense? How much is age important in the prediction of the loan? How important is this variable? Did that go inside your head? Seep inside your head? What did I tell you? I told you information gain is a measure of how much a feature provides. Okay. See, correlation is a different concept. Okay. Correlation is when column A, column B are correlated. They both provide the same information. I am basically trying to tell you the importance of A for the prediction of target. Okay. I want you to think of it like this, not correlation. Correlation happens only in the feature space, not feature versus target space. Okay. Have you heard of something called correlation and covariance? Point number one, never ever get confused by the concept of correlation and covariance. Correlation happens when you have a feature called A, B, and C, and you have to predict a target. How related A, B, B, C, and AC are is correlation. Are you clear? Okay. Covariance is when A changes, how much B changes. When A changes, how much C changes. When A changes, how much B and C change. That is covariance. One thing changes, what causes the change in another? If I move 1 centimeter, how much the column B moves? 5 centimeter. This is covariance, clear covariance. Okay. We don't check it with respect to the target, the information it holds to the target. Okay. Anyways, information gain is a measure of how much a feature provides about a class. Everything will make sense. Okay. Information gain, it calculates the difference between entropy before split. Okay. Entropy before split and average entropy after split. And average entropy after. This statement is not going to make any sense to you. Even if I teach it to you, it's not going to make sense. So allow me to jump into a mathematical exercise and you will understand everything. But let's write down the formula first. Information gain for the class S as a function of F is equal to entropy for that class minus summation of, because I want to take an average, the class feature that maps to function F S nu by S. And this is a mod function. That means you cannot take a negative function, entropy of S nu. Now tell me one thing. Who here understood what the equation tells you? Who understood what is S nu? What is a function F? When I initially learned decision tree, when I was going through the concept of information gain, entropy, and all of that stuff, right? It was, of course, complicated for everybody to understand. But then what I did is I solved a problem statement. I actually solved a problem and everything started making sense. So did everybody get the formula? No, right? I'm hoping you don't get it because I will be able to sort of teach it to you in a nicer way. You guys got it? You did get it, right? Yeah, that's the beauty. For the very first time, imagine an instructor being happy that you didn't get the formula because, once I actually solve it, you guys will get it. Okay, give me 1 second. Yeah. Do you see this data set right in front of you, everybody? Is this visible to all of you? Yes? Okay. This data set is very, very simple. Okay. What this tells you is, what was the outlook of that day? Was it sunny? Was it rain? Or was it overcast? What was the temperature that day? Was it hot, cool, or mild? What was the humidity? How was the humidity like? Was it high, normal, or high or normal? And actually both. Wind was weak or strong, depending on all your feature variables like outlook, temperature, humidity, and windy or wind. Did you actually decide to play tennis? Yes or no? This is the prediction that we want to do. Agree? This is the prediction that we want to do. If it was rain that day, the temperature was mild, the humidity was high, and the wind was weak, you actually went ahead and played tennis. So this is my actual data set on which I'll be working on. Let's start solving manual exercise. Let's do this. Did you all understand the data set? You understood. What is the first thing you're going to calculate before even jumping into anything? What did I tell you? The first thing you calculate in the entire data set is the entropy of the data set, isn't it? We calculate the entropy of the entire data set, yes or no? 100% yes. Let's calculate the number of no's and yes. How many no do we have? 1, 2, 3, 4, 5. How many no's? 5 no's. So in the entire data set, how many classes do I have? I have 9 yeses because this is 14. So I will have 9 yeses and how many no's? 5 no's. Yes or no? Because remember, we have to calculate the category of our output, which is 9 yeses and 5 no's. So if you calculate the entropy E of S, how will you calculate this? Minus of 9 by 14, because the overall data set size is 14, right? Log to the base 2 of 9 by 14. What is the next sign? If you keep minus outside, then you will get plus. But if I don't keep minus outside, I'll still get minus. 5 by 14 log to the base 2, 5 by 14. If you solve this particular example, you will get an output called 0.94. What is the entropy of the data set before even doing anything that we got? What is the entropy of the entire data set that we got? 0.94. This is the chaotic, the most mixed answer that we can get, the most highest entropy answer that we can get, 0.94. Answer has arrived. Okay. What is the next step? Next step is you are supposed to select each column and test how good is this column, because after calculating entropy, what is the second biggest fight that we do? What is the fight we have to do? The next biggest fight that we have to do after calculating entropy, what do we have to do? To decide what? To decide who will be what? Root node. The next biggest fight is, bhaiya, who will be root node? If you don't know how to calculate right after entropy who to decide as root node, kuch nahi kar sakte aap. You can't even make a decision tree. The first thing that you have to do, I'm saying second first because entropy needs to calculate first, is to calculate who will be root node. Will outlook be root node? Will temperature be root node? Will humidity be root node? Or windy be root node? Which node decides the best way to split my data, to create my decision tree? So tell me one thing. Can we take outlook as an example? First example, we will take outlook since it's a part of the beginning. So tell me one thing. Outlook. What do we do about outlook? Now tell me, outlook has how many categories? How many categories? Sunny. What is the next thing? Overcast and rain. Yes or no? So outlook has 3 categories inside it. Let's calculate each category. So what is S of sunny? SUNNY. Sunny. My people only and only consider sunny. 1, 2, 3, 4, 5. How many sunnies are there? In sunnies, how many yeses and how many no's are there? So in sunny, we have 1, 2, 3, 4, and 5. So basically 2 yeses and 3 no's. Yes or no? 2 yeses and 3 no's. Yes or no? For S of sunny, for class sunny, we have 2 yeses and no. Now, why are we taking yes and no? Because the target is yes and no. Agree or disagree? If the target was 3, we would have taken 3. But the target is only yes and no. So I'm only taking 2. So my people, how do you apply entropy for sunny? Now you have to calculate, okay? Entropy for S of sunny is how much? Minus 2 by 5 log to the base 2 by 5 minus 3 by 5 log to the base 2 3 by 5. Are you clear? You will get an output called 0.971 entropy for class sunny. Okay? You will get this output 0.971. We will keep it as this is for now. What is the next category we need to calculate? S of overcast. Yes or no? Now tell me, how many overcast yeses and no's do we have? So overcast 1, overcast 2, overcast 3, overcast 4. So together 4. So you will have 4 yeses and 0 no's. All yeses, right? So we will say 4 yeses and 0 no. Let me tell you one thing, my people. If any of the answer is either yes or no is 0, the entropy for that variable becomes 0 automatically because log is added. So multiplication of anything with 0 is a 0. So if any of the categorization either on the left or either on the right is 0, the answer is 0. You don't even have to calculate. The answer becomes 0. It summations to 0. Okay. What is the next category? S of rain. Now, my people, can you help me with how many yeses and no's in the rain? 3 yes and 2 no. So tell me one thing. Entropy of S rain, okay, for category rain is minus 3 by 5 log to the base 2 3 by 5 minus 2 by 5 log to the base 2 2 by 5. Yes or no? Shouldn't this be the answer? If you calculate this, okay, let me help you calculate. I want you guys to calculate this in the beginning. What would be the answer for this? What is the answer for this? 0.9. I think it would be takriban 0.9 exactly, if I'm not wrong. 0.94 exactly it should be, or 0.9 exactly. Can you calculate this quickly and give me a solid number? 0.9 something? I'm assuming something like 0.9, I guess, right? This should be the answer. Entropy for rain. Are here yeses and nos are different, right? Two yeses, these are three yeses. Three no, two nos. The numbers are different. What is the output here, everybody? Did you calculate this? Yes or no? 971? Okay, no problem. Okay, tell me one thing. What have you calculated so far? What have you calculated so far? You've calculated entropy for the entire data set before the split. Okay, can you have a look at this example? After the split, it'll all make sense now. This is the entropy of the data for the entire data set. Agree? According to the information gain formula, did I not write it like this? Information gain, which is gain of class S for Outlook category as a function of Outlook. Did it now make sense? What is this F? What is this F? Is your class, and S is all the subcategory of the class. For example, Outlook में sunny, overcast and rain. So this is sunny, overcast and rain, and this is Outlook. Does that make sense? चलो मैं question मैं formula ही लिख देता हूँ. Everything will make sense. No problem. Entropy of S minus, can you see I've taken minus? Summation of, tell me one thing. I am categorizing for how many subclasses? Sunny, overcast and rain. So mu, the mu or the nu has to repeat for how many classes? Sunny, overcast and rain. S of nu divided by S, entropy of S of nu. Okay. If I replace the values inside this, sir, I want to replace the values inside it. Okay, no problem. What is the entropy of S means the entire data set. What is the entropy of the entire data set before the split? What is the entropy? 0.94. Very nice, my people. Now you're getting it. 0.94 minus. Okay. Now I'm going to write down this formula. Okay. How many times does Sunny repeat? 1, 2, 3, 4. And where is one more? How many times is Sunny repeating itself? 5 times. 5 divided by, what is the total data set size? Into entropy of Sunny minus how many overcast is that? Or how many overcast do you have? 1, 2, 3, 4. So minus 4 divided by 14 into entropy of overcast minus how many rain do we have? 1, 2, 3, 4 and 5. Minus 5 divided by 14 entropy of rain. Did you understand the formula? Because it belongs to all categories. So their calculation is important. So is equal to 0.94 minus 5 divided by 14 into what is entropy of Sunny? We just calculated 0.971 minus 4 divided by 14 into overcast is 0, correct? We had nothing. Minus 5 divided by 14 into 0.9 something, 71, entropy of rain. If you replace all these values, you will get a gain of 0.2456 or 64 something. 2464, 2465 something you will get like this. This is the gain for what category or what variable? Only and only Outlook you got for. So you got for Outlook. If you repeat the same exercise for temperature, humidity and wind, whichever value has gain higher, that will be selected as root node. Did it make sense? My people, did you get the concept? I'm not going to repeat it again and again because it's a longer exercise. If I do it by hand, trust me, it's going to take us more hours. I just taught you how to do it for one category, and I'm very sure you guys, if you want to try it out on your own, you can do it for multiple categories. But do you see, we used the concept of entropy, and we calculated something called gain at the end. And gain told us how important this feature is in predicting target. Hence, this should be selected as root node. Remember one thing, my people, it never happens that gain of one variable and gain of other variable are always equal. ये कभी नहीं होगा. Okay, let me tell you something. Okay. Let's pretty much take it like this. Okay. Imagine. Okay. How many variables are there? How many variables are there? 4. How many? Imagine, for simplicity reasons, the gain of S comma outlook is equal to how much was it? 0.2464. 0.2464. For simplicity reason, let me say the gain of S comma, what is it? Outlook के बाद temperature. Gain of S comma temperature के बाद क्या है? Humidity. Humidity. ठीक है? Gain of S के बाद क्या है? Wind. Comma wind. Okay. Imagine for simplicity reasons, okay, this is 0.0289. हाँ मतलब some random values I'm giving. 0.1516 and आप इसको ले लीजिए कुछ भी ऐसा 0.0478 example. Which gain is the highest number among all? Which one will you select as a root node? Remember one thing, my people. Decision tree is like a blueprint. Yes or no? Once the tree is made, every decisions will be taken based on the blueprint. You remember the giraffe exercise I showed you? I pulled a giraffe, it goes to the left, then it goes to the right, it goes to the right, and it comes to the bottom. Decision tree is like a pratha. Once it is established, everybody has to follow it. And then you will be segregated in the bottom. Are you clear? Are you clear? Is everybody clear with the concept of it, my people? Just tell me yes or no. I will get clarity, boss. मतलब मेरे को समझ में नहीं आ रहा है. Did you get it? Not get it? And let me be very frank. Okay, let me tell you one thing. Nobody in this world teaches manual or mathematical exercise for decision tree. I even took that effort. Bhaiya, chalo, let's make the person understand how actually decision tree root node is calculated. You guys got it, right? So the feature with lowest information gain will be at the bottom of the tree. Not bottom of the tree, will be one of the last decision node. And any tree that you make should only have one root node. You can't have two. Okay, hold on. First of all, when you have two root node, is it a tree or is it a graph? Did you understand? A root node decides the flow. Two root node decides. Okay, how do I say this? Like it's a part of data structures. Have you seen a single linked list which is connected to another list? Then you have something called doubly linked list, which has a single and two pointers. Then you have a circular linked list, right? The flow is unidirectional, correct? When you open the tap, the water flows. Or do you pump water through the tap? Are you understanding what I'm trying to say? A decision tree is called a decision tree because it's a unilateral flow, one flow. The input comes to the top, output goes to the bottom. If the decision tree actually will not be called decision tree, has two different nodes, it's not a node, it's a graph. Okay. You have to calculate the process of information gain for outlook, temperature, humidity, wind, and for each of it category unless you exhaust all your feature space. Until the feature space is exhausted, until all the feature variables are taken with respect to the tennis of yes and no, until then you have to do this exercise. You have to keep repeating this manually. How about you want to see this example in real life? And you know what? Just for fun, I mean, not for fun though, proper understanding of things also. What if we take the same exact data set like we did with tennis DF and we solve and see how that works? Then we'll take one more data set. The one that I just taught you right now, this tennis data set. How about I teach you a decision tree classifier? How will it be done in practical with this? And at the same time, we'll take another data set for practical purposes. Let's look at both the data sets, okay? So that you guys will get a pretty good idea. Now tell me one thing. Import pandas as PD, yes or no? Import numpy as NP, yes. Pansas, sorry. I don't know about pansas, but I know about pandas. Happens. I'm a really fast, I type so fast that sometimes my pansas library is not to be seen. No problem. df equals to pd.read csv. Okay. If you guys didn't know this, I'm just letting you know. You can do this. Am I getting the output? Sunny, hot, high, false, no. Sunny, hot, high, weak मतलब false and no. मतलब मैंने weak नहीं लिया है. Weak, strong को true, false ले लिया है. Sunny, hot, high, false, no. Sunny, hot, high, false, no. Data वही है. I mean, are you understanding what I'm trying to say? Okay. If you do df dot shape, how many columns did we have? 5 columns and 40 row. Yes or no? Agree, disagree? Okay. Now tell me one thing. Before I even do anything, will I be able to run machine learning or any analysis on this? High, low, good, bad, true, false. इस पे कुछ कर सकते हैं? Can we do something on it? Is it possible to even approach anything? Can we do anything in this? You need to convert. You need to encode this, yes or no. Otherwise, how will you run a decision tree classifier? From sklearn, what do you need to do? From sklearn, because this is a part of pre-processing, you have to call pre-processing. and you have to import. Thank you so much, my dear friend. This is awesome. Ronak, label encoder. We are going to import label encoder. Now let me give it a function. Label encoder is equal to label encoder. Say example like this, right? Label encoder. But this function needs to be callable. Are you clear? You need to put a bracket inside this. Here you have no bracket because you're importing a part or module. Here you need to put a bracket because you are calling that function. So df is equal to df dot apply. You know what apply is? Apply lets you run the output, the function on entire columns one by one. If you know, in pandas, we have a function called apply. Apply runs it on the columns. Le dot fit the model and transform the model. Basically fit transform. We call it fit transform. And if I run df dot head of 5 again, is everything converted? How many days has it been since you guys have learned machine learning? How many days has it been? How many machine learning classes have you taken, my people? I have a question to ask you. 4. Okay. Can I tell you guys one thing and you should take it as an important interview question? If I tell you, will you please agree what I'm saying is an important question? In your interview, this person, your interviewer, is going to ask you this question. What is dot fit in machine learning? Okay. What is transform in machine learning? And bhaiya, what is fit underscore transform in machine learning? इन तीनों का डिफरेंस बताओ. ये क्वेश्चन इतना इंपॉर्टेंट है. I cannot even tell you the importance this question carries in your life. If you are not able to answer this, don't even talk about decision tree. वहां तक नहीं जाएंगे कि why have I only applied fit transform? Why did I not do label encoder dot fit and then transform? Actually आंसर ही दे दिया मैंने. But will you please finish this as an assignment कि in machine learning why do we do dot fit? Why do we do dot transform? Why do we do fit transform? थोड़ा मेहनत करो. Do hard work, Arpit. Good. Label encoder will give it 0, 1 and 2. Right? This is going to give it a label encoding. Why don't we do one hot encoding? You can even do one hot encoding. That's not a problem. Because the numbers of subcategories are so low, label encoding works well. It has no problem. The machine learning model does not get biased when it is categories. Let me give you an example. Have you heard of something called nominal categories and ordinal categories, my dear? What is a nominal data as an ordinal data? What is it, dear? Can you tell me what is a nominal data? What is an ordinal data? Example? Yes. लो हाई समझा नहीं मैं इतना इतना ज्यादा साइन लैंग्वेज नहीं समझ में आता है मेरे को विच डेटा ऑर्डर मैटर्स in which category order matters ordinal or nominal example if you rate your food 1 2 3 4 5 will the order matter and suppose I tell you car like Mercedes Benz Audi and Ferrari example does the order I rank them in matter. Coming back to the same topic, does the order matter here? So it's nominal or ordinal? Nominal. Very good. The encoding that you can apply to this is both one-hot encoding and label encoding. So your question is absolutely right. Because the categorizations are so small, it won't make any difference for the machine learning to give a bias. Okay, so label encoder is like a good choice. Not a problem. You can apply it here. Okay, good. Growing every day. Very nice. Very proud. I like it. Everybody clear until here? What is my feature space? If I just drop, what do I drop? Just the play part. Okay, just the play part for all the axis as 1. And if I take x dot head of 4, did I just get my variable outlook, temperature, humidity, and windy, which is my target variable, the one that I want? And if I want to take y, I just need to take df dot play. That's it. Done. If I just take this part, my y category is set, right? My y dot head 5. I got my feature and my target. Agree, disagree? Now we will split the data. From sklearn, what have I taught you? Dot model selection, what do we select? Import, xtrain, xtest, ytrain, ytest. From sklearn, dot tree, because you're doing a tree-based classification. Dot tree, import decision tree classifier. Are you clear until here? The classifier is equal to decision tree classifier. And remember one thing, you want the tree to be split on based on entropy or Gini impurity. What have I learned? What have I taught you? That we split the tree based on what? Entropy, right? I have taught you that we split the tree based on entropy, right? Like we calculate entropy. Yeah, that's nice. So what will you write? Criterion is equal to entropy. Are you clear? Until here, are you clear? Classifier dot fit. What will you fit inside it? What two variables need to fit inside a variable? X underscore train and y underscore train. Yes or no? Did I get a classifier run? Is my classifier basically done? It's running, it's getting the output. Is it basically run? How do you predict the output? Ypred equals to Ypred equals to what do we say for Ypred? Classifier dot predict x underscore test. Yes or no? Okay. From sklearn dot metrics, okay, import. You remember what we had imported yesterday? Accuracy score. So how do we do? Accuracy score of what do you pass? Y test Ypred. What answer did we get? Imagine 100% accuracy we got. If you do this, are you starting to get an error, my friend? Ronak, you see, we got an output. Okay, first of all, like you said, I got an X test, comma Y test. I've added. ठीक है, मैंने X test डाल दिया, Y test डाल दिया. But why is it giving me error? Can you tell me? The reason why accuracy scores only work on Y test, Ypred is because for the Y test result and the Ypred results, aren't we comparing what we got? Aren't we kind of getting an understanding that, okay, what did I do to get an output? What did I do to fix this output? Basically, all the test set that I've taken, how many test set have I taken? If I take 20%, does it change the answer? Let's teach you something important, okay? Decision tree classifier, come here. My people, I have used criterion equals to entropy. What if I use criteria equals to Gini? Then kya hoga? Let's try. Am I getting an output called 33%? Okay. Ronak, why do you think it will work? Matlab, I'm just curious. If you can just type it out, I would love it. Like, what makes you think that if you just add that, it'll work? Like, what makes you think that if you add X test, Y test, it'll work? Okay. So we can do it in single line. Okay. Can you write down the code for that? Like, if you can just share it with me, I would love to see it. If you can, I mean, if you can just try and run it and maybe just share it with me, I would love to see it. Okay. Just share it with me. I'm telling you it won't work, but let's have a look at it. Okay. No problem. Okay. So here I changed it to Gini impurity. Okay. I told you one thing, you remember? Either we decide on the basis of entropy to split the data or Gini impurity to split the data. Any one can be chosen. Yes or no, my people? Okay. Tell me one thing. Initially, I chose the entropy as the criteria and I ran it. What was my output like? 100%. But suddenly I changed the entropy to Gini and Gini to impurity. Now it is giving me 66%. Isn't it weird? Let me show you once again. Hold on. Cell, run all. Okay. It's giving me 33 now. Okay. Cell, run all. It's giving me 100% now. Cell, run all. It's giving me 100% now. Now see what happens. The moment I change this to Gini, cell, run all, 66%. Okay. Cell, run all, 66%. What's happening? What do you think is the reason for all of this? See, coming over here, okay, or coming and trying to teach you how to use a classifier syntax is not my job. My job is to make you think deeper. Okay. My job is to make you think the things you would have never thought of thinking. That is my job. What makes you think this is okay? Let's do one more thing. Let's make you think more weirder stuff. पूरा confuse करते हैं आज तुमको रुको. Okay. I don't want any class weights. I don't want max features. I want to not touch this. Default is 2, which is fine. Min sample weight, max features. Max features are actually fine. But actually, you know what? By default, it is, let's take it as square root, I guess. Okay. Let's try to change the hyperparameters a little differently. Okay. Let's take this to Control Z, entropy. Cell, run all. If I take, okay, random state is not one of the main causes. We'll talk about that later. If I run this and I have taken entropy, okay, my criteria, cell, run all. Give me 1 second. Okay. What is the final output that we are getting? 100%. Agree or disagree? It is overconfident in its output. Okay. Let me tell you the problem that this decision tree faces, okay? My people, remember one thing. Decision tree is an important algorithm. Very nice, very good. But do you know what is the biggest problem of decision tree? It usually tends to overfit very easily. Are you clear? Depending on the sample size, the data that you have given it to train, if the training set is so small, it usually will overfit. Do you understand, my people? Listen to me very carefully. Imagine I have 14 samples and I only gave it 10% of test size. What is 14 of 10%? What is 10% of 14? 1.4. Usually Python takes a lower record size, which is 1. I am only taking 1 as a test set and the other as a training set. Are you understanding what's happening here? Did you understand what's happening? Hold on. Let's make the test size as I don't know, 40. Cell, run all. Look, the output is 0.16%. What did you understand from this? Point number one. Decision tree is a terrible algorithm if the data set size is lower. Are you clear? It will overfit, and it is usually an algorithm that tends to overfit. Are you clear? Any confusion in here? Please don't think anything else. Decision tree is a right algorithm if you have a large quantity of data, you have a good equation for test and training. If you have such a small data of 14 records and you're trying to fit decision tree, you think that's a good option? For a minute, logistic regression would have worked better, but not decision tree. Are you clear? There is nothing to be confused here. It's common sense. I wanted to just run it through you and tell you the answer. That just because I gave praises to decision tree in the beginning, that it can do both regression, it can do both classification, doesn't mean you use it for everything. Decision tree usually tends to overfit. It is usually overconfident. अरे मेरे को तो सब आता है. एक बात बताओ, do you all understand the concept of overfit का मतलब क्या होता है? आप समझते हो? Do you all understand the meaning of overfit? Does everybody understand the meaning of overfitting? Let me go through the concept. Okay. People, imagine you have exams to give. Okay. You have exams to give. I will give you a question paper, a test paper. 1 plus 1 equals to 2. 2 plus 1 equal to 3. 3 plus 1 equal to 4. Example. In the exam, if they ask what is 5 plus 4, aren't you supposed to solve that problem? Because you're supposed to understand the basics, the pattern of the test. Yes or no? Okay. What is overfitting, underfitting, and right fitting meaning? The meaning behind it is whenever you are asked the question 1 plus 1, automatically you will say 1 plus 1 is 2 because all you saw is 1 plus 1 in the test. Yes or no? In the training of your mathematics class, you saw 1 plus 1. But the moment I will give you 2 plus 3, you will not be able to do it because that was not taught to you. You will be able to do 1 plus 1, 2 plus 1, 3 plus 1 because you've memorized it so much. You've memorized the data so much that the moment something comes, you've memorized it so well, the output comes. That is overfit. Are you clear? Overconfident, overfit. Only what training comes, I'll able to answer that. The goal of machine learning algorithm is only to pick up patterns, right? And not memorize anything. Correct or not? The goal of machine learning is to understand the patterns behind the data, not to memorize the data. When you overfit, you memorize it so well that you become overconfident. अरे मेरे को तो मैथ में सब आता है, अब पेपर आने दो, फाड़ दूंगा मैं. That is the overfitting problem that decision tree usually has. Can somebody tell me why? Because decision tree are once finalized, will be finalized forever, correct? एक बार decision tree बन गया, it is not going to change, correct? Did that make sense, my people? Once a decision tree's root node is finalized, another nodes are finalized, will it automatically adapt itself or change? Or will it remain constant no matter if the data changes also? That is the problem. It is constant. Let's plot it. Let's try to visualize it. Okay. But did you guys get the concept which was important? I'll show you. Okay. I'll show you. Import matplotlib.pyplot as PLT. Okay. As PLT. Okay. As a PLT. From sklearn, skimage nahi, sklearn, import tree. Okay. Here, I've just taken matplotlib as pyplot as PLT. From sklearn, I've imported tree. Figure comma axis, or not this, figure comma axis. You guys remember, right? In matplotlib, we have an option of taking sub figures also, multiple sub figures if I want to take it. Like if I do like this, subplots, like this, like I have the options of taking subplots. Okay. N rows equals to 1. N rows equals to 1. I hope I'm taking it right. I've not done it since a long time. I don't remember. I may not remember the syntax, so apologies for that. What is the figure size or figure size? Let's take it a minimal 5,5 figure size. Oh, let's take it smaller actually, not more. 4,4. Let's take it 4,4. Yeah, I mean, let's keep the DPI to a minimum of 150, 200. Okay. Is it plot.subplots or is it plot.subplot? Give me 1 second, guys. I just need to. Pyplot.subplots, n rows, n columns, and DPI is equal to, what is the usual DPI format? It is what? No, hold on. It is grid space. अच्छा DPI नहीं है क्या इसमें? Plot.subplots DPI तो होना चाहिए क्योंकि how would I know what? ठीक है. I'll just see. Tree dot. Okay, let me just basically run this. Tree dot. Okay, so if I say plot tree and if I pass in the value of a classifier like this, okay, so I think it should run. Okay, Okay, let's keep the DPI smaller. Let's keep it 100. How? Do you see the tree it created, my people? See, you can visualize the tree. The class is outlook, okay, which is less than equal to 0.5. The entropy was 0.811 according to its calculation. Okay, the entropy was this much, the entropy was 0, and it basically created a tree for you. So can you see I'm actually plotting the tree that the classifier actually made. If I would have taken Gini, it would have given me a different tree. You can even plot a decision tree and validate the results. It's not that you just run it and you have to accept it. See, this is the plot that the classifier built from the code side. Are you clear with the concept? Okay. There is another library called GraphViz, decision tree. Remember one thing, my people, there is another library called GraphViz. I actually learned about it a little later because I never implemented a decision tree in production. To be frank, no company would have deployed decision tree as a production in their company because there are better algorithms like XGBoost, multiple other better algorithms. So see, this gives you a much prettier result. So this is a library called GraphViz. You can even try this out. See, this is a GraphViz library. So I have imported the tree package from, sklearn package. But if you want to make it appear more beautiful, more pretty, you can do that using that also. As in, you can do it prettily in a nicer sense also. That was the point. Did you all get the concept? Did you all get the idea? Did you all get sort of like a process of what we are doing, how we actually did that? Okay. Now coming back to this question, okay, you make this test size as 30. Don't make it higher. Okay. Usually, if you take a test size of 30, you get a decent score of 40%. Okay. Remember one thing, my people, there's a thumb rule. If your data set size is smaller, make sure that your test and test size are almost nearer. So 60-40 split is usually taken, or maybe 70-30 split is taken. You don't take more. If your training size is bigger, then you take 80-20. Are you clear? If your data set size is smaller, usually people prefer 60-40 or 70-30. But if your data set size is larger, you prefer a set of 80-20. Okay? Are you clear? The tree that I have now is a little different from the tree in the past. Why is that? What did I change that it ran? Okay, let me run it again. Okay, cell run all. Is the tree now different? Let's change the DPI to 150. Chalo 100 ही रख लेते हैं. Kernel restart and clear output. Okay, restart and clear output. Kernel cell run all. Okay, look at the tree now. Okay, is it slightly different from the previous tree? This is happening because, the test keeps changing. Thank you so much. Also, I have not used any randomizer here. Here, I would have taken some seed function, which you called as a random state function. If I would have kept it same, it would have been same. You guys got the concept, right? Like whenever you work on decision tree, you fix the data, the sampling of the lowers and the rights, the test and the train, so that they don't get sampled again and again. Okay? Because they get sampled again and again, the value changes because what would have been in training now goes in testing. Okay. So this was just to give you guys an idea about what we solved here versus what we got here is kind of similar. And it also gives you an understanding of how important this library, this package is. But tell me one thing. I want to ask you guys one thing. In your real life machine learning, will you implement multiple algorithms or will you take one data set and on that you will implement multiple algorithms? What do you do? What do you do, my people? The second one, yes or no? Can we try that? Can we take one data set, implement logistic regression, implement a decision tree, for fun, implement a dummy classifier and print AOC ROC score, print accuracy score, print confusion matrix, and then decide it would be amazing or not? Should we do it on a different practical data set? This was just to make you guys understand few things in life, but this was not like the actual data set that I wanted to start with. This was just like, so it's for fun. Okay. Anyways, df is equal to pd.read_csv of. Now here I want to take another. How do I say this? You can. Okay. Let's think of it like this. Okay. See, I want to basically take like a different data set for you. I think हाँ यही करा देता हूँ. चलो आपको ये data set भी अच्छा लगेगा. You guys will like it because it's very numeric in nature. You guys will understand. You guys will love it. Okay. This is okay. You know what? Amazing. I think this data set will teach you a lot in life. Listen to me carefully. Okay. This data set is all about a person's age. Okay, a person's age, a person's you know what, give me 1 second. I'll make it easier for you to understand. दिख रहा है आपको? पहले डेटा सेट समझते हैं. कब ये? ठीक है? This is a column called person's age, 63, 60, 37, 41, 56, 57. Any confusion? Second is by sex. अगर 1 है तो मेल है, 0 है तो फीमेल है. CP is nothing but just chest pain. आपका chest pain किस टाइप का है? Do you have asymptomatic, एटिपिकल एंजिना, नॉन टिपिकल एंजिना या टिपिकल एंजिना पेन? ये भी हमें पता नहीं है, बट 0, 1, 2, 3 लिखें, लेबल एनकोडेड है. दिस इज लेबल एनकोडेड. थ्रेश बीपीएल इज द रेस्टिंग ब्लड प्रेशर ऑफ द पर्सन. देन यू हैव द कोलेस्ट्रॉल, द फास्टिंग ब्लड शुगर, echocardiogram result. Okay, this is the heart rate of a person. Okay, this is the included exercise angina. This is old peak slope and basically बहुत सारे medical values दिए हुए हैं. Did you understand? You see target is equal to 1. आपको यहां दिख रहा है क्या? Target heart disease 1 मतलब नहीं आया, 0 मतलब आया. Given somebody's age, his, her sex, the chest plate and all of that, did the person get heart attack or no? The possibility did the person get heart attack or no? Heart attack or no? Isn't this a logistic? Isn't this a classification use case? तो अपने को clearly पता है कि अपना target ही target है. The target itself is a target. Yes or no? This is my data set. What is the things that you usually do? पहले तो देख लेते हैं how big is a data set, right? So when we do df.shape, how big is a data set? How large is a data set? 303 rows, 15 columns. 303 rows and 15 columns. Now tell me one thing. If I want to split my x and my y separately, what do? Won't I just go ahead and drop? What will I drop from that particular thing? I will drop target. Yes or no? I just want to drop target from the column and axis equals to 1. Okay. And axis equals to 1. If I do this, I will get the value of x. Yes or no? And if I take y, can I not just take df dot target or df of target, anything? You can take it however you want, right? So if I do y dot head of 4, did I just get my x and y separated properly? I have no issues. Everything is proper and sorted. I have my x and y sorted. But you know what? In machine learning, there is one more problem. Let me ask you what that problem is. My people, imagine you have a person whose column is age and another person whose column is salary. Now tell me one thing. Age is of what limit? Maybe 18 se leke 70 max. Agree? The salary range could be ranging from 15,000 to 1.5 crore. Now listen to me very carefully. Because the column age has a different range and salary has a different range, won't machine learning give preference to the salary column more than the age column because the numbers tend to be higher? Agree or disagree, my people? If you didn't know, I'm telling you this right now. Look at the data. Cholesterol is between 200. Age is between 63. CP is a variable which is 0, 1 and 2. And old peak is 1.2, 2.3. Aren't we seeing multiple ranges here? Yes or no? Won't it be amazing to convert everything between 0 and 1? Age also between 0 and 1. Salary also between 0 and 1. If everything becomes standardized, my machine learning model won't get confused and will be able to do a better job. Did you understand what I'm trying to say, everybody? See, the amount of people in this class who are listening to me, okay? I told you this yesterday. You guys can make me the Prime Minister of India if you want me to, because you guys are in such good quantity, okay? I hope nobody... I have taken an X variable, I have taken a Y variable because X features and target needs to be separate. Now tell me one thing. Can we split the data? Can we basically go ahead and split the data into multiple different types? Like basically, can we do this? Can we say X underscore train, comma X underscore test, okay, comma Y underscore train, comma Y underscore test? Can we do it? Is equal to train test split is equal to train test split of X comma Y comma test size equal to, let's keep a test size of 20%, not more, okay? Let's not keep a test size higher. मैंने X train, X test, Y train, Y test कर दिया. But now I will take something called scalar is equal to, do you know or do you understand that in Python or specifically in our libraries, we have a scalar called standard scalar. Have you heard of it? I'll show you. See, यहाँ पे, before importing the package, let me also do import statement, okay? From sklearn dot pre-processing import standard scalar run. Okay, what I did, I have imported something called standard scalar. तो मैं यहाँ पे क्या करूँगा? I'm going to call standard scalar. What standard scalar is going to do for me? What did I just tell you right now? What standard scalar does? What will it do? x underscore train equals to scalar dot fit transform. Okay. What? Fit transform what? X train data, because this is what I want to basically transform. I will take similarly x test is equal to, what do? Scalar. But यहाँ पे आप fit transform नहीं करोगे, यहाँ पे आप transform करोगे. That's why I told you we need to know the difference between the test, the fit, the transform, and the fit transform. Are you clear, my people? I run it. I'm set. I'm sorted. And don't worry, इतना कोई complicated चीज नहीं है वो. Fit, transform, fit, transform. It's a sequential process. Can we have like a dummy classifier? Do you know what is a dummy classifier, my people? A random classifier, a random guesser. वो guess करके ही अपना output निकाल लेता है. That is called as a random or a dummy classifier. Have you ever heard of this dummy classifier? Yes or no? Okay. No problem. Like it's like a random classifier. No problem. From sklearn dot dummy. Okay. Import dummy classifier. Okay. I've imported a dummy classifier and I'm running it. How do you call the dummy? See, what dummy classifier will become is, it will become like a baseline for us. Okay. So let's say dummy underscore CLF underscore classifier is equal to. Now, how do you call dummy classifier? You call it like this, dummy classifier. Or you know what? एक काम करते हैं, छोड़ो, dummy को नहीं लेते हैं. I don't want to confuse you guys anymore. Then you guys will be unnecessarily confused. Let's not take any dummy classifier. Ignore करते हैं, no problem. पहले logistic ही लेते हैं, no issues. ठीक है? I don't want you guys to get confused later on. Okay? Logistic. What is the use of dummy classifier? See, dummy classifier is like a baseline model. Okay? What happens is when you choose 3 different models, you need to know the worst. How worse are you performing? मतलब if you are performing worse randomly, how terrible are you performing? It tells you the baseline कि इसके नीचे तो खराब होना ही नहीं है. If you have a data set and if you have a problem statement, how worse can you perform? The worst accuracy you're getting is 45%, and below this it's not possible. So minimum efficiency that you are allowed to reach, or you're reaching even if the worst case happens, that is dummy classifier. Let's call logistic. Now, how do you import logistic, my people? From sklearn, what do we call? Dot linear model. Import logistic regression. Yes or no? Agree or disagree? I'm just calling logistic regression. Acha. Lage haath. Let's also import decision tree. How do we call? From sklearn dot tree. What do we call? Import decision tree classifier. Acha, you know what? Lage haath. Agar now that we've imported it also, from sklearn dot metrics, what do we import, my people? First, let's import confusion matrix. आप लोगों को आज confusion matrix कैसा होता है वैसे दिखाता हूँ. Okay, import confusion matrix. Point number 1. Let's also import something called accuracy score. Let's also import something called classification report. You remember I've shown you how classification report looks like. Let's also import F1 score. और अगर AOC ROC score करेंगे तो वो भी निकाल लेते हैं. चलो, ROC curve and ROC AOC score. Okay, और AOC ROC score. ROC curve ले लिया. ROC AOC curve भी ले लेता है. ठीक है, because we'll also run AOC ROC at the bottom. So we've imported all the packages. Yeah, most of the packages I've imported. No problem. Now tell me one thing. How do you import logistic regression? Can I say something like this? Log reg is equal to logistic regression callable function, which is a callable function. What do you usually do once the log reg is done? Do we not fit it? Do we not fit it? Log reg dot fit the model. अब हम fit के अंदर क्या डालेंगे? X test, Y test, Y pred, Y test, or what? X train, Y train, है ना? The log output, log reg dot predict. What do I pass inside it usually? Isn't it the function X test that gives me the prediction of all the Y predictions? Okay. Logistic regression accuracy score. So logistic regression accuracy score is nothing but accuracy score of, what do I pass inside it? Y test and what do I pass? Y test and Y pred log. Yes or no? ये वाला जो हमारा पार्ट है, this is for accuracy calculation. Let me call it metrics. Somebody should gift me a good keyboard soon. Otherwise, I'm going to break my laptop. Okay, I got an accuracy score. Okay, LR underscore F1 underscore score is equal to, what are we calculating here? F1 score. So can I call F1 score? What do I pass inside this? Y test, comma, Y pred underscore log. Any question? Any question in this part? Logistic regression confusion matrix. I'm just printing confusion matrix equals to. I'm going to call confusion matrix, and what I'm going to pass inside this? Y test, Y pred log. कोई भी accuracy parameters are all the same. Y test, Y pred log, Y test, Y pred log, Y test, Y pred log. That's nothing else. Let's make it a little neat. Let's make it a little nice. Okay. Print. How do I print this? Print. First F. What am I printing? Accuracy score. what do I pass? LR underscore ACK underscore score. This is my accuracy score. Yes or no? Print F double quotes F1 score. F1 score is always on a test set. I hope you know. F1 score doesn't happen on a training set. ऐसा नहीं होता है. LR underscore F1 score. ठीक है? Print. अच्छा accuracy और F1 हो गया. चलो थोड़ा better print करते हैं. Star star hyphen star star into 8. ठीक है? Star and star. हाँ, I will give a better output. Okay. Print confusion matrix. If I want to print confusion matrix, what do? Just print LR underscore conf underscore matrix, yes or no? And take the same exact code, paste it here. But do you remember I also taught you a beautiful concept called classification report? If you remember, I also told you there is something called classification report. Print classification report of same thing, y test, comma, y pred underscore log. If I run this, are you getting all the metrics that we need to print? So can you see I am printing something called pehle to accuracy score. Oh baba, 100%. Look at this. F1 score is 100%. Overfitting. Data bhi acha khasa hai. Why is it overfitting? We'll come to that, no problem. Do you look at the confusion matrix? Look at the precision and recall. 0, 100%, 1, 100%. Result to terrible aaya. Yes or no? Agree or disagree, my people? We all agree the results are terrible. I have run logistic regression. Can I run decision tree on it? Can I copy the whole thing exact as it is, because I don't have the energy to run it again, and I'm going to implement it here. Instead of calling logistic regression, can I call it decision tree classifier here directly? And rather than calling it logreg, let me call this tree. Yes. So instead of logreg.fit, can I say tree.fit? X train, Y train will remain same. Y pred log ke badle Y pred tree. Yes or no? And this will be tree.predict. Did I just change the line number, the first 3 lines as is? Tree is equal to decision tree classifier. Tree is equal to tree.fit. X train, Y train मैंने डाल दिया. Y pred tree को मैंने बोल दिया कि this is tree.predict X test. भैया first 3 lines are sorted. What do I change here? LR के बदले what do I pass here? Tree accuracy score is equal to accuracy score Y test, Y pred tree. Yes or no? अच्छा, ये LR के बदले हम क्या लिख सकते हैं? Tree F1 score. तो यहाँ पे हम क्या पास करेंगे? Y pred tree. LR confusion matrix के बदले हम लिखेंगे tree confusion matrix and we will pass Y pred tree. Is this done? So LR के बदले हम लिखेंगे tree accuracy score, tree F1 score, tree confusion matrix, and classification report will have tree. Agree or disagree? If I run this, भैया ये भी overfit कर रहा है. This also is overfitting. What is the problem? है ना? See, we have a good enough test site. हमारे पास data तो अच्छा खासा है. Why is it still overfitting? You know why it is overfitting? I'll tell you. My people, the moment something overfits, what is the thought in your data? What is the thought in your brain? Something must be wrong in the way I must have run the algorithm, isn't it? Your first thought process is maybe something I have imported is wrong. Maybe something I have done is wrong. You forgot the most basic thing here. Can somebody tell me what is the most basic thing I did while importing the data here in this particular part? See, I have taken this data here, correct? I have taken this data here. df is equal to pd.read csv. I have taken this. Do you see another column called unnamed equals to 0, which is 0, 1, 2, 3, 4, 5, 6, 7. It's increasing. And the machine learning things, that's also a part of the label. Did that make sense to you? So if I put a column here, I say index call equals to 0. Listen to me very carefully. If I run this, did I just drop the column index call equals to 0? That 0, 1, 2, 3, 4 was there. The column that you had, see, this column I'm talking about. If I run this, do you see unnamed equals to 0? Do you see this column unnamed equals to 0, my people? Yes. If I paste it again and run it, it's gone. Let's run it again. Did we get a different accuracy? Now my accuracy is 77% and my accuracy for decision tree is 67%. So tell me one thing. You must be thinking the problem is such a big problem, but where did the problem actually turn out to be? Where did the actual problem turn out to be? In the way you imported the data. So listen to me very carefully. As a data scientist, shouldn't you keep every step in your brain what I'm doing? You think about it, you plan it, and you know exactly what you're doing. Am I making sense? The moment you got 100% as your accuracy metric, overfitting both logistic and decision, you got confused. You thought maybe your program is wrong, maybe the data is wrong. You must have done one thing. You must have ran to your manager. You must have ran to your senior and say, sir, data acha nahi hai, it's overfitting. And if your manager or your senior sees this, what do you think he's going to make you of? What do you think he or she is going to do? After they see this is the silly mistake you have done, what do you think is going to happen after that? Are you understanding what I'm trying to say? Are you? Yes. That's why I thought that this example was very relevant. That's why I got excited in the beginning, because I have so many data sets. I randomly choose any one data set and I start teaching. Luckily, you guys got a data set like this today, and I thought maybe I'll make an example and teach you guys that it is very important to pre-process the data, to know exactly what is going in your X, to know exactly what is going in your Y, and you print the output absolutely accurately. You have to be very careful of the data processing that you do before you even start adding the values to it. Now, chalo, rest aside, let's try plotting AOC ROC's curve. But before we do that, let's have a proper formatted and a very nicely documented thing, okay? So let's take another column called model evaluation equals to. Now I want to convert this into a data frame, okay? So pd.data frame. What do I pass inside this? You can take it as an array, right? Like the model versus its accuracy. So we can say something like the model that we chose were of this type and the accuracy, okay? Accuracy was of this category. And if you also want to plot an F1 score, you can also plot an F1 score against it, right? So what model did we implement? Logistic regression, yes or no? We also implemented something called decision tree. What was the accuracy of logistic regression? LR underscore accuracy underscore score. Then tree underscore accuracy underscore score. Then for F1 score, what did we have? Tree F1. So LR underscore F1 and tree underscore F1. If I run this, right, and if I print model underscore EV, is this giving me like a proper analysis of the things that we've gotten, like a proper neatly arranged data frame that gives me an idea about, okay, you know what looks like that you have properly and very neatly arranged the accuracy and the F1, and you have a comparative advantage of proper printing the whole thing out in a nicer way. Now tell me one thing. If I want to plot the ROC curve, so don't you think we need to have false positive rate and true positive rate, if you remember? So false positive rate for logistic regression and true positive rate for logistic regression, comma, what was that another thing that we did? THRESHOLDS, thresholds underscore logistic regression. And I used a function called ROC curve to pass in y test, comma, y pred log. Do you remember we did this? Y test, y pred log. Okay. If I copy the same thing and if I paste it here, instead of log, I'm going to call this tree. Instead of log, I'm going to call this tree. And instead of log, Control Z, I'm going to call this tree. And what do I need to pass here? Yes, false positive rate, true positive rate. For logistic regression, I'm crossing the ROC curve. Any confusion in this part? What error is it giving me? Give me 1 second. Let's see. For input variables with consistent number of samples. Give me 1 second. I think I've changed something. FPR, DPR, ypred log, ypred tree. Did I have ypred tree? I had ypred tree, right? Tree.predict x test. Oh, tree.predict log reg.predict x test. Tree.predict x test. I have that. No problem. What seems to be the error? The error seems to be generating from FPR this thing. Okay, hold on. Give me 1 second. Okay, I wrote it right. I did, right? I'm getting the same error. FPR, PPR, thresholds log, ROC curve of ypred log. Hold on. Let me just check the syntax, okay? ROC curve, sklearn. Sometimes what happens is when I'm basically trying to print the values like this, I have to sort of be validated with if the results have been coming out right or not. Maybe sometimes I have issues with it. So y true, which is y label, right? I've passed in the y label properly. Y pred is correct. Oh, I'm so sorry. Do you see the mistake that I did here? It's y test, which is the y true. And I already have a y score. So yeah, that happens. Oh my God. Yeah, give me 1 second. Let's see. You have pos label as none and sample weight and drop intermediate. Acha nahi. Haan, we don't need that, right? We don't need that since it's a very simple. Hold on. Metrics.roc curve and y and scores and pos label equals to 3. We don't need pos label for that. Yeah. Y test, y pred. Y test, y pred. Y true with the y score value. I got that right. ROC curve for that. Okay, cool. Got it. Yeah. Because I usually have the habit of saying ypred. So I passed in ypred twice, not knowing ypred log is the ypred. So that happens, right? So plot. How do I plot a diagonal curve? Do you remember I taught this yesterday? Do you remember this? 0, 1, 0, 1, and then you have an R dash, like a dash line, or you can change it later on if you want to. I'll show you how you can actually do it. Plot. What is the first plot that I want to do? FPR log, comma, TPR log, right? Like true positive, comma, false positive rate log. What do you pass inside it? You pass label. What is this algorithm that I'm passing through? Logistic regression, right? So logistic regression. What is the next data that I've taken? Plot. What do I pass inside this? FPR underscore tree, TPR underscore tree. What do I pass inside it? Sorry, LABEL, right? Label. Yeah, LABEL. Label equals to decision tree. And we will do legend and we will do X and Y axis later. No problem. What am I doing here? You guys understand? What do we do properly here is plot.x label. Okay. Pass in plot.y label, and what I'm going to pass in on y label. And I will also do legend because legends are important, right? Because I've already passed in the label. I'll say location equals to upper or lower. I think let's keep it best. Okay, location equals to do. I don't need to do plot dot show because you just don't have to worry about. Let's also take a title. Plot dot title. What title do we take? This is AUC ROC curve for what algorithm I have taken? Logreg and decision tree. Okay. X label. What comes on your X label? The false positive rate, right? And this is the true positive rate. Okay. अब हम इसको पूरा ही ले लेते हैं जैसे तो copy paste and apart from false true positive rate. If I run this, which algorithm would you prefer for the output? Which algorithm is giving you much considerably better results in terms of accuracy in F1? So tell me one thing. For now, I have taught you how to implement only two algorithms, correct? Eventually, when I start teaching you 5, 6 algorithms, can you implement even 10 algorithms together, map them together and choose the best? My people, what I've taught you today is a practical way of doing things in your career, in your professional career. This is how you solve a problem. When you sit in a company, your company is going to give you data. This is how you run the test. This is how you actually implement the algorithm. Are you clear? I've just shown you guys a simple example, but I hope you got the concept of what I meant. I'm not sure if this is a good option. I'm asking. देखो, I mean, I'm just giving you guys an idea. ठीक है, I'm just letting you know. See, मैंने आपको क्या क्या implement करके दिखाया. We have done implementation of logistic regression. We basically did logistic regression, correct? We did linear regression. We did in classification. We've also done decision trees, like specifically decision trees. What we've done. But imagine if I actually run. Okay, you know what? I think we can let it be. I was thinking I will run 5 more algorithms and show you, like support vector machine, naive-based classifier in the same code. And then you could have decided, but I have not taught you the algorithm, so let's not do that. So the thing is, there are some best classification algorithms, जैसे logistic regression, support vector machine, you have XGBoost, you have random forest, right? I was thinking that why not run like 6, 7 algorithms and show you, but I'm thinking that because I've not taught you, it'll be a waste of time. But yeah, I mean, you guys got the concept, right? You guys can implement it on your own. Anybody confused with the way I've imported my data set? Anybody confused with the bf.shape? Okay. How about the variable x? I have taken a feature space or feature variable as the predictor variable as x. The target variable is this y. Any confusion here? I don't think you will be confused here, but mostly you will be confused in these 3 lines. Yes or no? I knew it. Okay. See, have you ever heard of a concept called standardization and normalization in machine learning? Have you ever heard of the concept called standardization and normalization? I'm asking everybody. And I have also one more question. The moment you eat your breakfast, won't you become a little sleepy? थोड़ा नींद आने लग जाता है कि नहीं? थोड़ा आलू का पराठा खा लिया तो थोड़ी नींद आ जाएगी. Huh? That's what's happening with all of you. What, my people? Huh? The moment I give you guys a little break, you come back like zombies, yeah. You come back like zombies. You had sprouts and you have lost energy. My people, are you all here? All the 87 people, all the 90 people, all the 50 people, all the 47 people, जितने भी हैं इस बैच में, 40-50 लोग जितने भी हैं इस बैच में. Are you all here, my 50 people, 40 people, जितने भी बैच में हो तुम लोग? You're there? Okay. Are you all focused? थोड़ा, are you all listening to me and alive and the food has not made too much change too much comfort in your body where your body is calling you to sleep in the middle of the night, in the middle of the day. It's 12 o'clock right now. How can you sleep? I don't know. But awake, can I teach you some new concepts which is going to be super important for your machine learning journey? You cannot afford to sit and relax, but to listen. You have to listen to me. You know what? I swear to God. I swear to God. I mean, if there was a technology that I could reach from my laptop and to reach all of you, I would have reached out. I would have just, what would I have in my phone? Not phone. I would have like a water spray, and it is considered as not a good practice, but I would spray the laptop constantly with water so that all of you are like up constantly. My question was very simple. I got no answers for it. I asked you a question. I said, you know what? Have you heard of a concept called standardization and normalization? And no, I am not talking about 2NF, 3NF, 4NF of databases. I'm not talking about database normalization. That is a different concept. That concept is a different concept. That concept is to standardize the data. Okay. We are not talking about 1NF to 1NF तो होता ही नहीं है 2NF 3NF that normal factor I'm not talking about. Standardization का meaning है, listen to me very carefully, okay? Standardization meaning everything follows a specific standard. Will you say this is the right statement in an English if I say? मतलब अगर मैं simple हिंदी भाषा का उपयोग करूं or if I talk to you in English, what is the difference in standardization and normalization? Acha, I want to ask you, have you ever heard of standardization and normalization? Okay. Can you give me a definition for it? Can you give me a definition for it? Okay. Can I say standardization and normalization, they follow under what topic of machine learning? Yes or no? Let's talk about standardization a little score. Okay. Do you know the another name or yet another name for standardization? It's called Z-score normalizer. Normalization, it's up to you. I like to call it normalizer because that's how I was taught. Standardization is also called Z-score normalizers. What it does, it takes each point and subtracts it with the mean. Each feature point subtracts it with the mean. The formula for standardization, S of sub Z, can be not sub G, the one that we eat, but sub Z, S of Z, S sub Z. Okay, S, not sub G. Be very careful of that, okay? X minus mu divided by sigma. What is happening here? Each data point X of I is been subtracted with its mean. Aren't you dividing that with the standard deviation? Yes or no? Yes or no? Okay. We have used a package called standard scaler. Standard scaler. Did we use standardization or normalization in our code? Standardization. Are you clear? The range after standardization ranges between what? What is standardization? Scalar. Standard scaler is a type of standardizer. Are you clear? Let's talk about normalization. If I tell you really one function that has truly 0 and 1 significance, it is not standardization, but it is normalization. थोड़ा भेजा फ्राई करता हूं आप लोगों का so that you wake up. Between standardization and normalization, a true function that really stays between 0 and 1, it is normalization and not standardization. Are you clear? The difference in standardization is the mean is converted to 0 and the standard deviation is converted to 1. But the range is not converted to 0 and 1. Are you clear? But the range for normalization is clearly between 0 and 1. Any confusion here? It will still make it between 0 and 1. Depends on the data. I'm just saying that normalizer will always make it between 0 and 1. In normalization, you know what is the most important thing that we do? We subtract a value, okay, then divide it with the range that it is supposed to have or it has. That is why it's called normalization. What we do is we take a variable called x. Suppose it is a variable. You take the minimum number or the minimum value or the range it has and you subtract it with this range of max and min. This is what normalization is. This is what standardization is. Any confusion? In normalizer, you will have a function called min-max scalar. Have you heard? Have you heard of something called min-max scalar? That is a normalizer. This is a standardizer. Look, the most important thing that you should realize, okay? Standardization scales the data around 0, okay? Rescales the data so that it has a standard deviation of 1, okay? It's useful because you want to have a very neatly arranged normal distributed data. But the normal distributions or a normalizer's job is to basically rearrange the entire function between 0 and 1, preserving the information. That's it. Standardization is used to preserve normal distribution. Normalization is to convert everything into a range of 0 and 1. So tell me one thing. In the code that I wrote right now, instead of using standard scalar, if I would have used min-max scalar, would it have made any difference? Would it have made any difference? I'm asking you, my people. No. Try implementing it. You will know what I'm talking about. Try implementing it on your own and then come back and tell me the feedback. Sir, I implemented min-max scalar. There is a clear difference in accuracy. Can you do that? Will you guys even remember the assignment I gave you? Can somebody remember the assignment I gave you? I told you to calculate the difference between fit transform and fit transform. Point number 2, I gave you an assignment to read, at least if you can't type it, if you are sitting free for 5 minutes, just to learn about what is standardization, what is normalization. If I apply min-max scalar here, what output am I getting? Is it good or not? I want you to try it out. You know what? I don't want to give you guys a hint. Try it out on your own and let me know what answer you get. Okay. My people, I have a small question I want to ask you. Have you ever heard the story that if you take a stick and try to break it, it will break easily. But if you take a stick and then you take another stick and then you take another stick and then you take multiple sticks like these and then you tie them up and you try to break them, you can't break a stick. So unity is a strength, they say. The example or the moral of the story, what they say is that unity is strength. Have you heard of that story? Again, no replies on the chat. If I was born in 1950s or something, I would have been known as the worst teacher in the planet because I would have carried a stick, huge stick, like a big fat stick I would have carried and a rat my students. Like, learn. Oh, you can't do that. Of course, you can't do that. With all of you, of course, I can't do that. I'm just thinking that, that is the best way of teaching, right? Like, people just get scared and they learn, right? So, my people, are you all here? Are we learning or not? Virtual stick, like, okay, listen to me. See, the point that I'm trying to make is you have multiple sticks, and those sticks, if you bend, you can't break them because there's unity. My question to you is, people, rather than having one decision tree, what if I have 500 decision tree? Like, rather than making just one decision tree on one data, can I not make 20 decision tree, different types, and then take a vote which is giving the right output? Could I not do that? Think about it on the top of your head. Could you not do something like this? One decision tree is not a good thing, is not a very great thing. Why don't we reshuffle the data, make another decision tree, reshuffle the data, make another decision tree? Like this, suppose I made 3 trees. Suppose tree number 1, tree number 2, okay? And tree number 2. And this is tree number 3, okay? My people, suppose this decision tree is saying that I believe the output is low. This believes the output is low. This believes the output is high. How many trees said low? How many trees said high? 2 trees are saying that the output, I believe, is low. 1 tree is saying high. So because 2 trees are confident, can we not classify that the output is low? Rather than having one weak learner, can I not combine multiple weak learner and together they become strong? My people, this is the concept of another topic that I'm teaching you called random forest. Now remember one thing. What is the biggest problem that decision tree gives me? The biggest problem that decision tree gives me is that it is very easily overfit. Yes or no? It will overfit very easily. To solve the problem of decision trees overfitting comes another algorithm called random forest that avoids overfitting. Are you understanding what I'm trying to say? Now remember, my people, ऐसा नहीं है कि you just decide to randomly make multiple decision trees, so you do it. Random forest has completely different technology, completely different random sampling. See, you have to do something called bagging, okay? Bootstrap aggregating when you do something called random forest. I'll have to come to that topic. The point that I'm simply trying to make today is just to introduce you to the topic of random forest, okay? Remember one thing, on the same data where decision tree performed terribly, random forest performs the best. If there is a data where no matter how good you have tried, your decision tree is always giving you a terrible result, random forest acts smartly. It creates multiple trees and each tree learns a specific pattern. I'll come to that. I'm just teaching you the basics, okay? Let's not go into the depth right now. I'm only teaching you the basics. So stick at basics. Then slowly and eventually I'm going to go down. Don't worry. I love the way you all ask questions. बहुत deep questions पूछते हो. But हम सीखेंगे. Don't worry. मैं हूं ना. I'm there. When I'm here, why fear? I'm there. Okay. So what did you understand from the analogy of random forest? Random forest does not believe in making one decision tree and taking all the decision based on one decision tree. Yes or no? It will create multiple. I'll give you an example. Imagine you are a CEO of a company. You have a CTO under you, CXO under you, CBO under you, C something BO under you. Won't you take the feedback from all these people? And based on the feedback, whoever has the highest number of people giving feedback कि हाँ सर एक काम करो, एक बिस्किट के बीच में एक पाइनएप्पल का सिरप लगा के फ्लेवर लगा के ये बिस्किट बेचेंगे तो बहुत बिकेगा. Example, a biscuit manufacturer. Most people will say हाँ sir, do it. One person says don't do it. So won't we always prefer taking vote? Whoever says the highest number, we prefer that mostly they are right. A random forest works on the same principle, exact same principle, nothing different. Are you clear with the concept? Okay. Can I take you guys through the concept of random forest in a little bit more depth, if that's okay? Can I take you guys through the concept of random forest a little bit more in depth? Okay, yeah. But before I do that, you need to understand something between vote matching. Okay, you need to understand vote matching. My people, I swear on all the gods, this question will come in your interview for sure. The now is bagging. भैया आपको पूछेंगे what is bagging. The full form of bagging is bootstrap aggregating. What is the full form of bagging? Bootstrap aggregating. Bootstrap का मतलब क्या होता है? What is the meaning of bootstrapping? My people, listen to me. Imagine you have a column called age, salary, and locality. And your target is, will you get a loan or not? These are your columns. What is your target variable and what is your feature variable? What are your feature variables? What are your target variables? Tell me fast. I want answers. Otherwise, virtual stick is coming. Loan is my target. Imagine, my people, you have 5 records. How many records? Okay, this is record number 1, record number 2, record number 3, record number 4. इसको मैंने आधे में split कर दिया तो record number 5. See, दिमाग. Smart. I'm very smart like that. Okay. How many records do I have? 5 records, 3 features. Yes or no? Listen to me very carefully. In creating a decision tree in random forest, you don't take all 3 features. Are you clear? You don't take all 3 features. You randomly take only 2 features, either age or locality, either salary or locality, either age or locality. Any 2 random you take, and in the entire record of 5 data sets, you randomly take maybe 4 random or 3 random. Are you clear? You don't take all 5. You randomly take record number 1, 3, and 5. So what did you take to create the first decision tree? Decision tree 1, you only took age, you only took locality, and you only took record number 1, 3, and 5. Are you clear? This is going to create your record or decision tree number 1. I will tell you why are we doing this. Don't worry. I will tell you everything why are we doing this. But please listen to me carefully. Everything will make sense. This is your decision tree number 1. Your decision tree number 2, randomly you now take salary and you take locality, and the random records is 3, 3, 5, 1 or comma 1. Duplicate records are allowed. Are you clear? You created another decision tree, which looks like this. Now, this practice is called bootstrapping. Okay. Now listen to me. Why are we doing this? My people, machine learning, every variable or every target, every feature variable has some importance, right? Like age has importance in predicting loan. Salary has an importance in predicting loan. Locality has an importance in predicting loan. Correct or not? If I just want to create a decision tree. Now listen to me very carefully, people. Imagine आप एक mechanic हो. Imagine you're a mechanic. Listen to me very carefully, okay? Everything will make sense. Imagine there is a bike. एक मिनट मैं आपको एक I'll make you understand, okay? I promise I'll make you understand. Oh my god, this is one of the weirdest bike on the market, but चलो ठीक है, इसी को सुना देता है. चलो. Imagine in a garage there are 4 people. Person number 1 is Tom. Person number 2 is Jerry. Person number 3 is Mike. And person number 4 is Harvey. Okay? Imagine there are 4 people in the garage. Apologies for that. See, Tom is a very good mechanic for only and only tires. Tom only understands tires very well. Jerry, on the other hand, understands engines very, very well. He does not know anything else. उसको बस engine कैसे ठीक करना है पता है. He knows how to fix an engine. Mr. Mike knows how the bike's shape, size, and chassis should be fixed, how the handle should be fixed, where are the handles, bolts, and all of that. And Mr. Harvey fixed only and only the headlamp. Are you clear? 4 people in the garage. 4 has a specific specialty. But to fix a bike, don't you need to fix a tire plus engine plus chassis or chassis plus light? Won't this become my feature space and my target is my bike is fixed? Example, I'm just giving you a weird idea, but the point is that each person is a special or has a specialty in fixing tire, engine, chassis, and only this. Yes or no? Agree or disagree? Now imagine in decision tree, when I'm taking age and locality, isn't this decision tree the best decision tree to tell you if age and locality come, I will tell you how to fix age and locality. Loan age and locality के हिसाब से कितना मिलेगा? Based on these two variables, I'm the best person to answer. And the second variable says, based on salary and locality, I'll tell you which is the best output. Are you understanding? Each decision tree is given a specific speciality कि तू इसको master कर, बाकी भूल जा. You become a master in this. If age comes of what category, you tell me what prediction should be. And tell me, because I'm combining all these specialists, won't at the end of the day, these specialists' answer are voted and the best answer we get? Are you now understanding why this weird thing happens in decision in random forests? Are you understanding the concept? You do not take all 3 variables. And you know what? I'll tell you something. The number of variables you're supposed to take is the square root of variable. How many variables do we have? 3. What is the square root of 3? 1.9. मतलब answer is approximately 2, correct? Answer 2 आ रहा है ना? तो randomly you only select 2 variables. Are you clear? कैसे decide होता है कितने वेरिएबल लेने? अगर 9 वेरिएबल है, what is root of 9? What is root of 9? So you will only take randomly 3 variables. Am I making myself clear? You guys got it right? अब चलो थोड़ा एडवांस में देखते हैं. Why is duplicate record allowed? Why are duplicates record allowed? My people, there is a small problem in random forest. एक छोटा problem है, मैं बताता हूँ. मैंने decision tree 1 बनाया. I created decision tree 1. I created decision tree 2. Please observe that while creating decision tree 1 and decision tree 2, I have covered all the variables properly. Age, salary, and location. All 3 variables are covered properly. Yes or no? All 3 variables are covered. But do you see that in decision tree number 1 and decision tree number 2, one record never made it to the decision tree, and that was record number 4. Record 4 never saw itself being represented in either decision tree number 1 or decision tree number 2. This record is called OOB, out of bag error. This happens in random forest. Because duplicate records are allowed, some records never make it to any decision tree. What do you call this? OOB, out of bag error. What do you call this? Out of bag error. Remember, when you write random forest code, you have the option how much percentage you want the errors to exist in the model. If you want 15% of the data to never go in any of the decision tree, you can control that. Are you clear? You can tune it. You can control it. Are you understanding what I'm trying to say? अभी use case पे आते हैं ना बाबा, आते आते हैं. We'll come to the use case also. पहले let's learn what is an aeroplane. Then I will make you sit inside an aeroplane. Then let's learn to fly an aeroplane. ठीक है? Let's go step by step. Don't worry, मैं सब सिखाऊंगा. Gentleman's promise. Okay? I will teach you everything. ऐसे I will not let my students be fools. Right? I will of course teach you everything. धीरे धीरे one step at a time. सब सिखाएंगे. Okay? And don't take me seriously. I do a lot of fun and jokes. So don't take me seriously and say that अरे सर तो बहुत ज़्यादा explain कर देते हैं. Right? I hope you don't take me in a wrong way. I'm just a little fun, happy-go-lucky kind of personality. So I usually tend to make jokes a lot to break the ice, right? So don't take me in the wrong sense. Just letting you guys know, okay? Don't take any of the things that I say seriously. Apart from the teachings that I'm doing, don't take any of the fun things seriously. Anyways, my point of explaining something to you was, you make a decision tree number 1, decision tree number 2. My question to all of you, should we control how many decision trees we want to make? Yes or no? Yes. Point number 1, 100% we control how many decision tree we make. You know what? If you don't give how many decision tree you want, random forest decision tree you want to make, by default, the model will make automatically 100. Are you clear? By default, this is called as a hyperparameter. You can decide the number of trees you want to make in a forest. But by default, if you don't input anything, it will make 100. But you control. Can you also control the out of bag error? That is also an out. This is also an hyperparameter tuning. You know what? You can even control the depth of the tree. How deep my tree goes. This depth is also controlled in random forest. You don't, yes, that's called max depth. You don't want your tree to go much more deeper. You don't want it to have more leaves, more splits. You can control the maximum number of features, maximum number of depth, everything you can control. Are you getting the concept? Look, guys, I haven't even taught you random forest. This is basic. मैं तुमको अभी bootstrapping properly भी नहीं सिखा रहा हूं. I'm just taking you through the top. Please don't think I've taught you bootstrap aggregating सब हो गया. इसको manually solve करेंगे, है ना? We'll solve it, right? So that we'll get idea. इसको करेंगे. I'm just giving you guys an idea कि इसका idea क्या है? What is the concept behind it? Are you clear? You guys got the concept clear with this so far? So are you now clear with the concept of what a random forest does? How it creates multiple trees? How many trees we also control? How many out of bag error we have that we control? And what happens at the end is, my people, remember, this is my data. Okay, this is my data. Don't you split this data into multiple format and create multiple small tables, multiple smaller data, and then you create a decision tree 1, decision tree 2, and decision tree 3, and then you get an output called 0, 1, or 0, and then you combine the output and say the output is 1. So bagging means this step is called bootstrapping and this step is called aggregating. Aggregating means combine karna. So this is bootstrapping and this is aggregating. So that is why it's called bagging. Bootstrap aggregating. So go bootstrap aggregating ka B agging. So you got it where the name comes from, bagging, bootstrap aggregating. Pehle bootstrap karo, data split karo, then combine them together. This step is called vote matching. Are you clear? Where multiple votes, whoever votes is higher, that gets the vote. I have a small question to ask you guys. Instead of having 3 trees, if I have 4 trees, suppose tree number 4, and the output for this is 0, what should be my vote matching? What should be my output? Array, they are tie, no. 0 and 1 is tie, right? 2 zeros and 2 ones. How will you get an output? How will you get an output? Can I tell you guys what happens in the actual reality? The number of trees are always odd. In reality, even if you give an even number, it has a mechanism called tiebreaker mechanism. Okay? If you've not heard of it, let me give you guys an example. In every machine learning algorithm, okay, there is specifically a tiebreaker mechanism. What it does is when something is getting tied, it breaks that by creating one more tree or by adding some error into the problem so that they don't become even. That's what I'm saying. So imagine for 100 trees, you got 50, 0 and 51. Okay. Imagine for 100 trees, you got 50, 0 and 51. Okay. First of all, this condition happening itself is very rare. Will you agree? Will you agree? Given the entropy in the data, given the randomness and the chaos in the data, it is not always very much possible that 50-50 happens. But for some reason, you have given 100 tree, 50 is becoming 0, 50 is becoming 1. Then there is another function called tiebreaker mechanism that enters. What it does, it adds one extra tree so that it becomes odd. Did that make sense to all of my people? Because it becomes ties, it adds one more tree. That tiebreaker will not be activated if the even odd are is different. It only gets activated when both are equal, which is the rarest of the rare case. ये बहुत मुश्किल से होता है. It's done automatically. You don't have to worry of it. It is taken care of automatically. You will just get the output. So see, we learned and we questioned so many things in random forest, didn't we? Bootstrap aggregating क्या होता है? ये कैसे बनता है? How does the whole thing work? And कितना amazing algorithm है, right? Like how amazing is this algorithm, right? It's combining all the weak learners. It's taking a learner which is weak. Why do we call the learner weak? Because this learner only knows part information, right? Partial information. This learner is not a strong learner like decision tree. So can we say bagging is reducing error and optimizing the model in comparison with decision tree, reducing overfitting issues? Yes. But the problem in random forest is it introduces bias. उसकी भी बात करेंगे, ठीक है? But Ronak, on an generic agreement level, yes, bagging helps you do something called vote classification, with which your overfitting is to an extent reduced. But what random forest does is it adds an extra bias to the model. हम उस पे आएंगे, ठीक? Tell me one thing, is anything in the world 100% safe? Algorithm, food, medicine, कुछ भी perfect है इस दुनिया में? नहीं ना? So do you think this algorithm is also perfect? No. This also has problems. It has big problems. We'll talk about that. Okay. We'll talk about that a little later. But it solves the problem that decision tree created for us, which was overfitting. Is that sort of clear to everybody? I hope everybody's clear with that analogy, that better than decision tree. Can you tell me why? Because decision tree is a very deep tree. Yes or no? Decision tree makes itself very deeper. The number of tree length becomes bigger. Here, the length is clipped. Are you understanding? This technique of clipping the tree is called pruning. What do you call this? What do you call it? This is a very important interview question. It's called pruning. Whenever you have a tree, imagine, my people, listen, this is the tree I have, okay? Listen, this is the tree I have, okay? Listen to me. I don't want my tree to be so deep. So I can prune it. यहाँ से काट दिया, यहाँ से काट दिया. आप समझ गए? This is called pruning. Like how we prune, जैसे हम we give the shape of the trees some shape, right? Like elephant shape, giraffe shape. In the gardens, you must have seen that exact same concept. In random forest, it's controlled because we prune the tree. We don't let the decision tree become deeper. Are you understanding? So that overfitting is reduced. Are you clear? One decision tree would be so deep, but in decision random forest, you're not allowed to go deep. That is why overfitting is avoided. How do you feel after me teaching you a couple of new concepts? How do you feel? Is it logically making sense to all of you? Let me ask you guys a question, okay? And I would love to get your answer on it, okay? Sir, do you also do pruning in decision tree? Yes. See, you can also control the depth of a tree based on the data in decision tree also. But it is one decision tree, so it is going to overfit. Just know this for a fact. Max depth pushkar also exists in decision trees also, but in random forest they are highly controlled. In decision tree they are not controlled. It's an option. In random forest it's not an option. Sir, one question. By pruning, model is doing thing for us, like shrinking features to some extent, like 100 to 50 or 60, that it could get preserve even 80-90% of genuine data. Very good question. Yes. By pruning, what we do, okay, we reduce representation. Okay, representation. So let me give you an idea. If you take column age and salary, when you create a decision tree based on age and salary or maybe other column is getting represented, correct? Suppose there are column called A, B, C, D, E, F, G. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. H, example. So I am randomly taking ABC or BCD or ABC, right? BCD, CDE, EFG and FGH. For example, I can take any of the random thing. By reducing the depth, we only reduce the representation. Okay. By reducing the representation, of course, we are reducing the extent of the data that is represented by the model. But what it does in real life is, suppose you have a column called high, low, and medium. Okay. Column A. One decision tree. Okay. And you have a target called will go to tennis, will not go to tennis. What a decision tree does is all the high yeses and all the high no's, it will learn in one tree. All the low yeses and all the low no will be represented in another tree. All the medium yeses, all the medium no's will be represented by another tree. Are you got it? And this tree will be replicated also. Multiple trees like this will exist. So it will go deeper and deeper. So we cut the representation because we know at the end of the day, we will vote match them later. So the representation is reduced. Each representation has its own specified decision tree. Yes, to answer your question, yes, representations are reduced, but that is deliberate. We do that with a specific intention. Remember, my people, in an interview, you do not have to worry about prepare machine learning in such a way that you're having a conversation with your interviewer and not an interview. He asks you something, you answer right there and then with an example. See how I'm giving you a couple of examples. You say, "Ek kaam karta hu, main example se batata hu." Give an example. How impressed will the interviewer be? Because you have an in-depth knowledge of how things work. You know how many default trees are created. You know there is a max depth feature that cuts the tree. You know you have to create a root node, like how decision tree works, and you are creating a random forest. Is everybody clear with the concept? So yeah.
Just a quick info, guys. Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI, and Power BI. Get a data science certification from IIT Empowertak, an innovation hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.
Random forest. Okay. Random forest. Now, I gave you guys a subtle hint when I started decision tree. We can conclude through decision tree how many scenarios based on data. Is that correct? Yes. We can conclude that is my decision tree first of all balanced? Okay. Is my decision tree based on the look of it? Does it look like it's a balanced decision tree? Every variable was split accurately, perfectly. Looks like everyone was given equal importance, and it's not sort of one-sided. It's kind of balanced. So that's sort of the aim of plotting the decision tree. You can't do anything about it. It's just to analyze. Okay. Anyways, right now I'm going to take you guys through a concept called random forest. Now remember one thing, random forest is a very important algorithm for many reasons. Do you guys remember why random forests are considered better over decision trees? Why decision trees are not considered good? What could be the problem, or what could be the, I don't know, the issue of decision trees? What do you think are the problems? Yes. What do you think are the problems of decision trees according to my people? Decision trees are prone to do what very easily? Decision tree are prone to what? मतलब फटाफट सबसे पहली चीज, what are they good at? They are good at understanding the data that they're trained on, correct? Are you understanding? Decision tree learns the best thing it can from the data it is trained on. But the moment you test it out, it is not very confident. So can I say there is instability with respect to variance? Instability with respect to variance ka meaning is it is very good in training data, terrible in test data. Number one. Number two, can I say it overfits super easily? You don't even have to work hard. You don't have to work hard. It will overfit itself easily. Okay. Point number three. Can missing values or NaN values cause problems in decision tree? 100% easily. If you pass a column of 20 data rows, and if 4 are empty, look at it overfit at another level. Extrapolation becomes hard. Are you understanding what I'm trying to say? Decision tree is highly unstable. Okay. It overfits very easily. You pass some missing values, it's done. Sorted. Everybody sorted until here. Now, random forests are actually implementation of something called ensemble learning. Have you heard of this concept called ensemble learning, my people? Have you heard of a concept called ensemble learning? No. Let me tell you what that is. Let me tell you what ensemble learning is. Guys, tell me one thing. When you take advice from people, or when you start taking advices from, okay, rather, let's say you are hurt. Okay. Let's say you were driving and you got hurt and you hurt your arm. Okay. You went to a doctor number one, and unfortunately, the doctor that you went to said you will have to amputate your arm. Now, tell me one thing. Will you just believe what doctor number one said, or will you maybe go to maybe doctor number two, doctor number three, doctor number four, and see which doctor claims that he can save your arm? It's called having second opinion. Yes or no? Correct or not? We call this having second opinion. In India, we are proud creators of the concept called second opinion. No matter how rich you are, you always have a concept called mother. Okay. And a mother will always take a second opinion from everybody, right? Same thing happens in all our families. So the point is that you take a second opinion. Imagine you have a data, and on this data, you run logistic regression, and logistic regression says, Bhaiya, you will get a heart attack. Suppose 0 and 1. 0 means no heart attack, 1 means heart attack. Isn't it better that you take also another algorithm, pass through the same data, and let's say random forest? What is it predicting? 1. You also pass it through naive-Bayes classifier. What is it predicting? Bhaiya, it predicts 0. You also pass it through support vector machine. That says, no, bhaiya, you will not get it. Suppose you also pass it through XGBoost. Okay, this is also another algorithm. That also says no. So how many algorithms opinion did you take on the same data? 5. How many are 3 and how many? Who is winning basically? Are you won't get heart attack, you will get attack. Who's winning? You will not get heart attack is winning, right? Yes, this kind of technique is called ensemble algorithm. Ensemble meaning you take multiple experts, you let those experts run on the same data and you let the experts give the output. Whoever is answering higher, that vote will be considered correct. Did you understand? Here we are taking whoever has the highest voltage, that person will be considered as the right answer, or that answer will be considered as the right answer. This technique is called ensemble learning. Are you clear? Did you understand? You are combining multiple algorithms to create what? To create one strong classification algorithm. Did you understand? Rather than having one classification algorithm that can overfit, underfit, that will have a lot of problem. Rather than that, you are combining all the algorithms and let them answer the stuff for you. This is called ensemble learning. Random forest is sort of like an ensemble learner. You know how? Let me tell you. I told you, imagine you have a data called column A, column B, column C. You know what? Let's give it a good let's give it a good tadka. Okay. Let's say you have a category called age. Okay, you have a category called salary. You have a category called years of experience. Okay, you have a category called domain. Which domain do you work in? You know, IT and all of that sense. And the target variable is okay, will you be given a loan or not? Okay. Will you be given loan greater than 10 lakh rupees? Okay. Example. Okay. Will you be given a loan higher than 10 lakh or not? So this is my columns. These are my features and my target variables. Okay. Age, salary, years of experience, domain. And here is the thing. Now tell me one thing. Let's be smart about it. Let's understand what kind of data we've gotten. पहले तो age is a number between 18 to 70, correct or not? This is the range for age. See, salary could be, yeah, 15,000 से लेके 15K से लेके 3 crore तक. Example. Okay. Years of experience can be up to 0 years of experience up to max 50 hota hai, right? Like above 50 people end up retiring, I'm assuming. And domain is category, right? Like tech domain means 1, non-tech domain means 0. Yeah, tech domain, non-tech domain. And loan is 0 and 1. Do you see the things that you're dealing with in the data? One is a variable that is between 18 to 70. Other is between 15,000 to 3 crore. Other is between 0 to 50. Domain is a categorization of 0 and 1. So out of all these variables, where will you apply standardization? Where will you apply normalization? Where will you apply both standardization or normalization and get the data in the range? What will you do here? 30. कर देंगे इसको, no problem. Where will you apply standardization? Where will you apply normalization? Do you guys know what is standardization? Do you know what is normalization? Do you guys have any idea about it? Okay. So tell me one thing. This is a range between 18 to 70. This is a range between 15,000 to 3 crore. This is a range between 0 to 30. Won't you apply normalization on all three? Not standardization, normalization, Preeti. Think about it. Don't you want the numbers to be between 0 and 1? And you don't care if the mean is 0 and standard deviation is 1, which is what standardization does. Standardization does what? It creates a distribution where your mean is 0, standard deviation is 1. But you want values between 0 and 1. So won't you apply min-max scalar here? Yes or no? Won't you apply min-max scalar here? And all the ranges will be between 0 and 1, 0 and 1, 0 and 1, 1 and 0. And then output is 0 and 1. Now you can run machine learning on it. Let me tell you one thing. My people, listen to me. Listen to me very carefully, okay? Look, if you are, okay, now in this current scenario, if you people don't know that this data cannot be used for machine learning, you guys are in big problem. Okay, because you guys are studying data science, you guys are learning machine learning, but you still don't know whether you want to apply standardization, what normalization, where do we have to apply, how do we have to apply, then there's a big problem. Okay, so let me ask you once again, did this make sense? Why did I apply it? Did you understand the logic? So that the reason why we apply it, because so that every range will be converted between 0 and 1, yes or no? Why do we convert between 0 and 1? Because mathematically computation will be reduced, correct or not? Information lost will not be there, and everything converts itself between 0 and 1. Did you understand? So that the machine understands and calculates things very easily. Yes, that's what we. Okay, anyways, let's learn what a random forest does, how to implement it in program. Okay, super simple. And today I will also teach you, have you heard of something called hyperparameter tuning? Okay, when a decision tree is made, a decision tree's depth you can decide, the width you can decide, maximum samples you can decide. You can also decide how much pruning I need to do on the left hand side, right hand side. So all this stuff we can decide, right? But when I implemented the program, हमने कुछ किया? Did we do anything? Has decision tree been passed with any variable here? None, no hyperparameter. So there is no concept of tuning, but I'll teach you how to tune also. It's a very practical aspect. It's a very, very important and a practical aspect. We'll come to tuning also, no problem. So coming back to our random forest. So sir, what is random forest? Okay, what exactly is random forest, sir, and why do we need to implement it? Remember people, whenever you have a variable called age, salary, years of experience, domain, and the target variable is loan greater than 10 lakh and not, you will get or not. So suppose if this is your domain or this is your data. I told you random forest works on the concept called bagging. What was the full form of bagging? Bootstrap aggregating. For people who do not remember this concept, let me tell you what bootstrapping means. What is bootstrap data? Okay. Point number one. What is bootstrap data? You see this particular column that we have: age, salary, years of experience, domain, and loan. So let's say you have a column called age, you have a column called salary, you have a column called years of experience, you have a column called domain. See, assume people in the entire data set of age, salary, years of experience, you have takriban 10 records. Suppose this is your overall 10 data. In bootstrap data, you take equal amount. If the overall data set size is 10, you take equal amount of samples in your original set. But here, the number of records that can repeat or duplicate are allowed more than one. Suppose there was record number 1, record number 2, record number 3, record number 4, and record number 5. So suppose you took record number 1, record number 2, record number 2 is repeated, record number 2 is repeated, record number 3. 4 and 5 are missing. This is called as a bootstrap data. Am I making myself clear? This is called bootstrap sample number 1. Did that make sense? So what is step number 1 in creating random forest? Create a bootstrap data set. Once this bootstrap data set is created, now you build a decision tree on top of, okay, age, salary, years of experience, and domain. So let me tell you the incomplete part first, and then let me tell you the complete fast. Because actually in real life, when a random forest is, when a decision tree is created, we come back and check the accuracy using the out of bag errors. Okay, we actually come back with the out of bag error samples and we check it, but I'll come to that later. Okay, let's learn the easy part first. Once you've created the bootstrap data set, now tell me one thing, guys. How many columns do I have to split the root node on or decision tree on? How many do we have for my decision tree to be created? How many variables do I have? 4, right? But do you use all 4 to create a decision tree? No. Did you understand? Once a bootstrap data is created, you use random subset of variables. Suppose from salary and years of experience, you choose any one of them to first create a root node and then split the node for further, choosing random subsets of variables. Are you clear? It's completely random. First, you choose 2 variables to become root node, other 2 variables to become subnodes, then other variables to become as subnodes. Am I making myself clear? You don't choose all 4. You choose any random ones to decide which one do you want to make root node. And based on that, you create your first decision tree. Are you clear until here? And this decision tree is created on what data? Not the original data, but on the bootstrap data. Are you clear? This decision tree is not created on the original data. It's created on the bootstrap data where multiple duplicates are allowed. Am I making myself clear? So you just created the first decision tree. Now what do? Repeat step number 1 again until How many decision trees you want, that many decision trees have been created. Did you understand the topic, the concept? The logic is very simple. Are you clear until here? You have original data. You take a bootstrap data. You create decision tree number 1. Remove that bootstrap data. Create another bootstrap data called bootstrap data 2. Make another decision tree. Remove it. Make another decision tree, bootstrap, until how many trees you want. How many trees you want, that decision is up to you. By default, if you don't mention how many decision trees does random forest create by default, 100. My people, if you don't tell random forest how many trees it will create, how many by default it will clear, it will create 100. Let me show you. Let me show you. Do you see this? The number of trees in the forest, by default it is given 100. N estimator is nothing but the number of trees you want. Am I making myself clear? See, by default it gives you 100. Okay. After you have created this step number 1, 2, step number 2, and repeat this, step number 4 is final vote matching. What do you mean by vote matching, people? Suppose you created 100 trees. Okay. Out of this 100 trees, 70 trees says that yes, you will get a loan, and 30 tree will say no, you will not get a loan. Who is the clear winner? The people who have said yes, you will get a vote, 70. So are you clear how a random forest does? Did that make sense? If the data set is small, okay. So here is the thing. If your data set is even of 5 records, it will try to create 100 trees. And these trees will be duplicates of themselves because there is no versatility in the data. But unfortunately, you do not implement decision tree on a smaller data set, or random forest on a smaller data set. You can do it. Did you understand the concept, my people, of decision tree or random forest? It's not a very complicated thing. Did you understand until here? Step number 1, the easiest way I could have taught you, I have taught you. Can we go a little more deeper? Should we go a little bit more deeper? We should. Tell me one thing. How many columns do I have in my data? How many columns do I have in my data, my people? Let's take it like this, okay? Age, salary, years of experience, and domain. Okay? Okay, let's remove this. Imagine there is record, say 23 years old. Salary is 48,000 rupees. Years of experience is 2 years. Domain is tech. Will you get a loan or not? ये तो हम बाद में देखेंगे. Age is 45. Salary is 1.8 crores. Years of experience is 15 plus. Domain is tech. 33 years old guy. Salary is 78,000 rupees. Non-tech person. Okay. Age is 59. 3.2 crores. Okay. 16 plus 18 plus years of experience. Non-tech domain. ठीक है, दोनों ले लेते हैं, एक और ले लेते हैं. 61 years old, 4.1 CR, 22 plus years of experience, tech domain. ठीक है, अब एक बात बताओ. This is record number 1, this is record number 2, this is record number 3, this is record number 4, and this is record number 5. Does anybody has any confusion in the records? This is the data that I have written. I created my bootstrap data called BT1. Okay, I have created a bootstrap called bootstrap 1, where I have taken a record called 1, 2, 3, 3, 4, and 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I need to remove the last one. This is bootstrap number 1. Okay. You created a decision tree out of it. I create another bootstrap record called BT2. I take a column called 1, 2, 2, 3, 3, 2. Example. Okay. I'm just giving you an idea. Here you create another decision tree. Listen to me very carefully and try to understand what I'm trying to tell you, because everything will make a lot of sense to you right now. Okay. It will make a lot of sense to you in a minute. Okay. Think about this. When I create a bootstrap data 1 and I create another decision tree, before I create a decision tree, okay, before I even start creating a decision tree, don't I need to know that from age, salary, years of experience, and domain, do I randomly select between salary, years of experience, or salary, years of experience, and domain? Yes or no, my people? Do I choose randomly between 2 records, randomly between 3 records, randomly between all the records? Don't I need to test that, verify that randomness also should be how random? Did that make sense to you? In random forest, okay, the very first thing that we create without any problem is a bootstrap data set number 1. Okay? Once we create a bootstrap data number 1, a bootstrap data meaning what? Meaning very simple. We take original data, we let the duplicates also come into the original data, but the data set size is as big as the original data. The size. If the original rows were 1,000, you take 1,000 only, but it is bootstrap. Duplicates are allowed. Now, what happens is when a bootstrap data is created, the next step is to create a decision tree, to actually create a tree. But the problem is, should I randomly choose between variable or feature number one, feature number two? How many features do we have? Age is feature number one, salary is feature number two, years of experience is feature number three, domain is feature number four. So decision tree says that, hey, should I randomly choose two or three or four? You know what decision tree, what random forest does? It randomly chooses two first, creates a forest. Then it creates three, creates a forest. Then it randomly chooses all four, creates a forest. Whichever decision random forest performs the best on out of bag data, that forest is kept. Are you clear? Even to choose between random features, it runs iteratively. It doesn't just choose between two. Am I making myself clear? Because it's random, right? So ordering won't matter. It won't matter. What order you take it, it won't matter. It's highly randomized. Did everybody understand the concept? Then your random forest is created. This random forest is tested on the out of bag data, and then out of bag data pay, if it does good job, it is given to you. Tell me one thing, whenever we run machine learning, won't we divide the data in X test and X train? Yes or no? So why do we have out of bag data when we have X test data? Remember one thing, my people. X test data is to test whether the algorithm works best or not. Correct or not? Out of bag data is to test whether the forest that has been created is good or not. So did you make sense? Test data is different. Out of bag data is different. Out of bag data tells the random forest classifier that the forest that is being created is good. It is for internal validation. Test data is for the algorithmic validation. I hope that the concepts are clear. Out of bag error is for internally decision tree to make a good judgment. But the X test is for the entire random forest to make a judgment on the entire algorithm, the pattern, the entire data set. Did it learn the patterns or not? So I hope the concepts are clear. X test and out of bag errors are completely different. How many percentage of out of bag error is seen? 1/3 data of an entire data is in random forest considered to be an out of bag. And remember one thing, guys, you must hear a term called OOB error, out of bag error. Out of bag error means, suppose 9 classes out of 9 categories out of bag error, 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 of them were give loan, 5 of them were not give loan. And my prediction was 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. One prediction I gave wrong and rest I gave correct. This is 1% error. So out of bag error means from the original out of bag data, how many were you not able to predict correctly? That is called out of bag error. Did the logic make sense? Good. My people, in this entire data set, isn't row number 5 my out of bag data, which could never make it to bootstrap number 1 or bootstrap number 2, correct or not? So actually in real life, the data is that my age is 61. I make 4.1 crore rupees, 22 plus is my age, and the output is that I gave him a loan. Okay. So suppose my output is I gave him a loan. Okay. This is my target variable. Okay. This is my target variable. I give him a loan. On this data, my random forest predicted that I did not give him a loan. So am I not wrongly predicting the out of bag error? Out of bag data set's actual prediction, true positive, is yes, you give it loan, but your prediction is don't. So isn't this an error on an out of bag data? This error is called out of bag error. When you do wrong prediction on an out of bag data, it's called out of bag error. You just need to calculate how many numbers you did wrong and convert it into percentage. That's called out of bag error percentage. Did that make sense? Isn't training data, my target variable prediction is 1, and once you create a random forest, you can make a prediction on the out of bag data? Did that make sense? Once your random forest is created, can't you help take your random forest and say that अब इस डेटा पे predict करके बताओ कि इसका आंसर 1 है या 0 है, and if it says 0, target actual value 1 है, your prediction is 0. So won't you get an understanding? There is a feature called, you know what, A B के बदले, let's write it like this. Feature number 1, feature number 2, and a target variable t. Yeah, this much you understood? Okay, so see dear, in Bootstrap data, what we do is, suppose there are 3 records. Okay, imagine my original data has only 3 records, record number 1, record number 2, record number 3. When I create a Bootstrap data 1, dear, okay, feature number 1, feature number 2, feature and target number 1. So here, Nadir, what happens is, let's say I randomly chose, row number 1. So chalo, row number 1 I took. Okay. Then I take row number 2. Then I will take row number 2 again. A duplicate is allowed. So this is called Bootstrap data, dear, where in original data, all records are unique. Yes or no? Each record is unique. 1 record, 2 record. In Bootstrap data, you're allowed multiple duplicate value. You know, it can happen that one Bootstrap data can have all 2s also. All 2s also can happen in Bootstrap data. Did you understand? In a Bootstrap data, we take multiple copies, multiple duplicate values. Did that make sense, dear? That's all Bootstrap data is. Originally, the dataset size was 3. After Bootstrap, the dataset size is 3. It's just that you're taking more than once multiple duplicate values. Okay, this is what I wanted, okay? To get clarity that you guys got the concept of random forest. It's not a very complicated topic. It's not. Genuinely, truly, frankly, it's not. If you know decision tree, you will know random forest. But the fact that I wanted you guys to know that, you know what? A decision tree is created in a random forest in a very different way. And my question to you is, guys, have you observed or did you think, why are we creating bootstrap data? Why are we randomly taking only 2, 3 variables? Did anybody think, why are we actually doing this? Why are we doing this? Why are we randomizing things so much? Why are we allowing duplicate records? Do you remember I told you that random forest is a technique where weak learners combine to become a strong learner. When you're alone, you are weak. When you are with multiple groups, you are strong. This is to avoid overfitting problem, to increase randomness, to increase variance, not increase variance, but to balance bias and variance, okay? To balance bias and variance, basically. So the point why we do this is because won't random forest tell the algorithm, or the random forest will tell the decision tree that you, from age and salary and years of experience and domain, you become a master of how salary acts with a domain. You only learn salary best. Forget about everything else. Other decision tree will learn how about salaries best. So won't that knowledge of combined people, experts will give you a better clarification that, hey, based on my experience, it looks like it's 0. And then your output comes relevantly better, and more the decision tree, better is the classification, because more training happens on those decision trees. How about we implement random forest practically? Would you be up for that? We ran uh, uh, a decision tree. We ran couple of different algorithms. Okay. Today we want to implement random forest. What do we want to implement? A random forest. Now, how do you implement a random forest? Very simple. Do you remember I just taught you a concept called ensemble learning? Ensemble, combination of weak learners. sklearn.ensemble. Just call sklearn.ensemble. Import. What do we import? Random forest classifier. That's it. It's that simple. That's all you have to do. From sklearn.ensemble, you call something called random forest classifier. Okay. So every supervised learning algorithm can be implemented as an ensemble technique, because when the data is labeled, you can run the algorithm for it to learn the pattern, to understand what's exactly happening. So you can run multiple different types of algorithm on one data set. We were implementing. Okay. Here's a great stuff. I think I love this. Has it ever happened to you that you wrote a code today? You understand that code like 100%. The next day you come and look at it, the code may not be that understandable by you. Has that happened to you ever? You wrote a piece of code. Okay. You wrote a piece of code. You wrote a piece of code. You wrote it. You created the logic. You are everything that's created. You understood that. You slept in happiness and peace that, look, I wrote such amazing code. And the next day you come, you actually has to read what I wrote. Once you read it, you will understand, but you have to read through it, right? Look how amazing is that. We wrote a code 1 week back, and now looks like, hey, I need to sort of do a quick revision of my code. Let's do that. Okay, let's do that. The solution to this problem is, don't worry. Don't be scared. Go to the very first line and read through it one by one. What did we do, my people? कुछ भी नहीं किया हमने. We imported sklearn pre-processing standard scalar. We loaded the data set. Once we loaded the data set, boss, we figured out its shape. We dropped the target, right? We dropped the target variable because we want the target variable to be in the y, not in the x. Then we took the target variable in the y. Then we basically what we'll do, we'll run it once again. Okay? We'll run it once again. So run it, run it, run it. Okay, we take shape. We ran logistic regression code. We ran decision tree code. We ran decision trees plot algorithm. But guess what? After decision tree, aren't we supposed to implement something new today? Isn't it? Aren't we supposed to implement something new today? So what did I teach you today? Didn't we just learn Arabic right now a while ago? Ahlan wa sahlan. So we will be implementing Arabic right now. How do we implement Arabic? Random forest classifier is equal to, how do we do it? What do we write here? Random forest classifier and this much. Yes or no? Do you remember we didn't actually need to implement the whole thing from scratch? Do you remember what we did? We just took the entire code, we copied it and we pasted it here. You remember? And we just changed this tree into random forest classifier is equal to, we just changed it to random forest classifier. Do you remember? Line by line we had changed. So this tree dot fit will become what? RFC dot fit. X train, Y train, right? Let me comment out these so that only the uncomment ones have been corrected. Any other issues here? No. Right? I have implemented everything correctly here. Okay. Now let's fix this line. Y underscore pred underscore tree. Instead of this, can I say forest? This is y underscore pred underscore forest. So instead of tree dot predict, can I say RFC dot predict x test? Makes sense. Let's fix the matrix part of it. Okay. Let's fix the matrix part of it. So my people, tree underscore accuracy underscore score. Is that something that we can take? Actually, no. It is random forest classifier. Instead of tree, we can replace RFC. Instead of this, we can replace RFC. Acha, what do we need to replace here? Y underscore pred underscore forest. Y test. Y underscore pred underscore forest. Any confusion in this part? We've just converted everything into a forest part. Yeah, no confusion. Confusion matrix. Y test. Y pred forest. Y test. Y pred forest. Y test, Y pred forest. Y pred forest is written RFC dot fit of X train, comma Y train. Nothing is wrong. Okay. What do we do here? We implement this. How do we implement this? Now tree underscore accuracy underscore score ke badle we write RFC underscore accuracy underscore score. Yes or no? Tree underscore F score means RFC underscore F1 underscore. So we will come here and we will paste it here. Tree underscore confusion underscore matrix ke badle RFC underscore confusion underscore matrix. And Y pred tree ke badle, we will have to pass Y pred forest because this is also another thing that we have to pass. And if I run this, what answer did I get? Do you see that it is doing a fascinating job at precision and recall? 92% precision on 0th and recall of 93% on 1. Average is 84%. Yes, my people? Yes. Any confusions? We just ran random forest classifier right there in front of you. I've run it. Can I teach you how to make this algorithm even better? How to increase the accuracy? I'm not done yet. अभी तो बहुत करना है. अभी तो we have a lot of things to cover. I'm not done yet. But tell me one thing. Right after this is done, am I not printing that I've run logistic regression decision tree? What is the last algorithm that I just implemented for you? Random forest. So accuracy is LR accuracy score tree underscore score. After this, what will come? RFC accuracy score. Yes or no? Random forest accuracy score. So I will say random forest accuracy score. F1 score के लिए RFC F1 score. If I copy this and if I paste it here, do you see that I'm getting the accuracy for logistic regression, decision tree, and random forest? Yes, it is same. It is same. Both F1 and accuracy is same. We will change that in a while. Don't worry. We will change the variables. We'll change the whole LR, T, F1. We'll change them in a while. Don't worry about it. How about FPR log, FPR tree? What do we need to do now for this particular example? What do I need to? Acha, can I copy the same thing and paste it here? Can I do this? So can I say FPR underscore RFC or yeah, tree TPR underscore random forest classifier and threshold of RFC? Can I do this? Just to say that this is a random forest classifier. ROC curve of Y test, Y pred. What did we pass inside this? Forest, right? Did it run? So what do I need to write? One more line as plot dot plot. What do I need to write here? Plot dot plot. FPR underscore tree ke badle RFC. TPR tree के बदले TPR RFC and label is equal to random forest. Random forest. Do you see the difference? Do you see logistic regression and random forest, because they had the same output, they are hidden. They are overlapping each other. So you are only seeing two graphs. Did that make sense? Because they are overlapping each other, you are seeing two different graphs. So see here in my random forest part, y test, y pred forest, y test, y pred forest, y test, y pred forest, RFC, F1, RFC, accuracy score, confusion matrix, and all of that stuff. We plotted that basically. We got, a similar answer in the, in the whole categorization. I got the same answer. But I want to make my algorithm perform much more better. How do I do that? Okay, think about it like this, okay? See, what happens is when the original data that you have has 5 rows or 5 subsets of values, and you take the first bootstrap data number 1 and bootstrap data number 2, right? Some data will never be visible in the bootstrap number 1 or 2 or any part of that data. The number of this data who never make it to this is 1/3 of the size. Now what happens? Suppose the target variable for this said that the loan will not be given to this person. The loan will never be given to this person. Okay. Oh, look at that. Somebody wants to give me a loan and credit card. So a lot of calls every day. So what happens is this data is used to then tell internal random forest classifier that are you performing good or are you performing bad? So suppose if this data was never seen in the training and I want to validate my result, suppose a random forest was built. Now random forest prediction is 1. The actual value is 0. Your prediction is 1. Aren't you giving an error and your model needs to improve a little bit more? So the entire random forest will be deleted. Another random forest will be created where the out of bag error is lesser. Okay. Did you get it? If you want, I can implement it. If you want me to implement out of bag error also, I can implement it. It's not a very complicated thing. Let me show you. Do you see this? Yeah. Do you see this? OOP score, out of bag score. Score of this training dataset obtained on an out of bag estimate. This attribute exists only when OOP score is true. So this is a float value. आप कुछ भी दे सकते हो float value में. जैसे I'll show you. Okay. Here they must have given you an OOP score ka answer. Give me 1 second. I'll show you how that is done. Okay. Give me 1 second. Yeah. Can you see this? OOP underscore score equals to false. So what we will do is, if we go back to our code of decision tree or random forest, we can pass in OOP score equals to true. Okay, run this. And hold on, let me just cell run all karta hu main, okay? Cell run all. Let's see. Do you see a slight difference in the random forest accuracy? Initially, logistic regression and decision tree were overlapping, and now suddenly there's a slight change in the algorithm's accuracy. It was overlapping earlier, right? You guys saw that, right? Like after I make the OOP score as true, what true means is you decide and minimize the score like that. Like you decide and make sure that the out of bag errors are 1/3 and there's a proper proportions or all of that. Now they are distinct. Bas itna implement karna hai, nothing complicated. It's very simple. That's it. There's nothing fancy to that. Okay. Can we implement hyperparameter tuning now? Can we make our logistic regression better? Or we can try to. If it is not going to get better, it's not a guarantee that the hyperparameter tuning will give you a better result. Depends on the data. But can we at least try? Can we choose max adapt hyperparameter tuning cut down tree? 100%. That's what I'm teaching, Ronak. That's exactly what I'm teaching right now. Okay, that's exactly what I'm going to be teaching you right now. How many algorithms have we taken? Logistic regression. What did we take next? We have taken decision tree. And what have we taken? Now, before I jump into hyperparameter tuning, can I teach you guys the theory of hyperparameter tuning for 15 minutes and then jump? Otherwise, if I just directly jump into something nonsensical, you guys won't understand. I will be ineffective at teaching, and that would be a big failure on my part to not first introduce you to the topic. It's like this, okay? Imagine you have a best friend. Now this best friend has done nothing in your life but give you problems. Suddenly he tells you, hey, I have a beautiful friend I want to introduce you to. Now what will you think? He will introduce me to somebody. I think he will be a guy or a girl, and I think he's just going to make fun of me. And suddenly one day he actually brings in this good looking person in front of you and say that, you know what, I want you guys to hook up. The thing is, When you have a friend who from you expect nothing but terrible stuff, and then when a person does a good job or something that is, so you don't feel happy or sad, you feel surprised or shocked. So I don't want to give you the same shock unless we don't do the theory. So before we jump into the part of hyperparameter tuning, I want to tell you guys a concept of hyperparameter tuning. First of all, do you know what is hyperparameter? Does any of you have an idea about what is a hyperparameter? Let me give you guys an idea. See, every algorithm has a tuning that can be done. I'll give you guys an example. Okay. Have you ever used a radio like this? Have you ever had the opportunity to use a radio like this? These are called transistor radios. They were a big, these were big things in my state in Punjab back ago, long ago. When you want to listen to a song more clearly, you first increase or decrease the volume. Yes or no? Given the distance from the tower to your exact location of your radio, you also need to tune, right? So that the tuning gives you the most clearer voice. Now, the tuning depends on the distance, right? Like the distance, because the waves have to travel via a distance. By the time they come to the nearest station, they have decreased in the amplitude and decreased in the time frame, which is frequency equals to 1 by time period. I hope you remember, or else, ignore. I'm going too deep in physics also. Ignore, Madi. Let go, sir. So depending on the distance, you actually also have to tune your tuner. And this tuner is nothing but it's a impedance. It's like a, how do I tell you? Okay, you know what? A tuner exists, okay? This tuner, if you change, the voice will become clearer, clearest, then terrible, terrible, terrible. At a time, this was the best tune, right? The one where you heard the best adjusting, clarity of the sound, and then the voice also is higher, 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 the highest. But on maybe in this position, you heard the best sound. So this is the best setting for that radio at that particular time. Yes or no? Among all the values of volume and tuning, this is the best. Similarly, a machine learning algorithm like decision tree. Ab let me tell you. See, हमारे decision tree में did I give any details like, अच्छा चलो random forest ले लेते हैं. Did I give any details like how many estimators, how many trees should you keep? नहीं बताया. Did I tell it which criteria you need to split on? नहीं बताया. Did I tell you how much depth should the tree have? नहीं बताया. How many minimum samples should you take to split the data? Do you remember I told you in the bootstrap data there are 4 columns? How many minimum you have to choose to split the data? That is min sample split. To split, sorry, उसका बोल रहा हूँ मैं. This is used to decide to split an internal node. Sorry, this is for internal node. And this square root, max features, this is that variable. You remember 4 columns, which one will you randomly select? So it either takes a square root or a log to the base 2 value or none, and it decides which to select between randomness, all that stuff. We haven't decided any of this tuning factor, correct? हमने तो जैसे रेडियो आया उसी को ऑन कर लिया, गाने सुन रहे हैं. Is the voice proper? Is the thing proper? We are not care. We are not bothered. We haven't tuned it. Yes or no? Agree, disagree? So tell me one thing. For a random forest classifier, imagine I started with making 100 trees, 200 trees, 300 trees, and 400 trees. This could be one of the hyperparameter, right? From 100 to 400, decide which is best. From minimum sample leaf of 2, 4, 8, and 10, decide which is the best sample leaf split. Decide how deep the tree should go. 1 depth, 2 depth, 3 depth, 4 depth. Isn't the algorithm going to tell us that for 200 the tree, for sample size 8, and for depth 3, I'm getting the most accurate results. So the output is this. Did you get what hyperparameter tuning is? You give it multiple values. Among those values, which combination gives the best result is what hyperparameter tuning is. But remember, this operation is a very expensive operation. If your data set size is large, won't this take time? Because it needs to do permutation and combination. It needs to see 100 with 2, 100 with 1. Yes or no? Are you understanding what I'm trying to say? First, it needs to 100 tree for sample 2 for this. 100 for sample 4 for 2. 100 for sample 8 for 3. 100 for this and this. After all this operation is done, what happens next? It runs for 200 2, 1. Are you understanding? Then 200, 4, 2. Then 200, 8, 3. Then 200. Are you understanding how cube it's becoming? It's becoming A cross B. Did you Are you guys understanding what's happening here? You need to find out the best particular but hyperparameter tuning takes a lot of time. Remember one thing, hyperparameter tuning can be done in two ways. Okay. One using something called random search CV and grid search CV. Now, I'm not going to go too in deep because it's going to take a lot of time for me to teach you cross validation. And remember one thing, there are two types of functions in hyperparameter optimization. Always choose random search CV. Are you clear? It is the fastest. Are you clear? I will teach you what this random search CV is, grid search CV in a while, and not now. I will teach it to you eventually. But remember one thing, the best hyperparameter optimization technique that exists in machine learning till date is random search CV. Actually, there's more. There's something called Bayesian optimization. If you guys don't know, okay. When I say something is the best, doesn't mean it's the best in the industry, okay. There is something called Bayesian optimization that is considered to be the peak of optimization, which is hyperparameter tuning. If you guys don't know, optimization is to make something better, a version of himself. Under optimization comes hyperparameter tuning. You guys should know this, okay. You guys understand the concept? The broader term is optimization. The undergo term is hyperparameter tuning, okay. It's called algorithmic optimization. Okay. Can we implement something if I have the permission and the blessings from all the use? Yes, you have to. Okay. First of all, have I imported this package random search CV? Did I import it? Acha, random search CV must be also important, right? Because if I have to implement random search CV, how do I just like randomly not call it and just be done with it? I can't do that. I have to import random search CV. So how do I import random search CV? You don't have to import it as, you don't have to write any single line of code. You can do it right here. Hold on, I'll show you. Where have I imported all the libraries, man? Right here. My people, did you import something called train test split here? कहाँ import किया यार मैंने? कहीं ऊपर तो नहीं कर दिया? Right here. Okay, I'm just gonna copy this. Give me 1 second. I'm gonna paste it here. थोड़ा नीचे, so that you guys are understanding. Yeah. Do you see that I've imported from sklearn.model selection import train test split? Put a comma, write grid search CV. Done. That's it. That's it. You've implemented grid search CV. Implementing, matlab you've called grid search CV basically. You've just called them and now you want to run it. Now, after this, code is written, we now need to give some options for logistic regression to test on. Okay. You are doing, or you're going to make a grid of values with which logistic regression will be worked on. So let me take you guys through logistic regression. Okay. Logistic regression, not graph. I just want logistic regression, sklearn, and this. Do you see that in logistic regression, there is a hyperparameter called L1, L2, elastic net, and none. Default is L2 regularization. Did we try L1? Did we try L1 or L2? We tried none, right? हमने दोनों ही ट्राई नहीं किए. Look, can you see? Where is it? Logistic किधर गया? Logistic. Right here. Just because I said random search is best doesn't mean I'm not going to implement both and show you the result, right? Difference. So I'm also going to show you the difference of time. How long does one take than the other? You want me to directly do random search? We can do random search directly. See, we can, if we implement random search directly, it will save us a lot of time. But I thought that if actually, if you implement, actually we can do both. I believe if we do both, it will give you guys a good idea. Because see, the thing is, you don't actually have to implement anything complicated. See, okay, I'll tell you something. When you implement something like this, right, like a grid search CV or a random search CV, what it basically tells you is, देखो, यहाँ पे ना, मैं आपको एक चीज समझाता हूँ. Rather than calling grid search, just call random search, and nothing changes. Just the grid search changes to random search. The params, I'll write it down. I'll write it down for you. Acha, tell me one thing. Tell me one thing. What is the first term in this that we pass? Penalty, right? In logistic regression, penalty, yes or no? So we will come here and we will say penalty. Now tell me one thing, my people. How many penalties were given, or how many penalties are given in linear logistic regression that we can implement? L1, L2, elastic net, yes or no? L1, L2, elastic net. There are three types. I'm only going to take two, okay, just for simplicity purpose. L1, I'm going to take L1 and I'm also going to take L2, okay? I have taken two different penalties that I wanted to try. In logistic regression, if you don't know, there is also another value called C, which is called inverse of regularization. If you can see here, can you see the C equals to 1? C equals to 1. See, what happens is multiple values of C decides chooses whether the output will be good or not. Okay. So what we'll do is here we will take a range of values. Let's say C, okay, a category called C, okay, the category called C, and I will take multiple values for it. How do we take multiple values? Write a bracket, or we can write it like this. NP dot, have you ever worked with something called log space? Have you ever worked with a function called log space? Do you know what log space does? If I write -4, 4, say 20 or 30, it will jump through that value until the value of 20 is reached. Do you didn't know? Okay. Okay. Do you see this particular thing? Log space, start, stop, number is equal to 50, endpoint equals to true, base is 10, d type equals to none, and axis is 0. So np dot line space start start sum. It's if the base is scalar, log space is equivalent to this particular code. But if you give it a decimal point value, then line space has a problem that it does not sort of give you this distributed answer. Log space does that. You guys can try this out. If you guys want to implement it, you guys can implement it out. What I'm basically doing is I'm giving it a range for it to work on. From -4 to +4, I'm giving it multiple C values. And I want it to iterate for multiple operations. If I do this, have I chosen 2 hyperparameter penalty and C? But could I have chosen more? Could I have chosen more? Of course I could have. Okay. So I'm just going to say grid underscore search underscore what are we doing? We are doing logistic regression. So we are going to say grid search for logistic regression. I'm going to call grid search CV. Now here is where the magic happens. You have to use something called estimator. Estimator is what is the name of the library or the function that you wrote for logistic regression? What is the name? What is the name of the model that you want to run that you have written? Log reg. Logistic regression. Have I not written it like this? Log reg. Whatever name you have given, that is your estimator, the one that you're trying to estimate, the one that you're trying to fix. So estimator is equal to log reg. Okay. Here, there is something called param grid. Param grid is basically what parameters do you want me to update myself? What is the param grid I have written here? Param grid underscore log. Yes or no? This is what I want to pass. So I'm going to say param grid underscore log. Any confusion? Now this is called CV is equal to. CV का full form है cross validation. Now listen, but just assume that it is a number between 1 to 10. I will take a number called 7 just for simple purposes. Scoring equals to what scoring do you want? I want accuracy to be the score. I want F1 score. Sorry, I want accuracy to be the number of score that I want to do. N jobs equals to -1. Now this is, see my people, do you have CPU in your computer? Or a GPU in your computer? Do you agree that every CPU, every computer either has a CPU? Minimum CPU to hona chahiye, nahi to the laptop that you have is just fake. To use the CPU effectively, to use the CPU effectively, there is a concept called cores. 1 core, 2 core, 8 core, 9 virtual core, 4 actual cores. If you don't know, there are cores in CPUs. When you say n jobs equals to -1, you tell the CPU that, listen, I want you to use all the resources, but I want this answer faster. So when you say n jobs equals to 1, everything runs parallelly. Are you understanding? When you say number of jobs equals to -1, you're selling open access to all the cores. Run parallelly. I want answer faster. Timing is more important to me than the resource. So it will assign a lot of RAM and it will let your CPU run all the cycles of all virtuals and actual cores, and it will give the results. So n job equals to -1 means that n job equals to 1 means run only 1 core. N jobs equals to 4 means run only 4 core. N jobs equals to 0 means whichever you think is the best, only assign that many cores. Did that make sense? Now that I did this, I'm going to call this function called grid search log dot. We need to fit this model again. Okay, we need to do a lot dot fit again. What do I pass in dot fit? X train and Y train. Yes or no? In the fit, don't we pass X train comma Y train? I am telling a machine learning model that with all the parameters, I want you to fit another model called X train Y train. Now, once this model is fit, once this particular model is fit, you need to actually print which parameter is giving the best accuracy. Yes or no? So is L1 working well or L2 working well? Don't you need to print also which one is working best so that I can go back to my algorithm and fix it? I need to know the parameters, right? So that I can go back to the code and fix my algorithm. So what do? We write a function called log, which is give me the output for params equals to grid search log, which is the this thing dot best params. Can you see this? Best params. Give me the best params per particular thing. And then you can go ahead and print the log params. Okay. What this does is it's going to run the logistic regression. Tell me, what did it tell you? It told me for the given data, the best answer will come if you keep the penalty L2 and if you keep the C value as 0.033596171. Did you get it? We just got the best hyperparameter for our logistic regression code. Did that make sense? From L1 and L2 and between the numbers, it told me the best output you're getting among this accuracy. Okay. One other thing, if you are irritated with these unnecessary nonsenses of warnings, you can also do one thing. I hope you know you can ignore warnings in Python. I'll just show you how it is done. अरे कहाँ मैंने import कर रखा है? I get irritated with my own code. यही मान लेते हैं. My people, if you don't know, there is a package called import warnings. Have you heard of it? So you have to write something called warnings.filter warnings. And inside this, you can write a function called ignore. Just how we ignore problems in our life, right? Same thing. Cell run out. Give me 1 second. Let's see if it gives any error. Yeah, see, no warnings, nonsense. All the nonsense, red thing gone. We don't need that. So warnings are gone. So what do we do now? We got a penalty of L2, yes or no? So we will go here to our logistic regression algorithm. And what do we do here, my people? What do we do? Penalty equals to L2. And what do we do? C equals to what? What is the value of C that we will give? This. Copy and logistic and C equals to this. Did you understand how we figured out the best particular technique? And then our if you see clearly, the precision and recall has also changed a little bit. It's increased a little. We'll see that later. Don't worry. Did you understand the part of the code, my people? In logistic regression, first you have to take the param, all the params. How many hyperparameters do you want the algorithm to check? Once you do that, you have to pass it inside grid search. You have to pass what estimator, because you're doing logistic regression. So you have to pass that model. You have to pass the grid. You have to give it, cross-validation score, accuracy score, and n jobs equals to 1. And yes, remember one thing. This C value will change again and again because remember, it is randomized. I hope you understood. Just because this value is decided to be 1 doesn't mean it's going to print the same value, because our model is also randomized. I hope you know this. If you want to fix this, np.random.seed. You guys know this, right? Any randomization, if you want to stop, np.random.seed, everything will be stopped. I told you this like long ago, that your answer, that the logistic regression answer that you're getting and the logistic regression I get, the code, the data is same, may not be the same. You have to stagnate the data in order to get the right output. So I think we discussed this long back. If you remember, we've spoken about this. Okay. Anyways, no problem. Shouldn't be a problem. So now tell me one thing. Okay. Logistic regression, the ones that I ran, okay, the one code that you ran, okay, did it give you a good accuracy of 89%? It's giving us a good accuracy. Yes or no? After you've implemented the logistic regression code, what is the next thing that's remaining? Decision tree. Can I copy the whole thing as is? Can I do this and paste it in the decision tree part? Yes or no? Now, param underscore grid underscore log ke badle, can I say it is for tree and remove this value from the क्या बोलते हैं, from the entire table, क्योंकि हम decision tree कर रहे हैं. Now let's come to decision tree. Okay, decision tree. What hyperparameters I told you exist in decision tree? Are so many, right? We have criteria, max depth, min sample leaf, max leaf size, max feature, random state. चलो criteria ले लेते हैं. Criteria में both Gini and entropy exist. Yes or no? So can we take criteria? Can we take this criterion? Yes or no? Let's copy this. Let's paste it here. What do? We first write criterion is of what type? We have 3 types. Yes or no? Gini and entropy and also log loss. Chalo तीनों ही ले लेते हैं. Let's try that out. Paste. This bracket is this. Remove this to this, and this to this. Any questions? I have taken 3 criteria. इसमें समय लग जाएगा बहुत. Log loss निकाल देते हैं. मैंने criteria ले लिया. I have taken criteria. Next, what is the thing? We have something called max depth. Yes or no? Can you see this? Max depth. चलो max depth ले लेते हैं. Let's say max depth is how much? Okay, what do we take? See, max depth can be of any value. So let's take 2, 3, 4, 5, 6. Try for all the 6 values. Now, what do we take? Min sample split. Can you see this? Min samples leaf, min sample split. चलो ये ले लेते हैं. Min samples leaf ले लेते हैं. Copy this, paste it here. Okay, paste min samples leaf. अब मिन सैंपल लीव्स का भी आप ऐसे ही दे सकते हो, 4 5 6 7 8 9 6 7 8 लिख देते हैं, ठीक है। व्हाट इज द नेक्स्ट वैल्यू? मिन सैंपल लीफ हो गया, मिन वेट फ्रैक्शन लीफ हो गया। आपको ये भी देखना है कि यहाँ पे एक वो होता है मैक्स लीफ नोड। See, this is a very important hyperparameter, okay? I want to show you specifically this. See, this is actually a very important hyperparameter. It's called max leaf nodes. Max leaf nodes decide how much, okay, of the tree that you want to grow with, such that it grows in limited number of fashions that pruning is not needed, okay? अब इसमें भी हम एक वैल्यू दे सकते हैं, 7 8 9 10 12 13 14 15 16 12 13 14 15, okay? For example, let's take multiple values of 12 13 14 15 and all of that. So basically कितना grow करेगा ये ऐसा. We can take one more, we can take another variable. एक और ले लेते हैं, splitter ले लेते हैं, best या random. हाँ चलो, let's take splitter also, ठीक है? Let's take splitter, है ना? Let's take, should random be decided or should that be decided? Random या best, ठीक है? इन दोनों में से ले लेते हैं. Make it here and make it here. Are you understanding what's happening right now, my people? I have given multiple different hyperparameters, okay? And I am basically running this particular exercise, okay? Now tell me one thing. This grid search log can be converted to what? Can I say that this is grid search tree? The estimator is not log reg anymore, but what would be my estimator? What did I write for decision tree, my people? Did I not write the estimator's name as tree, the model name as tree? So I'm going to come here and I'm going to say that the estimator is nothing but tree. Yes or no? The param grid is param grid tree. Agree, disagree? I will keep the cross validation as is, accuracy same is, and jobs as is. Okay, I'm not going to change anything there. Grid search log में क्या change करोगे? क्या won't I say grid search log के बदले I will say grid search tree dot fit? Instead of saying log params, can I not say tree params is equal to grid search log के बदले grid search tree dot best params? And if I run this, it's running. Can you see it's running? It ran. Do you see it gave me a good output? Use entropy. Max depth should be 3. Max leaf node should be up to 12. Minimum samples 8. And the splitter is to be considered at best. And it gave me the params for the best running, which could be the considered best. Now tell me one thing. Won't you get much better result if your array is bigger? You give more granular values. You give 0 to say like 100 tak, if you have the time, the chance, the energy. Does that make sense, my people? Did you understand how you got it? Like you were able to basically set it. अब यही चीज आपको ट्री के लिए करनी है, रैंडम फॉरेस्ट के लिए करनी है. Will you guys try for random forest or do you want me to write it also? Do you want to give it a shot or do you think I should write the code? You guys can give it a shot. Can I understand and agree that all my dear friends here are going to give it a shot? I can write the code. I've written this much. 2 lines won't make any difference for me. But if you give it a shot, you guys will try it on your own and that will make you feel good about yourself. Okay, no problem. I will show it myself, no issues. Let's copy this. Let's write random forest. Okay. How do we change for random forest? What do we change for random forest? What do we change for random forest? Param grid forest, hide everything. अब इसमें criterion होता है. If you don't know, मैक्स लीफ जो नोड्स होते हैं ये होते हैं मैक्स डेप्थ होता है और मैक्स फीचर्स होते हैं. तो इसमें स्प्लिटर नहीं होता. इफ यू डोंट नो, आई एम जस्ट लाइक टेलिंग यू दैट व्हाट अ रैंडम फॉरेस्ट हैज इज, सबसे पहले क्राइटेरियन एग्जिस्ट. मैक्स ये मिन सैंपल लीफ जो है, ये जो मिन सैंपल लीफ है, दैट डजंट एग्जिस्ट. वी विल नॉट टेक केयर ऑफ दैट. आई एम जस्ट गोना रिमूव इट. ओके, so we have criterion, we have max depth, we have max leaf nodes. I'm going to keep it to Gini and entropy same. Max depth, I don't want to give it more. I just, ठीक है, 2 3 4 5 6 रख सकते हैं. Max depth we can keep it that much. Max leaf nodes we can keep it to 12 15 14 15 20 ले सकते हो, 50 ले सकते हो, 100 ले सकते हो. It's up to you. We can decide a lot of that. But what another thing it has is had something called max feature. If you don't know, hold on, let me show you. Random forest. Do you see this max feature? Here in the max features, you have something called square root and log. दोनों ही copy कर लेता हूँ मैं. I have either I want to choose based on square root logic, which is to decide the square root of the feature size, or do I want to take it log of log to the base 2? Okay, let's remove this, and let's add together. Any confusion? Criterion remains the same. Max leaf nodes remain the same. Max depth remains the same. Just added max feature. So can I remove this and say grid search forest? And the estimator, what was the name of the forest that I wrote? RFC. So estimator is RFC. Any question here? And this would be param grid forest. This I'm going to keep it same. How do I change this? Grid tree, grid search, forest dot fit. Tree के बदले हम बोल सकते हैं forest param. ठीक है? Grid search forest dot best param and print forest. What does this tell us? Let's see. Let's run. What's happening right now? What's happening according to you? Oh, forest param जी कहाँ दो दिया मैंने? अरे how did you no, but I understand वो तो ठीक है, but what's happening right now? Is it taking time? For Python, when you get answers, is it taking time? Do you now understand why you don't run algorithm just like that? Of course, performance issues. ये तो कुछ भी see, I'm teaching you on toy data set, यार. We deal with data sets larger than GBs of data, यार. I mean, you have to, yeah, there's a lot of problem that happens. So what did it tell you? Criterion Gini, max depth is 2, max features is log to the base 2, max leaf is 13. Did you get it? Did you understand? Are you now clear with how a grid search hyperparameter tuning is done, how you take the same values, paste it in the whole thing, and that's how you do it? What 2, 3, 4, 5? It tells you the depth of the tree. It tells you how deep do you want your tree to go. Max depth is to decide the depth of the tree. Yeah. So I hope everybody understood the concept of how a random forest classifier works. I even showed you how you can do grid search CV. My people, same exact way you can do random search. You will see the difference of time. Can you do at least this much? वो तो काफी. Can you just replace grid search with random search and test it out? इतना तो कर ही सकते हो. I think I'm not asking way too much here. No, right? Okay. So my people, this is exactly how in real life, in practical aspect, trust me, you will not be given a data set and you will be implementing algorithm one by one. At the end of your management, the management will be like, हाँ भैया, हाँ कौन सा बेस्ट आ रहा है? Random forest अच्छा लग रहा है? चलो ठीक है. Random forest is the best classification algorithm. Can you see? According to AUC ROC, green is at more peak than decision tree. आपने देखा random forest is at the peak. ये देखिए point थोड़ा ज्यादा आगे है. So we will say random forest is best. We'll implement that in a production. Simple as that. That's how decisions are made. And you know, because random forest took a lot of time for what is the shape of the data? Let's see. What is the name of the DF? DF ही होगा क्या नाम रखा था मैंने? DF dot shape. ठीक है? कितना बड़ा data है अपना? Let's see. 300 rows. Okay. Do you know how to time? How long did it take? Do you want to know how to time a function? Put double this thing and do you see time it? Time it. अच्छा TIMEIT एक ही है क्या? चलो ठीक है एक ही देख लेते हैं. Better give me answer on CPU cycles. Give me 1 second. I don't use Jupyter Notebook in production, so it's just funny for me sometimes. अरे नहीं यार ये नहीं है. Give me 1 second, my people. Hold on. Execution time का क्या था? अरे nonsense यार खुद ही बनाते हैं. इतना समय किसके पास है? Import time. ठीक है? Start is equal to time dot time. लिखिए time dot time. Okay. Write it like this. Time dot time. Once this whole thing is over, end equals to time dot time. ठीक है? Time dot time. ठीक है? Time dot time. Total time took print. Total time to run this code was bracket seconds. ठीक है? और हम यहाँ पे क्या करेंगे? F लिखेंगे क्योंकि this is a ED minus ST लिखेंगे. अरे यार ED. Sorry. Yeah. Let's see. कितना टाइम लगा हमें? कुछ सेकंड्स तो लगी गए होंगे. Did I write it correctly? Time dot time ही है ना? हाँ ना I know. I'm just checking it out. Time dot time. हाँ. Time dot time method. Give me 1 second. Time dot time and minus difference. What is the function? Time dot time, right? Time dot times returns this. Yes, I have done it correctly. There is no problem in my code. ED minus ST. Time dot time, yes. एक बार प्रिंट करके देखते हैं ST को. ST प्रिंट करेंगे और if I comment everything out, it returns this time. ठीक है. और अगर मैं ED को करता हूँ and if I print ED, तो ED भी यही टाइम रिटर्न कर रहा है. ठीक है, नो प्रॉब्लम. तो ST ले लिया एज अ टाइम डॉट टाइम, ED ले लिया एज अ टाइम डॉट टाइम. नाउ इफ आई रन इट, अरे प्रिंट स्टेटमेंट तो दिया ही नहीं भाई. डोंट टेल मी ED minus ST. या end minus start basically. अरे how do I say this? End minus start basically means that the moment it ran the code, it had logged a time. See, told you, na, right? Say 15 minus 15.5. I think the process was not done. I was like worried. I was like, अरे ऐसे कैसे भैया? So basically, when you run this start equals to time dot time, before the program runs, it measures some time. Then this entire application is going to take 15-20 seconds. And then this time is measured. So if you do end minus start, won't it tell you the difference, how long it took? So that's it. See, it took 15 seconds for 300 record data. Agar 15 seconds it is taking for 300 records data, how many seconds will it take for a data set size 1 lakh? 1, 2, 3, 4, 5. Can you do this math? How do you do this? X into 300 equals to 15 into 1 lakh. Yes or no? So how will you, how will you do this? X equals to 15 into 1, 2, 3, 4, 5 divided by 300. What is the answer? Agar 15 seconds it took for 300 record, how many seconds will it take for 1 lakh record? What is the answer? I want seconds. 5,000 seconds कितने minutes होता है? How many minutes are 5,000 seconds? It will take 83 minutes. Are you ready to wait 83 minutes? An approximate guess I'm making. 83. Did you now understand why hyperparameter optimization is a good thing? But doesn't mean कि आप करते रहोगे तो आराम से 1 घंटा लगा के चले गए and then the understanding. Did you understand the concept? Beauty of time. It's important. You can't just train every day and that too for 300 rows only. So yeah, random forest does take time because it is iterative in nature. Didn't I tell you that it iterates, create a forest, destroys, again creates a forest for out of back data? So imagine if it was 10 lakh records. Imagine if it was 20 lakh records, 50 lakh records. Where will you go? This is what's important. Anyways, are you all clear until here? Is everybody sort of sorted until here? We kind of got an analysis and understanding on what a random forest is, what exactly it does. Can we look at it from a perspective of a PPT also once, just to get a clear idea what is a random forest, how it does. We will also read some definitions that have not been learned. Okay, see people, decision trees have been around for a long time and also known to suffer from bias and variance. Who here in my class has no idea, bhaiya, what is bias, what is variance? Who has no idea? You don't know what is bias, what is variance? No, you should apply hyperparameter tuning. It's just that you should not choose bigger values for hyperparameters. It'll take a lot of time otherwise. You can. I mean, there's no rule. If you have the time and energy and the money, do it. No problem. Simple. Very nice. My people, tell me this. As a machine learning engineer, your first job is to check for bias and variance. Agree or disagree? Let me explain variance first. When your machine learning algorithm works best on the training data. On the training data, you're getting the best results. But the moment you test it on the real world or the test data, it performs terrible. Do you have high variance or low variance? You have a high variance. Are you clear? You have a high variance. Your data is, your machine learning is performing good when I was training it. It's a, sab sikh liya maine. See, in our school, we always had one student who used to boast about a lot of things in his life. Or I will get 90%, but when the results come, he would fail. Okay. We all had a friend like that who would boast a lot, but turns out air. High variance is exactly like that. It does fascinatingly well on the training data, but the moment you put it in the real world, goes down. This is called high variance. Essentially, you want an algorithm with a variance to be low, yes or no? The performance of the model should be good on the training data and also on the real world data. Yes or no? It can't be zero. It can't be as close to zero also. I'll tell you why. What is bias? Ek baat batao. I'll give you guys a very frank example. Imagine I get married, okay? And I have a wife. After spending a couple of years with her, I would be biased towards her, right? Like I would be biased towards my wife than any other women that I see outside. A mother is always biased towards her children than anybody else outside because there's a certain kind of soft corner that people have towards a certain people. Biasness is rather than doing things correctly, you give preference or you give more priority to something else. Bias in machine learning. Can somebody tell me what bias in machine learning means? Can you guys give me an example of what is a bias in machine learning? Yes. Give it a shot, then I will explain it in my own way. Let me tell you an idea. Whenever we work on the data, do we not, the first step that we do from data is sample the data? Agree or no? When we have a very big data, don't we do data sampling? Why we did sampling? Isn't it not possible that knowingly, unknowingly, I chose certain group of people which are higher in distribution than the other? Bias has been introduced. An error, slight error has been introduced. Because already the sample has a bias and now I decided to use decision tree, won't decision tree give priority to certain variables more than the other variables, and now another kind of bias has seeped in? From sampling bias, this is called sampling bias, to algorithmic bias has seeped in. Agree or disagree? Yes or no? So do you see what's bias in machine learning? All the way from each step, there's a chance that human errors can get involved in the machine learning algorithms. Now tell me one thing, do you want the bias to be high or low? एक बात बोलूं, variance and bias are inversely proportional. If you increase the variance, bias will decrease. Think about it. समझ में आएगा. If you decrease variance, bias will increase. So is it not possible to not increase both but balance them? Rather than increasing or decreasing both bias and both variance, you can balance the variance and bias. This is called bias-variance trade-off. This is the most important interview question you're going to get. I write and give you this today. If this doesn't come in your interview, you come and change my name. Almost 99% of this population, you will encounter what is bias-variance trade-off in your interview. I guarantee you this. So if you don't study this topic, then just don't tell everybody I was your instructor. If you're not able to answer this, that's it. Should I repeat bias once again? 100%, no problem. Did you see when we do sampling of the data, okay, a certain proportion of people have been higher in distribution than the other people in other. A certain bias has been introduced because the distribution was not proper. Suddenly, when I run algorithms, won't each algorithm have their own biasness? Decision tree tends to overfit. Logistic regression tends to always choose a variable with a higher number. Random forest always uses a very good, overfitting problem, but the problem is it is not very good with variance. So every algorithm you choose has a bias. Every data strategy you choose has a bias. Bias is a small error that keeps introducing in your program. When you start extracting the data from the table, to how you extract it, to how you work on it, that is called bias. Bias matlab some error being introduced when you give some favor. So did you, my people, my point to tell you was bias variance trade-off, how to avoid overfitting, underfitting and regular fitting. ये सारे questions are the Bible for you guys. आपके interview में आएंगे ही ये questions. These are the, if you guys sit with me for 1 hour and if I take your mock interview, the questions I am asking are the questions you will get in your interview, क्योंकि उसके अलावा कुछ है ही नहीं. But I'm not going to do that. Can you ask me why I will never give you guys the questions, all the questions? Okay, so I have, or I can write maybe 111, 112 questions, which are 99% surety you will be able to clear. Why do you think I will not hand it over to you just like that on a silver platter? You know why? Because it will be terrible of me to do that. I'll tell you why. Every company deserves a really good employee. Okay. If I give you questions right there and then, have you gone through the journey of working hard, getting frustrated, getting angry at yourself, doubting yourself, then coming back to discipline once again, and then acing your interview, versus I make you skip all of this journey, give you the question bank and you pass, but you fail in your life. So I would never do this to you. I will never give you all the questions. I can only give you resources, but I would never give you all the resources with which you can clear your interview. That's never going to happen. So point being, you guys should start practicing for interviews from today. I'm not joking. I'm not lying. If you think I'm lying, no. My people, remember one thing. Interview is a skill. Giving an interview is also skill. Being a very comfortable, calm, and a conversational person is also very hard. Okay. So you should start preparing for the topic and the code and the interview, each topic by topic. If you finished random forest today, learn how interview questions come in random forest. Prepare ho jaoge aap. Don't let at the end of the day I'll prepare for an interview. Then you will have multiple algorithms to cover. Nahi ho payega. Should not do that. You have to be smart. That's a recommendation I can give. Again, it's up to you if you guys want to follow it, not follow it. Okay. Pushpa only speak. To listen or not, what do we do? In yes, datainterview.io, devinterview.io. What do we do, my people, in ensemble method? We take a data set, we make multiple training set. When you make multiple training set, won't you call that as bootstrap data 1, bootstrap data 2, bootstrap data 3, a set of k bootstrap data, and each bootstrap data has its own model, and each model we combine the classifying output as 0, 1, whichever is the output, the maximum, we get that answer. Yes or no? Haven't I taught this as ensemble technique? You split the data, combine the data, split the data, combine the data, bagging, bootstrap, aggregating. Bootstrap split करना, aggregating combine करना. Bootstrap data, datas with duplicates split करना. Aggregate, combine, vote matching. We've learned this. Yes. See? Tu bene? Okay, random forest. Revision. A technique to perform ensemble decision trees. Used when our goal is to reduce the variance of a decision tree. Do you see? Decision tree has high variance because it overfits. Because it overfits on a testing data, it does not perform well. And hence, the variance reduction of decision tree is why random forest was made. Decision tree is that one child who's overconfident but performs nothing in the exam. Creates several subsets of data from the training sample chosen randomly with replacement. My people, randomly with replacement का क्या मतलब होता है? Bootstrapping. Did you understand it? Random sampling with replacement का मतलब है bootstrapping. That's another way to look at it. With replacement, each collection of subset data is used to train its decision tree, ending up with different models. You combine them. What is the difference? If we input a training data set with features and labels into decision tree, it will formulate a rule, but only one blueprint it will make. Random forest will make multiple blueprint and let voting happen and decide which one do good. Decision tree might suffer from might nahi. They do suffer from overfitting. Mostly random forest avoid overfitting because of randomness in the data. Because no biasness seep in, variance is decreased, overfitting is decreased. How does random forest work? I've already taught you this. I don't need to go through it once again. This is the hyperparameter tuning or hyperparameters of the random forest, and this is how random forest works. Okay, hands-on random forest. We've actually done random forest hands-on, but I will try to get a hands-on, a different kind of program also done for you guys if you want to get it done on a random forest. Next topic that I want to start is naive-Bayes classifier, but I'm thinking that today is enough, and I will let your brain calm down a little bit. I will not confuse you a little bit more. I know that the brain has a certain capacity and I don't want to exceed that capacity and I will not exceed that capacity. Okay. Please explain overfitting. Very good. When there is a training data and when there is a test data. अच्छा ये तो सिखा सकता हूँ ना overfitting, underfitting, best fitting. Can I teach at least this much quickly? When you have a training data, when you have a test data and you apply an algorithm. Okay. When you apply an algorithm, the algorithm learns the training data so well that it thinks that the entire world works on training data. Example, suppose in the teaching you mathematics, I told you 1 plus 2 is equal to 3, 4 plus 1 equals to 5, 1 plus 1 equals to 2. My job was to teach you the pattern recognition, right? How to combine the numbers, yes or no? Agree or disagree? My job was to teach you mathematics, how to add two numbers. When a machine learning overfits, if a data like 1 plus 1 is equal to comes, automatically it will be very confident and say 2 because in the training data that sample exists. But the moment you say 1 plus 3, is 1 plus 3 existing in the training data? No. So it will not be able to answer. It learned the training data so well, it didn't learn the pattern. It didn't learn, okay, I am not supposed to by heart or mug the entire training data, but I'm supposed to learn the pattern. Rather than learning the pattern, it mugs up the entire training data. So how will it perform on the test? Terrible, right? It performed good in training, but in the real world, will it perform? It's all memorized. So that is called overfitting. Are you clear? Overconfident हो जाना कि अरे अब तो सब देख लिया मैंने, अब तो मैं पार कर दूंगा सब कुछ. That is overfitting. Okay. What is underfitting? Underfitting means whatever you have in the training data, it learned neither the memorization of it, neither the pattern part of it. It couldn't even learn it couldn't even memorize. It couldn't even learn the pattern. That's called underfitting. What is right fit? It didn't memorize, but it learned the patterns really well. That is called right fit. So there are two types of thing: overfit, underfit, and right fit, also called as best fit. I want to show you guys something. I would love to show you guys something. Whenever you hear the term underfitting, overfitting, and right fitting, I want you to look at this graph. My people, don't we want in machine learning, the aim is that we want to basically segregate the circles with the crosses, yes or no? We want the algorithm to learn to move circle from the crosses, yes or no? Underfitting algorithm is so terrible, it didn't learn what is a circle, what is a cross, couldn't do it. This is called underfitting. Overfitting is so good that it is separating each circle from the cross. Yes or no? We also don't want this, because what if next time the circle is not in the exact position? It's maybe here. Yes or no? Overfitting means it is learning to draw a curve exactly wherever. No, we want it to generalize. Won't we want it to be generic in nature? थोड़े बहुत मिस हो गए तो चलेगा. जैसे in the circles, if two crosses come, it's okay. Some error is fine. But don't be so overconfident that every time the data will come like this and I will fit myself like this. No, what if a circle comes here? What if a circle comes here? Won't you need to move your curve a little to the left and right? That's why appropriate fitting or right fit or best fit is considered best. And our aim is to do that. And we avoid overfitting and underfitting. Are you clear? Acha, can I ask you guys a question? Sir, how to know my model is underfitting or overfitting? Yes, that's a question. How to know, sir? You have to plot a graph called train versus validation loss curve. Your graph should look like this. If your training error is decreasing with the validation error, it's the right fit. If your training and error validations are different, this is underfitting or overfitting, depends on the ratio. You have to plot something called loss versus epoch or train versus validation. See, loss versus epoch graph. Can you see this? It's called train versus validation loss graph. You have to plot this and you will get a good idea. It's a good fit. It's a good fit. Yeah, that's good. Done.
Just a quick info, guys. Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI, and Power BI. Get a data science certification from IIT Empowertak and Innovation Hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.
I will be taking you guys through another classification problem called naive Bayes or naive Bayes, whatever you call it. People call it multiple names and I call it naive Bayes. Okay. Now remember one thing, I have taught you supervised learning, and under supervised learning, I have been teaching you things like linear regression, logistic regression. I've taught you decision trees. I've taught you random forest, and now I'm teaching you naive Bayes classifier just for your understanding. Let me tell you how many algorithms exist and how many are useful. Okay. If you want to do regression, if you want to do classification, if you want to do regression, there is linear regression. There is polynomial regression. If you guys don't know, linear regression, polynomial regression, which is actually called orthogonal regression, if you don't know. Okay. Then you can also use random forests for, or you can use CART rather than saying random forest. You can use regression trees as regression classification also. You can use XGBoost as an algorithm that can do fascinating regression type. In classification, you have multiple algorithms, like you have logistic regression, right? You have support vector machine. If you don't know what this is, ignore, right? Support vector machine is a beautiful technology. It's an algorithm. You have decision trees, you have random forest, you have naive Bayes classifier, right? You have multiple other type of classification algorithms. You can also use XGBoost, right? For classification, you can use AdaBoost, okay? You can use CatBoost, right? You can use LightGBM, LGB, it's called as. There are multiple algorithms that can do fascinating classification, solutions for you. Naive Bayes is yet another classification problem. Of course, it is supervised. What you mean by supervised is that your data is labeled. The data that you're working on is going to be labeled. And how does a naive Bayes classifier work? Well, my people, naive Bayes classifier works on Bayesian probability. Okay, it works on Bayes theorem. Now, I know most people here will be confused with the Bayes and Bay. Look, let me tell you one thing. BAE Bay and BAYES Bay, they are two different things. Okay, don't call it the Bayes theorem. Like you guys understand. I am not a Gen Z, but you guys are. Hopefully, I'm assuming not all of you, but some. So Bayes theorem is the name of a scientist versus Bay. Bay is, I think, a general slang for babe, right? I believe that's what they use it for. So remember that Bayes theorem is not Babe's theorem, right? It is a different name of a scientist and not any other babe. So do not confuse yourself with anything else. Bayes theorem comes from Bayesian probability. Okay, Bayesian probability is a very, okay. So here is what I want you to tell me. Have you heard of something called conditional probability? Have you heard of something called conditional probability? Conditional probability is a very simple concept, people, okay? It's a very simple concept, okay? What it means is, imagine you have a bag, okay? And this bag is black in color. You guys can't see it. There are 4 red marbles in it. How many? 4 red marbles. 3 black marbles. And 2 green marbles. Let's say somebody removed 1 green marble, 1 black marble, and 2 red marbles. Okay. So how do we actually write it? We say that or I'm just gonna circle it off. Okay. Somebody removed 1 green marble, 1 black marble, and 2 red marbles. Can you tell me what is the probability of getting 1 red marble? What will be the probability of getting 1 red marble? It will be 2 divided by 4, correct? It will be 2 divided by 4, correct? You know why? Okay, marble. I can independently लेना पड़ेगा. चलो, let's say a red marble. ठीक है? I'm gonna copy this and I'm gonna paste it. ठीक है? Red ले लिया. अभी एक blue ले लेते हैं. Let's take the blue marble. Fascinating. Copy and paste. चलो blue ले लिया हमने. अभी एक green ले लेते हैं. Green marble. That's right. Perfect. Copy image and paste. Now, my people, imagine there is this huge bag. Okay. There's like a huge bag. There's like a huge bag. Okay. Under this bag or inside this bag is marbles or are marbles actually. That's the correct English way of saying it. Control copy, control V, control V, control V. Okay. Char marble. There are 4 marbles, red marbles. Okay. And let me reduce this a little bit and let's call it control V, control V. ठीक है 3 हो गए ब्लू और ले लेते हैं ग्रीन ले लेते हैं ठीक है इसको करते हैं कॉपी इसको करते हैं पेस्ट 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 ठीक है 1 2 3 4 and 5 okay my people this is the initial state of marbles in the bag agree or disagree what is the probability of me getting a red marble if I want to extract red marble how do I get it so it will be 2 right 1 minute not 2 sorry red marbles कितने हैं 4 हैं how many red marbles are there divided by 1 2 3 4 5 6 7 8 9 10 11 12 so can I say 4 divided by 12 4 1s are 4 4 3s are 12 1/3 probability can I say to get a red marble the probability that you will get a red marble is 1 by 3 what is 1 by 3 if you ask in percentage what is 1 by 3 in percentage 33% chance आपके पास 33% chance है that you will get a red marble but in real life, things are dynamic in nature. Suppose if I removed 1 green marble already, 1 blue marble and 2 red marbles I have already removed. Okay? I have already removed this many from the bag. Now what is the probability of getting a red marble? The probability of now getting is, how many reds are there? Only 2. Divided by total, how many marbles are there in the bag? कितने marble बचे? 1, 2, 3, 4, 5, 6, 7, 8. So 2 divided by 8. So 2 1s are 2 4s are 1/4 chance. 25% chance you will get a red marble. Did you understand? This is called conditional probability. You change the original state to a new state. Pehle originally everything was there. I changed the state. Now to calculate the probability based on some condition is called conditional probability. Okay. This concept is also called posterior probability. What is it also called? Posterior probability. Posterior probability is slightly different. Listen to me very carefully. See people, posterior probability means, okay, let me take you guys through some concepts of probability. You guys will understand. My people, there is an original state of something. I changed the state. The probabilities will change, yes or no? Could I have moved marble in such a way that the probability of red could have been 1/3 still? The probability of red before and the probability of red after is still the same probability. How can I do this? Could I have done it first of all? I have put my red marbles, green marbles back. Okay. What is the probability of getting a red marble? 1/3. Correct? Hai? Probability of red marble was 1/3. Can I move some numbers in the blue and green so that the probability afterward is also 1/3? Think about it. Ask questions so that you removing 2 marbles, but 2 which marbles? Okay, my people, listen to me. Listen to me. Listen to me very carefully. Thoda shanti se suno. How many total marbles are there? 12 total marbles. Agree? The probability of getting a red marble is 4 divided by 12, which is 4 1s are 4, 4 3s are 12, 1/3 probability. Correct hai? Imagine this is the probability of getting a red marble. Correct hai? Initially, if I remove red, 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 1, 2, 3, 4, 5, 6, and yeah, what is the probability that I will get a red marble? Is it still the same? Yes or no? My question to you is the probability of getting a red marble from this bag is also 1/3. Would you agree or disagree? So tell me one thing. Conditions changed, things changed, but sometimes the probability remains the same. Well, oh, fun, amazing. That's just amazing information. Right. Now, Posterior probability, okay, posterior probability is a concept different from conditional probability, because what it says is posterior probability means there was an original condition which is guaranteed to change. You will never get back the original result back again. वो chances बहुत कम है. That is difference of conditional probability to posterior probability. Are you clear? Posterior probability will make sure that the events have changed in a way where the originality never retains itself. The chances are very less. Are you everybody's clear with this? So my people, I was talking to you about probability. Remember, I told you something called Bayes theorem. Something called Bayes theorem. Bayes theorem works on a conditional probability of event A given B has already occurred. What is the chance of event A happening given B has already happened? Let me give you guys an idea. You have a father, you have a mother. If you are a lucky person on this planet, you will also have a sister. Okay. Now, imagine you suddenly just hit your sister. I don't promote violence on your sisters at all. Let me give a disclaimer. I do not promote violence on your sister at all when people are watching. I'm kidding. Okay. No violence. Suppose you just touch your sister and she starts crying with a sentence, and your father listens to that somebody has hurt my daughter. This event has already happened. Okay. You know your sister is a drama queen. And your sister has started crying and your father has heard that. This event has already happened. What are the chances that your father is going to hit you, throw you out of the house, or you're almost killed? Right? So you understand when something happened, what is the probability that A is going to happen? You understand what I'm trying to say? If you all have sisters, you will relate with me. Okay. If you don't, then you're missing out on a lot. But you understand what I'm trying to say. Event B has already happened, has occurred. What is the chance that event A is going to happen? That is given by a formula called conditional probability. That probability of A happening given B has already happened. Have you heard of the concept called mutually inclusive event and exclusive events? Mutually exclusive probabilities. I'll come to that. No problem. The formula for this, or the Bayesian theory, is probability of B for A into probability of A or event A happening divided by probability of B. My people, even if you don't understand this formula, I want you to by heart this, drink it, eat it, marry this formula if you have to. This formula is going to be asked in your interview, and this is my guarantee. This is going to be asked in your interview for sure. Can't escape it. This is a 5-star question. You ignore this formula, you ignore one chance, 1 point in your interview. This is a super critical formula. ये तो पूछेंगे ही पूछेंगे. I've given you a formula, but do you really understand the formula? Do you really understand the formula? You don't, right? We don't really apply the formula, correct? Yes or no? So shouldn't we actually see how to implement it? You remember in decision tree, I taught you a topic called tennis data set. You remember a tennis data set I took you guys through? I taught you decision tree on it. How amazing would it be if I could take you guys through a physical exercise of how to solve a naive-based classifier using this formula on a tennis data set? Then we will get much more mathematical in-depth clarity. Oh, this is how naive-based works. Okay. There's energy with you guys. You guys have energy. How many people have joined this class? Well, good enough people have joined the class. Very nice. Very nice. Very nice. Okay. My people, in machine learning, don't you have things like features like X1 feature, X2 feature, and things like, for example, there's a feature called X1, there's a feature called X2, there's a feature called X3, there's a feature called X4, and then you have a target variable, like call it output or a target variable where the answer is yes and no. Correct or not? This is what a binary classification looks like, right? Either the output will be yes, either the output will be no. Agree or disagree, my people? 100% you have to agree with me. The probabilities, okay, of you, PABC stands for. PABC stand for, what is C? C kahan pe yahan pe? Where is C, my dear? Wait, hold on. Are you asking me what is A, what is B? Oh, acha. Okay. My bad. I'm so sorry. My handwriting, look, I had a teacher. She's tried her best to teach me how to write in a good handwriting. And I made sure that I make her life a living hell. So unfortunately, I've never learned how to write well. I'm so sorry about that. My handwriting is just, actually, my handwriting is a work of art. You won't get it. It's an advanced level art. So I apologize for my art. Okay. Just ignore. Listen to me. You have a data set where you have 4 features, x1, x2, x3, x4, and you have an output variable called yes and no. Now tell me one thing, is this a binary classification problem or not? Your main goal is to predict the output yes or the output no given the 4 features, yes or no. So naive-based classifier, what it does is it calculates probability of yes given feature x1, comma x2, comma x3, comma x4. Did you understand? On this is where Bayesian theory is applied. Did you understand? I'll tell you. If you expand this formula, you will get probability of yes into probability of all the x1, comma x2, comma x3, comma x4 given the probability y. Do you see this? Probability of b by a. See, this is a. This is B. So you have probability of B by A, which I've done exactly this like this, and probability of A, which is Y. Divided by, what do you divide it by? Probabilities of B's. What are B's? Probability of X1 feature, X2 feature, X3 feature, and X4 feature. Did you understand how I'm applying it? Did you understand how I'm applying it, my people? Do you have any questions here? Probability of yes, given all the features. What will be the output of, what is the probability of getting a yes given all the features? X1, X2, X3, S4. So see, if this is A, this is B, I'm applying exactly Bayes theorem here. Any confusion until here? So can I not write down this formula? एक मिनट रुको, पहले तो ना एक बात बताओ, तुम लोगों में से मैथमेटिक्स किसका कच्चा है? Very weak mathematics, bad, terrible mathematics. Who has terrible mathematics skills here? It's okay to say. It's all right. Good. So I know how slow I want to take it. My people, hold on. यहाँ पे ले लेता हूँ मैं. चलो, एक बात बताओ. Okay, listen to me. This is my data set. Agree or disagree, my people? Yes or no? This is my data set. How many features do I have? कितने features हैं मेरे पास? 4 features हैं. When 4 features come, only then I'm able to predict the target, right? Yes, the output is yes, the output is no. Correct or not? 4 features का ही output yes or no आएगा. If your job, your aim is to get output yes or no, don't you need to calculate the probability of yes and no? Because that's what matters. Your features don't matter. So what is the probability of yes given 4 events? X1, X2, X3, X4. Yes or no? And the other probability will be probability of no given X1, X2, X3, and X4. Agree or disagree? Does this look like it is probability of A divided by probability of B? Follow this formula. Follow this formula. What is probability of A given B is like this, right? Probability of, can you see probability of B, my people? Probability of A. A is what? Yes. So I will say probability of yes into probability of B given A. Can you see B divided by A, reverse case? So here B is this, right? X1, X2, X3, X4 given yes divided by probability of all the features X1, X2, X3, X4. Have I not followed the same principle in writing A, B by B, probability of B using the same Bayesian theorem? I've just replaced yes as A, B as the other condition, correct? So if I expand this, probability of yes into probability of x1, because x1, x2, x3, x4, x5, there are multiple variables. So can I not write it like this? Probability of x1 given y into probability of x2 given y into probability of x3 given y into probability of x4 given y divided by probability of x1 into probability of x2 into probability of x3 into probability of x4. If I replace all these variables, won't I get a percentage probability of getting a yes given all the features? If you give me a feature x1, x2, x3 and x4, won't I be able to predict y? Just like y is equal to mx plus c, given x, I will be able to predict y. Did that make sense to all of you? I have converted it into an equation where I put the value of x, I get the probability of y directly. Yes or no? All I need to do is just replace the variable x1 with the numbers and I will start getting the probabilities of y. Yes or no? Don't worry. I will show you manually also. Mathematically, I will go through it. But let's understand the formula first. Everybody, did you understand the equation of yes? Okay. Can we do it for no? Yes, you can. If you want to try it out, you do it out. This is for yes. You can also do it for no. Agree, my people? You guys are here with me? Can we take a mathematical exercise? Hold on. Give me 1 second. Yellow. Is this visible? Okay. I'm only going to take one variable, okay? I'm not going to teach you for all four. I'm going to take one. You guys will get an understanding. Let's take a variable called outlook. How many features are there? Feature 1, feature 2, feature 3, feature 4, and the target variable t. Isn't it just like the one that I taught you on the top? Very nice. How many features are there? 4 features. My people, your aim is to predict the output yes and no. Yes or no, my people? Your aim is to predict whether the answer is yes or no given the outlook. Yes or no? Let's write it like this. Outlook. How many yeses are there? How many nos are there? How many different subcategories does outlook have? Sunny, overcast, and rain, correct? So I will say sunny, overcast, and rain. My people, tell me how many yeses are there in sunny and how many nos are in sunny? Can you please tell me? How many yeses in overcast? How many nos in overcast? How many yeses in rain? How many nos in rain? So let's see. Sunny has 2 yeses and 3 nos. Overcast. You guys have any questions so far? Okay. How many yeses in overcast? 1, 2, 3, and 4. 4 yeses and 0 nos, correct? What about rain? So 3 and 2. Is this correct? Overall, the value of yes is how much? What is 4 plus 2 plus 3? 9, correct? Overall value of yeses and overall values of no's is 5. Yes or no? Let's write another column called probability of yes. Let's write another column called probability of no. Okay, let's write it like this. My people, what is the probability of yes and probability of no? So first of all, the probability of yes is how much? 2 divided by how much is the total yes? 9, correct? 9. Total probabilities are 9. This is 4 divided by 9 and this is 3 divided by 9. Yes or no? The probabilities of yeses, I just taught you conditional probability. What about this? 0 divided by 3 divided by 5, 0 divided by 5, and 2 divided by 5. Yes or no? Would you agree with this condition? Just for fun, let's take one more variable so that you guys will understand why am I doing this. Let's take outlook. Let's take temperature also. Chalo, temperature bhi le lete hain. Okay. Let's copy this, paste it, and bring it here. Okay. Let's erase everything. Hold on. What is this variable called? Temperature. Temperature में कितने categories है? Hot, mild, and cool. Correct? Hot, mild, and cool. Yes or no? सही है ना? Hot, mild, and cool. The number of yeses and a number of no's. चलो बताओ मुझे. I want you guys to fill this for me. How many yeses and how many no's? Hot में कितना है? 1, 2, 3 और 4. 2 yeses and 2 no's. Correct? Mild में 2, 3, 4. So 4 are yeses and mild में एक दूसरा और दूसरा no है. तो 2 no होंगे mild में. Is this correct? 4 yeses and 2 no's in mild. 1, 2, 3, 4, 6. Huh, correct. Yes, that's right. What about hot? Sorry, cool, cool. 1, 2, 3, and 4. So 3 and 1. Yes or no? 3 yeses and 1 no. So what is the probability of 4 plus 3 plus 9? What is the number? Same, right? 4, 5, 6, 7, 8, 9. 4 and 5. Yeses and no's remain same, right? So can I say probability of yes is 2 divided by 9, 4 divided by 9, 3 divided by 9, and this is 2 divided by 5, 2 divided by 5, 1 divided by 5. We've taken it for 2 variables. Yes or no? Now tell me one thing. Let's only look at target variable. Play tennis. Okay, let's only look at another variable called play tennis. Play tennis. Only and only play tennis variable. How many yeses and how many no's are there in the target variable? How many yeses and no's do I have on the target variable? अब कितने yeses हैं मेरे पास और कितने no's हैं मेरे पास? Let's see. Or let's write it like this. ऐसे लिखते हैं इसको, ठीक है? Let's write it like this. Play tennis, okay. How many target variables do you have for category yes and category no? How many yeses are there? Let's calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 yeses and how many no's? Minus 14, 5. So 5 no's. Correct? So can I say that 9 and 5 together are 14? Totally the numbers are 14. And the probability of having yes is 9 over 14. And the probability of no is 5 over 14. Yes or no? This is with respect to my target variable. Agree, disagree? This is with respect to my target variable. Yes or no? Acha. I am not taking humidity. I am not taking wind, okay? Because my example will become incredibly large. I don't want to do that. I have calculated these values, okay? I have calculated these values. My aim is I want to calculate the probability of yes, given the variable that day was sunny. It was sunny that day and it was hot that day. Are you understanding? It was sunny that day. What is the probability of yes I am going to get if it was sunny that day and it was a hot day that day? Will I get a yes or a no? That's what I'm trying to predict. Understand? So Isn't this like a Bayes theorem, probability of A divided by probability of B? Yes or no? Doesn't it look like Bayes theorem? So tell me, if I replace the values in this, won't it be probability of yes into probability of Sunny, 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 given it is a yes, given the Sunny it is a yes, into probability of hot given it is a yes, right? Hot given it is a yes, divided by probability of what you divide it with? Or rather, let's not divide it with anything now. I'll tell you later. First, let's solve this particular thing. What is the probability of yes? What is the number? 9 divided by 14. Do you see this? 9 divided by 14. Into what is probability of Sunny given yes? Sunny given yes. What is the probability? Sunny given yes. Can you see this? 2 divided by 9. Yes or no? Into 2 divided by 9. Into probability of hot given yes. What is hot given yes? 2 divided by 9. If you multiply these numbers together, you will get something called 0. If I'm not wrong, 031, something like that. Yeah, you'll get into, okay, by 9, 2 by 9 into 0.444, right? What are you guys getting? Are you getting the same exact number? This is the probability of yes given Sunny, or that day it was hot. But you need to calculate the probability of no also, because whichever is higher, we will choose that. Given it was sunny that day and it was hot that day. Now let's calculate that. What will be the answer for this? Probability of no into probability of sunny, SUNNY, sunny given no, into probability of hot given no. If you replace the numbers here, what is probability of no? 5 by 14. Yes or no? What is probability of sunny given no? Sunny and no is 3 by 15 into probability of hot no, 2 by 5. Oh, sorry, 3 by 5, right? Oh, yeah, not 15. Apologies, 3 by 5. That's correct. I'll have to calculate this again. Right. Did you get the same answer? Sunny is 3 by 9. No, no, no. It is no. It is no. Hot given no, not yes. It's not no. Okay. Yeah. Okay. Did you get probabilities of yes and no? Don't worry about division yet. Abhi divide nahi karna hai. I am not doing the division yet. Wait for a while. Did you get the probability of yes and no? So what answer did we get? We got probability of yes, given it was sunny and it was hot that day. The probability that we got was 0.031. Yes or no? The total probability is 0.031 and 0.085 that we got. 0.085. Yes or no? For total probabilities, for yeses and nos, it's called as a conditional, the whole probability. Take 0.031, add it with 0.085. What is the answer for this? Can somebody tell me what is the output for this? What is the output for this? And probability of no given sunny and hot will be 0.085 divided by 0.031 plus 0.085. How much is this? How much is this? 0.031 divided by 0.03 plus 1, 0.085, and 0.085 divided by the same number. What is the answer? About 27%. Are you saying that probability of this is 27%? What is the output for this? Can you quickly calculate this? This, the bottom one? Almost 70%, I guess, right? 73%. So tell me, people, given the probability, what is the probability of yes given sunny and hot? Only 27%. But what is the probability of no given sunny and hot? 73%. So tell me one thing. What is the output? Which is the answer for this particular thing? Will you go to that tennis if it's sunny and hot? No. Look at the answer. Sunny, hot. Can you see sunny, hot? No. Sunny. Yeah. Can you see sunny, hot? Both the conditions are giving no. And the answer was also 73% confident no. Agree, disagree? I mean, I'm just asking you. Did you understand how naive Bayes works? Plus, did you all understand how this naive Bayes works? Did you all just get a clarity on how this is working? Why are we doing this? How did we do it? We've applied naive Bayes theorem, just like how we had done it for the last class. For decision tree, same thing, we applied it mathematically and we got two different conditions. That yes, probability of yes is this much, probability of no is this much. Whichever probability is higher, you get that. Remember one thing, there could be a chance probability of yes and probability no could be an equal number. So that is why in naive Bayes theorem, there's a tiebreaker mechanism. It never becomes equal. Is everybody clear with how naive Bayes works? It's a very simple algorithm, my people. Can I tell you one of the most highest asked interview question in naive Bayes algorithm? This interview question is also guaranteed to be asked in your interview, 100% sure. What is naive in naive Bayes? In Hindi, do you know what is the meaning of the word naive? In English, there's a word called you are so naive. The question is, what is naive in naive Bayes? Remember one thing, there is one assumption naive Bayes algorithm makes. Okay, one assumption naive Bayes algorithm makes. Naive Bayes says that feature A, B, C, and D and the target variable T. A, B, C, and D are not dependent on each other, or A, B, C, and D are not correlated with each other. Naive-based classification algorithm says there is no correlation of A with B, B with C, C with D. They are all independent. But in reality, does that happen? That's why the name of the algorithm is naive-based, bhola-based. Okay, if you don't remember, just call it key. If somebody is asking you in an interview, tell me what is naive or naive in naive Bayes. So you can say that ki sir bahut bhola algorithm hai. Okay. It assumes that each feature is independent. They have no correlation with each other. Hence it's called naive Bayes. Are you clear? This is a very important interview question. They will ask you what is naive in naive Bayes. You have to tell it very clearly. Sir, naive Bayes algorithm considers one thing which could not be practical. And that answer is, sir, each column or each feature is considered independent and have no correlation, but that doesn't happen in real life. But naive-based classifier actually works really, really well. It gives you good output. Are you clear, my people? Are you clear with the understanding of naive-based classifier? How does it work? How does it calculate the probabilities of yes and no? Now I have a couple of questions I want to ask you. Would that be fine if I ask you? I told you an example of naive-based classifier, which is a binary classification problem. Correct or not? You must have seen this as a binary classification problem. But do you know that naive-based classification is of two different types? It's not of one type, but it's of two different types. There is multinomial naive-based classifier. Then there is another kind of classifier called Gaussian naive-based. There are two types of naive-based classifiers you will find in your. The answer, my dear, is very simple. Whenever you have features, for example, outlook, temperature, humidity, and wind, to predict whether you will go play tennis, yes or no. Naive-based classifier assumes that outlook, temperature, humidity, and wind, all these four variables are independent. They have no correlation with another variable. Like outlook and temperature are looks like it is correlated, right? Like looks like they're similar type. Naive Bayes ignores that. Even if you're of same type, it includes that in the algorithm. That's why it's called naive or naive. I swear to God, I'll tell you one thing, my people. If I was features independent, that's understood. But record rows as well. Sir, अगर feature ही independent हुए तो records तो independent होंगे ना? If a column is okay, listen to me. If outlook and temperature are similar or of similar category, if the variable itself is of similar category, won't the numbers also match of similar categorization? Not in terms of range, but they are almost together. One thing increases, other thing increases. There is a correlation. Do you know there is something called positive correlation and negative correlation? They are both correlation. If one thing increases, the other increases. If one thing increases, the other decreases. But they are also correlation, right? There is a relationship, right? Tell me one thing. एक बात बताओ. I have a question to ask you. If you want to do linear regression, and if you've taken a column called salary, and if you've taken a column called yearly income, and if you've taken a column called age, अब इस इन दोनों वेरिएबल में से which variables are correlated highly with each other? Which variables are highly correlated? Salary and मतलब the money that you make in a year are highly correlated, right? Agar if you add this in the linear regression, won't linear regression be confused and give more priority to these two because they both seem to improve and increase and decrease whenever they decrease, increase whenever it's increased? So tell me one thing, won't my algorithm have a high bias then? So essentially, when you do machine learning, before doing machine learning, take all the columns, identify which column is highly correlated with the other column, drop it, right? Either drop salary, either drop year, and do the other one with the. Are you understanding what I'm trying to say? The correlation, positive or negative, is a cancer for the machine learning algorithm. It should not exist. Did you understand? Any correlation, positive correlation, negative correlation, is a terrible thing for machine learning algorithm. It will give you bad results. I hope you understood. Naive Bayes algorithm is applicable in all conditions, but the problem is you should know that it has a certain bias. What is the bias? It assumes everything is independent, and you have to apply it on your own goodwill. Nice. So, should we implement naive-Bayes classifier quickly? How do we implement naive-Bayes classifier? Do you remember the code that I have taught you long ago, where we took one data set and you remember we did a lot of stuff to this. We applied a logistic regression, a decision tree, a random forest, and we found out using some hyperparameter tuning that maybe random forest works the best. How about we apply a naive-Bayes classifier to this equation? But before you do that, I wanted to tell you the difference between multinomial naive-Bayes and Gaussian naive-Bayes, and when you should apply which one. Okay, can we do that? Can I teach you two different kinds of classifiers, the ones that exist in our midst? But basically, I would want to teach you which classification algorithm should be applied in what scenario. Clear until here? Could I do that? See, my people, the answer is very, very simple. When you talk about multinomial naive-Bayes, okay, this particular algorithm called multinomial naive-Bayes algorithm or multinomial model. Have you heard of something called multinomial distribution? Have you heard of something called multinomial distribution? What is the full form of, or what is the meaning of multinomial? What is the full form of more than two, correct? Relationship of multiple variables, correct or not? A with B, A with C, C with A, C with B, B with A, B with C. You're understanding? ABC has a relationship with multinomialness, right? B with C, B with A with B, A with C, C with A, C with B. Multinomial, multivariate, like just how univariate, multivariate analysis, something like that. Whenever you're working with discrete variables, what do you mean by discrete variables? Column A, column 1, column 2, 0, 1 and 2. When you're working with labels, right? Label. You guys understand labels, right? Like suppose if there is a hot cup of tea, or okay, so tea can be defined as hot, cool, and mild. What kind of variable is that according to you? According to you, what kind of variable is that? It's categorical. And when you look at our data here, okay, look at this. Do we have categorical variables but also continuous variables 233, 255, 204 within the range? Whenever you're only and only very purely working with categorical variables, you have to use multinomial. But when you're working with ranges like 233, 250, 204, see 145, 130, 130, 150, 187, 172, 2.3, 3.5, then you use Gaussian naive-Bayes. Purely discrete variables, multinomial. If it's multinomial, if it's variations like numbers, continuous categoricals with columns like 0, 1, and 2, use Gaussian naive-Bayes. Are you clear? If your problem statement is whether you make good money or not, good money, money, yes and no. Are you male or a female? Male or female? What category is this? Is this categorical? Is this categorical values? Yes or no? Yeah. If you have specifically categorical variables only to implement the output in yes and no, use multinomial naive-Bayes. Are you clear? Just categorical values. If the data set has values which are ranges 145, 130, 132, can you see everything in threshed BPF will be a range between 80 to 140? It's a continuous number. It's not a categorical value. It's a continuous number 140, 148, 147, 147.26. If you have such data, apply Gaussian naive-Bayes. Am I making myself clear? Did I make myself clear? What will you apply here? What will you apply here? In this case, in our data, Gaussian. Now somebody is asking me why. Sir, why should you do this? See, the reason why we should do this is because multinomial distribution and Gaussian distribution. Can I say Gaussian distribution is a normal distribution? Yes or no? Multinomial distribution may look like this. You get the idea, right? Like it's a three-dimensional multinomial curve, right? Like it's not a normal distribution, but it's like a categorical histogram of multiple data and its density. So you will find something like this, like data like this. Like, are you understanding? On a three-dimensional plane, all the numbers are plotted. Because everything is categorical, it has to pass through multinomial distribution to get the output. But if you have real-time variables, don't they follow continuous stream? Hence, they have to follow through normal distribution to get the output. That's why they are different. Because categorical variables are discrete, right? Discrete means non-continuous, correct? You guys understand what is discrete, right? Non-continuous. Because of their behavior, they have to pass through multinomial distribution. And because they are continuous, they have to pass through Gaussian distribution. That's sort of like the reason behind it, Arun. It actually follows in inferential statistics also. That is, something is of a sample size. If it's continuous, then it passes through Gaussian because you want to pass it through a distribution philosophy. So that's why it goes through both of them. I hope it answers the question, because if it does, then we can move forward. So tell me one thing. So tell me one thing, my people. Do you see sklearn.naive base multinomial NB? Do you see sklearn.naive base Gaussian SNB, which is NB naive base? Do you see that from now on, the moment I tell you to see, look at the algorithm, the first thing you should look at is what are the hyperparameters. Look at it. Alpha, force alpha, fit prior, class prior. Look at the attributes, feature count, classes, class log prior, class count, n features, feature names. Can you see there is something called Bernoulli NB, categorical NB, complement NB? Okay, so hold on. Let me make you feel a little good about not knowing things. Can you see there is also something called Bernoulli distribution? If you guys don't know, there is also something called categorical NB. ज़्यादा use नहीं करते हैं, complement भी नहीं ज़्यादा use करते हैं. But I'll show you. There are multiple types of naive-based classifiers. What does complement naive-based classifier? It is used to correct the severe assumption made by the standard multinomial naive-based classifier. So it's like multinomial naive-based classifier, but the severe assumption, what is the most severe assumption a classifier makes naive-based? The assumptions that are made is that each variables are independent of each other, yes or no? And they are of discrete type. Imagine you don't want to make that assumption. You want categorical values, but you want assumptions to be penalized. That's when you use complement NB. Did you understand? Didn't follow completely? That's okay. You don't have to. Complement NB is not something that I would be interested in teaching you also. Did you understand multinomial and naive Gaussian? Did you understand these both at least? How do we implement it? There's an array, there's a Y array. I implement something like from sklearn.naive base import Gaussian, classifier equals to Gaussian, fit X train comma Y train, classifier.predict given certain probabilities. It will predict whether the output is 1 or not. And then you can also do something called partial fit. Partial fit is something that you should not worry about now. Okay, it's something that we'll eventually talk about later. So how about we implement a Gaussian naive base algorithm in the original data that we have? How about we do that? Yes, let's do that. Now, how do we do this? Very simple. Where is our original import? Yeah, here is the import. What do I do, my people, here? From sklearn.naive base import Gaussian NB, yes or no? So rather than doing random forest ke niche, let me plot another thing. Let me copy this whole thing and let me paste this here. Now, the random forest, right? Yeah. Okay, so now let's implement Gaussian naive Bayes model. Okay. And let's try to sort of fix it line by line, because if you remember, we had written this code a while ago, right? We had implemented a logistic regression here. Let me show you the code very quickly. We had implemented the logistic regression code, right? So the logistic regression code is here. This part of it is the logistic regression code. This part here is the decision tree code. This part here is the random forest. This is the decision tree print that we did of all the tree structure that we saw. Right. At the same time, this is the random forest. Yeah. So random forest is on the top. And now we will implement naive Bayes classifier. What is the first thing we will do? First line, rather than calling it RFC, let's call it naive Bayes. And instead of calling this random forest classifier like this, let's call it Gaussian naive Bayes and make it a callable function. RFC will become nb.fit, and ypred we can call it nb, naive Bayes, so that we can make our life easy. And RFC ke badle we can make it naive Bayes. Any confusion in this part? I have just converted my model's name and I have just converted everything like this back. Okay, this is an implementation of naive Bayes classifier, implementation of Gaussian naive Bayes classifier. Would that be fine? Is this okay or something more? Comments on the previous one too? Sure, no problem. Why don't you help me and write the comments on the previous one? And that would be helpful, so that at least you'll read the topic. And I mean, it's not very hard. I can definitely do it. It's not a very complicated thing. So copy this, paste it here. This is an implementation of random forest classifier. This is an implementation of printing a decision tree to visualize the aspects of tree. This is an implementation of a decision tree classifier. This is an implementation of logistic regression classifier with hyperparameters calculated using grid search. Import statements go here. Is this enough? Is this fine? I've written it on most algorithms, and I've also written it here. That's fine. Okay. Now let's change this to NB is equal to Gaussian NB dot fit X train Y train Y pred NB NP dot predict. RFC के बदले लिखते हैं NB, RFC के बदले लिखते हैं NB, RFC के बदले लिखते हैं NB. And this is accuracy Y test Y pred NB, NB, and we will print this. Yeah. Do you see that we got the output for this particular example, the Gaussian naive Bayes? I did NB dot fit. I did NB dot fit with Y pred NB is equal to NB dot predict X test. Okay. NB accuracy score, NB F1 score, and NB confusion matrix. Okay. Accuracy score with Y test Y pred NB, Y test Y pred NB, Y test Y pred NB. Accuracy score is NB accuracy score, NB F1 score, NB confusion matrix, Y test and Y pred NB. Naive Bayes. Okay. And here I can say NB accuracy score, and here I can say NB F1 score. Yeah. So now let's write a code for false positive rate and true positive rate for NB, for naive Bayes classifier. Okay. So false positive rate for naive Bayes classifier NB, true positive rate for naive Bayes classifier NB, threshold for naive Bayes classifier NB. So Y test Y pred forest ke badle I will say NB. So this is done. What do? We will do now plot of FPR NB, TPR NB, and we will have random forest ke badle naive Bayes classifier. So we can say naive Bayes Gaussian. If I do this, yeah. Do you guys see the difference in the tree? Logistic regression, naive Bayes classifier. You have this random forest. You have a decision tree. As we say in classification dataset, we take output feature that is either true or false. So what in case if there is a huge difference between 0 and 1, probability of data imbalance will be high. How can we handle that? Any confusion in this part? Any confusion in the false positive rate, the plot, the model evaluation, the action of naive Bayes algorithm? Anybody confused here? Can we implement a grid search for naive Bayes also, just like how we did it for other parameters? Can we do it for naive Bayes? Okay. Before implementing naive Bayes, okay, naive Bayes algorithm, the first thing you need to do is NB dot, there is something called get params. Okay. If you do this and do dot keys, what it will give you is this. Can you see that there is something called priors and variable smoothing? So my advice to all of you is, let's say you have a logistic regression curve. So log reg. Okay. Logistic regression that we wrote is log reg dot get params dot keys. If you do this, you don't have to go to the website to search for the hyperparameter. Are you clear? If you write this, you will get that a logistic regression has a hyperparameter called C, class weight, dual, fit intercept, intercept scaling. So for example, if I say tree, decision tree, dot get params, okay, dot keys. What will it return? All the hyperparameters that you don't remember. Suppose you don't have an internet connection. You just know, but you don't remember the name. So if you do this, it will return all the hyperparameters for that particular algorithm. Are you clear? So now that I know that a Gaussian naive Bayes has something called priors and variable smoothing, or called var smoothing. Okay, I'm just going to show you an example of var smoothing. It's very, very simple. What do? I will copy paste the decision trees code and paste it here. And I'm going to call it as naive Bayes, naive NAI Bayes. Okay. So first of all, param grid tree should be converted to param grid NB. Yes or no? Naive Bayes. Now it does not need all these variables. It might only need a variable called var smoothing. So I'm going to copy this. I'm going to copy this var smoothing. I'm going to copy and I'm going to paste it here. Okay. Now, if I'm not wrong, var smoothing is also a number between a certain range. Okay. So you can say np.log space. Okay. And I will give it a range of 0 to 20, 0 to 30. It's up to you. Hold on. Give me 1 second. Gaussian naive Bayes. Give me 1 second now. Let me just check what is the parameter like. Okay. So portion of the largest variance of all the features that is added to the variance for calculation stability. Okay. So that must mean 10 to the power of 9. So 1 to the power of minus. So let's take a negative value here, right? And we'll give it a jump of 4, 5, 6, 7. Doesn't matter. It actually, hold on. If it's for sampling variance, portion of the largest variance of all features that is added to variance for calculation stability. So how does it work? Is it a bool value? Is it a string value? I mean, is it a int value? I think it's an int value. It's a float value. Okay. Okay. 0.5. No, that is not how I want it to be. Not equal to 0. And it is a float point value. So how do I say var smoothing? What is the range? Range. So let's see the range let's see the range. Give me 1 second. Okay. So if this is the range, hold on. I believe it's a float point value. So even if I convert it into, I don't know, number of values. So hold on. Can I take this as a step of count 4, count 2? Let's take count 2. Okay, let's see if this works. Okay. And grid search NB, I'm gonna call this as NB. Grid search estimator is NB. The param grid NB is my param grid. Sorry, Control Z, NB. And cross validation is same. Number of this is same. Grid search NB dot fit X train Y train. Tree params is equal to NB params is equal to grid search NB, and I'm going to call it the best params. So rather than printing tree params, I'm going to say NB params. Give me an output. Give me an output. Ah, okay. What if I make it 5? How is the smoothing going to go? Oh, it does not matter, is it? Okay, 20 to this. Oh, it's found out the relevant value for it. Okay, makes sense. Makes sense. How about priors? How does the prior work? Oh, this is n classes. Okay, that makes sense. Okay, all right. Yeah. I got that. I got that. It's sort of like a. So what's happening here is in Gaussian naive Bayes or in any naive Bayes classification, what happens? They have a smoothing function. What this does is the var smoothing or whatever variable smoothing is. Have you heard of part in machine learning where whenever there is a feature called feature A, feature B, feature C, and feature D, sometimes what happens, feature A, feature B, and feature C have more priority for prediction of output than feature D. Like feature A, B, and C have more importance over feature D for predictions of an output. Feature D is important, but not to an extent A, B, and C are important. Doesn't mean we drop D, yes or no? Are you understanding what I'm trying to say? When you have multiple features, certain features with certain categories have more weightage onto it. What you mean by Laplace smoothing is, or whatever the smoothing that they've applied is what I've understood, is they apply a small portion of a number that is applied to all variables, all features with which it's sort of like balanced. Okay. The best Ware smoothing number that we got was this. And it is a float point value. So I gave a log space value, which works fine. So this is like the best parameter for that particular value. So what did we do? We implemented a naive Bayes classifier. We implemented the best, we did a grid search on finding out which is the relevant number for a range between this to get me a proper variable smoothing for whatever naive Bayes classifier that I am building. And I would rather first take out the params and paste it where? Paste it here. Yahan pe. So where have I implemented naive Bayes? I've implemented naive Bayes here. So what I could do, I could just go here. I could just take var smoothing, okay, this particular thing, or I can just come here. Yeah, and I can pass in a variable called var smoothing, and I can give it a number called 0.0000, whatever the number that I found out here, whatever this number is to the power of 19 zeros and then 2. I can put that number here, and it can give me considerably a better output on my classification algorithm. Do you have any question in the implementation of naive Bayes, or did you understand that every machine learning algorithm has a library? Library implementation is basically the same. All you did is just implement it and we got the output. How are we printing the accuracy? You don't print the accuracy. You print the accuracy like this. Once you have calculated the best parameter, you copy this parameter, you come back and you paste it here. Simple as that. You just paste the parameter right there and then, because it gave you the most relevant output. You remember in yesterday's class, I told you an example with logistic regression, that in logistic regression, we got the best penalty was L2 and the best C value was this using grid search. So we first did grid search, extracted grid search and put the penalty and then ran the algorithm. You remember we did that yesterday? Exactly what we're doing. My people, this is an old technology. Do you know what I do now? In my practical career, in my practical aspect, what do I do for hyperparameter tuning? I use a library called Teapot. Have you heard of it? Have you heard of a package called Teapot? Here is what it does. Listen to me. Listen to me. You guys will love why machine learning is awesome. Do you see what you have to do in order to understand which is the best classifier? You know what you have to do? You just have to import Teapot. See, Teapot, my people, is a library that is an auto machine learning library. You pass the data, you don't even decide which algorithm to implement. It will implement all the classification algorithms automatically. It will even tell you which is the best accuracy for that model. It will even tell you which is the best hyperparameter for that model. So this is a package called Teapot. What it does, it gives you an initial guess, right? Suppose you have a very large data. Suppose 5 lakh records, 10 lakh records. Of course, you're not going to put a 5 lakh record in Teapot, correct? You will take a sample of 2,000, 3,000, maybe 5,000. You will put it in Teapot. Teapot will tell you, based on the 5,000 samples, I believe that this algorithm does the best, and this is the hyperparameter. Won't it give me an idea that this algorithm is doing good on the sample? So most probably, I will try to test this on the actual 5 lakh dataset without worrying on testing all. Saves a lot of time and energy. So there's a library called Teapot. This is my recommendation to it. It's called AutoML. Okay. This is like a data science assistant for you. So you don't have to worry about it. It will calculate the most effective hyperparameters. It will tell you the relevant optimization, and it'll tell you everything. And then it'll give you the output. And it'll tell you that this is the best model that I ran. This is the best features that I got. Everything. I mean, it does a fascinating job. So this is what I use. I don't use hyperparameter tuning directly. I first get an understanding which algorithm is performing good on sample. They usually work well on the larger data set also. Then I very granularly hyperparameter tune that and then deploy that model. And it's always helped me. Matlab, the answer has always helped me. On the naive-based classifier, my people, did you understand the concept of naive-based classifier? Did you guys understand the concept of decision tree? Did you guys understand the concept of random forest? Do you guys have any questions for me that you would want to ask? Any questions? Feature extraction, exploratory data analysis. What is random search CV? Unlike grid search CV, random search CV, what it does is, my people, imagine there is a hyperparameter called max leaf, LEAF. Imagine there is a hyperparameter called number of depth. Imagine there is a hyperparameter called C. So suppose in the max leaf you have said 1, 2, 3, 4, 5. Number of depth is 2, 4, 3. And C is 0.001 and 0.002. What grid search CV does is, it will calculate for max leaf 1, number of depth 2, C is equal to 0.01, and it will print the answer. Then it will calculate, okay. Then it will calculate for this, then it will calculate for this, this, and this. Then it will calculate for this, this, and this. Once this is done, it will have values. Then it will implement this, this, and this. Then it will implement this. Are you understanding? Each combination is implemented. All combinations are implemented. The larger your hyperparameter numbers are, every will be implemented. But this is called grid search CV. But do you know what happens if you are smart? There is another model called random search CV. You know what it does? It will randomly select 4, 4, and 0.001. It will randomly select 2, 3, and 002. It will not run all, but it will run most. And from the most, you will get the highest accuracy. It is noted by experience and experiment that random search CV does equal good job of a grid search CV, because sometimes while randomizing, it comes up to the optimal solution randomly also. Rather than doing all permutation and combination, it randomly searches for random values and find out the best answer from that. Are you clear? This is what random search CV does. It does not do all combination and validation. I want to ask you guys a question. Imagine all these values are there. Suppose the most optimal solution is only this part. Okay. For example, the best answer is 4, 4, and 0.002. So that must mean that every other combination is a waste of time, right? Because this is the most optimal solution I have. Yes or no? So rather than that, if I randomly approach it, isn't there a probability that 4, 4, and 0.02 has a certain probability that there is a 25% probability that you will find it? Are you understanding? So random search CV, what it does, it randomly starts targeting columns and it calculates itself in a better way, saying that, okay, I believe from the random calculations of some variables, I found out this is the best. And mostly random search CV works better than grid search CV. In most cases, it works faster, it works better. Could you give us to a practice of random search CV? 100%. My recommendation is, rather than me writing everything for you, why don't you give it a shot once? It's very simple. Just the same thing. Hold on. Let me show you. Random search CV. sklearn.this. Do you see that you have something called estimator, param distribution, n-iter scoring, verbose, n random jobs? Okay, hold on. How have we taken it? We have taken estimator is equal to nb. Is there an estimator there? 100% there is an estimator there. Yes or no? Is there an estimator there? Very good job. What is the next thing that we've taken? Param grid. Is there a param grid that you can find here? Is there a param distribution rather than grid? It's the same thing. It's the same exact thing. Okay. Uske baad, what is cross validation equals to second. Do you have something called cross validation here? Can you see CV is equal to none? Yes, 100% है. अच्छा, उसके बाद क्या है? I have taken scoring equals to accuracy. Is there a scoring matrix here? Yeah, right there. Can you see scoring equals to none? अच्छा, उसके बाद is there something called n jobs equals to -1? n jobs equals to -1 दिख रहा है आपको? n jobs equals to none. Exactly same है. एक बार इंप्लीमेंट तो करके देखो अपने आप. Are you getting it? Like, try it out once by yourself. The reason I'm not doing random search CV is, you know what? If I implement random search CV here, okay, you're going to get one error. You're going to, okay. See, if I implement random search CV, there's going to be one error. And that error is solved with a very minor thing. If I tell you everything, you guys are not going to come back to me crying and say that, sir, I tried exactly how you said, random search CV, but now I'm getting an error. Help me explain what is that error. Then I'm going to be like, hey, did you not focus on the data? Did you not see where you're going wrong? And that's where I want to sort of like have a effect over you people. Like, hey, look, this is the error. This is how you fix it. Some of you will be able to fix it, but not all of you will be able to fix it. But at least try, fail a little, and then come back to me and say, I'm not going anywhere, right? Machine learning, I'm continuing for you guys. So it's not like I'm going anywhere. But can you give it a shot, fail a little, and then come back and ask me, sir, I failed. What happened? And then I'll be like, hey, this is what happened. You need to fix this in order to get an output. Want to give it a shot like that? Want to give it a shot at least? My people, do that. I'm telling you, the more you fail faster, fail harder. Learn to fail fast, learn to fail hard. Only then you will improve. Okay. This random search CV and grid search CV are used to improve our model performance by adjusting the parameters. Yes, Joseph, 100%. 100% it is. But let me explain what is this CV. Can I explain you something called cross validation, please? What this var smoothing is dear, it's a number that is added to each feature. This number is added to each feature to balance out the data set. That's what this var smoothing is. It's sort of like a Laplace smoothing. So what it does is each feature has its own importance, and each importance is added with this particular number so that they are equally balanced while going through the analysis for naive Bayes. This is what this means. Okay. Acha, can I explain you the concept of cross validation, my people? Because you've heard this CV is equal to 7, 7, 7. And now you must be confused. What is cross validation? Can I do it? My people, imagine, how do I teach you this? Chalo, ye acha hai. This is a good example. My people, what is K cross validation? K-fold cross validation, okay? Cross validation, my people, is a technique in machine learning where what you do is, suppose this is your entire data set, okay? If this is your entire data set, suppose this is your entire data set. When you split the data in training and testing, don't you think that is it possible that the training data is very good, testing data is very bad? Matlab the distribution, by chance, it can happen that the training data goes in a very good well and the testing data goes in a very different way. Matlab there is a certain biasness in the data. Agree or disagree? Yes or no? That can happen, right? The distribution of data could happen in such a way that the testing did not get good results or good outputs or good samples, but the training got very good samples. In order to solve this problem, rather than taking one data as a train and test, what we do is we take a data and the training data and we split the data into fold. How many fold is this data split in? 5 fold. How many folds? 5 folds. We split the entire data into 5 different parts. 1, 2, 3, 4, and 5. And what we do is the first fold, the fold number 1, it will be my testing data. Rest is my training data. And I do my training and testing on this. And I will get some output from some performance of this. Then what I do, I take the second fold as the test data and the rest 1, 3, 4, and 5 is my training data. So that the biasness of the training and test is not there. Are you understanding? We split the data into number of folds, number of separate groups, and each group is given equal importance to be in the training data and the test data. And each fold has its improvements. And we average the performance and we say that I am very sure my data is validated from our end. This is the training output. This is the testing output. Did you get it? Did you understand what I'm trying to say? I would first of all, let me copy paste and answer this to sort of, I have to paste this and give you a shout out. This is your expectation from a professional career also. Your understanding is that every ML model implementation is same, equally the same, is just that the library names are different. Okay. The important part is you need to first implement the model, see how the performance is, plot an AOC ROC curve, then do a hyperparameter optimization. The hyperparameters that you got, put it in the same model and get a much better output. Yes, 100% your expectations and your knowledge and your thought process is in the right direction. Sorted? You're thinking correct, my dear. You're in the right step. Okay. Did you understand the concept of k-fold cross-validation, my people? Each training data is split into multiple fold. One fold will be given as a testing data, other will be trained for training. Each fold will be given each chance to be in the testing, and each fold will be given a chance to be in the training data. We take all the folds performance and we average the performance. This is called k-fold cross-validation. This is called k-fold CV. Are you clear? Are you clear? The number of k is this number, 5. You can define k is equal to 1, k is equal to 5, k equals to 20, depending on the data. You decide how much fold you want to do. K-fold cross-validation or cross-validation has multiple types. K-fold cross-validation. There is something called LOOC1, leave वन आउट क्रॉस वैलिडेशन. इसको लिखने से अच्छा मैं सिखाई देता हूं. LOOCV. सी LOOCV को हम बोलते हैं लीव वन आउट क्रॉस वैलिडेशन. लीव वन आउट क्रॉस वैलिडेशन इज सिंपल. व्हाट इट डज इज, सपोज योर डेटा सेट साइज इज 100. One data, only one data will be testing, 99 data will be training. Did you get it? One data will be tested. Rest 99 data will be used for training. No one implements LOOCV because it takes a lot of time. LOOCV, leave one out cross validation. People don't use it because first of all, one data is training, one data is testing, rest is all training. Training में 99% जा रहा है, 1% is testing. So people don't prefer using this. People using K-fold cross validation. Are you clear with the concept of cross validation, my people? Why do we do this? Because we don't want some data to be biased and go to training and some go to testing. We want equal importance to be given for all data, all folds on both training and testing, and that's why we do k-fold cross validation. My people, do you have any other questions that you won't want to ask? Could we implement random forest visualization also? No, unfortunately random forest visualization does not happen. You have number of trees. As per my knowledge, there is no visualization for random forest. There could be now, but I don't believe there is any visualization for random forest. Yeah. Can you see that I am manually writing all the code here? I'm doing parameter grid myself. I'm doing, all the keying myself. I'm adding all the things myself. What they've done is, rather than you writing an extra code, they've automated that. So all you have to do in Teapot is you have to just select what, okay. So you have to pass in your data. Once the data is passed, each column is tested to be categorical, continuous, cross, continuous, ordinal, nominal. It identifies depending on the data type you have, and depending on the data type, it decides which algorithm will be best for it. It decides which tuning it needs to do. It decides how the output should be. So everything is taken care by the automated thing called Teapot. Matlab, you don't have to do anything. In within 10-15 lines of codes, it will tell you the algorithm that performs the best. But that doesn't mean it is guaranteed to perform in your entire data set also. You still have to implement the algorithm. But at least Teapot gave you an initial guess. Yeah. Teapot gave you an initial idea that looks like on your data, random forest does a better job. With precision and with recall, it gives you a better job. So won't you fine tune random forest much accurately rather than wasting time on logistic regression, its AOC, ROC curves and all of that? You will focus on specific algorithm because it does a better job. So Teapot is here to save time, not for production, not for Teapot is just for saving time. You have to think of it like, rather than giving your job to somebody as an intern, doing everything by yourself, Teapot just helps you get answers faster. Think of it like that. What in case classification output data 0 and 1 having, ये मेरे को समझ में नहीं आ रहा है. How to normalize this data since it will affect the accuracy score even with hyperparameter, isn't it? देखो, there is a data set and there is a number called 15,000 rupees to 1.3 crore. If we normalize this becomes 0 to 1. Yes or no? This is point number 1, correct? Normalization and standardization is a good practice. Okay. When you convert your data between a range of 0 to 1, it does not lose any information. Just because you converted everything between 0 and 1, you have just scaled the whole value. मैं आपको एक example दिखाता हूं. My people, imagine you have built a house. Okay. Imagine you've built a house. The house, this length is 10 centimeter, 10 centimeter, 20 centimeter, 20 centimeter, 20 centimeter. I want to reduce this half. I want to reduce the size of the house by 50%. तो आपको each number को किससे divide करना पड़ेगा? By half, right? So 10 divided by 2 is 5. 10 divided by 2 is 5. 20 divided by 2 is 10. 20 divided by 2 is 10. And 20 divided by 2 is 10. Did you just decrease the original size by 2, but you not lost any information of the house? घर में अभी भी 2 छपरे 3 दीवारें हैं. You had a house which was 10 centimeter of slope, 10 centimeter of slope here, 20 centimeter walls and 20 centimeter floor. You wanted to reduce the half of the size of the house by half. You have just changed the scaling factor, the SF, just the size. But did the numbers decrease? Did the shape of the house become irregular? No. Normalization works exactly like that. If somebody is making 15,000 or 1.3 crore, normalization just reduces the number between 0 and 1. But the information, example, somebody was making 15,000 will be converted as 0.02. Somebody is making 1.3 crore will be 0.87. So you see, 1.3 crore is higher and the scaling factor is also higher, 0.87. Somebody who's making 15,000 is 0.02. वो छोटा है. Information loss नहीं होता है. Just that the ranges get converted. And this is what the computer understands also. That, hey, 1.3 crore matlab 0.87 matlab he must be making good money. 15,000 0.2 he must be making lesser money. Are you understanding? So normalization has no effect on hyperparameter tuning. They are independent of each other. Normalization is not a necessity. You have to do it. You can't run machine learning without it. Once you normalize between a range of 0 to 1, hyperparameter tuning can be done easily. It's not a problem at all. Not a problem at all. You don't do hyperparameter tuning on the feature. You do hyperparameter tuning on the variables, right? The variables that the library has decided. You don't do a hyperparameter tuning on, suppose if someone's salary is 15,000, so you're testing 15,000, 18,000. You don't do this. You do hyperparameter tuning on the entire variable that the library has decided for you. You don't do hyperparameter tuning on the features. You do it on the variables, on the hyperparameters. Okay. So be clear that hyperparameter tuning and normalization have no relationship with each other. They're independent. Normalization can always be used when you have multiple different numbers of different ranges. If there is a shape of data 10,000, 10,000 rows, 10 columns. We are taking output as last column. Now shape of trained data is this and test data is this. Now if output column having this and this, I'm asking it will affect any inefficiency. Am I clear now? यार कॉल पे पूछ लेता तेरे मतलब फॉर्चुनेटली क्या है कि और चैट्स आर वेरी ऑसम मैं समझ नहीं पाता हूँ. होल्ड ऑन. एक डेटा सेट साइज है जिसमें 10,000 रोज हैं. ओके 10,000 रोज हैं और कितने कॉलम्स हैं 10 कॉलम्स हैं. ठीक है. देयर आर 10 कॉलम्स ए बी सी. एक मिनट ऐसे नहीं ऐसे लिखते हैं. होल्ड ऑन आई अंडरस्टूड. फीचर 1 फीचर 2 फीचर 3 फीचर 4 फीचर 5 फीचर 6 फीचर 7 फीचर 8 फीचर 9. The 10th feature is the target. So he's saying that if I remove the last feature, which is the target, which is we don't need, I have 9 features. Okay. I will be left with 9 features and each feature is a total size of 10,000. Ab samajh mein aaya bhaiya. Okay. Now the shape of trained data is 10,009 and test data is 10,001. Okay. Now if the output column is, here is where you're wrong, my brother. Okay. Yahan pe aap galat ho. You are saying because I have split the data into क्या बोलते हैं 10,000. अब ये क्या है 9 columns हैं and this is column number 1. You are saying sir my training data is 9,000 test data is 1,000. ऐसे नहीं होता है सर. ट्रेनिंग डेटा एंड टेस्टिंग डेटा दोनों 9,000 है और वो भी 9,000 है. I'll tell you how. आप ट्रेनिंग डेटा और टेस्टिंग डेटा को कैसे स्प्लिट करते हो? हाउ डू यू स्प्लिट दिस डेटा इनटू ट्रेन एंड टेस्ट? डोंट यू मेक अ स्प्लिट लाइक दिस? This entire thing will be training and this entire thing will be testing and you are not supposed to consider this column as a testing data. ये पूरे data को आप column को test नहीं ले सकते. ऐसे नहीं होता है. You divide the entire data. The size of the testing and training is still 10,000, 9, 10. Sorry. आपको समझ में आया? You don't split it column wise. आप उसको row wise split करते हो. Example के लिए अब अगर मैं बोलता हूं कि माई ट्रेनिंग डेटा इज 90-80%. सपोज मैंने बोला कि माई ट्रेनिंग डेटा विल बी हाउ मच परसेंट? माई ट्रेनिंग डेटा विल बी 80%. तो वोंट यू स्प्लिट द डेटा वेर 80% ऑफ द डेटा इज गोना बी फॉर द ट्रेनिंग ऑफ द एल्गोरिदम एंड द रेस्ट 20% विल बी फॉर टेस्टिंग एंड दिस इज कॉल्ड एक्स ट्रेन, दिस इज कॉल्ड एक्स टेस्ट and this is called y train and this is called y test. This is how you split it. ये एक इंडिविजुअल कॉलम टेस्ट नहीं होता. कॉलम को निकाल लेना, फीचर को निकाल लेना, फीचर टेस्टिंग नहीं होता है. फीचर होता है. ओके ट्राई टू अंडरस्टैंड. देख बहुत सिंपल सी चीज है और तेरा क्वेश्चन बहुत वैलिड है ब्रो. मतलब आई एम नॉट, मैं ये नहीं बोल रहा हूं कि तेरा क्वेश्चन वैलिड नहीं है. काफी सही क्वेश्चन पूछा तूने एंड आई एम ग्लैड तूने मुझे पूछा. देख क्या होता है ना, whenever we do training and testing, तेरे को पता है ना कि जब हम मॉडल की ट्रेनिंग करते हैं, whenever we do model training, we need to give each feature input and we need to also टेल द मॉडल दैट हे भैया इसका आउटपुट ये आया था, यस आया था, इसका आउटपुट नो आया था, तो मेरे को बोथ फीचर एंड टारगेट दोनों की जरूरत पड़ेगी ना मॉडल को ट्रेन करने में, कि देखो ये सब डालोगे तो ये आंसर आना चाहिए, समझ लो, ये सब डालोगे तो ये आंसर आना चाहिए, समझ लो। तो मेरे को दोनों चाहिए, राइट? ट्रेनिंग और टेस्टिंग दोनों, लेबल डेटा भी चाहिए, टारगेट भी चाहिए, फीचर भी चाहिए। ये अपना फीचर भी चाहिए, टारगेट भी चाहिए, मॉडल को बताने के लिए कि देख इन सारे इंस्टेंसेस को समझ के ये समझ ले कि टारगेट ये होना चाहिए। और फिर जब हम टेस्ट पे करेंगे और जब ये आउटपुट आएगा तो वाई प्रेड से इसको कंपेयर करेंगे ना कि क्या कितना क्लोज थे हम आंसर के। समझ में आया? सो प्लीज डोंट इमेजिन एंड इंक्लूड दैट द ट्रेनिंग टेस्टिंग द लेबल विल बी और क्या बोलते हैं टेस्ट डेटा। पूरा डेटा ही आपका ट्रेन और टेस्ट होता है, आप उसको रो वाइज स्प्लिट करते हो, कॉलम वाइज नहीं। एक बात बता हीरो, मेरे को बस एक चीज समझा, ठीक है? लेट्स से कि एक बंदे की एज है, एक बंदे की सैलरी है, ठीक है? एंड आई वांट टू प्रिडिक्ट वेदर आई विल गिव हिम लोन और नॉट। और मेरे पास चार वैल्यूज हैं, ओके? एज 23, salary is 23,000 rupees, so he will not get a loan. Age is 54, salary is 1,50,000 rupees, so I will give him a loan. Age is 15 years old, 1,500 rupees, I will not give him loan. And age is 22 years old, salary is 25,000 rupees, and I will give him a loan. ये मेरा डेटा है, अग्री और डिसअग्री? इतना हाँ या ना बता दे, इतना समझ में आया? ओके। हाउ मेनी कॉलम्स एंड हाउ मेनी रोज डज माई डेटा हैव? दिस इज हाउ मेनी कॉलम, हाउ मेनी रोज। सो कैन आई से 3 कॉलम्स एंड 4 रोज? सो द शेप ऑफ दिस डेटा इज 3 क्रॉस 4, 3,4। इतना समझ गए? इतना समझ गए? वेरी गुड। ओके, अब आई गिव यू क्लैरिटी, गिव मी 1 सेकेंड। देख, दिस इज माई एंटायर डेटा, अग्री? Among this data, this is my feature variable. ये हमारा फीचर है, FEATURE फीचर, एंड दिस इज माई टारगेट। मुझे ये प्रिडिक्ट करना है, yes or no? मुझे ये प्रिडिक्ट करना है। इफ आई वॉन्ट टू गिव दिस टू द ट्रेनिंग ऑफ द मॉडल, अब ट्रेनिंग के लिए एक बात बताओ, लिसन टू मी वेरी केयरफुली। इफ आई टेल यू माई एज इज 23, माई एज इज सैलरी इज 23,000, वॉन्ट द मशीन लर्निंग मॉडल नीड टू नो कि तुमने कितना दिया, तुमने दिया नहीं दिया, डिड यू गिव अ लोन और नॉट? डोंट इट नीड बोथ फीचर एंड टारगेट टू लर्न फीचर क्या था and what was the target that the person assigned? Doesn't it want to learn? Doesn't it want to see what you gave so that I also can predict in the future whether it is a yes or a no? So how will you split this data in training and testing? Suppose I split this data like this. 3 data points will be used as a training. ये जो डेटा है इसको ट्रेनिंग के लिए यूज करूंगा और इसको टेस्टिंग के लिए यूज करूंगा। इतना समझ में आया? दैट दिस विल बी यूज्ड फॉर ट्रेनिंग एंड दिस विल बी यूज्ड फॉर टेस्टिंग। अब लिसन टू मी वेरी केयरफुली। ट्रेनिंग में जब डेटा जाता है, फीचर सेपरेट, टारगेट सेपरेट नहीं जाता है। फीचर्स एंड टारगेट गो टुगेदर, एक एरे में जाता है कि 23,23,000 का आउटपुट था नो। This is how machine learning reads it. This is how the data goes in the model. So it knows कि जिसकी एज 23 थी, somebody whose age was 23, who was making 23,000 got no loan. तो तू समझ रहा है, फीचर अलग नहीं होता, फीचर हम अलग करते हैं बट इनसाइड एक साथ ही जाता है। अब क्या होगा कि बिकॉज मैंने ये फीचर को डिवाइड कर दिया, तो ये जो पार्ट है, ये जो ट्रेनिंग डेटा का पार्ट है, दिस एंटायर थिंग, व्हाट कैन वी कॉल दिस एज x अंडरस्कोर ट्रेन? यस और नो? दिस इज x ट्रेन वैल्यू एंड दिस इज कॉल्ड y ट्रेन। यस और नो? ये x ट्रेन है, ये y ट्रेन है। दिस इज x टेस्ट, दिस इज y टेस्ट। यस और नो? X train, Y train, X test, Y test. Did you get it? In every algorithm, what did we pass in the fit model? X train, Y train, right? हमने whenever we did a fit of the model, did we not pass X train, Y train as an input? Look at this algorithm. मैं तेको दिखाता हूँ. Hold on 1 second. Look at this. See, X train, Y train. X feature भी भेजो, target label भी भेजो. Both X train, Y train. See, tree dot fit. See, X train, Y train. See, X train, Y train. Look at this. इसमें भी हमने X train, Y train भेजा है, देख. How to reduce bias and variance? Do you want to know? Suppose if you're working on a model, first of all, understand this. Bias and variance is not reduced on a target or feature. It is reduced on a model. Are you clear? Are you clear until here? First of all, are you understanding? देखो क्या होता है कि bias and variance, okay, are seeps in or they come in when there is a model. Okay, so one of the best way to reduce bias and variance, and by the way, you cannot reduce bias specifically, variance specifically. They are not very good. आपको क्या करना है? आपको ज्यादा ट्रेनिंग डेटा देना है. If you want to reduce bias or variance, give it more training data. make the model more complex. For example, rather than using logistic regression, use decision tree. Isn't decision tree more complex? Isn't random forest more complex? Use regularization. If you don't know what is regularization, मैं सिखाऊंगा कभी आप लोगों को. Use cross validation, k-fold cross validation implement करो ताकि biasness खत्म हो जाए. Ensembling technique use करो. Use ensemble algorithm rather than using one algorithm. Use multiple algorithms so that your bias will be gone. समझ रहा है? Are you understanding what I'm trying to say? To reduce bias, increase the training data ताकि more knowledge comes. Increase the complexity of the model, or do ensemble modeling, or do cross validation. Your bias will go off, your variance will go off. There will be a trade-off. समझ में आया? Are you understanding? Will naive base work well with the target variable has more than one class? I mean, what if the target column is not binary but multi-class? Look, if you have a multi-class classifier or a multi-label classifier, naive base performs good. It's not a problem. Okay. Both for multi-class classification and multi-label classification, it does a good job. It is known to perform better whenever it's assumed to be not perform better. But if you want to do multi-class classifier and multi-label classifier, one versus rest is usually a best approach. So what you do is one versus rest classifier. So people usually go with this multi-class classifier and one versus rest. So you usually compare one versus OVR and one versus multi-class classifier. With this, you can have either an option of multi-label classification or multi-class classification. आप दोनों कर सकते हो. You can do both. Actually, ensemble models perform better in multi-class. And stacked classifier. Have you heard of something called stacked classifier, my people? Have you ever heard of something called stacked classifier? Ever had a chance to work with a stacked classifier? Okay. Do you want to know what is a stacked classifier? Do you want me to give you guys an idea about what is a stacked classifier? Can I show you something in this code? Can I show you something amazing in this code? Can I? Have you ever heard of something called stacked classifier or stacking classifier? Okay. You guys haven't heard of stacking classifiers, right? Okay. Let me introduce you to another topic called stacking classifier. See, my people. Okay. Hold on. Let me see if I have ML extend. From ML extend.classifier. अरे बट एक और था ना stacking classifier CV भी था इसमें. एक मिनट रुको. With cross validation. Exactly. This is what I'm looking for. क्या नाम है इसका? Stacking classifier. अरे threefold cross validation कैसे कर सकते हैं इसमें? Okay. So I'll give you. अच्छा स्टैकिंग सीवी क्लासिफायर बोलते हैं उसको. ठीक है मैं समझ गया. फ्रॉम एमएल एक्सटेंड डॉट क्लासिफायर इंपोर्ट स्टैकिंग सीवी क्लासिफायर. ठीक है एक मिनट. आई एम गोना शो यू समथिंग. गिव मी 1 सेकंड. यू गाइस विल जस्ट लव मी फॉर टीचिंग यू दिस एंड यू विल अंडरस्टैंड आल्सो. गिव मी 1 सेकंड. क्या ये इंप्लीमेंट है? मेरे पास एमएल एक्सटेंड नहीं है. ओके एमएल एक्सटेंड कैसे लोड करेंगे? पाईपी में जाके लोड करेंगे. तो एमएल एक्सटेंड पाईपी, come to ML extend, just copy this, come back to a Jupyter notebook code. If you want to install a new package, this is how you do it. You put a next sign, you say ML extend, just say pip install 3, isko comment out kar do, run it. It's gonna install the library, collecting, requirement satisfied, install successful. Isko comment kar do aap, you don't need this, come to ML extend, run this. Now it's running. Okay, I want to show you guys something. Okay, I taught you guys ensembling a lot of times, right? Like ensemble algorithm, you can implement multiple ensemble algorithms, you can combine multiple algorithms together and you will get like a good output. You remember we've done this? I will show you how stacking is done. And let me tell you what is stacking classifier, okay? Stacking classifier is, let me first tell you what is a stacking classifier. See, my people, imagine you have a training set. Imagine you have a data. Listen to me. Imagine you have a data and you have a multiple algorithms. That data is being trained on logistic regression. You are doing it on naive-based classifier. You're doing it on decision tree. You're doing it on all of that stuff. After the output of all these classifiers, you do vote matching and that output goes to another classifier called meta learner and you get a final prediction. This is called stacking classifier. समझ में आया concept? Hold on, let me teach you. See, my people, imagine rather than doing multiple classification of an algorithm, can't I do this? Can't I take a learner, suppose logistic regression as one classifier? This is my original data. There is another classifier called naive-based classifier. There is decision tree and there is random forest. Can I not pass the same exact data to a logistic regression, naive-based decision tree and random forest and let them all make a prediction for the feature? This is the output. Suppose this is my output. And depending on the vote, I pass it to another classifier, which is a much better classifier. Call it support vector machine. And this meta learner will give me the final output. This is called stacking classifier. You stack multiple algorithms. You use another algorithm called meta learner, and that gives the prediction. So no bias, no variance. It is balanced. Okay, I'll implement it. I'll implement it and I'll show it to you. Did you understand the logic? I'll tell you why these are all important. ये सारा doing all of this nonsense is important because it's important. Okay, see now in the stacking classifier, you have to pass what classifiers do you want to actually run as this, as the base learner. Can you see base learner and meta learner? Can you see base learner and meta learner? So first you have to say how many algorithms do you want it in the base learner. एक काम करते हैं, हमने क्या क्या algorithm लिखे हैं? logreg लिखा है, तो logreg को बना देते हैं मेटा लर्नर. हमने नेव बेस्ड क्लासिफायर इंप्लीमेंट किया है, राइट? हमने सपोर्ट वेक्टर मशीन नहीं किया है, बट डिसीजन ट्री किया है, तो ट्री कर देते हैं. ओके, अब एक मिनट पहले मैं ये देखता हूं कि इसमें क्या बोलते हैं. इसके लाइब्रेरी में गिव मी 1 सेकेंड ना. इसके लाइब्रेरी में डिसीजन ट्री को ट्री ही बोलते हैं, राइट? गिव मी 1 सेकेंड ना. केएनएन रैंडम फॉरेस्ट और एक मिनट ना, गिव मी 1 सेकेंड. तो स्टैक सीवी अगर मैंने किया and I'm passing it as this, तो KNN, अच्छा हाँ 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 करेक्ट, तो ट्री को ट्री ही पास करना है, ठीक है, तो ट्री है. ओके, दिस इज माय बेस लर्नर. अग्री और डिसएग्री माय पीपल? दीज आर ऑल माय बेस लर्नर्स, करेक्ट और नॉट? नाउ आई नीड टू पास समथिंग कॉल्ड मेटा लर्नर. ओके, something called meta classifier. Now meta classifier, देखो remember, even if you give the classifier NB as a classifier, आप meta learner को भी you can replicate the algorithm. Are you understanding? You can replicate, if you've given naive Bayes as a learner, you can still give meta learner as one of the classifications you can give. So here is what I've done. एक काम करता हूं मैं, since this is highly random, मैं इसको एक जगह स्थिर कर देता हूं. So this is what I did. SCV dot fit. What am I fitting here? X train underscore Y train. Yes or no? Agree or disagree? What am I doing? I am passing the accuracy of SCV. Correct or not? मैं उसको fit कर रहा हूं. अब मैं क्या करूंगा? SCV को let's say predicted values. Okay, predicted values will be. Now here's what you understand. When you want to do predict something, what do you pass inside this? What do you pass inside this? Dot predict. What do you pass? You pass the X test value, right? So that the output for X test comes as a prediction. Yes or no? So SCV underscore, let's say confusion matrix. So conf underscore matrix. अब मगर उसका मुझे confusion matrix बनाना है. Was there a formula that is there a module that I've imported? Yes, confusion matrix. Can you see what you have passed inside it? Y test. And what do I pass inside it? SCV predicted. Correct or not? Agree or disagree? This is my confusion matrix. अब मुझे accuracy score print करना है. SCV underscore accuracy underscore score is equal to. अब how do you do accuracy score? SCV accuracy score. Just call accuracy score. What do you pass inside it? Same thing. Y test, Y pred. Okay. Y test, Y pred. अब what is the last thing that is pending? Classify F1. चलो F1 print कर लेते हैं. Support CV underscore F1 underscore score is equal to. अब इसमें क्या import करूंगा मैं? F1 को import करूंगा. What do I pass inside it? Y test, Y pred. Any confusion in this part? We're sorted until here. If I print these values, so can I say print SCV predicted? नहीं, predicted नहीं, confusion matrix. पहले confusion matrix print करते हैं, फिर print करते हैं SCV accuracy score, okay, and then we will print F1 score, ठीक है? SCV, एक मिनट, print SCV underscore F1 score, ठीक है? अब इसको मैं लिखता हूं as a F, डबल कोट डाल दिया यहाँ पे और इसको कॉपी किया and I will paste it, colon ब्रैकेट पेस्ट, ठीक है? इसको निकाल दिया मैंने एंड आई विल कॉपी द सेम थिंग फॉर एफ टेस्ट बोल रहा हूं मैं, पेस्ट, एंड दिस इज क्या है? कंफ्यूजन मैट्रिक्स के बदले एक्यूरेसी स्कोर है, करेक्ट? सो आई एम जस्ट गोना कॉपी इट हियर, पेस्ट इट हियर एंड आई एम गोना पेस्ट इट हियर एंड देन आई एम गोना कॉपी दिस. पहले इसको कॉपी करना था, होल्ड ऑन, कॉपी एंड पेस्ट. अब मैं इसको करूंगा F1 स्कोर को कॉपी, आई विल पेस्ट इट हियर एंड आई विल पेस्ट इट हियर. इफ आई रन दिस, आपको दिख रहा है क्या कि I got a stacking accuracy of F1 score? मेरा confusion matrix भी है, इसमें classification report of Y test, Y pred. मैं आपको बैटरी दिखा देता हूँ, hold on. या आपने को classification report दिख रहा है क्या? या दिख रहा है आपको? Do you see that it also gave me an output? It's called as a stacking classifier. आपने multiple classifiers ensembling use करके you figured out that ensembling works almost okay, great, but not that great. But you just implemented right in front of you. See, आपने meta learners में ये लगाया, sorry, आपने base learners में ये सारे लगाए, meta learners में NB लगाया. Now, if you keep changing the learners, won't the output become better? Hopefully. This is ensembling. This is adding multiple classifiers to give one result. This is ensemble classification that I did right in front of you. You guys are understanding what I just taught you, or is it confusion for you? Stacking classifier is a combination of multiple classifiers, right? Multiple classifiers are telling you which classification is good, which classification is bad. That's what I did, right? इसमें भी you can do hyperparameter tuning. Any confusion? Any questions, or you guys got it? So random state 22 is because naive Bayes and logistic regression are highly random, right? So I want the output to be same every time. Can you see that my precision is 0.88%? If I run it 0.87%, if I run it again 0.87%, it's not changing very frequently. If I remove this, look at my output, 88, 88. Okay, it's 65, 62, 75. So the reason I wanted it to be fixed, I wanted the random state, the seed to be fixed so that the numbers don't change frequently. That's why. It's up to you. Add it, not add it, doesn't make a difference. It's going to give you a very fair accuracy. Did you guys get it? Like, are you understanding what we did here? Yes, you need to first run the classifiers first. You need to first implement the classifiers and then write it, because we've implemented logreg, this and tree, and then we were able to get the output. If you've not implemented it, you can't implement this. Regression, normalization doesn't matter if you're doing a classification problem or regression problem. Normalization matters what kind of variable you're dealing with. You can do normalization for both classification problems and regression problems. Yes, it depends more on the feature you have. Okay. The job is not to find out which is the best classifier in stacking. That's not what you're doing. You are combining a classifier group and having a meta classifier. There is no best in this case. You are not finding which is the best. To find out which is the best classifier, you have AUC ROC score. But here you're just passing multiple algorithms to get a combined prediction. That's what you're doing. Okay, there's no best. Yes, it doesn't. Normalization is a technique. It has nothing to do with what is classification, what is regression. If your problem statement has multiple ranges, to convert them into 0 and 1, you use normalization. That's it. You don't think once again for that particular thing. Okay. So now let me go ahead and explain it to you. What is it called? FF-Dawn. 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 Okay, fine. I'll do it. Tell me one thing. I have a question I want to ask you. I'm so sorry. I forgot the question I wanted to ask you. Give me 1 second. Okay. Explain fit transform and did. Dot is a transform. What is a fit transform? Dot fit. What is dot transform? My people, fit model is used for training the model. Will you agree with me? A fit model is used to teach the training model to the model what is an X train, what is a Y train, to estimate the parameters. Agree or disagree? To tell the algorithm, hey, learn from the feature and learn from the target. For that, we use fit. We use transform when the model is trained and now the numbers are generated. So for example, I'll tell you guys an example. Tell me one thing. You had a number called 50,000 rupees to 1 crore 30 lakh rupees example. So you want to convert these numbers into 0, 1. Yes or no? You want to transform this number between 0 to 1. So whenever you want to convert the number into a different form, you use transform. Yes or no? Fit is used for training of the model. Transform is used to convert the original data into a different kind of data. And fit transform first fits the model and then transforms the model later. First it will fit, then transform. That's why it's called fit transform. It does both the things which you are using separately. It does it in one line. Simple. It's as simple as that. You fit the model, you fit the training data and the test data. You transform the numbers into a different type of transformation. So you use transform. What about fit transform? You first fit the data, then transform. Transform like convert the array, convert the type, convert the data, formation type, all of that. That's what transformation is. Thank you so much for joining today's class. And it was really nice talking to you. Catch you up with a new algorithm for next. Okay. Bye-bye.